This massive and comprehensive Python API course is taught by Sanjeev Thiagarajan. He is an excellent teacher and has taught many popular courses.
Hey, how's it going, everyone? I just wanted to welcome you to my Python API development course. So in this course, I'm going to walk you through building out your very own API in Python. However, keep in mind, this course is so much more than just building out a simple API. In fact, as I'm sure you saw the video length, this course does come out to a whopping 19 hours in length. And so you're probably wondering, well, what exactly are we going to be covering for 19 hours? We don't need 19 hours to create an API. Well, first of all, we're going to build out a fully featured API that includes authentication, CRUD operations, schema validation, and we're going to set up documentation for our API because that's very important. However, the learning doesn't stop just there. This course is going to extend well past just basic API development. We'll also learn all of the tooling that surrounds building a complete and robust API. I've dedicated a large section of this course to learning SQL. And I've noticed that a lot of the other API and web development courses, they just quickly gloss over SQL without diving into the nitty-gritty of how SQL databases work. For this course, we're going to cover SQL extensively, and we're going to start from the absolute basics, so you don't need to know a single thing about databases or SQL in general. But by the time you complete this course, you will be very proficient at generating database schemas. You'll know core SQL concepts like primary keys, foreign keys, table constraints, and you can pretty much be able to generate SQL queries to grab the exact data that you're looking for. And on top of that, I'll show you how to integrate your SQL databases in your API using two different methods. So we'll cover both using raw SQL queries as well as ORMs, so that no matter which method you ultimately prefer, you'll have all the skills and resources to start building out your own projects. We'll also familiarize ourselves with database migration tools like Alembic, which allow us to make incremental changes to our database schema to track changes in Git, just like we can with our regular Python code. We'll also learn how to use tools like Postman to construct HTTP packets so that we could test our API during the whole development process. And when it comes to testing, I've added about 2 to 3 hours of content going over how to set up automated integration tests so that when you make changes to your code, you can run these automated tests to verify that your code changes haven't broke any pre-existing functionality. And then after testing, we're going to move on to the deployment phase. We're going to actually deploy our application. And I didn't just include one method of deployment. I've actually included two different deployment scenarios. The first scenario is probably the most common scenario, which is deploying our app onto like an Ubuntu machine that can be hosted on any cloud provider like AWS, GCP, Azure, or even DigitalOcean. And we'll cover things like how to set up Nginx to act as a reverse proxy. We'll configure our own systemd service. We'll set up a firewall to block all non-HTTP traffic. And we'll even set up SSL so that our application can handle HTTPS traffic. But after that, we'll also take a look at how we can deploy our application onto Heroku. Just because if you don't have, maybe you can't afford to pay for cloud services, or you just don't have the ability to sign up for an account or something like that, I do want to make sure that you still have a way of deploying your application so that you can show off to your friends and family what you created. So I added the Heroku section because they've got a very, very nice and convenient free tier where we can deploy our entire application for free. We don't need to sign up with a credit card. So that's why I included that second deployment scenario. And since all the cool kids are hardcore into Docker today, I'm going to show you how to Dockerize your API in case that is your preferred method of deployment. And then finally, we're going to wrap things up by building out our very own CI/CD pipeline using Github Actions. This will allow us to push out changes to GitHub, resulting in our pipeline running, which will pull our code, run all of our integration tests, build all of the necessary images, and if all the tests ultimately pass, it'll actually push out our changes to our production environment so that we can do all of this in an automated fashion without having to manually go in and run each step manually. So let's take a look at our tech stack. Since this is a Python API course, we will be using Python to build out our API. There were a couple of different web frameworks in Python that we could have used, most notably Django and Flask. I decided to use neither one of them, and I decided to use a newer framework called FastAPI. And the reason why I chose to use this framework was because it has APIs kind of built in mind, right? It wasn't there to address like the model view controller type scenario. It really is all about building out APIs. And on top of that, it is really fast, right? But when I say fast, it's not just fast from a performance perspective, which it is, but it's also fast from the fact that it makes it really easy and quick to spin up new APIs. And one of my favorite features of this framework is the auto documentation functionality. When you build an API, you have to document how your API works. And this is a very cumbersome task because anytime you make any changes to your API, you have to remember to update your API, or then the front end could be making the wrong requests. FastAPI automatically documents your API for you so that you don't have to do it yourself. It's truly a game changer. And finally, the most important reason why I chose FastAPI is because of this. You see this magnificent beast? This is the creator of the FastAPI framework. And my mama always told me, when someone with a mustache as glorious as that creates a web framework, you use that damn framework. Now, as I mentioned, we will be covering SQL extensively, and I've decided to go with Postgres. It doesn't really matter what type of SQL database you use. They're all fundamentally the same with only minor differences. I chose Postgres because that's my favorite, and who doesn't like elephants anyways? For our ORM, when we do eventually migrate to ORMs from using raw SQL queries, we will be using Sqlalchemy. I decided to use that because that seems like that's the most standard one for Python. I really could have chose any of them. I didn't really care which one I used, so I just picked the most popular one. So that covers our tech stack. Let's now take a look at the project that we'll be building. Now, I would love to show you some cool, flashy website that you can show off to your friends. However, we're not building a website, we're building an API. And unfortunately, APIs don't really have a visual aspect to them. So I don't really have anything to show you. I mean, I could, I guess, construct a couple of HTTP packets and send it and verify that we get the proper JSON response, but that's not really exciting. So what I'm going to do is I'm going to show you our documentation for our project so that you can see all the different features that we implement. And the nice part about the documentation is these are interactive docs. So from the documentation, I can actually send HTTP requests to my application and get a response back. So you can really see all of the different features, things like the authentication and the CRUD operations that we'll be performing and setting up in our API. So the app that we're going to build for this course is going to be a social media type application where users can create posts, they can read other people's posts, they'll be able to perform all of the CRUD operations, so they'll be able to create, read, update, and delete posts. And we'll also be able to vote on posts. So, you know, most social media apps have some sort of like system or voting system. And so we will be able to like other users' posts as well. So this is the built-in documentation that comes with FastAPI. And you'll be able to see all of the API endpoints that we're going to create in this course. So we're going to have all of the post endpoint, which is going to be responsible for retrieving all posts, creating posts, retrieving an individual post, updating a post, as well as deleting a post. Then we'll have the user-specific endpoints, so things like creating a user, getting a user's information. And then we've got our authentication, which is going to be used for logging in. And then finally, we've got the one for voting. So when you want to vote on a specific post that you like, you can go ahead and like that post. So let's just use the documentation to actually test out our API. So first things first, let's actually try to retrieve any or all of our posts. So if I hit this get button right here, we can actually try to send a request to our API with the built-in documentation. So you could just say execute, right? And you'll see that we got a 401, which means that we are right now not logged in, so we are unauthorized to retrieve any of the posts. So the API that we're going to build is going to require all users to be logged in to even be able to read the posts. So let's actually go ahead and create a user. And so we'll go down to the user's endpoint under create user, and I'm going to do try it out. And it's going to give us an example of the structure of the data that we have to send to our API to create a user. So we need to provide a username or an email and a password. So I'm going to create an email. I'll call this john@gmail.com. And the password is going to be something simple, just for demonstration purposes. And we'll execute that, right? So it'll actually send that data back to our backend. You can see we get a 201, which means we were successfully able to create it. You can see the ID of the user account that was created. We can see the email is what it is, and then we can see the date that it was created at as well. And so now we can actually log in as this user. So there's a couple of different ways to log in. I can go to the login endpoint, or we can just go up here at the top and just do authorize. And then we can provide that information. So I'll do john@gmail.com, and we'll provide his password. And if we do authorize now, we can see that we have successfully logged in. So I'll close this out. And so now if I try to retrieve the posts and then hit execute, you could see that we were able to retrieve all of the posts in our database. Right now, there's only 2, but you could see that these were created by some other users like Sanjeev in this case, and then Sanjeev123. And if we want to create our own post, we can go ahead and do that. So I'll go to the create post endpoint, and we'll do try it out. And it's going to give us an example here. So we have to provide title, content, as well as is this post going to be published or is it going to be a draft? And you'll actually see the structure of this schema right down here. I think it's at the bottom, actually. So if you go to post, create here, this is going to show us the schema that we have to pass. So we have to provide a title, Content, so the asterisk means it's required. The published is not required, and you can see that it defaults to true. So if we don't provide a value, it'll default to true. So let's test that out. And so I'll just say favorite foods is going to be the title, and then content is going to be pizza and burgers. And I will remove the published section because it is optional and it'll default to true anyways. And we'll hit execute. And if we take a look at the response, we get a 201, which means it successfully created it. And you can see what the post looks like in our database. You've got the title, content. We can see the published got defaulted to true. We can see the ID of the post when it was created. We could see the owner ID, which is, who created the post. And so that's the ID of our account, which is 17. And we can see the information about the owner. So this is john@gmail.com. And then, as usual, we could perform all the other CRUD operations. So we can retrieve an individual post, update it, and delete it. And then once again, if we go down here, we can also vote to like a post as well. And so, this kind of forms the backbone of a traditional social media type application. So once you can really do this, you can really create any application you want. And I think this covers enough things from an API perspective, as well as from a SQL and database perspective, that you will have a solid foundation to really build out any API that you're interested in building out. And so I think that's enough talking. Let's get to actually start coding out our application. In this video, we'll take a look at how to set up Python as well as VS Code on a Mac machine. So the first thing we're going to do is we're going to just search for Python, and the first result should take us to the main Python page. And what we want to do is select downloads, and it's automatically going to give us a button to download whatever the latest version of Python is. And the nice part is it'll automatically detect what platform you're using, so it'll know that we're on a Mac. And right now it says that the latest version is 3.9.6, so it's going to offer me that. Keep in mind, if you're watching this video in the future, it's going to show a different version. And it's okay for you to download a newer version. As long as it's later than 3.7, you should be okay for this course. So I'm going to select this, and it's going to download it like any other application. Once it's finished downloading, I'm going to select that and then select the file that we just downloaded. And then this is going to take us through the Python installation process. So we'll hit continue. We'll hit continue again, continue. We'll hit agree, and then install. And then it's going to prompt us for a password. All right, and so once you get this pop-up, it means that Python was successfully installed. So we can then close that out real quick. And then we can move this to trash. And the next thing that we want to do is go up to your search bar at the top, and I want you to search for the terminal application. All right, and it should find that. Just double-click on that so we can open up a terminal. And with our terminal, what we want to do is we want to type in Python 3 -- version. And the reason we specify Python 3 is that you can actually have a Python 2 and a Python 3 version simultaneously installed simultaneously on your machine. We want to make sure that we got Python 3 successfully installed. So if we type this in, it should then print out the version that we installed, so we can see that we did successfully install Python 3.9.6. So we should be set from a Python perspective. And now that we have Python installed, let's go ahead and install VS Code. So like I said, VS Code is going to act as our text editor or our IDE. And so what we're going to do is just search for VS Code. And this is going to take us to the Microsoft page. And then once again, Microsoft will automatically detect that we're running a Mac. And then we could just go ahead and select Download Mac Universal. All right, and once that's done installing or downloading, we can select that and open it up. And you'll get this warning, just go ahead and select Open. And so this is going to open up our VS Code. And what we need to do is, VS Code is just a very basic text editor. However, it comes with extensions that we can install that make it significantly more feature-rich. So it'll almost act like a traditional IDE. And if you select the extensions icon, which is this icon right here with the extra blocks, select that, and I want you to search for Python. And the first result should be the one you want, and it should be the one that's made by Microsoft. So this is going to provide things like linting, IntelliSense, debugging, and a few other features that are going to come in handy when it comes to writing Python code within VS Code. So go ahead and install this. All right, so now that it's installed, what we want to do is select this icon to go back to our folder menu, and we want to select Open Folder. So what we're going to do is we're going to create a folder to store all of our project code. So I'm going to select Open Folder. Now, we haven't created a folder to actually store our application, so I'm going to go under my traditional users, Sanjeev, and then I'm just going to store this within my document. So I'm going to make a new folder called, I'll call this, we'll just call this FastAPI. So I'll create that, and then we're going to open up the FastAPI folder that we just created. And so this is going to open up all of our project code. Right now we have no files, and that's to be expected. But what I want to do is I want to right click here and select new file. And what we want to do is type in main.py. And before we hit enter, I want you to look down here. So when I hit enter, you'll see that something's happening. So it's activating the Python extension, and it's automatically going to select a Python interpreter. And so like I said, you can have multiple different versions of Python. So technically we could, for any one of our projects, we could be running 3.9.6, or maybe we're running 2.7 if we want to stick to Python 2. We can actually select which specific Python interpreter we want to run on a per project basis. And if you ever want to change this, or for some reason it wasn't able to find this correctly, just go ahead and select View, Command Palette. And then it automatically found the most recently used ones, but you would just search for Python, select interpreter, select this, and it shows the currently selected interpreter, but you can also enter in the path to find a specific interpreter. So you would just find wherever Python 2.7 was installed if you wanted to use that, or if it was unable to find 3.9.6, go ahead and just find where Python 3.9.6 was installed on your machine and point to that python.exe file. Well, actually, it's not called .exe within Mac. I forget what it's called on a Mac. I actually use a Windows machine for most of my things, but that's all you have to do. And so at this point, we've got Python set up, and then we've got our VS Code set up. So once again, anytime VS Code closes, you want to open it back up and then open up the folder FastAPI in this case. In this video, I'm going to walk you through setting up Python as well as VS Code on a Windows machine. So the first thing that we're going to do is within your web browser, just search for Python, and then we're going to select the first result. So this is going to take us to the main Python page, and we want to go to the download section. And so here, Python, the website's going to offer you up whatever the latest version of Python is. In this case, it happens to be 3.9.6. Keep in mind, if you're watching this video in the future, it's going to show some other version, and that's okay. Go ahead and just download the latest version. As long as it's later than 3.7, you should be okay. So I'm going to just hit download Python 3.9.6. I'm going to download that. Once it's finished downloading, I'm going to select that, and it's going to open up the installer. Now with this installer open, it's very important that you select Add Python 3.9 to path. Do not forget to do this, or then you're going to run into some issues. So make sure that's selected and then hit install now. If you go through the installation process and you realize you forgot to do this, technically there's a way to fix it afterwards, but instead of me explaining to do that, the best thing to do is just uninstall Python and reinstall it. So we'll hit install now. You'll get a pop-up, just go ahead and hit yes. All right, and once you see this message where it says setup was successful, that means Python was installed. And the next thing that we want to do is just quickly verify that Python's up and running and working. So what we're going to do is we're just going to search for CMD. So that's going to open up our command prompt or our terminal. And then in here, just type in Python -3 -- version. Sorry, we should actually type in Python py-3 -- version. All right, and so when you type this command in, it's going to tell us the specific version that we installed. So we can see that I was successfully installed Python 3.9.6. If you get any kind of error or any message saying that this command is not available, that means that Python wasn't installed successfully. So just go ahead and redo that process just in case. Now, the next thing that we want to do is install VS Code. So let's open up a new tab, just search for VS Code. And then we'll select this. It's going to take us to this page. And you'll see that VS Code will automatically detect what version you're running. So you can just select download for Windows. And then once it's finished in downloading, go ahead and open it up. Hit the accept agreement, hit next, next, next. And then you can leave everything as default. And then go ahead and run install. All right, and then go ahead and finish. It's going to automatically open up VS Code. Now there's a couple of things I want to do. So VS Code at its core is just a basic text editor. However, we can install extensions that give it extra functionality, extra features that'll make it operate a little bit more like a full-blown IDE. So go ahead and select this icon right here. This is for extensions. And then what we want to do is we want to search for Python. And we usually just want to select the first one. It'll have a star, and it's going to be the one made by Microsoft. You'll see that there's other ones made by other users, but we want the main Microsoft one. Hit install. And so this extension is going to give us IntelliSense, linting, debugging, and a few other features that are going to make it a little bit easier to start working with Python within VS Code. All right. And so now that it's done installing, we can just close this. and then select this one to get back to your main file browser. And right now we haven't opened up any folder. So what we want to do is we want to create a folder to store all of our application code. So select Open Folder, and then figure out where you want to store your application code. So I'm just going to store this in my documents. You can store this wherever you want. I'm going to create a new file or a new folder. I'm just going to call it FastAPI, but you can name your project whatever you want. So just select Folder. And so that's going to not only create the folder, but it's going to open it up within VS Code. If you get this error, just select Trust the Author and just select Yes. And then we can close out this welcome menu. And so now what we have is we've opened up, we've opened up VS Code, and within VS Code, we've opened up our project code. So right now there's no code, that's to be expected. But what I want to do is I want to create a new file real quick, just for testing purposes. So I'm just going to right click, hit new file, and I'm going to name it main.py. And so we want to name it .py because this is going to be a Python file. And before I hit enter, I want you to focus your eyes right down here, and you'll notice something happens down there. So when I hit enter, you'll see activating extension. So it's activating the Python extension. And what the Python extension is going to do is it's automatically going to select the correct Python interpreter, or it may not be correct depending on what happens on your machine. For me, it automatically detected Python 3.9.6 was installed on this machine, so it selected that one for me. Keep in mind, if you have multiple versions of Python installed, it may select the wrong interpreter. So what you can do is if you ever want to change the interpreter or specify a specific interpreter, go to View, Command Palette, and what I want you to do is search for Python interpreter, and then look for Python select interpreter. So right now, it's going to highlight where the current Python interpreters, which one selected, and what's the executable for it. But if you want to change that, you can select Enter Interpreter Path and then provide the path to the specific version that you want. So you can obviously change it, but usually it's able to detect the latest version, so you should be good to go. And so that's all I wanted to do from a setup perspective. There's one more thing that we'll cover later, but we'll get to that in the next section. But right now we've got Python installed, and we've got VS Code set up, and we've got our project directory set up, so we should be good to go. So now that we have Python and VS Code set up, the next thing that we have to do is set up our virtual environment. Before we do that, we have to actually talk about what are virtual environments and what problem do they try to address. So let me give you a little bit of an example scenario of the issue that we can run into when working with specific packages within Python on your local machine. So let's say that we created a project, and this project is called Project 1. And what we need to do is we need to install FastAPI version 1.2.1. So what do? We install version 1.2.1 on our machine so that we can actually use that version. Now let's say later down the road, we start a new project called Project 2. And let's say this version requires us to run FastAPI version 2.4.3 because we want to try out some of the newer features. Well, at this point, if we need to try out a newer version, we have to upgrade FastAPI to version 2.4.3 on our local machine. And this may or may not be a problem. It really just depends on if version 2.4.3 is backwards compatible with version 1.2.1. Because if version 2.4.3 has breaking changes, then ultimately that's going to create issues with our Project 1 because that project expects us to run version 1.2.1. And so if we can't upgrade, well, we're in a little bit of a pickle because one project needs one version, the other project needs another version. We can't have two different versions installed on our machine. So what exactly do we do? Well, this is where virtual environments come into play. So with virtual environments, let's say we want to create a project. So we create Project 1, and what we do is we create a virtual environment. Call it whatever you want. And so this is a isolated environment that will not affect any other environments. And within this environment, we can install any Python packages running whatever version we want. And it's completely isolated to this project. And so when we create a second project, what we can do is we can create its very own virtual environment as well. We'll call it Virtual Environment 2. And within this virtual environment, we can install any version of any package that we want. So then we can install version 2.4.3. And so both of these virtual environments are completely separated, completely isolated with one another. And so we can essentially install multiple different versions of a single package for each of our projects. And that way our projects don't end up stepping on the toes of other projects. And so now that we have a basic understanding of virtual environments, let's go ahead and figure out how we can actually create our first virtual environment and use it within our project. In this video, I'm going to walk you through setting up a virtual environment on a Windows machine. Now, if you already closed out your VS Code window, go ahead and open up a new one and make sure you open up the specific directory we created a couple lessons ago. Now, what we want to do is we want to select terminal and we want to select new terminal. And this is an awesome feature with VS Code. It allows us to have an integrated terminal within our VS Code window. And this terminal is fundamentally no different than a regular terminal within Windows. It's just built into VS Code so that we don't have to keep flipping between different windows. And if you actually take a look at this right column, we can have multiple terminals open, and we can even use different terminals. So the default one on this machine happens to be PowerShell, but you can also use Command Prompt if that's what you prefer. So if you select Command Prompt, it's going to create a new terminal, and you can see that this is a traditional command prompt. So I'm going to use this one because that's the one I normally use. However, if you're more comfortable with PowerShell, feel free to use that. Now, the command to actually create a virtual environment within Windows is py-3-m VNV, so that stands for virtual environment. And then you want to give it a name. So give whatever name you want for your virtual environment. You could name it after your project name, or you could just do what I do, which is just call it VNV. And what I like to do is for all of my projects, I give it the same exact name. And that's perfectly okay because this virtual environment is going to be isolated to this project directory. And so even though this project has a virtual environment named VNV, I can create another virtual environment in any other project with the same exact name. And they're all going to be isolated to that specific project folder. So go ahead and hit enter. And take a look over here. You'll see that a folder was created called virtual environment or VNV. And that's going to be, the name of this folder is always going to refer to whatever name you gave it. So if I named this cookies, this would open up a new folder called cookies. And if you want, you can take a look at what's in here. And if you go under scripts specifically, you'll notice that we've got our Python executable. So this is going to act as our new interpreter. And so what we want to do is right now we are using our global interpreter and we want to change that. We don't want to use the global one. We want to use the specific one in our virtual environment. And that way we can install packages that are exclusive to just this specific virtual environment. And so to do that, go ahead and select View once again. And we want to go to Command Palette. And then search for Python Select Interpreter, as usual. And then you'll see the one we're currently using, but we want to pass in our newest one. So select Enter Interpreter Path. And then we want to give it the path to our interpreter, which is the path from the root of our project directory to this python.exe file. So we're going to say dot, which is our current folder. So this is going to be the FastAPI folder. And then within here, we want to go into scripts. And then within scripts, we want to go into the virtual env folder, then scripts, and then python.exe. Go ahead and hit enter. And then if you look down here, you'll see that this gets updated. So now we're still using 3.9.6, but we're using our virtual environment. And so that's all we need to do. And it should remember this every time we open up our project. However, double check every time you open up just to make sure you're using that. If it's for some reason moved back to the default one, just do the same process. Now, the second thing that we need to do is we need to make sure our terminal is also using the virtual environment. And so what we want to do that is just type in the path to this specific activate.bat file. So this is going to activate that virtual environment within our command line as well. So I'm going to say virtual env, and then we want to pass in our scripts folder, and then activate.bat. Hit enter, and then notice what's changed, right? So when you're using a virtual environment, right, you're going to see the name of the virtual environment to the side of it. So always double check whenever you start up VS Code and you start up your project that this is enabled. If you don't see this, then just run this same exact command, and that's going to reactivate the virtual environment. And so at this point, we are good to go with our virtual environment, and we can start coding out our project. In this video, I'm going to walk you through setting up a virtual environment on a Mac machine. Now, if you've already closed out your VS Code window, go ahead and open it back up and open up the folder that we created a couple lessons ago. Now, within here, what we want to do is we want to access our terminal. So we can access our terminal just by selecting this, and then this is our terminal. However, VS Code has a feature where we can access the terminal directly within our VS Code window. So if we select terminal and then new terminal, that's going to create a new terminal for us. All right. And so this is fundamentally the same thing as this terminal right here. It's no different, but at least by having it built into VS Code, we don't have to keep flipping back and forth between the two. So you can use either one, whichever your preference is. Keep in mind that when you open up the terminal within VS Code, it automatically moves you to the directory folder of your project, so you don't have to move there yourself. You can use whichever one you want. Now, I'm running Mac on a virtual machine right now just because I natively use a Windows machine, so I don't actually own a Mac. So this is a little bit buggy. If you see me type things, you can see it vanish. So for demonstration purposes, I'm just going to use the regular terminal, but I strongly recommend you use the one built into VS Code so you don't have to keep flipping back and forth. Now, to actually create a virtual environment, there's one command that we have to run. So you run Python 3 -m venv for a virtual environment, and then you have to give it a name. So what name do you want to give your virtual environment? You can technically give it any name you want. You can name it after your project. You can give it some arbitrary name. What I like to do is I like to name all of my virtual environments venv. And so for every project that I create, I just create the same exact virtual environment name, venv. And that's not going to create an issue. It's perfectly okay to name all of your virtual environments the same thing because it's all going to be exclusive to this specific project folder. So no other projects can access it. So it's okay if they all use the same name. It's just easier. And so that way, if I ever create a git ignore file, I can automatically add venv, and I can make sure to just use the same exact git ignore template across all of my Python projects. So I'm going to use venv, and I want to make sure that you pay attention right here, because after I run this command, take a look at what happens. It creates a folder called venv, and that's based off of the name of the virtual environment. And if we take a look at our virtual environment, you can see a couple of different files. You can see the Python file as well. So if you go under bin, this is going to be the new Python file or the Python 3 file that we're going to use for our interpreter. So down here at the bottom, you'll see that we are still using the global interpreter. We no longer want to use the global one. We want to use the one in our virtual environment. That way we don't, cause any issues with other projects. We want to use the virtual environment. So to do that, what we want to do is we want to select a view, command palette, and then we want to do the Python select interpreter again. So we'll select that. Right. And so right now it shows us that we are using the global one. However, we're going to pass in the path to our specific interpreter within our virtual environment. So we'll select enter interpreter path. We'll say dot for current directory. And so that's going to mean the current FastAPI directory. Then within there, we want to go into the virtual environment folder. And then within there, we want to go into bin and then just say Python. And so we'll hit enter and then take a look at what happens down here. Right? You notice that the version still says 3.9.6, but our interpreter is actually pointing to our local virtual environment now because we changed the interpreter to use this specific Python file right here. And so this is what's going to allow us to install our own specific FastAPI version, as well as any other version of any package that we want, so it doesn't actually install it globally on our machine. Now we're almost done, but there's one other thing to note. If you look at our terminal isn't using our virtual environment. So if I run pip install any package, it's not going to install it for our specific virtual environment. It's going to install it globally. So we have to enable the virtual environment for the command line as well. And to do that, all you have to do is type in source. And then we want to pass in the path to this specific activate file right here within bin. So we do venv /bin/activate. You hit enter, and then notice how our command line changes. Now it's prepended by the name of our virtual environment. So since we named it venv, you can see that it shows it right before the terminal. And so that's all you have to do. Our virtual environment is set up. Keep in mind, if you close out your terminal and then reopen it, you'll notice that your virtual environment is gone. So you have to run that same exact command every time you open up your terminal to ensure that you are in your virtual environment. And anytime you close out VS Code, make sure that when you reopen your project, it still points to the virtual environment. If for some reason it changes, then just go back to that command palette by going to View, Command Palette, and then selecting the interpreter that you specifically want. But that's all we have to do, guys. So our virtual environment's set up. And so at this point, we can go ahead and get started on coding out our project. So now that we got our environment set up, it's time to get started coding out our project. And what I want you guys to do is, first of all, go to the FastAPI documentation. This is really important. What I want you guys to do is really get a solid understanding of how the documentation works. So pull up the FastAPI website and then head on over to the tutorial section and then select the intro part. So this is going to walk us through setting up our project. And what we will need to do is, first of all, we need to install the FastAPI package. And so what we can do is we can either do pip install FastAPI, or we can do pip install FastAPI all. When we do pip install FastAPI all, it's going to install all of the optional dependencies as well, which we may or may not need depending on what features we want. We're going to go ahead and use the all option because we're going to use a lot of them, and there's no point in having to go one by one and install them. So that's what we're going to do. So here in our command line, and make sure that we are in our virtual environment, and then just type in pip install FastAPI, and then we'll pass in all, and we'll let that run. Now it's moving fairly fast, but if you kind of scroll through the history, you'll notice a lot of packages and a lot of dependencies that are getting installed. So we'll take a look at those once it's done, just to see what are the different dependencies that were installed. And so now that that's done, if we type in pip freeze, this is going to show all of the packages that were installed. So it's not going to be just FastAPI, it's going to include a lot of the optional dependencies as well. So if we take a look, you can see that we've got GraphQL installed if we want to use any GraphQL. We have bcrypt, UVcoin, that's going to be like our web server, WebSockets if we want to work with WebSockets. So it already comes bundled with a lot of things that we're going to use. And I just wanted to make sure that you guys understood what's happening when we pass in that all flag. And if you want to, if you open up your virtual environment folder and you go under lib, you'll see all of the code associated with those packages that we installed. So that's where all of them are going to reside. They're all going to reside within the lib folder. All right, so now that we've got FastAPI installed, the first thing that we have to do is we have to import FastAPI. And to import FastAPI, we just say from FastAPI, which is the name of the library. We import FastAPI. All right, so we've now successfully imported FastAPI. Let's create an instance of FastAPI. So we'll say app equals FastAPI, and then we'll call that function. Keep in mind, you can name this anything you want, but if you take a look at the documentation and just follow along, you can see that it's going to name it app. So I think it's best if we just kind of follow along with that convention. Then what we're going to do is we're going to just copy this code right here. So this is going to be what's referred to as a path operation, and we'll go over what that means in a bit. And we'll just paste this here. I want you to save your code. You'll see if you get this warning or this message saying formatter AutoPep 8 is not installed, go ahead and hit yes. And so this is nice because it'll automatically format our code. So if we ever put too many spaces or things like that, you'll see that as soon as you save it, it's going to snap into place and make everything look nice and pretty. So let's save this. And so once we've got our code, let's actually start our web server up. So how do we actually start our web server? Well, once again, let's go to our documentation. So we're going to make use of the UVcoin library. So because we installed FastAPI with the all flag, it automatically installed UVcoin. If you didn't use the all flag, then you'll have to do pip install UVcoin as well, but we already got it installed. And so let's go back here and let's run our API. So we do UVcoin. Then what we have to do is we have to reference the name of our file. So this is their entry point into our application, which is our main file. So here we're going to say main. Keep in mind, if this file was named anything else, you don't have to name it main. You can name it anything else. You would just want to pass the name of whatever the file name is. Then you do colon. Then you pass in the name of your FastAPI instance. So we named it app. And so we'll do app. And then we'll start that. Right. And so this is saying that we started our server. Perfect. And we could see the URL that our server is running on. So it's going to say http://127.0.0.1. So if you guys don't know what that address is, that means it's this machine. So whatever IP address this machine runs on, that's what this is going to be. So it's just saying, hey, we want to refer to the local host, and it's going to run on port 8000. So if you want to, you could just copy this URL, go to your web browser, paste it in here, and then see what happens. And then look at this. I'm going to zoom in for you. It says message hello world, and that's coming from our code. Right, and that's coming from this return statement right here. So this kind of verifies that everything worked perfectly. All right, so now that we've got everything up and running and working, and you can see that when we go to our website, we can see that we are properly getting back our message. Let's pause this video, and in the next video, we'll take a look at exactly what each line of this code actually means. All right, guys, so let's take a look at the code that we added and actually dissect what each line means. So we've got these 3 lines of code, and if you take a look at the FastAPI documentation that we were on, it's going to define those 3 lines of code as a path operation. So that's the terminology it's using. It refers to this as a path operation. Now, The name itself doesn't really matter. You'll see that in other web frameworks, especially in other languages. Sometimes they refer to this as a route, but they, within the documentation for FastAPI, refer to it as a path operation. So you'll see me flip between those two terms, but they fundamentally mean the same thing. So let's actually take a look at this specific path operation, and we can really see that it's made up of two components. The first component is going to be the function, and the second thing is going to be the decorator. So we'll come back to the decorator in a bit. Let's take a look at this function. So this function is fundamentally no different than any other Python function. It's a plain old function. You'll see that there's this async keyword. Technically, this is optional. This keyword's only needed if you're going to be performing some sort of asynchronous task, so something that takes a certain amount of time. So things like making an API call, things like talking to the database. If you want to do that asynchronously, you do have to pass in the async keyword, but we're not doing that right now. So what we can do is we can actually just remove that. So I'm going to delete that and just remove that. And so now it's just a regular function, and you'll see that the code behaves exactly the same. So we have a function. We give the function a name. So the documentation just shows an arbitrary name of root. Keep in mind the name itself doesn't matter. So if I wanted to name this, get user, then that's going to be fine. It's not going to change anything. It's an arbitrary name. However, I do recommend you name your functions, your path operation functions, to be as descriptive as possible. So if you're trying to log in a user, then maybe you should call this login user, or just log in, so that it's as descriptive as possible. But keep in mind, the name that we put here does not matter. So I'll change this back to root for now. And then within this function, you can perform any kind of logic. So if this function is meant to log in a user, it's going to have all the code for logging in a user, whatever that may be. So maybe, checking the passwords in a database to make sure that they match and to make sure that the credentials are properly accurate. And then after that, just like any other function, we can return something. So whatever we return here is going to be the data that gets sent back to the user. So if we go back to the website, go to our web server, if you take a look at this message, hello world, that's exactly what we sent. And if we change this to be whatever we want, it's going to get returned back in the same way. So here we're just returning a Python dictionary, I guess. And what happens is FastAPI will automatically convert this to JSON, which is the main universal language of APIs, right? We use JSONs to send data back and forth between an API. So it converts this to JSON and it sends it back to the user. And that's why we see that on the web browser. Now, the next thing that we have is this decorator. If you're not really familiar with decorators in Python, it's okay. You don't really actually need to understand, the core concept of a decorator. Just understand that when you apply a decorator to a function, it's going to perform a little magic to this function. Because if I remove this decorator, and if we just comment it out, take a look at this code. This code has nothing to do with FastAPI. It's a plain old function. So how do we actually make it, act like an API? Well, we have to use this magical decorator. This decorator turns this into an actual path operation so that someone who wants to use our API can hit this endpoint. And so you just specify the @ symbol. That's how we clarify that this is going to be a decorator. Then we reference our FastAPI instance, and then we have a couple of different options. So what we pass in is the HTTP method that the user should use. So this is a get method, which means that we have to send a get request to our API, but we can use plenty of different HTTP methods. And I strongly recommend you actually take a look at the different HTTP methods. If you do HTTP methods, we can select this one. This is the Mozilla page. You can see all of the different HTTP methods. So there's get, post, put, delete. So those are the main ones. There's a couple of other ones that are sometimes used, but for the most part, those are the core ones. And so here, once again, just the HTTP method. And then finally, we have the path. And so this is the root path. And so it's a little bit hard to explain the path, but it's basically the path after the specific domain name of your API. So if you take a look at our URL, our web server is hosted on this specific URL. If I go to this page, let's open up a new link and just paste it in here. So the URL and the path in this case is just /. So that's the equivalent of just hitting enter right here or putting a /, which doesn't change anything, right? Right. Whether the / is there or not, it's basically going to take you to the same URL. It's very similar to going to, google.com, right? That's going to take us to google.com. But if we go to google.com/, it's the same thing. So it's the root path. So whatever domain name our API is hosted on, whatever URL, it's just saying it's the root path. If I change this to, login, right? That means that this path operation will only apply if the user goes to our URL and then goes to /login. So that decorator, this path right here, just references the path that we have to go to in the URL. And so if this is actually changed to, how about posts, and then, like vote, so maybe this is the URL for voting on a specific post, then we would have to go and do the same thing here. So we'd have to go to post/vote. So nothing too complicated, but those are the two pieces that make up a simple path operation. You've got the function, then you've got this decorator where you have to pass in the specific HTTP method, and then the URL you want it to go to. And I'm going to change this back to the default. And now what I want to do is, let's go ahead and make a simple change. So what I'm going to do is I'm going to change this. I'm going to change the message to be, welcome to my API. We'll save this. Go back to the root URL because we changed it to the root URL. Let's hit refresh. Notice how it still says hello world. Nothing changed. So what gives, right? Our code's changed. I saved it. Why are we not updating it so that it returns welcome to my API? Well, the problem is that anytime you make a change, we have to restart our server. So to restart our server, you hit Control-C, which is going to stop it. Then you could just hit the up arrow key so that you can find that command that you ran before and just run it again. And so now if I hit refresh, we can see that it updated. And I'm sure you're thinking, well, that's a little annoying. Every time I change my code, I have to do a Control-C and then an up arrow and then hit enter just so that I can, make sure that the server actually implements those changes. And it is a little annoying, but there is a workaround. So if we go to the documentation, you'll see that when they run UVcorn, they pass in the -- reload flag. And the -- reload flag will actually take a look at your code and monitor your code. So anytime that you change your code, it'll automatically restart your server for you. So let's try that out. I'm going to do a Control-C. I'm going to hit the up arrow, and I'm going to pass in the -- reload flag. So we'll hit enter. And now what I want you to do is make some changes. So it doesn't really matter what you change. I'm just going to add a couple of exclamation points. And then I'm going to hit save. And I want you to focus on what happens down here. So if I hit save, look at that. It automatically restarted the server for me. And so now if I go back to my website or my API, hit refresh, you can see that the exclamation points are there. So moving forward in a development environment, only when we're in a development environment, we're going to pass in the -- reload flag. When we go to production, we don't need that. We're not going to be setting it up because we're not going to be changing our code in a production environment. And so I think that's a good stopping point here. In the next video, we'll just quickly review exactly what is a path operation so that we could just reinforce what we learned in this lecture. All right, guys, so let's quickly recap what we learned in the previous lecture. I want to make sure that you guys have a solid understanding of the different components of a path operation because ultimately, that's all your API is. It's just a bunch of path operations. So first things first, we have our decorator. So our decorator has the little @ symbol, and so that's what signifies it as a decorator. And then we reference our FastAPI instance, which we called app. And then we have our HTTP method. So in this case, this is going to match only get methods. And then we have the specific path or the URL. So this is the root URL in this case. And then below that, we've got our specific path operation function. So this function is going to contain all of the logic for performing some kind of task. And when it's going to return some data, and that's the data that gets returned to the user when they hit this specific path operation. So now that we have a solid understanding of how path operations work, let's see if we can create a new path operation. And let's say this one represents retrieving a bunch of social media posts from our application. So in this case, there's two things that we need. So the first thing is our function, our path operation function. So we'll say def, and then we'll give this function any name. I think since we're going to be retrieving a bunch of posts, I think a good name is going to be get_posts. But keep in mind, you can name this anything you want. Like I said, it does not impact the behavior of anything. And then we want to see, so here we would pass in all of our logic for retrieving posts, but we don't actually have an application. So I'm just going to say return. And then we'll just say, maybe, I don't know, data. And this is going to be, this is your post. But in reality, we would provide a list of posts. So let's save that. And then there's one last thing. We have to pass in our decorator like we did before to actually make this turn into a special path operation function. So we'll say @ and we reference the instance, the FastAPI instance. We'll do app dot, and then we have to figure out what HTTP method we want to use for this path operation. So when it comes to retrieving data, you usually use a get operation. And if you don't know which one to use, you can just go back to this page right here, and it's going to explain what each one's for. So if you select get, it's going to explain when you would use a get. If you want to use a post, it's going to explain when you should use post. But I already know that for retrieving data, it's usually a get operation. So we're going to keep it as a get method. Now for the URL, I'm going to say to retrieve posts, we want to go to the /post URL. So let's save this, and then let's see if we can retrieve that data. So if I hit refresh here, it's going to say hello world, but that's because if you take a look at this, we're at the root path, and that's going to match this specific path operation. And this path operation is on /post. So if we go to /posts and then hit enter, take a look at that, we have now got our data, which is our posts. So we've hit that second path operation that we just created, and it really is as simple as that. You just define a function, you define the HTTP method, and then the URL. Now, there's one thing to note, and that is that the way that FastAPI works is that anytime we send a request to our API server, it's going to actually go down the list of all of our path operations, and then it's going to find the first match. And as soon as it finds the first match, it's going to stop running your code. So if I actually change this to just the /URL, just like this one above, what do you think is going to happen? Right? They both reference the get method, and they both reference the same URL. So which one do you think is going to win? Well, let's take a look. If I do just the / again, it says hello world. So it looks like the first one won. And the reason for that is that, once again, FastAPI literally just goes through the code and it looks for the first match. So there's really only two criteria in this case. What's the HTTP method? It's a get. So anytime you work in your browser is always going to send a get method by default. And then what's the URL? So the URL is the /URL. So it matches this one, and it does not continue past that. So it never runs this code. So it sends that back. Now, if I took this, copied it, and moved it to the top, what do you think is going to happen? Which one do you think is going to run? Well, let's hit refresh. Look at that. So that one ran. So the first path operation that matches is always going to be the one that runs. Simple as that. So the order does in fact matter. However, if I change this to posts and leave this at the top, right? If I hit refresh, we get hello world. So what happened was FastAPI went down the list, right? And it received a request that, let me just put some comments. So the request comes in, sorry, that's not the way to comment in Python. Request comes in with a get method, and it comes in with the URL is going to be /. All right. And so these are the two things that it looks for to match. So it hits the first path operation. So this is a get. So those two match. And then it looks at the URL, which is /, but that does not match. So it skips past this one. And then it goes to the next one. And then it checks to see if that matches. So then get matches, the URL matches. So then it returns hello world. And that's why it returned hello world. And the reason I wanted to highlight this is that the order, in fact, does matter. So you have to keep that in mind, and it can impact the way your API ultimately works. So I'm going to just take this, move this to the bottom. But in this case, the order doesn't matter because they're hitting two different paths or two different URLs. Till now, we've been using our web browser to generate HTTP requests to test our API. And that's fine for now. However, once we start getting into more complex path operations and routes, so things that involve having to send a HTTP put or patch or any of the other methods and having to send data to our API, it gets very complicated because there's no way to natively do that in the browser without generating or building out a complete full front-end application. And to test an API, you shouldn't have to build an entire front-end application to do that. That would be, unmanageable, unscalable. And so there's a lot of different tools that we have that we can use to test our API. And so one of these tools is called Postman. So if you go to postman.com/downloads, you can download this app. So go ahead and just hit the download button. It's going to automatically detect what your operating system is. But this is a very simple tool. It's just a tool that allows us to construct our own HTTP request. So we get to specify the individual fields of an HTTP request. So we could specify, what is the HTTP method? What's the URL? What are the headers that we're going to apply? What's the body? What kind of data is that going to carry? Is it going to have any authorization headers? So all of these things we get to construct in a nice GUI so that we can test our API. So go ahead and download this. Now I've already got it downloaded, but once you've got it downloaded, open up the desktop application and you should see something like this, right? Everything should be relatively empty. And what we want to do is, if we want to create a new HTTP request, all we have to do is hit the plus button. And before I do that, what I'm going to do is, let's change this to dark themes. So themes, I think this looks a little bit better. Yeah, that looks a lot better. And I'm also going to zoom in for you guys. Let's make it a little bit more. There you go. Hopefully that's nice and easy for you guys to see now. So what we want to do is let's create a new HTTP request. So hit this plus button. And you can see that this provides us all of the fields that we need to actually create an HTTP request. So the first thing that we need to do is specify what's the HTTP method. So if we go back to our code, right, we only have GET request. So whether we want to hit either one of these path operations, it's going to have to be a GET request. So we're going to leave it as GET, but you can see we have all the other, we have all of the other options. Then we have to specify the URL. So this is no different than the URL that we went to in our browser. We just copy this URL. And we actually need the HTTP in there as well, probably. So if we actually go back to our server and see where we started it, and actually the best way to get the URL is just to stop it, start it, and then that's going to give us the URL. So we just needed the HTTP beforehand. And then we just paste that in there. Okay, and so if I leave this as the the root path, whether I include the slash, it doesn't really matter actually. I can just hit send. And you look at this, this is the result that we got back from our API server. So it says message hello world. And once again, you guys already know where that came from. And that came from this specific return statement. And so you could see that this is so much easier than using a web browser. Well, you guys may not notice how easy it is at this point, but once we get to constructing more complex path operations, you'll see that it's so much easier to use a tool like this. And keep in mind, this isn't the only tool that does this. There are plenty of other applications that also do this. This is just the one that I'm familiar with and the one that I use, but I don't want to, force any specific application down your throat. You guys can use whichever one you want. So if you already use one that you prefer, feel free to stick with it. But before we wrap up this video, let's just test out our other specific path. So this one's going to reside on /posts. We're going to try that. We'll do /posts. We'll hit send. And look at that. We got our data that says this is your posts. So now we were successfully able to test both of our path operations using Postman. And moving forward for the rest of this course, we're no longer going to use the web browser. We're going to use Postman to test out our API. Till now, we've only been working with GET requests. So all of the HTTP requests we've sent to our API all have been GET requests. And so now we're going to learn about POST requests. And they're a little bit different, and I want to kind of highlight what makes POST requests different than GET requests. Now, we're going to compare the two right now, and I've drawn out a little diagram for us. So at the left side, we've got our web browser, or it could be our mobile device, depending on whatever the front end is. And on the right side, we've got our API server. So this is our FastAPI server. Now, with a GET request, what we do is we just send an HTTP GET request, and then we send that to our API server, and then our API server sends back some kind of data, depending on what they're trying to get. So if they're trying to get a whole bunch of posts, we send back the posts. Now, with a POST request, it's going to be similar, except there's one minor difference. And that is that with a POST request, we can send data to the API server. So in this case, a lot of times what you'd use a POST request for is for creating things. So if I want to create a post, I would, and when I say post, I mean like a social media post, not post as in post request. But if I wanted to create a social media post, I would send an HTTP post request, and I would include all of the data needed to create a post on my API server. So we'll send that data over to the API server, and the API server will send back whatever data it thinks it needs to send. And so in real life, if we were trying to create a post, we would include whatever data we needed for a post. So in this case, we would include what's the title of the post, what's the content of the post, what's the user of the post. We send that to the API server. The API server can then talk to whatever database to actually create the post, and then it can send back some data, something like, hey, I've successfully created the post, and then here's the final post after I create it, and then send those details back to your web browser or your mobile devices. So think of it like this. A GET request is basically saying, hey, API server, give me some data. Whereas a post request is saying, hey, API server, here's some data, do whatever you need to do with it. So so it really controls the direction of flow of data between the front end and the API server. So GET requests are getting data from the API server, whereas a post request is sending data to the API server. So now that we have a basic understanding of how post requests work, let's go back to our code and see if we can create a path operation for a post request. So let's go below our last path operation, which was for getting posts, and let's create one for creating posts. So first things first, let's just actually create our decorator first. So we'll do app dot, and instead of get, we're going to say post. So that's all it takes to convert a traditional GET request to a post request. You just say dot post, and then once again, we're going to say whatever specific URL the user should go to actually create the post. Now I'm going to do something a little bit bad. I'm going to say the path that we want to go to is called create posts. And if you've ever worked with APIs, this is kind of going against best practice, but don't worry, we'll correct this in the next lesson. Because there are certain best practices. It's not going to break our application by any means. We'll say this, and then we'll say def, and then here we'll just name our function. I'll just say create post. Like I said, the name of the function never matters. And then here, all we're going to do is we're going to return, we'll say message, and then we'll say successfully created posts. So let's save that, and let's go to our Postman. And so we've got already one request, so I could just change this to post. And then we have to change the URL in this case. So we'll go back and see it's at create posts. So it's going to be at create posts. And let's hit send, and let's see what happens. Look at that, message successfully created. So we have successfully sent a post request to our API. Now, one thing I like to do with Postman is that you can create multiple requests and then have them saved. So I'm going to actually change this back to just go to posts and then go to get, and then we'll keep that. And what we can do is we can just add another request. And so I'm just going to copy the URL here. I'm going to paste this, and then this is actually going to be create posts, and then this is going to be a post request. And so now we can hit a get request and then hit a post request really quickly because they're essentially, we've got them in two different windows. And let's just quickly double check that still works. That's good. And then let's double check a get post. That still works. Perfect. Now that's cool and all. However, the whole idea behind a post request is to send some data to our API server. So how do we do that? Well, let's go to our post request. And what we want to do is we want to send some data in the body of the request. And to do that, within Postman, you would go to the body section right here. And then within body, what we want to do is go to raw and then select the type. And normally, when you're working with APIs, you want to use JSON. However, you can use XML and a few others. However, most people use JSON. So we'll select JSON. And then we'll do, and JSON looks it operates very similarly to a Python dictionary. So it's, curly braces, and then it's going to be a whole bunch of key value pairs. So here I'll say, what's the title of my post? Well, title of my post is going to be, we'll say top beaches in Florida. And then the content of the post is going to say, check out these awesome beaches. All right. And so now if we hit send, let's see what happens. Great. So it says successfully create post. We successfully hit this endpoint, but in our path operation, how do we actually extract the data that we sent in the body? How do we retrieve that body data? Well, what we can do is within our path operation function, I can say, I can just assign it some variable. So what variable do we want to store that body data? You can pick any name you want. I'm just going to say this represents payload, although it could be something like body or anything else. So we'll say payload. And then what we want to do is colon. And then we want to say it's going to be of a type dict. And we want to set this equal to body. And we want to import this. So this is actually something that comes from the FastAPI library. So if you do tab, if you hit tab, it's going to automatically import it, or you can select it. So you hit body and then do that, and then triple dots. And just to keep in mind, right, if you see that from FastAPI params, it imported body. So what this is going to do is it's going to extract all of the fields from the body. It's going to basically convert it to a Python dictionary, and it's going to store it inside a variable named payload. Pretty simple. And all we have to do is, let's say, print. Let's just print out payload. Now, if we hit that post request again, look at this. Right here, we can see that it converted it into a Python dictionary, and we extracted the title field as well as the content field. And so that's how we extract the data from the body of the payload. All right, and just to quickly recap, once again, we imported body from fastapi.params, and we let VS Code do it automatically for us. I always recommend letting VS Code do it for you so that you don't have to memorize and remember, you know, where in the FastAPI library this property is stored. So we're taking the body, and then we're converting it into a dictionary, and then we're storing it inside a property called payload, but you can name this whatever you want. And so what we can do is we can take this data, and then we can say, let's say we're going to return back a new post, and then we're just going to send the data. So we'll say title, and we can actually change this to a F string. And we'll say title. And then we can pass in payload. And you'll see that it's, we can just reference the title property, because it's just a regular Python dictionary. And we'll say that the content is going to be payload content. So let's save that. And then now let's hit send. Now look at this. We got our new post, and it sent, whoops, it looks like I made a mistake. Yeah, no, actually that's correct. Title, top beaches in Florida. Content, check out these awesome beaches. So that's pretty simple, guys. I showed you guys how to not only send data in the body within a Postman request, we're also able to extract that data and send it right back to the user. Now, in a real application, we would take the data, and then we would normally store that data inside our database so that we can create a new post, store it in the database. And then now, anytime the user tries to retrieve the post, we can fetch that data from the database. We don't have a database set up just yet. So for now, I'm just showing you guys how to extract that data and then send it back in the request. In the last lecture, we learned about how to work with post requests. We learned about how to send data in the body using Postman, as well as how to extract that data within our path operation so that we can perform some logic. And there's some issues that we're running into at the moment based off of the way we've kind of set up things. All right, and the first thing is it's kind of hard to get all of those values from the body. We have to, you know, extract each one individually. On top of that, the client can send whatever data that it wants. And this is a big issue, right? I don't want the front end to send arbitrary data. If the user is trying to create a post, I want the title, I want the content, nothing else, right? I don't want them to send any extra data, right? And on top of that, the data itself isn't getting validated, right? So how do I ensure that the user is sending what I want, right? What if the user sends a blank title? I can't have a post with a blank title. So how can we validate that the data that the user sends is actually valid, right? And ultimately what we want to do is we want to force the user into a schema that we can expect, right? That's the term that we always use at the API, a schema, where we want to define exactly what the data should look like so that it's almost like a contract between the front end and the back end saying, hey, the back end sends a message to the front end saying, listen, I expect my data to look like this. If you don't send me the data that looks exactly like this, I'm going to give you an error. And that's the way you want to work with APIs. You want to explicitly define what the data should look like so that the front end can send you exactly what you expected. So let's see how we can do that using FastAPI. Now, what we're going to do is we're going to make use of a library called Pydantic. Now, we've already got this installed because we used that all flag when we did pip install FastAPI. So if you actually go back to your code and go to your lib folder, you should see Pydantic somewhere in here. And you can see that Pydantic's already installed. So we can make use of Pydantic to define what our schema should look like. So let me quickly show you how to work with Pydantic. It's really simple, but keep in mind, technically Pydantic has nothing to do with FastAPI. It's its own complete and separate library that you can use with any of your Python applications. FastAPI just makes use of it so that we can define a schema. So let's import Pydantic. So we'll say from Pydantic, import base model. And so if we go down to our, our create posts path operation, ultimately what we want to do is we want to tell the front end what a post or a new post should look like. What data do we expect? So let's figure out what data we want for a specific post request. So two things that we want. We want a title, which is going to be, a string essentially. And then we want the content, which is the content of the post, which is going to be, some sort of string. All right. And so we expect the user to send both of those things. And then we don't really want anything else. We don't want the user to send any other piece of data. We just want these two things. And we can put in any other pieces of data we want. So if we want the user to pass in something like, what is the category of the post, we can include that. We can maybe include the number of, I don't know. You can really think of anything, maybe a Boolean that kind of represents, is this a published post or do you want this to be saved as a draft? So you can construct it however you want, but we're just going to stick to title and content. So the way that this works is, I'm going to remove this comment right here. We're going to define a class. So we'll call this class, and then we'll give it whatever name we want. It's going to represent what a post should look like. So I'm just going to call this post. And then this is going to extend base model. So this is what makes it a special Pydantic model. We just extend the base model. And then here we pass in the different properties for our post. And like I said, we want a title. And we also want the content. Now, what we pass here is going to be, what is this type of data? So if we go to this Pydantic library, you'll see that there's the different field types. So we can set things to be a Boolean. We can set it to be an int, float, string. So all of the common Python types, list, tuple, it's all available within Pydantic. So we know what ultimately what a title should look like. So what do you guys think should be the field type for the title property? Well, I think it makes sense. It should be a string because this looks like a string. It's got some text. It probably should be a string. So let's set this to be string. And the content should be the same thing. It should also be set to string. And now what we can do is, let's take this model and go down to create posts. And instead of extracting the payload, what I'm going to do is I'm going to reference that post Pydantic model. And then I'm going to save this as a variable called post. Once again, they don't have to match, but since this will represent the post, I can call this maybe new _ post or something like that, and then reference the post Pydantic model. So what's going to happen is, because we pass this into our path operation, FastAPI is automatically going to validate the data that it receives from the client based off of this model. So it's going to check, hey, does it have a title? If so, is it a string? If the title doesn't exist, or if it's not a string and maybe we pass an integer, then it's going to throw an error. It's also going to check for us if content's available. If it is available, it's going to make sure that it's a string. And if content's not available, or if it's not a string, it's going to throw an error. So it's doing all of the validation for us, and it's defining the schema of what it should look like for the front end. What kind of the data should the front end send to us? So we're going to remove all of this nonsense. I'm just going to, for now, just say data, I don't know, new post for now. And now what I'm going to do, instead of print payload, we're going to say print new _ post. So let's save this. And then I'm going to send a post request. Okay, so that updated fine. But let's take a look at what this printed out. So take a look at what it printed out. Look at that. It automatically extracted all of that data for us. So now we can access, post.title, and we can get the title of the post. And we can also access post.content to get the content of the post. And just to prove that to you guys, we'll say post.title. So we'll save that. We'll send a request. And now look at that. Look how easy it is to extract that data because it's already assigned to that new post variable, and we can just access each property based off of what the model is defined as. Now that's great and all, but let's check to see if it's actually performing all of that validation. So if I go to my Postman and I remove title, let's see what happens. I'll hit send. Look at this. Look at this. It's saying that inside the body, there's a title field and it's saying a value error, it's missing. Now we didn't tell FastAPI to send this, but it automatically does the validation for us and sends back an error message. And then it sends back a status code. So this is the status code of the message. It sends a 422. We can change that later. Don't worry about that. But it's automatically performing the validation. And that's what's awesome about this. And if I add the title back, what was it? Top beaches in Florida. And instead, actually, if I change this to be a 1 or something, and I need that comma, let's see what happens. If I hit send, it looks like there's no errors. And that's because the number 1 can actually be converted into a string. So it's not going to throw an error on that, and that's perfectly fine. And that's perfectly fine, so that's not a big deal. But let's change this back. Like I said, it's going to try to convert whatever data we give it to a string. So as long as it's able to convert it to a string, it's okay. And any integer that we pass can be converted to a string. So I'm going to change this back, and I'll add top beaches in Florida. Florida. Let's see what happens if we remove the content now. If I hit send, look at that. Now it's saying the content is missing. Perfect. So our validation is working exactly how we expect it to. And then I forget what was it? Something beaches, or I can't remember what it was. Now let's say that we want to assign a property that's optional, right? Like what if we wanted to make it so that the front end can either choose to send some piece of data or not send a piece of data. So let's say that we want the user to be able to define if a property, if a post should be published or not. Well, we can create a field called published, which is going to be set, which is going to be a type of Boolean. And we can say, first of all, we can say if the user doesn't provide us a value, we can give it a default value. So here I'll say true. And so if the user doesn't provide published, then it's going to default to true. If it does provide published, then whatever value you give it, that's what we're going to use it as. And I'm going to go down here and we're going to change this to, we're going to grab the published value. And then down here, we'll say published. Whoops. It's going to be set to true. So let's hit send. And we can see that it got set to true. That's good. If we set this to false, hit send, we can see that it's false. And then if we remove this altogether, move that comma as well, hit send, look at that. It defaults to true. So now we've created an optional field for our schema. So the user doesn't have to provide this, and it's going to default to true in this case. Now, let's say we wanted to create another field. However, instead of giving it a default value if it's not sent, we want it to default to none. So we want it to be completely optional, and we're not going to store any value if the user doesn't provide it. What we can do is, let's say the field is a rating. Let's say the user can give each post a rating. What we can say is optional, and we're going to have to import optional from the typing library. So import optional. And then we have to pass in the type. So what is it going to be? In this case, a rating, I think an integer makes sense. And then we can say equals to none. So this is going to be a fully optional field. And if the user doesn't provide it, it's going to default to a value of none. And so here, I'm just going to get the value of our rating. And so if I hit send right now in our body, we don't have a rating field. If I hit send, you can see that it defaults to a value of none because we set this to be optional none. However, if I pass in a rating field, I need to give it a value, some kind of value. So I'll say, we'll give this maybe like 4 stars or something. If I hit send, we can see that now look, the value of rating is set to 4. And then finally, the last thing I want to note is because we set the type to be an integer, so even though it's optional, we still have to specify the type. If I give this a value of a string, so something like hello, which is not a valid rating, take a look at what happens. Look at that. It says in the body, the rating field, the value is not a valid integer. So it wasn't able to convert whatever value we sent into integer. And so that's why it's throwing an error and saying like, this does not match up with the schema, and it's throwing an error. And so that's what's awesome about this is now we can ensure that our front end is sending the exact data that we expect by using these Pydantic models. So moving forward in this course, we are going to really make use of Pydantic models to ensure that the schemas not only receiving data from the front end, but also sending data back is all matching up with our organized schema. And actually, there's one last thing I want to show you guys, and that is that when we actually kind of extract that data and save it into new post, it actually stores it as a Pydantic model. So it's a specific Pydantic model. And each Pydantic model has a method called .dict. So if I print new post, below this, what we can do is if you ever need to convert your Pydantic model to a dictionary, all we have to do is write the name of the variable, and we say .dict. So this is going to take that Pydantic model, and then it's going to convert it to a dictionary. So let's print that out. Let's save it. Let's hit send. Whoops. And I forgot to, it's still throwing a validation error, but that's to be expected. So we'll say change that to 4. All right, take a look at the two different things. So this is a Pydantic model that's just printing out the different properties of that model, whereas this is a regular Python dictionary. So we can just send back a dictionary if we want to. So we do return new post and save that. Now if I hit send, we're just sending back a dictionary. And so now we send back the data with all of the different properties. And so you'll see that this is actually a nice little handy tool to be able to convert it to a dictionary, which is something that we'll be needing to do in some of the future lectures. So I wanted to make sure we just cover our bases real quick on that. And also, I don't like calling this new post. I'm just going to change this to post for now because I think that's a little bit better, in my opinion, because it is just a post. We don't need to know that it's a new post. It clearly is. And let's just double check that everything works. Let's hit send. Perfect. In this lesson, we're going to talk about what a CRUD application is, as well as what are standard conventions when it comes to creating an API for a CRUD-based application. So CRUD is an acronym that represents the 4 main functions of an application. So any application, regardless of what it is, needs to be able to create things. So in our case, since we're building a social media type application, we need to be able to create posts, make new posts. We need to be able to read posts. And so that includes, retrieving all of the pre-existing posts. We need to be able to update a post if we want to implement that functionality. So if we decide to change what our post says, we would use the update functionality. And then finally, we need to be able to delete a post. And so the CRUD, that represents the 4 main functions of any CRUD-based application. So it's nothing more than an acronym. However, I created this slide so that you guys can understand what are standard conventions when it comes to creating an API for a CRUD-based application, because there are certain best practices that we need to follow. And so when it comes to naming the URL and the paths for each operation, there's a standard convention. And the first thing that I want to point out is since we're working with posts, it makes sense to name all of the URLs, all the paths with /posts. And it's important that you use the plural form of posts. You don't want to do /post. You want to do /posts as in plural. This is standard convention for APIs. And if we were working with users and we wanted to be able to create, read, update, and delete users, it wouldn't be /user, it would be /users. So always use the plural, that's standard convention. Now, when it comes to creating a post, right, that's always going to be a post request. So we've got the create functionality right here, and we can see that we have to send a post request. Standard convention. Anytime you want to create an entity, it's going to be a post request. And the URL or the path for that specific request is always going to be /post in this case. And if you want to see what that looks like for the decorator in FastAPI, it's pretty simple. You just do app.post/post. So this is something you guys already know. Now, when it comes to read functionality, which would be, reading or retrieving pre-existing posts, there's actually two different path operations we're going to create. So the first one is going to be /post, and this is going to be for retrieving either all of the posts or multiple posts, depending on what filter that we use. And so when it comes to retrieving information from a database or anything like that, retrieving data, it's always going to be a get operation. So you send a get request to /posts. And if you want to see what that the decorator on FastAPI would look like, it's just app.get/post. Once again, we already have this set up in our application so far. However, there's also going to be another path operation for reading, right? And that's if you want to get one individual post. So if we want to get detailed information about one specific post, we're going to send a get request to /posts/ and then we've got this ID right here. So anytime you create something, what's going to happen is anytime you add something to a database, the database is going to give it that specific item a unique identifier so that we can uniquely identify that specific entry. And so if I want to get detailed information about a specific post, I would just send a request to /posts and then pass the ID of that specific post I'm interested in. So that's what this ID represents. And within FastAPI, if you want to see what that actually looks like, you would just do app.get /posts, and then you do curly braces and then ID. And that'll allow you to extract the ID from the specific URL of the request. And then we can, take that take that ID and then, send it out to our database so that we can retrieve the information. So there's always going to be two specific path operations for read functionality. Then we have update. So this would involve updating a pre-existing post. So maybe we, posted out something and then we realized we said something offensive and we want to update it before anyone takes a screenshot of it. Now, when it comes to updating, right, there's two different HTTP methods that we can use. We can use put or patch, and it's really a matter of user preference. The only difference is that I don't want to spend too much time on it, is that when we use put, the idea is that you pass all of the information for updating it. So all of the fields have to be sent to the API server. Whereas a patch, we can just send just the specific field that we want to change. So put, you want to change the entire thing, you have to pass every field, even if it's going to be the same, and most fields don't change. Whereas a patch, we would just change the one specific field. So as an example, if we're working with users, actually, if we're working with posts, and let's say I wanted to change the title, all right, I want to update the title of a post. If I used a put request, I'd have to give the new title, and I would have to give the pre-existing content, right? Because the idea behind put is that you have to provide all of the same information so that we can, on the back end, just take all the information and then update the entity. Whereas a patch operation, I can just send the title, and then my backend should know how to just update that one field. We're going to stick with put, I believe, in our application, but really at the end of the day, it doesn't really matter. It's just a matter of user preference. But with update, just like when it comes to retrieving one specific post, we have to pass in the ID so that we know which specific post we want to update. And for the decorator in FastAPI, the only thing that we change is it's going to be app.put. And then we can pass in the ID like we did before. And then finally, we have delete. So if you want to delete a post, once again, you're going to send a delete request. So that the HTTP verb is going to be delete. And then we have to pass in the specific ID of the post as well. And then this is what the FastAPI decorator is going to look like. So it's actually not that hard. It's fairly simple. And you'll see that once you create one CRUD API, creating another one is almost a matter of copying and pasting, really. And so in the next video, we're going to make a few changes to our API so that we can make sure that we follow this naming convention, because right now, I believe when it comes to creating a post, instead of just using /post, we called it /create post, which once again is not following best practice. So we'll update that in the next video. All right, guys. So in the last lesson, we learned about best practice and naming conventions for an API. So what I want to do is quickly go into all of the code that we have and make changes so that we follow best practices. And so if you take a look at our GET request, you can see we send a GET request to /posts. That's perfect. We don't need to change anything to that. However, the issue is our create post functionality. So the path for creating posts, we can see that we send it to a URL of /create posts. That is not going and following best practice. So what we do, just change this to be /posts. And that's all we have to do. And so we'll save this. And we'll just double check inside our Postman just to make sure we update that as well. So this is going to be to /posts, and then we'll just test this out to make sure we didn't break anything. And it looks like it's still working just fine. All right, guys. So if we take a look at our code, you can see that for our create post path function, we're not actually doing anything with the data. We're not actually saving the post anywhere. Right now, we just print it out and then send it back to the user. So that's not exactly how a real application would work. And so what I want to do is I want to start saving these posts. I want to start turning this into a real fully functioning application. Now, ideally, we're going to save this within a database because that's how any application works. You want to take a post, you want to save it in a database so that you can persist that data. However, we're not quite ready to handle working with the database. It's a little complex. We're going to get to it in this course. However, I want to keep things simple. So what we're going to do is we're going to save the posts in memory. And how do we do that? Easy. I'm just going to create a variable just globally that's going to store all of our posts. So I'm going to say my_posts. And this is just going to be an array. And so this array is going to contain a whole bunch of posts objects. All right? And what each post is going to be is it's going to be essentially a dictionary. And the dictionary is going to look kind of like this. So we're going to have a couple properties. So we already know that our post is going to have a title, and then that'll have, whatever, title of post 1 or whatever. And then we're going to have the content, of course. And I'll just say content of post 1. This is just an example post. And then what we'll also do is, like I mentioned before, anytime you save a piece of information within a database, the database is going to create a unique identifier, an ID. Now, since we're not working with databases, there's no ID. However, it's going to create issues because, if you remember, when it comes to working with CRUD-based APIs, we need to be able to fetch data and update data based off of the ID of the specific post. So we do need to still have an ID so that we can uniquely reference any single item within this array. So we're going to have another field called ID. And then this is just going to have, be some random integer, 1, 2, 3, 4, 5. It doesn't matter. It's just got to be unique. That's all that matters. So this is what our post is going to look like. And we're going to just store it in this array. So we're going to have multiple posts. And I'm going to keep this one hard-coded in here because every time we change our code and hit save and refresh, guess what? It's going to clear this out because remember, this is just stored in memory. So every time our application restarts, we're going to lose that data. So just to keep things simple, I'm going to hard-code another entry. So for this post, we'll say the title is favorite foods. And the content will be I like pizza. And we'll just give this an ID of 2. All right, and so now that we actually have some place to store our posts, we can actually test out our get post functionality to see if it works. So I'm going to save this. We're going to go back to Postman. So find the one with the get operation where we're retrieving the posts, and then we'll hit send. Let's see. Well, when we hit send, nothing happens, of course, because we actually have to update the code to send that data. So let's go back to our code and let's go to our get posts. So right now we're just sending back this information. So let's update this so that we return my posts. And this should be fairly straightforward. What we can do is we can just keep this property called data, and then we can just remove this and just pass along my_posts. And so what's going to happen is FastAPI is great because if I pass in an array like this, it'll automatically serialize it. So it's going to convert it into JSON. JSON has something that's also very similar to an array, and it's going to change that into a JSON format so that we can send it over our API. So that's all we have to do. We just have to pass in the array, and it's going to send that. So now if we try this, look at that. So we get the data property, and within here we have an array. So this is JSON also has a concept of arrays, and then within here, you can see we've got our post 1 and our post 2. So that's really as simple as how to work with our API, how to actually retrieve posts. In the next video, we're going to update the create post path operation so that we can figure out how to add a new post into our my posts array. All right, guys, so let's update our create post path operation function so that we can retrieve the title and the content from our front end, and then create a brand new post and store it within our my posts array. So how do we do that? Well, we already know that we can retrieve our post by referencing this post variable, because this will take our schema, which remember we defined with Pydantic. It's going to do all the validation and it's going to store it within post. And so this is still going to be a Pydantic model. However, our array is going to be an array of dictionaries. So we have to convert that to dictionaries. And we already know that we can convert any Pydantic model to a dictionary by doing .dict. And then that'll turn it into a standard Python dictionary. And at that point, it's pretty simple. This is just standard Python at this point. We can just do a my_posts.append. And then we can append post.dict, just like we did before. We can remove these print statements. They're just cluttering things up. However, there's one little issue. Like I said, we need to have an ID for every entry. And normally the database handles that, but since we're not actually working with a real database, we're going to have to do this in software. So what I'm going to do is we're just going to assign it a random integer. Not really that reliable, but if we pick a random number between 1 and 10 million, the odds of us hitting the same number twice is almost next to none. So what we're going to do is we're going to use the random package. So we'll say from random import ran range, and this is what we're going to use to create a random number or a random integer. And so instead of doing this, I'm actually going to remove this for a second. And I spelled append wrong as well. What we're going to do is I'm going to say post_dict, which is going to be the post Pydantic model converted to a dictionary. I'm going to set that equal to post.dict. Okay, so this is going to be the dictionary. And so now that we have a regular Python dictionary, what we can say is post_dict. And then I'm going to reference the ID field that I'm creating. And I'm going to assign that to be a random number. So we're going to give it a range of 0 to, and then just pick some really, 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 really large number. So this is going to ensure that pretty much any entry for development purposes is going to be unique. But we'll append that to the array. And then here's the thing, when it comes to how a usual API works is that when a front end sends the data to create a new post, after we create the post stored in our database, we should send back the newly created post, including the brand new ID. So let's send that back. So in this case, I'm going to send back post_dict, because that's going to be the brand new post that we add to the add to our posts array. So let's try this out. Let's go to our post request that we have. And let's see all of our data. So we've got a couple of things: title, content, rating. I don't really care about the rating. But I'll just leave it in there for now. It shouldn't matter. And then we'll just hit send and let's see what happens. And it looks like we got an error, so let's see what happened. All right, it looks like there's and I already see what happened. I forgot to actually include post_dict. We actually have to pass in what we want to append to the array. Let's save that. Try this again. Hopefully no errors. Look at that, guys. So it looks like we got back the newly created entry, and we can see that it has an ID of whatever that number is. And if we do a GET request now to retrieve all of our posts, we should see that newly created entry. So let's take a look. So we've got post 1, post 2, and then we've got that brand new post. Look at that, guys. So we are a little bit less than halfway done with creating our CRUD-based application. Now, before moving any further and writing any more code, what I want to do is I want to actually save these requests, because right now they're just kind of stored in memory. If we close out Postman, it'll still remember it, but what we can do is we can create a collection. So here I'm going to select create collection, and I'm going to give this a name. So I'm just going to name this after my project. So I can call this, FastAPI course, or, since this is a social media app, we can call it whatever we would call it. I'm just going to call it FastAPI course. We'll save that. And then what I want to do is I want to save these two requests so that I don't have to remember this in case they accidentally get deleted. So I'll hit save as. We'll save it, and then you can give it any name. So this is going to be, I forget, this is the GET request. So I'm going to call this GET posts. I'm going to store it inside this collection. Right? And so now within this collection, you can see this request is stored in there. And I'm going to do the same thing for the post request. So this is for creating posts. So we'll do save as again. I'm going to say create post. And then it already remembers the most recent collection, but go ahead and select the collection if it didn't remember that. and then we'll hit save. And so now they're both saved in here, and we can easily bring these up anytime, even if we close out all of our requests. So I closed everything out, can bring that right back up. It's going to remember everything. And then it's the same thing with the post request. If I go to the body, it even remembers the fields. So Postman, one of my favorite tools when it comes to working with APIs. And, you know, as this course goes along, you're going to continue to learn more and more things about Postman. Okay, guys, let's continue building out our CRUD application. The next function I want to implement is retrieving one individual post. And so let's define a function for that. So here I'll call this get post. Keep in mind that this is singular. So I call this get post, whereas to retrieve all posts, it's get posts. But like I said, the name of these functions don't actually matter. It's just more for you, more for readability. And the decorator is going to look like this. And so this is based off of that slide I already showed you. So it's going to be a get method. And then here, the URL is going to be /posts ID, right? Because the user is going to provide us the ID of the specific post that they're interested in. And so that's going to get embedded in the URL. So they'll send a GET request to /post/ and then whatever ID. So if they want to see the information for post 1, they'll pass in a value of 1. And what this is actually referred to, the proper terminology for this is that this is called a path parameter. So this ID field represents a path parameter, and this parameter happens to represent the ID of a specific post the user is interested in seeing. And so what we can do is FastAPI will automatically extract this ID, and then we can pass it right into our function. So now our function has access to whatever value was in that URL right there. And so if we want to, I can do a quick print of ID, and then we'll just return some hard-coded data. So I'll just say data. Actually, we'll call this, how about post_detail. I'll say this is the post you're interested in. Or even better, what I can do is we'll change this to an F string, and I'll just say, here is post, and then we can just pass an ID. So let's save that. We'll go to Postman, and what we want to do is we want to create a new post, but let's create it in our collection. So I'm going to go in there, select add request, give it whatever name you want. I'll say get one post. And then for the URL, just copy the get posts URL. And then we want to pass in the ID that we're interested in. So we just do /. And then in this case, I'm going to get the post with an ID of 2. And the reason why I'm doing that is because we've hard-coded one of our posts to have an ID of 2. So I know that's always going to be there. And then we could just try sending this and see what happens. So it says post detail. Here is post, and then post number 2. So it looks like we were successfully able to extract the ID, the path parameter that was passed into the specific URL that the user sent a request to. So we now have access to that. At that point, we can just find whichever entry in my post has that specific ID. Now we have to implement the logic for actually getting that post. And so there's many different ways of doing this. And I'm telling you right now, this is probably not the best way of doing this. I'm not really even a Python expert. I'm sure there's much better ways of grabbing this information. However, keep in mind the code's going to be changed later on once we start working with the database. So this at this point is just basic Python logic. And I do want you guys to keep in mind that this may not be best practice for the best way of retrieving an individual post. But I'm just going to create a simple function, and it's going to be called find post. So this is how you find a post by an ID. So we'll pass in an ID in this function to retrieve the post. And what we'll do is we'll iterate over the my post. So we'll say for p in my posts, and we'll say if p, so p represents the specific post that we're iterating over. So if this specific post has an ID, which equals the ID that was passed into the function, then we'll return p. We'll return that specific post. And then at this point, we can call this function. So I'm going to remove that print statement and say post equals find_post ID. And then for this, we can just remove this and just return post. So let's save this. Let's go back to Postman and let's try this out. And it looks like I got an error. So something happened. And let's actually take a look at our code. Well, guys, I think I found the issue. So the reason why we keep getting none, right? If I keep sending hitting send. It says none. And what I did was I just printed out the post to see what we got. And it actually just prints out none. So for some reason, we're unable to find post. And I think I know exactly why. And so what I'm going to do is I'm going to do a print of ID again. And this is going to teach us an important lesson. So I'm going to send another request. And it prints out 2. However, what we're going to do is I'm actually going to get the type of ID. So I forget how to do that. I think it's the type. I think I could just do type in Python. So I'm going to figure out what is the actual type of ID. And now if I send this request again, right, you could see that the type is actually a string and not an integer. And so when we pass this check-in where we say if P ID, so if we get the ID field and compare it to the ID that we pass in, it's never going to equal that because one's an integer, the other one's a string, they're never going to be equal. So the first thing that we actually have to do is before we call this function, we have to convert it to an integer. So I can just say int, that's going to convert it to an int, save that, and then at this point, if I send this, it should now work. Look at that. So keep in mind, guys, anytime we have a path parameter, it's always going to be returned as a string, even if it represents an integer or a number. We always have to manually convert it ourselves. So don't forget to do that. Now, there is one little issue with what we're doing. So everything's working, and if I actually change this to a 1, we should get a different post. So everything's working great. However, what happens if I type this? Well, let's hit send. Well, we get an error, right? Because we're trying to convert this to an int, and it's going to throw an error. And then instead of sending back a nice, built-in response, we just get an internal server error, and the user has no idea what exactly is wrong. So we want to provide it feedback. So how can we perform some kind of validation to ensure that whatever data that's passed into this path parameter can actually be properly converted to an integer? Well, we can perform validation with FastAPI. So here, for ID, what we can do is we can say, I want this to be an integer. So what it's going to do is it's first of all going to validate that it can be converted to an integer, and then it'll automatically convert it to an integer for us. So we no longer have to convert this ourselves. So here I could just pass an ID because this will make sure that it's already converted. And so now, if I save this, and I change this back to a number first, let's make sure that everything's working. So it automatically converted it to an integer. And now if I pass in, a string, it's now going to throw an error. It's going to say for a path parameter of ID, you can see that this value is not a valid integer. And so now the front end has a good way of understanding what they did wrong. And, this can be anything, right? So if you wanted this to be a string, right, we can have this automatically get validated as a string and convert it into a string so that if they do actually send a string, no errors, right? And then if they try to, actually, even if you put in a number, it's not going to throw an error because any number can actually be converted into a string. But we want an integer, so I'm going to change this back to an integer. And then we'll just hard code this as 2. Perfect. Make sure you save your request. And so now we've implemented our third function within our CRUD app. So we've just got 2 more. We got to handle updating and deleting posts. But we've got getting all posts, creating a post, and then getting an individual post. And you'll see that for the last 2, it's pretty much the same thing, right? We just have to define our specific decorator and then define the logic for actually creating and deleting a post from that array or updating a post as well. Now, before we move on, I do want to show you guys one potential issue that you could run into if you don't quite understand how these routes work and how order matters within FastAPI. So what I'm going to do is I'm just going to create a dummy route, and you guys don't need to follow along on this. It's just a quick little demonstration. And I'm just going to make this another GET request or handler for a GET request. And then this one's going to be posts/latest. So what this will do is when the user sends a request, a GET request to this specific path, latest path, we're going to grab whatever the latest post is. And so here I'll just say def get latest post. And so all I'm going to do is I'm going to reference our my posts list, and I'll say we'll get the length of my post, and then we'll just -1. So this will grab the latest post, and then what we're going to do is just return that. Here we'll say detail, and then we'll pass in And actually, let me store this in a variable. Post equals, and then we'll return post. We'll save this, and I'm going to show you what happens. So let's create a new request. I'm going to just copy the URL from the previous one. Then here we're going to change this to latest. Let's see what happens. Interesting. We get an error. So what exactly happened? Well, let's take a look at the error. It's saying that we have a path parameter called ID, and it looks like it's saying that this is not a valid integer. So I'm not even sure why it's referencing this error. Because if we take a look at our code, right, there's no path parameter here. So what is exactly happening? Well, let's take a look, right? Our request looks like this. So it's going to /post/latest. So when we send this request, what's going to happen is that we're going to start all the way at the top, and FastAPI is going to go through the list of all of our paths, and it's going to find the first match. So we have one at just the root URL, so it's not going to match that. We have one at /posts. It's once again not going to match that. This one is for a post request, so it's not going to match that because we sent a GET request. But then something interesting happens here when we get to this GET request. Right? So this handles a GET request, and then it matches /posts, and then some variable. So technically, that variable could be latest. You see the issue that we're running into? Because there's no way for FastAPI to know that that route was meant for, that request was meant for this specific path. Right? Because it does technically match on this. And then what happens is, since it matches on this route, it then tries to perform validation on ID, which is, in this case, it's going to end up being latest. And then it's going to throw an error because latest can't be converted to an integer. And so this is the example of where order matters. So you have to be careful when you structure your API, especially with your paths and your URLs. You want to make sure that you don't run into this type of issue. So, one thing in this case you could do is just move this up. That would fix the issue, because now if you save this and then run this, right, it works. And if you try to reference a specific ID, that's going to work as well. Well, in that case, let's try 1. Yep. And so that works as well, because /post/1 will never match this one. It'll only match this one. So be very careful when it comes to the order. It always works top down. So anytime you're working with path parameters, it could potentially result in you guys accidentally matching other routes by accident. So, there's different ways to get around this. Like I said, you can just move this up, or if you wanted to change the URL altogether so that this is like a /post/ I don't know, just put in another keyword, something like a recent or something, recent/latest or something. Well, actually, even then that would, yeah. And so I just want to make sure you keep that in mind when you're structuring your API, because anytime you have a path parameter, it could result in you accidentally matching requests that were meant for a different route. So I'm just going to delete this. This was merely just for demonstration purposes, and I just want to make sure that you guys understand that FastAPI just looks at all of your paths and just works its way down the list till it finds the first match. For our get post path operation, specifically the one where we retrieve one specific post, we do run into a little bit of an issue. So if we go to our Postman real quick and send a request to get one post, but in this case, instead of doing 1 or 2, what I want to do is I want you to put in the ID, put in an ID that doesn't exist. So we only have right now posts with an ID of 1 and 2. What happens if we send it with a ID of 5? You can see what we get back. It says null, right? And I don't like that because it doesn't really give the front end any feedback as to what exactly is happening. So they don't actually know, they don't know if some kind of error occurred, or if we were unable to retrieve this information properly, or if there's a server error, or if this item doesn't ultimately exist. And so we need a way to accurately tell the front end that, hey, the ID that you're searching for does not actually exist in our database. And the best way to do that is through a method that I'm sure you guys are already a little bit familiar with. So right here, I've got my GitHub page for our course. And you can see it's just GitHub, my username, and then the name of the repo. But if I put in a whole bunch of letters afterward, what's going to happen is GitHub is going to look for a repo with this name that doesn't exist. And let's see what happens. It gets a 404. And I'm sure you guys have seen a 404 error at least once before in your life. So that's a specific HTTP status code that represents that this item was not found, that it does not exist. And HTTP status codes are important. We haven't really talked about it in this course up to this point, but there's a lot of different status codes. And if you actually just search for HTTP status code, you can just grab one of the top links. I'm going to go take a look at the Mozilla one, and you'll see all of the different HTTP status codes, and you'll see when to use them. Now, most of the time, you're going to see that we get a 200 response back. That's the default one the FastAPI sends. That usually means that everything's good, everything worked. That's why it says okay. However, we do have other ones that we do also commonly use. So anytime you create something, so within your CRUD application for create, anytime you send a post request, usually after you create that entity, you send a 201 back instead of a traditional 200. So there's a lot of HTTP status codes, and we're going to cover all of those in future lectures. But the ones we're interested in is for when we have an error. So if we scroll down, 400 usually means there's some kind of bad error, something happened. And most importantly, we want the 404 not found. So the server cannot find the requested resource. So that's exactly what we're looking for. Keep in mind, there's also 500 status codes, which means, some kind of server error or server failure. So what we're going to do is I'm going to go back to our code. And what we need to do is we need to manipulate the response, because right now we're getting a 200 back. We're getting a status code of 200. If I send it, it says null, and then it just sends 200. So that doesn't really give us a good idea as to what's happening. So how do we manipulate the response? Well, we have to, first of all, import the response from FastAPI. And then what we're going to do is we're just going to pass it in as a parameter into our path operation function. So I'll just call this, I'll store it in a variable called response. And so once you get access to the response object, we can tweak it however we want. So what I'm going to do is, after we search for post, if we didn't find a post, I'm just going to do a quick check. I'm going to say if not post, right? That means if we didn't find a post, what we're going to do is we're going to set the response, and then we're going to grab a property off a response called status code. So here we can tweak the status code of the response. I'm going to say, hey, I want this to be a 404. All right, now let's save it. Now, if I hit send, it still says post detail none, but take a look at the status code. It's now updated to 404. And if I change this to an ID that does exist, right, we get the post properly, and the status code changes to 200, which means everything is good. So that's one way of doing it. However, there's a slightly better way of doing it. Same concept, but instead of hard coding the value or trying to remember it, what we can do is we can import from the FastAPI library something called status. And so now instead of having to remember what to use, we could just type in status, and then it's going to show you all of the different HTTP codes. And so now you could just quickly just look through whichever one sounds the most accurate. So we'll grab the 404. And now you don't need to worry about putting hard coding in a number. We can just reference, I guess it's probably an enumerator, but I'm not really sure. So it doesn't really matter. And then that's all you have to do. So let's test this out again. So 200, good. Change this to 5. 404, perfect. But the next thing I want to do is I don't want to return null. That looks ugly. So instead, I'd like to actually throw an error. So in this case, in this if statement, I'm just going to call a return that only is going to ever run if post doesn't exist. And we'll just say, in this case, detail, or we'll say message. I'll just say message. F string, and we'll say post with ID. And then we'll pass in what was the ID. And we'll say was not found. All right. And now if we try this, look at that. We get our error, post with ID was not found. And that matches up with the ID that we gave it. And we got our 404. Now this is one solution. However, I think this is a little bit sloppy, and there's a better way of doing it. Instead, what we can do is we can raise an HTTP exception. So this is a built-in exception into FastAPI that'll automatically, you can pass in what the specific error code you want as well as the message. And so that way you don't have to hard code all of this. And it just makes everything look a lot simpler. So we'll go to the FastAPI up here, and we're going to import something called HTTP exception. And now we can delete all of this nonsense code. Actually, I'm just going to comment it for now, just so I can reference it in a second. And all we have to say is we'll raise an exception. So we raise HTTP exception. And then we have to pass in two things. So first is the status code. So we'll set the status code to be status dot, and then same thing, right? So far, nothing's really changed. And then here, we'll just pass in the value for detail, which is going to be the message that FastAPI automatically responds back with. And I'm going to pass in the same exact f string. And so now we've basically replaced this with just this one line right here, this HTTP exception. I think this looks a little bit nicer. I don't like having to do the set the response and then having to pass in. I don't like having to pass in the response into the path operation function, having to set a property, and then having to return my message. We can remove all of this nonsense. And I can get rid of all of these comments. And I think this is just a little bit cleaner. And moving forward, we're going to be using these HTTP exceptions a lot, because all we have to do is just pass in what's the HTTP status code and then the message we want to send back to the user. And then that's what's going to be sent to them. So now, once again, we're going to try this out. And look at that, right? So we got the 404 and we got the message, the detailed message, right? A lot cleaner, a lot simpler. Now, before we move any further and before we wrap up this video, I did mention that anytime we create something, we should send back a 201. So if we go back to our create post, and then we'll just create a new post again. We can just send this. We created a new post. Look at the status code that gets sent back. It gets sent back at 200. And that is wrong. Remember, anytime we create an entity based off of that documentation, we should send a 201. So how exactly do we send, how do we change what the default status code is for a specific path operation? Well, what we can do is we'll go back to our code and let's find our create post. And if you want to change the default status code, what we do is inside the decorator, we'll pass in another option. So we'll say status code here, and then we set this to be status, and then whatever our specific status code is. So I want 201, and then that's all you have to do. So now, by default, anytime someone sends a request to create posts, we're going to send a 201 created. So we'll save that. We'll give it another shot. If I try this again, now we get a 201. Perfect. So at this point, I think you guys will have a solid understanding of how to change status codes, whether it's because we're trying to throw an exception or if we want to just change the default status code of a specific path operation. All right, guys, so now it's time to move on to deleting a post. So to delete a post, remember, we're going to start off with our decorator, and it's going to request, or it's going to require a delete HTTP request. Right? And then the URL is going to be the same, so it's going to be posts, and then we're going to need the ID so we can figure out which post to actually delete. All right, then let's define our function. So I'm just going to call this delete post. And so here we have to implement the logic for deleting post. So what are we going to do? Well, for me, there's many different ways. You know, deleting a post is just a matter of trying to figure out which specific dictionary within this array has a specific ID of whatever ID we give it. And then we just remove it from the array. So however you want to do it, go ahead and do it. I'm going to just show you the first way that I thought of. Like I said, this doesn't actually have anything to do with FastAPI. This is more of just simply working with Python. So I'm telling you right up front, this may not be the most efficient way to do it. But like I said, we're eventually going to implement a real database. So it doesn't really matter how you do it as long as it works. And so the first thing that we're going to do is I'm going to look and to find the index in the array that has required ID. So we're going to look for what we're going to try to get the index of that specific item. And then all we're going to do is we'll do a my underscore posts dot pop and then just pass in the index. And so that's how we remove it from that array. Pretty simple. And what I'm going to do is I'm going to actually just define a function out here just to keep things simple. So this is going to be called find underscore index underscore post. And then we're going to pass in the ID that we're interested in. And then we're going to iterate over the array, but we're also going to grab the specific index as we iterate over it. And so you do that by using enumerate. So this is going to iterate over it. We'll get the access to the individual post that we're iterating over, as well as the index. And so we'll say if p if the ID equals ID, and I forgot the in keyword here, we'll just return I. So this is going to give us the index of the dictionary with that specific ID. So here we can just call that function, and we'll set it equal to the index. So index equals find underscore index of post, pass in ID. So we now have the index, and at this point I can just do a my posts dot pop, and then just pass in index. And then we'll try to do a return, and then here I'm just going to pass in, we'll say message, and we'll say post was successfully deleted. So let's give this a shot. So first of all, let's get all the posts. All right, if I do a get all posts, you'll see that we have 2 posts. And then I'm going to create a new request, and this will be called delete post. Just going to copy that URL, pass it in there. And so here I'm going to try and delete with a post of a value of 1. And I realized I still left it as get, so we're going to change this to delete. All right, and so now it throws an error. So what exactly happened? Well, if we go back to here and then go back to our console, it says none type object cannot be interpreted as an integer. And I realized I forgot to actually pass in ID into our function, so that's why it was giving us that error. So now let's try this again. And we see that we get the message that says post was successfully deleted. That's good. However, you'll see that the status code is 200. And so if we actually go back to our status codes, you'll see that there's a specific status code that we should be using for when we delete something. And that status code is a 204. And like I said, you can read the documentation, but this is something that just, comes with time of working with APIs. So you'll know that anytime you want to delete something, you want to use a 204. But before we actually do that, let's verify that it actually deleted it. So we'll go to get posts, and I'll send a request, and we can see that there's only 1 post. So it clearly did work. But let's update the status code. So do you guys remember how to update the status code, the default status code of a specific path operation? We just pass in status code into the decorator, and then we'll do status, and then we'll just get our 204. Now let's try to delete something again. We'll try to delete, where's my delete? We'll try to delete post 1 again. Let's see what happens. So you'll see here that we get the 204, so everything looks good. We didn't get any data back. And if we go back to our application, you'll see that we got an error, which says too much data for declared content length. And what's happening here is I actually had to look up this error, and that's because anytime you send back a 204, the idea is that since we delete anything, we shouldn't really be sending any data back. And so when we try to send this message back, FastAPI essentially throws an error saying, like, listen, you're sending a 204, we should not be sending anything back. So that's how they kind of implemented FastAPI. And so what you should be doing is, what we should do is actually just delete this. We should grab the response and then just pass in status code, status, HTTP 204. Right? So basically, we don't want to actually send any data back anytime someone deletes something. We just want to send a 204. And then one of the requirements for that to work is that we don't send any data back. I know it's a little confusing. If you actually just Google this error, you'll probably get better explanation. But 204, when you delete something, you don't want to send any data back. That's kind of the expected result. So let's try this again. Let's send it to... All right, so we got the 204, no data comes back, and no errors. So that's all we have to do. So this is just something special that you have to do for delete within FastAPI. Just keep that in mind. It's more of just a copy, a cut and paste type scenario. However, before we wrap up this delete video, we are still running into one tiny issue. If I try to grab an ID that doesn't exist, let's see what happens. Well, now we get a 500 error. And we get an error because, well, none type object cannot be interpreted as an integer. So since we tried to grab the index from this find index post, it's going to return nothing because there's no post that has an ID of 5. So we get nothing, and then we try to pop with an index of none. That creates an error. So we need to put in a simple if statement to actually catch that scenario. So we'll say if index equals none. So it'll return none if it doesn't exist. What are we going to do? Well, we're going to raise an exception again. So we can use that raise HTTP exception, and we'll just say status code equals, in this case, we want to send a 404 like we normally do. So we'll say status.http 404. And then we can send a detailed message. So in this case, we'll do once again another F string. And we'll say post with ID, pass the ID, does not exist. Let's try this out. Perfect. 404, post with ID does not exist. Let's just make sure we didn't break the original functionality. We delete it. Perfect. And let's just double check there's no errors. There we go. So everything looks good to go, guys. So we'll wrap up this video, and then in the next video, we'll take a look at how we can update posts. All right, guys, we're almost done with all of our CRUD operations. The final one is update. So let's create a new request. We're going to call this update post. And I'm just going to grab the URL from the delete post, because it's going to follow the same exact structure. So we're going to pass the ID of the post that we want to update. Now, since we are updating it, we need our front end, or in this case, Postman, to actually send the data that we want to update with. So since we are working with posts, and we take a look at our structure of our posts, it's very simple. We just have title, content, and then, published as well if you want to add that in ratings as well. And I'm actually going to remove that, so I don't actually want to have that. We'll keep it in for now. But we'll definitely remove that a little bit later on. And so if I go back to Postman, we can go to our body and then provide all of those fields. So we'll go to raw and then JSON. So this is just like when we were trying to create a post, we just pass that data in. And so here we'll get the title. And we'll give it a new title, so updated title. So this update request is just going to update the title. Now, we are going to use the put method. So with put method, we have to actually pass in the data for all of the fields, right? We want to pass in what the final post will look like after we update it. We don't just want to pass in the fields that we want to update. So if I go to, let's say, post 1, right? We have the title and then we have the content. So if I wanted to update just the title, right, I would make sure that I pass the content as well. So I'm just going to copy this. Since we're not updating it, I'm just going to send back the same exact content. All right, and then this is going to be a put operation. All right, and so this is what the request is going to look like. Now, let's go to our code and let's actually create our path operation for that. So here, we're going to do app.put. This is going to go to posts ID. And then we'll define our function. I'm going to call this update post. We're going to get the ID, and I'm going to convert that to an int. And then one other thing, right? Because we are receiving data from the front end, just like we did for creating a post, we want to make sure that it adheres to a very strict structure. So we have to use, I want to use our schema again so that the front end can't just send whatever it wants to. Now, I can create a new model called class, update post, and then we can pass in all the fields that we expect. However, it's going to be the same thing as the post because we expect a title, content, and then any of the other fields depending on what we want ultimately. But it's going to be a post, so it doesn't make sense to create a new schema. We can just use the pre-existing schema. And so here, I'm just going to pass in post and make this type of post so that it's going to make sure that the request comes in with the right schema. And then for now, I'm just going to hard code the return to be a message. And I'll just say updated post. And then here I'm going to do a print. Let's just see what the post looks like. All right, so we were able to extract all of that data, so perfect. And then what we're going to do now is, there's a couple things. So first things first, I need to find the index of the post with this specific ID. So just like we did with delete, I'm just going to copy this. Actually, we can copy all of this right here because if that ID doesn't exist, we want to send a 404. So we can reuse all of that logic. But if we did find an index, that means we do need to update it. So what I'm going to do is we're going to grab post_dict, which equals post.dict. So that's going to take the data we receive from our front end, which is stored in post, and it's going to convert it to a dictionary. That's all it's doing. And then what I want to do is I want to set post_dict of ID to be equal to ID. So we're going to set the ID inside this new dictionary to be that ID. And then we're going to say my_post. And then we're going to pass in the index of the specific post we want to update and set that equal to post_dict. And then lastly, we're going to return, I'll say data, and we're going to return our new post, which is going to be post_dict. So let's just quickly recap what's happening. So first of all, the user is going to send a put request to the specific ID of the post he wants to update. And we're going to just do a quick check. So we're going to see if we can find what is the index of that specific post within my posts array. If it doesn't exist, then we're just going to throw a 404. If it does exist, if it doesn't exist, we're going to throw a 404. If it does exist, well, first thing, we're going to take all the data we received from the front end, which is stored in post. We're going to convert it to a regular Python dictionary. And then we're going to add the ID so that this final dictionary has the ID built in. And then we're going to say, for the post within index, we're going to just replace it with our new post_dict. So that's how we update that specific spot in the array. And so let's give this a shot. So if I do get all posts, right, we can see we have post 1, and then the title is title of post 1. And then let's go to our update, and we can see that we're going to change the title to be updated title. And let's see if that works. Okay, so it looks like it worked. We got back the new post. So let's do a get all posts again, and let's see if it actually did update. And we can see that it did, in fact, update. Now, just to make sure everything else is good, let's also change the content. So let's say this is the new content. Let's send an update. And then we're going to run this again. And we can see that the content is updated. So now we're able to successfully update each and every post. And that's going to wrap up all of our CRUD operations. So you can see that building out an API, building out your CRUD functionality is fairly straightforward within FastAPI. We've got one more lesson where we're just going to restructure our code a little bit just to make things a little bit cleaner. And then we're going to start getting to the fun stuff, which is working with databases. So I'm going to show you guys how we can actually get a Postgres database installed on our machines and running, and then we'll actually start saving data into an actual database. In this lesson, we're going to talk about one of my favorite features of FastAPI, and that is the built-in support for documentation. So normally when you build an API, you're going to want to create documentation so that users know how to use it. And one of the challenges with that is that it's not exactly a simple process, and anytime you make changes to your API, you have to make sure that you update your documentation, and it's very easy to forget to do that. With FastAPI, FastAPI automatically generates the documentation based off of the path operations that you've defined. So it does it all for you, and you don't have to write a single piece of code to actually get the documentation in place. And so to actually see the documentation, you just go to the normal URL, but you just do /docs. And so this is going to show you the built-in documentation powered by Swagger UI. And so what's really nice is, and if you've ever looked at the documentation for our, some other APIs, you may have noticed something that looks similar to this, and that usually means that they used Swagger UI as well. So FastAPI has built-in Swagger UI support, and it automatically generates all of the routes and the documentation for all of your paths. And so if you take a look at all of our operations, our path operations, we've got the one for getting all posts. We've got the one for creating posts. We've got the one for getting an individual post. We've got the one for updating an individual post as well as deleting a post. And what's really cool about this is if we hit the drop down, right, it's going to show you how to use this specific path or how to use this specific API endpoint. So if you want to actually try it out, you can do that. So you could say try it out, and then you can just hit execute. Right? And so now it actually ran the query against our API server, and it shows us what the output is. So these are the two documents that we have, or the two posts that we've created. And we can do this with all of the API endpoints. So if we want to create a new post, it's going to give you an example of the data that we can pass in. So we can try it out. And then it's going to give us all the fields that we have to pass in, and then we can just customize this. So if I want to say creating new post with documents, and then I'll just, for content, I'll say, oh, this is really cool. We'll give it a random rating. We hit execute. Right, it actually runs that. It's going to show you how to perform the same actions using curl as well. And then it's going to show you the data that we got back from our API server, and we can see that we got a 201 response code. And so I want you guys to just kind of play around with this, get familiar with it. So there's going to be times where you may not even have to use a tool like Postman. You could just test things out using Swagger UI and the built-in documentation. And what's even nicer about this is that we have built-in support for two different types of documentation. So this is using Swagger UI, but if you use redocs, sorry, there shouldn't be an S at the end, it's just redoc, right? You could see a different format of the documentation using a tool called redoc. So it's going to fundamentally do the same thing. It's just a different documentation tool. So it's going to look a little different. Feel free to use whichever one you ultimately prefer, but by having it automatically get generated by FastAPI, you don't ever have to worry about updating anything. So if you take a look at like create post, right, we've defined the pieces of data that we need. And in the future, if we decide that the user needs to pass in another field, maybe like the date that they want it to get published, it'll automatically update this. You don't have to tell it. You don't have to manually go in and update it yourself. All right, guys, so we're going to make one slight change to how we structure our code. And what I want to do is, instead of just having my main file within my base project directory, I want to actually create a folder called app. So that's going to store all of our application-specific code and then put that main file in there. So it's a very small change, but we do have to change a couple of things to make sure that it doesn't actually break anything. So I'm going to create a new folder, and I'm going to call this app. And so this, in Python, if you aren't too familiar with how Python works, Python has a concept of packages. And a package is nothing more than a fancy name for a folder. However, for something to properly act as a package, Python requires you to create a dummy file. And this file is called __init__.py. Right? And so that's going to turn this into a proper Python package. Just know that you have to add this file. You don't have to put anything in the file. But anytime you create a new folder, just make sure you create a file with this exact name, and that's going to ensure that it is in fact a Python package. So now that this is an actual Python package, we can just drag this main file into our app folder. Right? And then now we're going to get an error, and that's perfectly okay. So we're going to cancel out of this. And I want you to take a look at the command that we run to start our application. So the command to start our application was we do uvcorn, we do the name of the main file, which is just main. And then within main, if you take a look at what's the name of our FastAPI instance, it's called app. However, now when we run this command line, it's going to look for a file named main. However, there's no file named main within our base project directory because it's now been moved into app. So to actually reference the main file that's inside of a Python package, it's pretty simple. You just put the name of the package beforehand. So you do app and then dot. So it's going to tell uvcorn to look inside the app directory for a file named main. So then we go in there, we see the main file. And then within our main file, we look for the app instance, which is our FastAPI instance right here. So let's give this a shot. Let's see if we broke anything. It looks like everything started up fine. I'm just going to do a couple of requests. So this is going to be just get an individual post. Looks like everything's good. I just want to make sure that there's no errors. And yep, everything looks good. So I think this is just a little bit better of a way to structure our application. We're going to put all of our app code moving forward inside of this app directory so that we can keep everything else separate. I think at this point, we have a basic understanding of how to work with FastAPI and how to set up basic routes and work with path operations. Until now, we've been storing all of our posts in memory, and I think we've made it to a point where we are ready to now start working with databases. And so if you don't know what a database is a collection of organized data that can be easily accessed and managed. And so when it comes to any kind of application-related data, so things like users that have registered, posts that have been created, all of these pieces of information are going to be stored within a database. So it's going to be stored on disk so that we can retrieve this information at a later point in time. Now, when it comes to databases, we never actually interact with the databases directly. Instead, what we have is a database management system that's going to sit in the middle. So when we want to perform an operation on a database, we're going to send that request to a database management system. That management system is then going to actually perform that operation, and then it's going to send the result back to us. So we never talk to the databases directly. Instead, we have a piece of software that sits in the middle and acts as the brains behind the database. Now, there's two major branches of databases. There's relational and NoSQL databases. Relational databases are usually SQL-based databases, and we're going to cover that in the next slide or so, but these are just some of the more popular relational and NoSQL databases that you guys have probably heard of. In this course, we're going to work exclusively with relational databases, and more specifically, we're going to work with Postgres. Now, if you ultimately want to learn how to work with MySQL or Oracle or SQL Server or any of the other databases, keep in mind that at the core, they are fundamentally no different than Postgres. I would say 97% of the things that we cover when it comes to Postgres is going to be almost identical in all of these other databases because they all, at the end of the day, use SQL. However, SQL, there is a little bit of slight nuances when it comes to each database. Each of them will implement it in a slightly different way. So you'll see that certain SQL commands aren't available in others. But for the most part, all of the core things that we cover from a SQL perspective is going to be applicable to any of the other relational-based databases. And so let's talk about SQL now. So SQL, or Structured Query Language, is a language that's used to communicate with the database management system. And so, when we want to perform an operation, we're going to send a specific SQL statement to the database management system. It's going to then take that statement and then perform the operation on the database, and then it's going to send that result back to us. So SQL is the language that we use to communicate with the database management system. Now, in the next video, what we're going to do is we're going to install Postgres on both Windows and Mac, depending on what you're using. And there's an important thing to note when it comes to installing Postgres, or really any database. When you install an instance of Postgres, what we can actually do is we can carve out multiple separate databases. Right? And this is kind of confusing at first because you're thinking, well, we installed Postgres, we have a database. Yes, but what we can do is we can actually create two different databases that are completely isolated and have nothing to do with one another. And that way, if I have application 1, we can create a database just for app 1. And then if I have a second application that I create, this application can have a separate database as well. And these two databases are going to be completely separate and completely isolated so that they don't step on each other's toes. So it's pretty cool, and it's a pretty awesome feature to be able to kind of carve out your Postgres instance to multiple databases. And keep in mind that you don't necessarily always create a separate database instance for each application, right? There are scenarios where you might actually create an app that's going to make use of more than one database instance within Postgres. However, those are very specific situations, maybe if you want some sort of multi-tenancy or things like that. However, we're just going to create one individual database instance for our application that's going to handle everything that we need. Now, when we install Postgres, what's going to happen is that the installation process is going to create a database within the Postgres instance called Postgres. A little confusing, right? It's Postgres within Postgres, but it's actually going to create this database named Postgres. And the reason we need to do this is that if you ever want to connect to a Postgres instance, what you have to do is you have to specify a database that you want to connect to. So some kind of default database that you want to connect to. You can't just connect to Postgres. You have to specify a database. And so that's why the installation process creates one database for you so that you can have something to connect to. However, we won't necessarily need that instance once we create our own. However, I usually just keep it in by default because it's not going to hurt anyone. In this video, we'll take a look at how we can install Postgres on a Windows machine. So let's go ahead and just search for Postgres. And it's almost always going to be the first instance. So just go to postgresql.org. And then we can just select the downloads button. Here, go ahead and select Windows. And then up here, just select the download the installer link. And so here you'll see all of the downloads options. So right now, the latest version is 13.4. So I'm going to just download that one. You may see a newer version. Feel free to download that. Nothing's going to really change between each version. Once that's downloaded, start the installer. If you see this pop up, just select yes. With the installer open, select next. You can leave the default installation directory. No one usually messes with that. Now here you can select the different components that you want to install with your Postgres instance. So for the first thing that you have is the Postgres SQL Server. That's obviously what you want to download. The next one is PgAdmin. So this is a GUI that can be used to manage your Postgres instance. We're going to be using that to actually manage Postgres. So you want to make sure that you've got that downloaded. Stack Builder, this is an extra feature that can be used to install extensions and extra features within Postgres. We're not going to be installing any of those extensions, so there's no need to have Stack Builder. However, it's not going to break anything if you do leave it checked. And then we won't be using any command line tools to manage Postgres. However, go ahead and just leave that checked just in case, down the road you actually do want to use it. All right, and then once again, leave the default data directory. Then you have to pass in the password for the super user. So make sure you remember this password. Then you got to specify the port that you want your database to be listening on. The default Postgres port is going to be 5432. You can change it if you want, but you have to make sure that you update everything else when it comes to creating our code to update that port number. I'm going to leave it as default, as do most people. And then just hit next on this window, and then next here, next. And then it's going to start the installation process. And once that's complete, just hit finish. And then, like I said, we're going to be using the PgAdmin GUI software to manage our Postgres instance. So if you just search for PgAdmin, you'll see that it's right there. Just select that and open it up. And then at that point in the next video, we'll start taking a look at how we can use that to not only create individual database instances, but also create tables and things like that. In this video, we'll take a look at how we can install Postgres on a Mac machine. So let's search for Postgres in Google, and the first result should be the one that we're looking for. And within the Postgres website, just select the Downloads button, and this is going to show you the different platforms it supports. So we're going to install this for Mac. And then select Download the installer. And then here we can see all of the versions that we can download. We're going to download whatever the latest version is. So in my case, it's 13.4. If you're watching this video in the future, it's probably going to be some other version, but it should all be relatively the same. So we'll just download under Mac. All right, and once it's finished downloading, just go ahead and select the DMG file that you downloaded, and then we'll set up the installer. And if you get this pop-up, just select Open, and then specify your password. With the installer window open, select Next. Leave the default installation directory. Now within here, by default, it's going to install 4 different components. I'm going to walk you through what each of these components does. The first one is the Postgres server. So this is the actual Postgres database, so we definitely want to install that. Below that is PgAdmin. This is a GUI that can be used to manage your Postgres databases. We're definitely going to install that because that's what we're going to use in this course to actually manage our database. Stack Builder is an extra, almost like an extra installer that's used to install extra extensions that give Postgres some extra functionality. We're not going to use any of those extensions, so go ahead and uncheck Stack Builder. And the last one is command line tools, so we can manage Postgres through the GUI as well as the command line. In this course, we're going to stick exclusively to the GUI. However, I would still recommend downloading the command line tools just in case you ever do want to use them. And then specify the default data directory, that's fine. Then you want to give the password to your Postgres instance, so this is kind of like the root user equivalent. Here we specify what port we want our Postgres instance to run. This is the default Postgres port. If you want to change it, you can do it, but just make sure that, whenever we get to actually coding out our API and specifying what port we connect to the Postgres database, make sure you update those accordingly. However, I recommend just keeping it as the default. And then everything else, just keep hitting next, and then it'll start the installation. All right, and once that's complete, just select finish. It's going to be, at that point, Postgres has been successfully installed. Then what you want to do is just hit the little search icon. And I want you to search for PgAdmin. All right, and so if you want to open up PgAdmin, which we'll cover in either the next lecture or the lecture after that, just search for it, select it, and that's going to open up the GUI tool used to manage your database. Before we get started with configuring our Postgres database, there are a few things that we need to cover. And one of those things is the concept of tables. And this is a very important concept when it comes to working with relational databases. So a table represents a subject or event in an application. And so what exactly does that mean? Let's use an example. Let's say we're building out an e-commerce application. You're going to have a table that represents each part of your application. So you're going to have a table for all of the users that have registered. You're going to have a table for all of the different products that you will plan to sell on your website. And then you're going to have a table for things like purchases and reviews. So each table represents a different subject or event in an application. And what's amazing about these tables is that all of these tables are going to form some sort of relationship. That's why it's referred to as a relational database. And if you think about it, right, the tables that we have listed right here, they're all going to have a very basic and obvious relationship. Right, purchases, right, when a user purchases something, that automatically implies a relationship because every purchase order has to be associated with the user account that actually filed that purchase order. And a purchase order is going to have a list of products that the user wants to buy. So we could see right there, all of the tables that we have already form some sort of relationship. And it's really important that when you design your database, that you figure out what are these relationships beforehand so that you can design a very efficient database. Right? Just like if we're building a social media application, right? We know we're going to have a table for users. We're going to have a table for posts as well. And we already know that there's going to be a relationship between the two because every post has to be associated with a user because users create posts. So you can see that, all data has some sort of relationship with one another. Now, when it comes to tables, we have columns and we have rows. A column represents a different attribute. And so if we're building out a table for users, we would create a column for the name. So this column represents the name of the user. We might create a column for their age, their gender. You might create another column for the email that they use to sign up. You might have a column for their billing or shipping address, right? It's up to you to figure out what are the different attributes we need to model a specific user. Then we have rows. Rows are very simple, right? Each row represents a different entry in the table. So if we have a users table, then each row represents a unique user. So row 1, this is the user, Vanessa. Row 2 is going to be the user, Carl. So each row just represents a different entry within the table. Now, databases have data types just like any programming language. And the reason why this is important is that when you create a column within a table, you need to specify what kind of data type you want to use. And that decision is going to be ultimately based off of what attribute this column represents. And so we have data types just like any other programming language like Python. And so if we were building out a table for, social media posts, one of the things that we might have is a column for what are the total number of likes or retweets. And so for something like that, you would want some sort of data type that's numeric, a data type that models numbers. And in Python, we have two main data types. We have integers and we have floats. Integers being whole numbers, floats giving you decimals. Well, Postgres has the same thing, right? It's going to have integers, it's going to have decimals, and a few others. Keep in mind that you don't need to worry too much about that. Just understand that there are numeric data types within Postgres that are just like Python. So when it comes to the number of likes of Postgres, maybe we would use something like an integer because we're not going to have a half a like or anything like that. Then if you're trying to model, someone's name or email or address, right, we would use some form of text. And within Python or any programming language, you have strings that allow you to represent text. Within Postgres, we have the same thing. It's just called something different. We have varchar, which is just short for varying character, which is once again just a string fundamentally. And then we have text, right? They're both going to do the same thing. Don't worry too much about the differences. Just understand that Postgres does allow you to work with text just like any other programming language. It's just called something different. And then for Booleans, Postgres and Python, they both support Booleans. They're going to work the same way. It's either true or false, very simple. And then within Python, we have lists. So anytime you want to model, multiple instances, so a list of something, we have arrays within Postgres. And you'll see that when you work with relational databases, you'll see that arrays aren't used very much, because a lot of times if you're using an array, it may be better to take that column and just convert it into its own table. But like I said, don't worry too much about that. We'll go over that in some upcoming lectures. When we create a table, we have to specify something called a primary key. And a primary key is a column or a group of columns that uniquely identifies each row in a table. So what exactly does that mean? Well, we need to tell Postgres essentially, how can we uniquely identify each entry in our table, each row? And so we have to give it a special column that ensures that every entry for that specific column is unique. And keep in mind that we can only have one primary key per table. You can't have more than one. However, a primary key can span multiple columns. However, let's keep things simple for now and just assume that primary keys are really just one column. And so a lot of times when you create a table, what we have is a column for a unique identifier. So anytime you create a new user, usually you're going to have an ID associated with that account, and that ID is going to be unique. And so the ID associated with John is going to be 77498. And that's how we uniquely identify each user based off of that ID. And so it makes sense to select that as the primary key, because we already know that each ID is going to be unique. So it fits the perfect definition of what a primary key is, right? And so the only requirement for something to be a primary key is that each entry must be unique, no duplicates. We can't have this same ID for another user. And so you're probably thinking at this point that, hey, we're going to create an ID column for every table and then make that the primary key. I'm going to tell you that that's not quite correct. The primary key doesn't have to be the ID column always. In fact, your table doesn't even have to have an ID column, right? It's up to you to decide if you actually want to have that. There's certain instances where you may not want an ID column. And so if you don't want to use the ID column, or if you don't have an ID column, you need to ensure that you have some column that's able to uniquely identify each and every entry. And so one good example of that, when sticking to the users table example, is that generally in an application, a user can only sign up with an email once. So we know that an email is always going to be associated uniquely with one account, right? We can't have two users with the same exact email. That's not going to work. That's usually not allowed. So we could definitely use our email column as a primary key. But there's plenty of other examples, right? Phone numbers, right? Generally, I can't sign up with the same phone number for two different accounts. So we know phone numbers are going to be unique. For the guys that are in the United States, you know what a social security number is. Two people can't have the same exact social security number. And so there's a lot of different things that you can use to choose for the primary key. Just keep in mind, it's not always the ID. So that's the main thing I wanted to focus on in this slide. Now, as we go through creating our table and creating each of the individual columns that represent a certain attribute for that table, we can add in extra constraints for each column. So we can put in extra little conditions. And so we already talked about the column that's going to be the primary key. And we know that the primary key has to be unique for each and every row. But what happens if we have another column that isn't the primary key, but we want to ensure that each and every entry has a unique value for that specific column, right? So take a look at the name column in this case. Let's say that we won't allow two users to share the same exact name. Is there any way we can tell Postgres to perform that check for us? Well, we can add in what's called a unique constraint. So we can, when we create the table, say that I want to make this column unique by adding the unique constraint. And so that way, anytime I add in a new user, it's going to check the name, and it's going to check to make sure that there's no other users with the same exact name. And if there is, it's going to throw an error. And we can do this with any column. You can do it with all your columns if you wanted to. That's not necessarily something you're going to do, but I just want to make sure you guys understand that, we can perform extra checks for each entry by adding in a constraint. The first constraint that we covered is the unique constraint, but there are plenty more. Now, the next constraint is called the null constraint. And when it comes to creating columns, by default, Postgres allows you to leave a column blank, essentially. So I can add in a new user, and I can say that I can leave the name column blank. So instead of having Vanessa for the first one, I could just leave it blank and not put any data in. And so what Postgres will do is it'll put in a value of null because we didn't provide it. And I could do the same thing for age. I don't have to pass in an age by default, and I don't have to pass in a gender by default as well. And it will put in a null value for each and every one of those. But let's say we want to tell Postgres to perform a check and say, hey, I don't want you to be able to create a user that doesn't have an age. So what we can do is we can put in a constraint, and this constraint is called a not null. That means we are not going to allow it to be null, right? We are not going to allow Postgres to use a null value. So if we try to add in a new user called Carl and we don't give it an age, well, Postgres sees that this column is not allowed to be null and it's going to throw an error because it's not null. So that's the second constraint. And I think these are the two main things that I want to focus on. And I think at this point, we have a good enough understanding of the different things that we can do with tables, columns, and rows that we can go ahead and start playing around with Postgres and really digging deep into how tables are created and how they work. In this video, we'll start taking a look at PgAdmin, which is the GUI that we use to manage our Postgres instance. We'll take a look at how we can define our tables for Postgres. We'll take a look at how we can create entries in our database, as well as how to modify and delete them as well. So go ahead and search under your applications for PgAdmin. And you'll see that once it pops up for the first time, it's going to ask you to set the master password for PgAdmin. And it's important to understand that this password is for the PgAdmin GUI. It has nothing to do with the password that you created during the Postgres installation. This is strictly for PgAdmin itself. And the reason it asks for a password is that ultimately we can store our passwords for connecting to our different Postgres instances within PgAdmin so that we don't have to enter it every time we want to connect to our database. And so that's why we have to create a master password so that we could store all of the individual passwords for all of our Postgres instances. So I'm just going to create a random password in this case. And keep in mind, it does not have to match the password that was created for your Postgres instance. These two have nothing to do with one another. Now, the first thing that we want to do is specify the connection details for connecting to our Postgres instance. And what's nice about PgAdmin is that it'll remember all of the servers that we've ever connected to so that we don't have to manually input this information every time we log in. Now, PgAdmin has done a little bit of the work for us automatically. So if you see under the server section, this is where we define our individual Postgres instances. Just hit the little drop-down arrow, and you'll see that there was a server called Postgres SQL13 already created for us. So by default, when you install Postgres, we know that we're going to have a local Postgres instance running on our local machine. So it's going to automatically set up the connection details for that instance. The only thing you have to provide is the password for connecting to that instance. And so now we want to pass in the password for the Postgres user for the Postgres instance. And this password isn't the password that we just created a few seconds ago. This password is the password for Postgres itself. So this is the one we created during the installation process. So go ahead and put that in there. And then you can choose to save this password so that you don't have to re-enter it. I'm just going to skip that for now. And so now it's taking that password and it's now connected to our local Postgres instance. And so you'll see a little bit of information about things like, what's the sessions, what are the transactions per second. So you'll see a lot of nice little pretty charts. However, I want to make sure that you guys actually understand how to define a new server instance. So what we're going to do is we're actually going to create this from scratch. So I'm just going to select this. We're going to select remove server. And we're going to do this straight from scratch. So I'll do create server. Let's give this a name. I'm going to call this my local Postgres instance because that's what it is, local Postgres. Then we have to specify the connection details. So here we give the IP address that the Postgres instance runs on. Because this is running on our local machine, we can just say localhost. However, if this was running within AWS or some cloud provider, that cloud provider would provide you an IP address or even a domain name to connect to, and that's what you would specify here in this case. But since we're connecting to our local machine, we just say localhost. Then here we give the Postgres password. Right when we did the installation for Postgres, we used the default port, so that's why we could just leave this as 5432. And then, as I mentioned, when we connect to Postgres, we always have to give it the name of a database to connect to. We always have to provide the name of a database to connect to. Since this is a fresh installation, the only database that's going to be there is going to be a database named Postgres, so it's going to connect to that by default. Then we have to give the username and password. And we haven't created a user yet, so there's always one default user. This is the super user, and the username for that user is always Postgres. A little confusing because the database name is Postgres, the name of the actual DBMS is Postgres, and then our username is also Postgres. So try not to get all three of those things confused. Then we could save in our password. So this is where we put in our Postgres password. And then if you want to save this for future so that you don't have to enter in every time, you can go ahead and do that. And at that point, hit save. And then you can see that once again, we created this from scratch. Now within PgAdmin, there's going to be a lot of menus, a lot of things that you see. and you may be a little overwhelmed, but I want you to keep in mind that a majority of the stuff we won't really even care about. Right? So when you focus on just the things that we care about, you'll see that there aren't many things involved when it comes to PgAdmin. And so like I said, within a Postgres installation, right, we're going to have individual databases, right? So we can create a separate database for each of our applications. So under our server, right, you'll see a section called databases. So this looks a little interesting. Let's click this. Right, and then if we drop this down or expand this, you'll see that we have our one default Postgres instance that was created for us during the installation process. Now, we're not going to touch this. We're just going to leave this there. But let's create our own Postgres instance. So right-click on Databases, hit Create, and then Database. And then here we just want to give the database a name. I'm going to call this, I usually just name it after my application name. So since this project is called FastAPI, I'm just going to call this my FastAPI database. And you'll see that there's a couple of other windows. We won't touch any of these. However, go to the last section right here where it says SQL. All right, and as I mentioned before, SQL is the language that we use to actually talk to Postgres. And since this GUI is here to manage Postgres, it's going to make our life a little bit easier. But at the end of the day, it's just passing in SQL statements. And so because we created a database through the GUI, it's kind of abstracting a lot of the SQL away from us. However, what's nice about PgAdmin is it's going to give you the underlying SQL that's used to actually create this database. So we could see that it's just a command that says create database, and then the name of the database we gave it. Here it's just specifying the owner, the encoding, and the connection limit. Technically, we could remove all of these lines and just take the semicolon and just put it right here. And then we could just do create database FastAPI, and that's how you do it through the command line. I think it's just nice and helpful that it provides this for us. However, ultimately, we won't need to do that because we do have PgAdmin, so we can do it all through the GUI. And if you guys are worried that we're not going to cover SQL, believe me, we will. But I just want to make sure we start off by taking a look at the GUI, learning it the easy way. Then we'll learn how to do it the harder and proper way. But once we got this set up, go ahead and hit save. And you'll see that we have our new database. Right now there's an X, but as soon as you click on it, it's going to turn yellow, which means that we have now successfully connected to this database. And then under this database, you're going to see a lot of different options. And like I said, we're not going to touch most of these. Instead, the only thing that we want to focus on is under schemas. So under schemas, and then under public, and I'm going to move this over for you guys, you'll see that there's one important section called tables. So this is where we actually create and define our tables. So right-click this, and actually if we hit the dropdown, you can see there's no tables, but that's to be expected because this is a brand new database. And let's go ahead and create our first table. So we'll do right-click, create, and then table. And then let's give this our table a name. So let's say we're sticking with the whole e-commerce example. So we're going to create a table called products. So this table represents the different products that we're going to sell. Don't worry about any of these other fields. It says the owner is Postgres because we're logged in as the Postgres user. However, if we logged in as a separate user, then you'd see the owner get updated accordingly. If we go into the column section, this is where we define our column. So this is where we're defining what is referred to as the schema of the database. So to add a new column, just hit the plus icon. And so now the first thing that we need to do is let's figure out what attributes does a product need. And a product is going to need a name. So let's give it a name. And so we'll call this column name because it represents the name of a product. Right, then we have to give it the data type. As I mentioned, there's going to be different data types that closely resemble or match the data types of a programming language. So a name is going to be, a certain amount of text, right? So we need whatever data type represents text. And so we've got a couple, right? We do have text, and then we also have varying character or character varying. This is the one I'm going to ultimately use. So we're going to select character varying. And if you actually want to see the difference between these, I recommend you go online, search for Postgres data types, right? And then it's usually chapter 8 of the documentation. You can select this, and then this is going to give you a breakdown of the different data types, and it's going to break it down based off of, numeric types. We've got date time, booleans, enumerated. We've got, if you want to represent IP addresses, we've got a data type for that. So there's a ton of different data types. Definitely take a quick read over all of these. However, we're just going to stick to the basics. So if you don't want to go through all of that, then we'll stick to just the core fundamentals for now. So anytime we're working with text, we're going to use character varying. And then as I mentioned, we've got a couple of options. So we've got the not null. And so right now it's set to no, which means that technically we can leave this entry blank. So we can create a brand new product with no name at all. And then Postgres is going to put in a value of null if we do that. But if we think about our application, right, would we really want to be able to create a product without a name? Doesn't really make sense. So I think we should set this to be yes, so that it actually throws an error if we try to do that. And you'll see a flag for a primary key, so we get to specify which column is ultimately our primary key. I don't think the name of a product should be a good primary key. We need the primary key to be a column that really emphasizes what makes each entry unique, and I don't think the name actually does that. So we're going to leave that set to no for now, and we're going to add in a new column. All right, and this time we'll add in, let's say, the price. And so now we have to specify a data type. So for numeric data types, we have an integer, which is going to be whole numbers, which probably isn't a good data type for prices because we need decimals. We do have numeric, and there's a couple of other ones. So if we go back to our documentation, hit numeric types, right? We've got numeric, so this allows us to specify also decimals as well versus integers. And then we also have floating point types as well. Either one of these can be used. They operate a little bit differently, but both of them will work. But since I want to keep things simple and I don't want to confuse you guys too much, I'm just going to use an integer to define a price. And I know technically there's no application that would ever use an integer to represent price, but I want to keep this simple. And I actually want to show you guys something unique. So you see that there's a couple of different types of integers. We have, first of all, a plain old integer. We've got a small int, and then we've got a big int. So what is the difference between all of those? Well, it's the number of bits that we have. So a small int has the fewest number of bits, which means that the maximum number we can go to is going to be a lot smaller versus a traditional integer. And then if we need to go up to a really high value, we're going to use big int, which is going to have the most number of bits. Right? And if you want a good explanation, just search for what is the difference between big int versus int. Right? And so we can see here, the difference between them is you can see the minimum value and you can see the maximum value. And so I think that's what, minus 2 billion to 2 billion. So we get it in the negative and the positive direction versus a big int, which is negative 9 to 9 billion. So you got to figure out what's the best fit for you. If you don't think you'll even hit 2 billion, then there's no reason to go to a big int. So I'm just going to leave this as a plain integer. We could definitely get away with the small integer, but let's not worry about that. I don't think we're ever going to have a product that's going to be $2 billion, but that's fine. All right, and then once again, we have the not null option. So it doesn't make sense to create a product that doesn't have a price. So let's make sure that's not nullable. And then the length and the precision, this is for floating points. So you can say like how many decimals do you want to support it for? For an integer though, it shouldn't matter. And it looks like I didn't properly select this. We'll do integer. All right, and then the last thing that we need is each product should have a unique ID. Right, and like I said, a lot of our tables are going to have an ID column. So here we're going to create a column called ID. And so what kind of data type should we use for this? Well, I think what makes sense is an integer, right? An ID is just going to be some random number. So we could use int, big int, or small int. And so let's just say we'll use an integer. I'm going to search for integer. However, I don't actually want to leave it like this. I did mention in one of the previous lectures that most databases support the ability to automatically generate a ID for you. So I don't want to have to be the one responsible for creating an ID and then putting that information into Postgres. I want to just provide the name and the price, and I want Postgres to generate a unique and random ID for that product. So how do we do that? Well, it's pretty easy. There's a data type called serial. And so a serial is just a regular integer. However, it automatically creates a random number. And it's actually not a random number. What it does is the first product we create will get a value of 1. The second one will get a value of 2. And it'll just increment by 1 for each product we add. So it's going to ensure that every single product we create gets a unique integer value for the ID column. And like I said, we do have small ints, big ints, and regular integers. This is the same thing, but it's just auto incrementing for those three kinds. So I'm just going to say it's going to be a regular integer that increments by 1 automatically. And then this is going to be what's going to be the primary key, right? We know that the ID has to be unique. I think that makes sense to make it the primary key. And I think for now, this is a good enough starting point to learn about SQL and Postgres in general. So let's save this. And we have then successfully created our first table. And so under tables, you'll now see our products table. So let's start playing with this products table. Let's create entries. Let's delete entries. Let's really start to have fun with it. So right click on it and select View, Edit Data. And then you can really select any one of these. If you select all rows, what it's going to do is it's going to fetch every single entry that we have in the database and show it to you. We don't have anything in the database, so it doesn't really matter. If you select first 100 rows, it's going to grab the first 100 rows in the database. And if you select last 100 rows, it's going to grab the last 100. Now, if this was a production server or something like that, we might have millions of entries. So you may not want to do all rows and then just get flooded with all of this data. So you may want to select one of these or filter out the rows based off of some criteria. But we have no actual data on it, so I'm just going to select all rows. And you'll see that within PgAdmin, we have these different tabs. So it opened up a new tab. And you see that there's like a little pop-up window. So if you can pause it and rewind, it says that it actually ran a query. And so what it did is it ran a query to retrieve all the rows because that's what I selected, right? I selected, get me all of the rows by selecting all rows. And if you look at this query editor right here, this is the actual underlying SQL that it ran. So it ran select star from my products table, order by ID in an ascending fashion. So it's going to grab the first product with the lowest ID number and the next product with the second lowest ID number, and it's going to keep incrementing up. We've got nothing in our database, so it didn't return anything, but I think it's cool that it does show us the underlying SQL. Now, like I said, we don't have anything in our database at the moment, so let's go ahead and create our first entry. And so I'm going to select this column, and I'm just going to give it a name. So this is going to be, let's say, a TV. And let's give it a price. I'll say this is $200. And then the ID, this is going to be automatically generated, so we don't need to provide a value. And so at this point, you may be thinking, well, it looks like we created an entry, right? We have our TV price of 200. Well, not exactly. To actually store this data in the database, right now we're just proposing changes. We have to select this button right here. So if you hover over this, this says Save Data Changes. So when you select this, this is actually going to push this data into the database. So let's do that. You can see that the data was saved successfully, and now it's actually in here in the database. So let's create a new entry. I'll say this is a DVD player. I don't know if anyone uses these anymore. And then let's give this a price. I'll say this is $80. And then we can just keep adding as many as we want. So let's add in a remote. This is going to be $10. All right, and you'll see that anything that's kind of bolded, so you notice how TV isn't as bolded as DVD and remote. So bolded means we haven't actually pushed it out to the database. It's just proposed changes. So we can push out both of these at the same time by pressing this again. So we push that, and then you can see that they got pushed out. And take a look at the ID column, right? The first item got an ID of 1, the second one got an ID of 2, and then 3, and it's just going to keep incrementing. Now let's have a little fun. Let's create a new item. This time let's make it a microphone or something. And let's leave this price column blank, and let's see what happens. So now if I press this, take a look at this error, null value in column price. So we left this value empty. So Postgres interpreted as null, but we set the column to be not null. So we told Postgres to do a check and say, hey, listen, if we ever don't provide a value, we want you to throw an error. So this is forcing us to provide a value for this because creating a product without a price just doesn't seem to make sense. So let's give this a price. Save that. And so now that worked. And then this time, let's try creating a product with a price, but no name this time. All right. So what do you expect to happen? Well, since we set the column to be not null, it's going to throw an error, or it should, hopefully. And look at that, null value in column name. So once again, it's not going to be supported, and it's going to throw an error. So let's just give it a name. Let's say this is a car, the world's cheapest car. Hit OK. Save that. That's been successfully added. All right, so now that we've kind of played around with it a little bit, let's make this a little bit more interesting. And let's add in a brand new column to our products table. So right click on the products table right here and select properties. Then under columns, we're going to add in a brand new column. So we're just going to follow the same steps. And this column is going to represent if an item is on sale. So I'm going to call this is_bool. Sorry, not is_bool. It's going to be is_sale. And it's going to be a simple Boolean as the data type because it's either going to be set to true, which means that the item is on sale, or false, that the item is not on sale. So we'll do Boolean. And then everything else we're just going to leave by default. So for not null, we're going to leave this to be no. So we are going to allow the user to input a value of null in this case. However, what we're going to do is we're going to add in an extra constraint, I guess. Actually, we're going to set a default value. So if the user does not provide a value for is_sale, we're going to give it a default value and say that by default, if a product doesn't receive a property for is sale, it's going to be set to false. So it's not going to be on sale. So let's hit save. All right. And then right now you don't see a new column, but that's because you don't see the new is on sale column, but that's just because we need to refresh this page. So let's go under object. I think we could do it here. I think it should be a refresh. I didn't do anything. So I think we're just going to do the same thing as we did before. There should be a way to refresh this, but it looks like if I just press it here, it doesn't do anything. So instead, I'm just going to do a view, edit data, all rows again. It's going to open up a brand new tab. And now we can see the is_sale column here. And what's awesome about this is that because I provided a default value, it went to all of the other items in my database that were created before this column was created, and it provided a value of false because I said, listen, if the value is null or if we didn't provide that data, go ahead and put in the default value of false. And so now if I create a brand new item, and I'll say this is for a pencil, and the pencil is probably only $2. Now, since this can be set to null, I'm going to just leave that blank. And now if I save this, take a look at this. It gets the default value that we provided. So you'll see that for a lot of your columns, you're going to want to provide default values if you expect it to be frequently inputted without a value and you want it to receive a default value. And now, once again, I'm going to actually create a brand new column once more. And then we'll go to properties. We'll go to columns. And then we'll add a column. And we'll call this column inventory. So this is how many of the items that we have in stock. And so here, this is going to be an integer. And I think it makes sense for in our application to have a value for our inventory. We shouldn't leave it null. So I'm going to set it to yes. And I want you guys to see what happens when we hit save. Because the big issue is, right, this column doesn't exist at the moment. And so all of these items were created before there was an inventory column that was created. However, this column has a not null value, but it doesn't have a default value. Right, we gave isSale a default value, so Postgres was smart enough to go into all of these pre-existing items and give it a value of false. Well, what's going to happen with the inventory? I didn't give it a default value, so let's see what happens. If I hit save, it throws an error. It says column inventory of relation products contains null value. So it's basically saying all of these products that you had before don't have a value for inventory. So at this point, you have a couple of different options. You could delete all of the previous products if you wanted to. And since this is a development environment, that's not a big deal. If you're in a production environment, that could lead to issues. Obviously, you don't want to delete your production data. So we could just give it a default value like we did before. And so I can just go back into, whoops, not there. We want to select this little button, go into constraints, and we'll say the default value is, let's say there's going to be 0 items. So let's hit save. And once again, I'm just going to open this up. I still don't know how to refresh it. I know there has to be a way. I can't find it, so it's okay. We could just open up this again, and then we can just delete these. I don't want too many of these. And I don't know why it's got squished up like that. But because we provided a default value, it got all values of 0. And so now if I create a brand new item, and I'll call this, and this will be a pencil sharpener. We'll give a price of $4. Is sale. I'll set to be true. Set to true. And then if we don't provide an inventory, right? It's going to get that default value of 0. All right, so I think we've almost wrapped up our schema for our products table. However, I want to add one more thing, and this is something that's pretty common. Anytime you create an entry within almost any other table, you usually want some sort of timestamp, right? So when did we add this product? When did this user create his account? When did this user create this post, right? So anything that we add into our database or in our application, it is generally best practice to store when that item was created, because you never know when you need to know that information. So let's create another column and let's see how we can work with timestamps. So I'm going to right click on products as usual, go to properties, and then under columns, we're going to add in a new column. And we'll call this column created at. And then here we have to select something that represents time. So what I recommend you guys do is just go to the documentation and then look at date time types. So there's a couple of different ones, but what we're going to do is timestamp with time zone. So we got timestamp without time zone and then timestamp with time zone. We've got just the date and then we've got just the time, but I want the date, time, and the time zone. So that's the most detailed. So I'm just going to search for timestamp, and we want timestamp with time zone. All right, and we obviously want this field always filled in. However, I don't want to have FastAPI be responsible for creating the timestamp. I want Postgres to automatically create the timestamp for when the entry was created. So I want to be able to just create a product, and then as soon as it gets added to our database, Postgres will just fill it in with whatever that current time is. So how do we do that? Well, we can go into this right here. So let's configure this, add a constraint. And then here, all we have to do is for the default value, I want you to just write now. So what this is going to do is the default value for any product that gets added, it's going to run this specific command on the CLI. So this command just grabs what is the current time. Pretty simple, right? Now, I think it's pretty straightforward. What time is it now, right? And so this will set the default value. So if I hit save at this point, all right, since we had all of these other items that were created previously before there's a timestamp, what it's going to do is it's going to set the created at time to whatever time it is now, which technically that's not accurate because that's not when they were added, but these were created before we were smart enough to actually have a timestamp. So if we refresh this, so I'm just going to do view edit all rows again. Right, you can see that they've all been given the same timestamp of whatever that current time was. And now if we add in a new item, and I'll add in, how about a keyboard? We'll give this a price of 28. Is sale, we can just leave that empty. How many in our inventory? We'll give it 50. And then we'll leave this blank. And so let's see if it automatically fills in what is the current time. And it should be later than this time, obviously. So we'll hit save. And so if we just double check, yep, we could see that this is about a minute later. And so now we've successfully added the created at timestamp. In this lesson, we'll run our first SQL command. However, before we do that, what I want you guys to do is create a few more entries within your database. And so you could see that off camera, I added about 6 or 7 more entries. And you want to make sure that you provide enough varying data to your database. So make sure the price is all different. Make sure that the is sale boolean is a good mix of true or false. Make sure that the inventory numbers vary enough, and then try to create them at different times as well if you can do that. That way, when we actually go to make queries, we can see a variety of different output, and that won't happen if you only have 3 to 4 entries. But once you do that, we should be ready to start our first query. And what we want to do is right-click on your database. So my database is called FastAPI, and then select Query Tool. So that's going to open up a brand new tab. And what we can do is we can run our query from here. So here we type out our query, and then we just hit the play button, and that's going to run our query. So how do we make a query within a SQL database? So first of all, let's start off with the most basic query. I'm going to type it out, and then after we type it out and run it, I'm going to explain to you exactly what each part of the command actually does. So here we'll do select star from products, : Then once we've typed this out, what we can do is just hit the play button and let's see what happens. So this is going to run the query. We got the same output here saying that it successfully ran, and it says 13 rows affected. And so what we can see here is it just printed out every single entry within our products table. Now we only have one table, so it's essentially just dumping out the entire database. But if we had more tables, you would see that this would only print out whatever was in our products table. So this command right here does one simple thing, and that is it's going to give us every single row within the products database. So let's actually break this down. So first of all, we start this command with select. So we're basically saying, hey, I want to select these rows. Ignore this for now. We're going to come back to this. And then what we do is we run from and then products. And so you say what table you ultimately want to run this command for. So you say from and then the table name, and then it's going to run that query against that table. If we had a table called users and we wanted to get every user, we could do select star from users. No different, right? So it's just a matter of providing your specific table name. So every query is going to be with regards to some table. And the thing about SQL is every single command is going to end with a semicolon. So if I don't put the semicolon, it's not going to do anything. Well, in this case, it actually ended up working, but that's just because we're using PgAdmin. If you did this in the command line, it wouldn't have worked. So remember, semicolon at the end of every command. Now let's talk about what this star or asterisk actually does. And so you can see by default, we get every row, and that's coming from this part of the command. But what does this do? Well, if you see here, we get every single column back from our table, right? And that's because we use the star here. However, in an actual database, your tables could have 50 columns, maybe more. They could have a ton of columns. And if you're running a simple query to get, some specific information, you may not want to get all of that data back. You may not care about most of the columns. You may only want 1 or 2 columns. And so we can filter out what columns we want returned back for each row. So the star means I want every single column. So we got every single column that we defined for the table. But if I wanted to run a query against the products table, but I only wanted a list of the different names of each product, I can specify just name. And so what this is going to do is this is going to grab just the name column from my products table. So if I run this again, you can see we got the same exact data. We got all 13 entries, but it only returned just the name column. And then we can add in as many columns as we want. So if I wanted the ID column as well, and the price, I can hit run. And so now we got the ID and the price. And what's really nice is it's going to line up with the order that I write them here. So if I want the ID first and then the name and then the price, I could change this to ID, name, price. And so now it's going to order it in that exact order. So we got ID, name, and price. But if you do a star, it's just going to return every single column. Now, before we dig any deeper into SQL and how to structure SQL commands, I want to talk about capitalization. And so you'll notice that when I ran this command, the word select and the word from is capitalized. And I want to make this very clear. Capitalization doesn't matter. So if I make this lowercase and I make this lowercase as well, and then hit run, you'll see that everything works just fine as it did when it was capitalized. So capitalization doesn't matter. However, with any SQL statement, we have 2 types of words. We've got SQL-specific keywords, which is part of the SQL syntax, and then we have our user-provided information. And so let's quickly talk about what those 2 things are. So the user-provided information is keywords that I'm inputting in. So I'm asking SQL or my Postgres database, I want the information from my products table. So I'm passing in this data. And so that one, you have to make sure you just match this up with whatever it's called within our table. But all of the SQL-specific words that I don't create, that don't match up with anything in our database, right? Those can be either capitalized or lowercase. It doesn't matter. It's not going to impact your SQL statement, but you'll see that best practice is to capitalize it. So we'll do capital select and then capital from. And the reason we do that is that we can much easier tell which parts of our SQL statement is user-provided information and what parts of our SQL statement is just basic SQL keywords. So this just makes it a little bit easier to read. You may not notice the benefit of it now, but you'll see that these SQL commands can get really long. They can span multiple lines. And so having those keywords capitalized, it makes it a little bit easier to understand, but keep in mind, it doesn't actually impact how the SQL statement actually runs. So it doesn't matter, but if you want to follow along with what I do, I like to capitalize them. Now with SQL, what we can do is when we perform a query, we can rename any of these columns. So if we find that this name is a little inconvenient and maybe renaming it makes it a little bit easier on our backend code to better interpret the data, we can pick any column we want and rename it. So let's say we're trying to fetch the ID column. I'm just going to run this. We can see we grab the ID column and it's named ID. But let's say this confuses our backend because we're retrieving maybe data from another database that also, for users or something, and then we also have an ID field, and we don't want them to get mixed up, I can rename this column. And we can rename it by using the as keyword. So I say ID as, and then specify the new name. So I can name this products_ID. So now if I run this, we can see that the column is now products_ID instead of just ID. And I can do this for any and as many columns as I want. So if I wanted to rename the is sale column, I can save it as on sale. And so there you go, guys. It's really as simple as that. Keep in mind, I kind of continued with my normal SQL format of capitalizing the SQL-specific keywords just because it makes it a little bit easier to read. All right, so let's clean this up a bit. I'm just going to change this back to star so that we can retrieve every single column. I'm just going to run that just to make sure nothing's broken. And so till now, we've been retrieving every single entry in the table. And that's because we've provided no filter criteria, no filter conditions. So let's figure out how we can filter the specific rows that we want based off a certain criteria. So let's say I want to match all entries that have a specific ID of something. Right? And we know there's only going to be one entry that has a specific ID because the ID field is a primary key. So we know that two different items can't have the same exact ID. But you'll see one of the more common tasks when it comes to working with databases is retrieving a row based off of a specific ID. So, a lot of times our backend will be like, hey, I want you to retrieve the product with an ID of 10. So how do we do that? Easy. We add the keyword where. Then we specify the column that we're interested in, that we want to match on. So we're going to use the ID column. And then we say ID equals, and then we pass in the value. It really is that simple. So if I want the ID of, and so if I want to get the product with an ID of 10, I just pass in 10. And remember to make sure you have the semicolon at the end, hit run. And look at that. We've now got our product that has the ID of 10. And then keep in mind, just like we did before, we can filter down based off of just the fields we want. So if we want just the ID and the name, we can do that, and it should work just fine. We'll change this back and run that. And so we got that. If we want to grab the ID of product with an ID of 3, run that. And so now we get the product with an ID of 3. But what's nice about this is that we can choose any column to match on. So let's say that I first dump everything so I can just see what I've got. And let's say I want to match on any product that has an inventory of 0. So that's basically saying, like, which products do we not have inventory of so that maybe we can place an order? Well, we can just say where. And once again, I'm capitalizing the SQL keywords. And I can say where inventory equals 0. And so now we've got a list of products where we need to place an order. It really is as simple as that. Now, working with numbers, you just place the number. So any column that uses integers or floats or anything like that, you could just say equals that. However, if you want to match based off of name, the name column, it's going to be a little bit different because the name column uses, varying characters or text or, what would be a string in Python. And so for those, what we have to do is, first of all, we'll use the column name equals, but we have to wrap it in quotes, single quotes to be specific. So if I want to get the product with the name of TV, I have to put in single quotes, search for it, and then now we get that. So keep that in mind, because if you remove the quotes, I believe you should get an error. Yep, and you do get an error. So just make sure when it comes to working with varying characters or any kind of text, you want to wrap it in quotes. Now, just like with most programming languages, we do have operators. And so till now, we've just been working with the equals operator. So if I need to get, any product that has a price of, 20, I would just say where price equals 20. And it looks like I don't actually have any items with the price of 20. So I'm just going to do 200 because I see that the TV is 200. If we run that, it works just fine. However, what if instead of doing this, I want to retrieve all of the items that have a price of greater than 50? How do I do that? Well, it really is fundamentally no different than how we do it in Python. So I could say where, and I'll say price is, and then we have greater than 50. So this is going to grab any item that's basically 51 or higher. And it's not inclusive, so it doesn't include 50. And so now look, it looks like it grabbed all of the items that cost more than $50. But if I wanted to say greater than or equal to 50, I can say just greater than or equal to 50. If I run this, we can see once again, it works just fine, but I don't have any products that are priced at 50, so I'll try this again with just 80. So we'll say greater than 80. It should not return this one because 80 is not greater than 80. So we can see the 80 is gone, but then if I do greater than or equal to, we can see the 80 is back. And we get the same thing with the less than and less than equal to. So I could say less than 80. And I could say less than or equal to 80 as well. And then the last operator that I want to discuss is the not operator. So if I wanted to grab any product that does not have a inventory of 0, I can say where inventory. And we have two different ways of doing this. I can say not equals. So this is kind of the similar syntax that you see in some other programming languages, not Python, but other programming languages. I could say not equals and then 0. This is going to give me every product that we do have adequate stock for. And so now we see we get no columns, or sorry, no rows with an inventory of 0, but we can also use this syntax. So the greater than, sorry, the less than, and then the greater than. If we run that, we should get the same exact result. All right, so let's move on to performing multiple operators. So let's say I want to grab any item that we have inventory of. So any item that has an inventory greater than 0 that also costs more than $10. How would we do that? And I'm sure you guys can probably take a guess at this, but we'll do inventory greater than 0. And then how do we add that next statement where we say greater than, I forget what I said, greater than 20? So we could just say and. Simple as that. We do and then we pass in the next criteria. We'll say and price is greater than 20. Let's try that out. And I realize I forgot the where keyword here, so that's why it's throwing an error. All right, and so now we got every single product that has an inventory greater than 0 and a price of greater than 20. And just like with an AND operator, we also have an OR operator. And so if I want to see any product that is either greater than $100 or less than 20, I can say where price is greater than 100 or price is less than 20. And so now we can use two criteria, and as long as it matches one or both of the criteria, it's going to return that result. All right, let's clean this up a bit. And let's say I want to retrieve products with an ID of 1, 2, and 3. How would I do that? Well, I can do where ID equals 1, and then we'd have to do an OR statement, and then we'd say ID equals 2, or ID equals 3. If we run this, it should grab just those 3 items. Now, there's another way to perform this kind of operation. And instead of using all of these ID equals 1, ID equals 2, and then just combining them with OR statements, we can use the in operator. So let me explain how the in operator works. What we can do is we can say ID in, and then we can provide a list of values. So I can say 1, 2, and 3. And once again, I forgot the where keyword. And so if you run this, you can see that we got the 3 items, and you can see that that's way more readable instead of having to type out that entire command. And let me show you the previous command. I shouldn't have deleted it. So I'm going to use the scratch pad just to show you guys. And so before we did where ID equals 1 or ID equals 2 or ID equals 3. So which one do you think is more readable? So both of them do the same exact thing. However, one's a little bit easier to read, and it cuts down on the number of keywords that you have to type. Now, before we proceed any further, I'm just going to retrieve all my all my entries once again. And what I'm going to do is I'm going to add a few items. And so all of these items are going to be named very specifically. So I've got a TV items. And so I'm going to create one called TV Blue. And then let me give this a price. And then everything else I can leave default. And then I'm going to create a TV Red. And then a TV Yellow. And then I'm going to save these to our database. And I forgot to give it a price. We'll just say all of them cost. Actually, let's give them different prices. So this one will be 200. Yellow, no one likes anything that's yellow, so I'll give it a value of 50. And we'll save to our database. All right, so that's in our database now. And we know how to filter based off of items. And we can use the where keyword, and we can do it for even columns that are based off of characters, like the name column. So let's say that I want to retrieve everything, all of my TVs. So this TV, this TV, this TV, this TV. How would we do that? Well, we can't exactly use the where statement because I can say where name, and then, I mean, we have equals, we have greater than, we have less than, but none of those really do what we want to do. So how can we match just on all of our TVs? Well, we can use our like operator. So we could say where name like, and then what we can do is we can pass in something very specific. So we pass in the text that we want, but then we can start using things that are kind of like regular expressions, like we have in Python. So I could say TV and then %. And what this is saying is that I want to grab every row that has a name that starts with TV, and then the % means any random characters afterwards. So this is just saying I want any product that has a name that starts with TV. So if I run this, you can see that we were able to grab all the TV. So it's very similar to regular expressions. And if I remove this and instead just add in the letter A, this is going to return all of my products that start with the letter A. And I don't have anything, but if I change this, I know I have one product that starts with an R. So if I try that, you can see that we get the remote. And we can also flip this. So I can say, % and then pass in some letters at the end. So if I want to grab anything that ends in the letter N, I can run that. It looks like I've got nothing that ends in the letter N, maybe E. Right? And so now we get all of the items that end in an E. Right? And then we also have the ability to do the opposite. So this matches anything that ends in an E, but if I want to get every line that doesn't end in an E, I can say not. So that's just going to give me the opposite. So that's going to give me every row except for those 2 rows. And what we can also do is if I want to get any line that has the letter EN somewhere in the name, I can do the % before and after. And so we just look for these 2 characters anywhere in the name. So if I run this, and it looks like I got an error, and I'm not sure what happened there, but I changed this. I just deleted it and retyped it, and so now it no longer gives me an error. So I'm not really sure why that happened. Could be a bug of some kind, or maybe there's a typo I didn't see. But this is going to grab any text that has the letters EN, and then it can have any characters before, any characters after. And then since we have the not operator, then it's going to do the exact opposite. But then I can also remove this so I can grab any lines that match just this. And then it looks like once again I get the same exact error. Okay, there we go. Now, when we make a query to our Postgres database, we can also specify how we want to order the results. Now, by default, it looks like it's just going based off of the ID, but it's not necessarily going to be like that. And so it's better to actually tell Postgres how you want to order the products. So in this case, I've got no filter criteria. I'm just returning everything. And let's say I want to filter or order the products that are returned based off of price. So if I say order by, I can then specify the price column. So let's see what happens when I run this. All right, we can see that it looks like it starts at the lowest price and then works its way up. So by default, when you specify the order by keyword and then specify the column, it does it in an ascending order. And so you could specify the order at which you want to go, the direction, I guess, by saying ASC. So this means ascending. So this shouldn't change anything because Postgres by default is going to always do it in an ascending order. So if I run this, nothing changes. However, if I want to do this in a descending order, I can say DESC for descending. So now it's going to start at the most expensive price and then work its way down. Now let's change this. And let's say we want to order by inventory. And I want to see which products we have the most of. So I'll say inventory and then descending because we want to start at the highest value and work our way down. So I'll run this. And then we can see it starts at the highest one and then works its way down. But we've got a whole bunch of zeros. And let's say that between these guys, I also want to specify a tiebreaker of some kind. We can also specify the order using a second column for these tiebreakers. So I can pass in another column. And so let's say that anytime there's a tie, I wanted to then order it by, let's say, price. So I'll say price, and then we'll say the cheapest price. So ascending. Now ascending is always the default, so we can just delete that keyword. And so let's run this now. And I forgot to put a comma. So after each column that you want to sort by, you have to do a comma. And so now we got all of our data. And so let's take a look and see if this actually worked. So we can see we're sorting based off of inventory. Then we get down to zeros. So these are all tied. So we take a look at the second column that we pass. In this case, we're looking at the cheapest price. And so if we see the first one, it looks like the cheapest price is 2. Then it goes up to 4, 10, 30, 40, 50, 80, 100, 200. And you can pass in as many columns as you want for your sorting criteria. You don't have to just stick with 2. And it's really just a matter of doing a comma and then passing in the next column and then whatever the criteria is. And you'll see that one of the common things to do is, let's say we want to get the most recent products. Well, I think it makes sense to just sort based off created. So that's the timestamp for when the product was created. So let's see what was the most recent products that were put into our database. We can just say created_at. And what order do you think we need? Do we need ascending or descending? If you don't know, think about it. And if you still don't know, test it out. That's the easiest way to find out. So we can see that the first one is, remember, this is always going to default to ascending. So when it's ascending, we can see that there's one at 820. It was created at 820. And then the bottom ones are created at 821. So it looks like this starts off with the oldest one and then works its way up to the most recent one because that has a later date. You could think of the later date as a higher value. So if we want the most recent products first, we would do descending. And so now we've got the most recent products. And with this order, with the sorting property, remember, we can just chain this on to any SQL statement. So if I also wanted to, get all of the products that have a price of greater than 20 and then sort it by something, I can just specify my where keyword and say where price is greater than 20. And then for all of those results, I want to order by who was most recently created. So we'll search that. And so there you go. And so that's the great part about SQL is you'll just keep chaining these different SQL keywords to filter out the exact data in the exact order that you want. Now, in an actual production environment, our tables could have millions, tens of millions, hundreds of millions of rows. And so it would never make sense to just perform a query like this where we just dump everything, because then all of a sudden we're asking our database to send back 100 million rows, and that's just unacceptable. And our software that we're using to even send the query may not even be able to handle that. And so usually you want to provide a limit of some kind. So you may want to say, hey, I want to grab, the first 10 rows that match this criteria. Well, we can do that by using the limit keyword. So we say limit and then pass in the number of rows that you want. So if I run that, you can see that we get 10 rows. If I lower this to 5, we can get this, we can get 5 rows. And you can chain this on to any SQL expression. So let's say I wanted to grab all of the products that have a price of greater than 10. Right, if I search that, you can see I get 10 results. And let's say I want to limit this to only the first 2 results. So if I hit that, you can see that now I get 2 results. So all the keywords that we're covering, including the order by and any of the filter expressions, we can just keep chaining on to our SQL statement to further specify exactly the data that we want. Now with limit, there's another keyword that I want to cover. And so let's say that I want to grab all products and I want to order by ID. All right, so this is going to return it like it normally does, and it's ordered by ID. And let's say I want to set the limit to be 5. So now we get products with an ID of 1, 2, 3, 5, and 7. Do I not have an ID of 6? I'm just curious, actually. So let me cut this out for a second. I just want to see if there's an ID of 6. There isn't. Okay, so that's expected. So let me add that back. So we'll say so I'll do order by ID, and then we'll limit it to 5. So we have the first 5. Now let's say that we want to skip a certain number of rows, because every time we search this, we're going to get the same result. And let's say that we don't actually care about the first 2 results, and I want to skip past them. We can provide an offset. So I'll do offset, 2. And so what that's going to do is it's going to skip past these first two results and then give us the next 5. So we should see the first result be remote, then microphone, then car, and then the 2 after that come after that. So if I search this, we can see that that first one is a remote and the last one is the pencil sharpener. And then if I do an offset of, 5, it's going to skip the first original 5. And so then we get pencil, pencil sharpener, and keyboard. So you're going to see that, when it comes to limit and offset, these are going to come in handy when we start implementing pagination in our API. We're going to definitely make use of the limit and offset keywords. Till now, we've been using PgAdmin to create new entries in our database by just going into the little GUI here and then just adding new values. However, when you're actually working with the Postgres database, you're never actually going to do this. This is more for administrative purposes, but a real application is going to use SQL. Just like we use SQL for making queries, we're going to use SQL for adding new entries. So let's take a look at what the command looks like for adding a brand new entry into our database. The command starts with an insert because we're going to insert a brand new row. And then we say into, and then we're going to specify the table that we want to add a new entry to. Now, in our database, we only have one table, so it's going to be products, but here you would provide whatever table you'd like to add a new entry into. Right, then we have to do, what we have to do is provide a list of columns that we want to provide data for. And so I'm going to leave this blank for now. We're going to come back to that. And then we specify values. And then here we're going to actually provide the values for each column. And so if we take a look at our products database, we know that the name is required. We know the price is required. And then that's about it. All right. We can choose to provide an is sale, but it's going to default to false. And then we can choose to provide an inventory if we want to. If we don't, though, it's going to default to 0. So we have to provide a name and a price. And it's ultimately up to us to decide what we want to pass in. So we know we need a name and we know we need a price. Now, let's say we're going to let Postgres automatically give us the default is sale value to be false. So we're going to leave that out because we're not going to pass in any data. So this column is just for all of the columns we want to pass in data. But let's say we want to give it a custom inventory value instead of just defaulting to 0. Here we would provide inventory. And then in the values column, these are going to be the values that you want to actually provide for the name, the price, and the inventory. So let's go ahead and provide that. So let's create a brand new item. So let's give it a name. And the order in which you pass things has to match up with the order that we pass in here. So the first column that we're going to provide a value for is name because it's the first one here. So what name should we give it? And keep in mind, since it's text or varying character, we're going to have to put this in quotations. And let's add in a tortilla. So now we're a grocery store. Right? And then the next one is going to be the price. So how much is our tortilla going to cost? We'll say it's $4. And then finally, we have to provide an inventory value. So let's say we're going to have 1,000 tortillas. And then as usual, you want a semicolon. All right. And so at this point, this is all we have to do to create a brand new entry. So let's hit run and let's see what happens. So query returned successfully. And so we see this insert 0, 1. And so at this point, it says insert 0, 1. And then query returned successfully. So did we actually successfully insert something into our database? And more importantly, what exactly does this mean? So if you see insert 0, 1, that means everything worked perfectly. There was no errors. What this means is that, first of all, ignore the 0. So this means that we're using the default Postgres configuration. So this represents the OID, but I believe Postgres by default doesn't use that unless you specify it to. So it's going to give a value of 0. And don't worry too much about that. That's kind of outside of the scope of this course. We're not going to mess with that. But instead, what we want to focus on is that second column. So this means that we inserted one row. So that means our insert worked perfectly. So let's take this. And what we're going to do is, first of all, I'm going to copy this. Cut it out, actually paste it into my scratch pad for now. And then we're going to say select star from rows. Sorry, select star from products. And we're going to run that. And so if we go to our bottom, we should see our brand new tortilla. And so we provided the tortilla value, we provided the price, and we did not provide an is sale, so it defaulted to false, and then we provided an inventory. Now, if I copy this again and paste it back into here, right, and if I move the name column right after the price, well, now SQL is expecting me to provide the value for price first, then name, then inventory. So then I would have to take the price, move that over to the first column, and then move that into the first entry, and then we have the name and then the inventory. And so keep in mind, the order here has to match the order here. So once again, I'm going to go ahead and just add this again, because why not? And so now, oops, it looks like we have an error. What happened here? All right, there we go. I guess we just needed that space. And so now it's in there. And you'll notice that once again, we get the 0, 1. So that means everything was inserted properly. So now we should have 2 items in our database with the name of tortillas. And when you're working with Postgres, and especially with an API where we want to create a new post, like in our application, the general convention in an API is once we create the new post, we want to return that data back to whoever sent that request to the API. So we want to get that brand newly created post with the new fields like the created at field and all the default values and send it back to the client or the front end. So how do we get Postgres to automatically return it? Because right now it doesn't seem to do that. And we could, just provide 2 statements, right? I can add in a second statement that says select star, from products. This is going to dump everything. We could potentially, filter on, where name equals, tortilla or something like that. And then at that point, we should have 3 entries, but that's one way of getting back the result. However, there's a much easier way within Postgres. So first of all, I'm going to change the name. I'm going to add a new item and say this is a car, and I'm going to give it a price of 10,000. And what we can do is we can pass in a keyword called returning. So this is going to return the newly created item or items if you want to insert more than one item. And then here we have to specify the columns that we want for the newly returned items. So if I do star, that's going to return every single column. If I do ID, this is just going to give me the ID of the brand new created item. I'm going to return every single column. So if I try this now, look at that. So it creates the new entry. We can see that has an ID of 26 and it gives back the entire row. Now, if you want to insert more than one row at a time, what we can do is we just do a comma here after values and then just provide the data for the next row. So we'll do, we'll create a new item that costs $50. And this is going to be a laptop. And then we'll say there's going to be an inventory of 25 of them. And then if we wanted to add another one, then we could just do another comma and then add some more values in. So we'll give this a price of 60. This is going to be a monitor. And then we'll say we have 4 of those. And so here we can then go ahead and run. You can see that it added 3 items and then it returned all 3 because we have the returning keyword. And if you wanted to, we could just say, I want the ID. We could just say, I want the ID and the created at field. Maybe the name as well. If I run this, we can see it created another 3 new items and then it returned just those 3 fields. And so that's pretty much all I wanted to cover when it comes to creating new entries in the database and inserting new rows into a table. All right, so in the last lesson, we learned how to insert new entries into a database. Let's now figure out how to delete entries. So let's clear out this query real quick. And the command to delete a entry from a database is going to be delete. Who would have thought, right? Delete, then you say from, and then you provide the table that you want to delete a row from. So we'll say products. And then we want to specify conditions. So what is our match criteria? What rows do we actually want to delete? So we have to tell SQL, I want you to delete this specific row. So what do we usually match on? Well, if you take a look at our API, specifically our delete endpoint, the user provides the ID of the product they'd like to delete. Or I guess in our application, it would be the ID of the post we'd like to delete, but we're working with products. So we'll say, just like with a regular select query, you say where, and we can say ID equals, and then the ID of the product we want to delete. So let's take a look at one of these products. I'll grab a product 10. And then let's run this. And then afterwards, let's actually do a select star from products so we can see all of the products afterwards just to verify that the ID of 10 or the product with an ID of 10 got deleted. So you can pass in as many SQL commands as you want here. So we'll run that. And so it ran. And then we can see that the product with an ID of 10 was deleted. Now, I'm going to change this to 11 because there's no longer a product with an ID of 10. So I'm going to delete this product. But what we can do is we can tell Postgres to actually give us back the specific entry before it's deleted, so we could see what that looked like. So we could just pass in the returning keyword just like we used with the insert statement, and then we specify the columns we want. So I'm going to say all of the columns, and then if we run this, we can see that it deleted the product with an ID of 11, and we can see what that product looked like. And keep in mind, if I don't pass any of this data and I just run this, right, you'll see that it says a delete of 1. So this is just telling you how many total rows it deleted. Now, let's say that we want to delete multiple products based off of a criteria. So let's say we want to delete any product that has an inventory of 0. How do you do that? Same exact command. We just have to match on any product with an inventory of 0. So let's say delete from products table where, and then we'll just say inventory equals 0. So this should delete every single product with an inventory of 0. If we run this, we can see it deleted 8 rows. Let's just do a select star from products. And you can see we no longer have any products with an inventory of 0. All right, so we saw how we can insert new data into our table, and we saw how we can delete entries from our table. I think the next logical step is to figure out how to update a pre-existing row. So the command for updating is going to be, as you guessed, update. And then we have to specify the table that we would like to update. And so in this case, it's going to be the products table. And there's going to be 2 things that we have to pass in. So first of all, we need to specify which entry we want to update. We can update more than one entry at a time, but just like when it comes to deleting, if you take a look at our API that we built so far, the user provides the ID of the specific post they want to update. So normally we're going to update based off of the ID column. So we'll say where, just like the select statement or the delete statement, we can just say where ID equals, and then the specific product of the ID and the specific ID of the product that we want to delete. So let's say we want to delete one of the tortillas. So an ID of 25. Sorry, not delete, but update. So we'll say 25. Then we want to pass in all the columns that we want to update. So we pass in the name of the column and then what the new field should be. So let's say the name column, I want to rename this to be flour tortilla. And then let's say I also want to update the price. So I could say the price equals and then 40. So right now the price is 4 and the name is tortilla. It's going to now be flour tortilla and 40. If I run this, and don't forget the semicolon at the end. And I realized I forgot one keyword. So before you pass in all of the new values, we have to use the keyword set. So it's update products. Then we want to set these columns. Then I run this and we can see that we updated one field. And I'm going to copy this, put it in my Scratchpad for now, and just do a select star from products. And so if we take a look at our tortilla, so now it's called flour tortilla, we can see the ID is still the same because we didn't change that. And the price got changed. However, all the other fields have all remained the same. So that's good. But just like when it comes to inserting new data, we generally want to return the newly updated product to the user. So how do we do that? We could just use the returning keyword. So I'm going to copy this again. And let's update a different product. So I'm going to update the car, which is a ID of 30. And let's just say I want to update one field. I'll remove all these and I'll just say I'm going to update the is_sale field to be set it to true, because right now it's set to false. We'll set that to true. And then we can say returning star. If we update this, we can see that we now got the car. We can see that the is_sale set to true and it returned that data and it was successfully able to update that. Now let's say we want to update multiple rows. And let's say I want to update, let's just update everything, right? So if I don't pass in a specific condition, I can update every column, or I can specify a condition and then update just those columns. So let's say I want to match any product with an ID of 15 or greater, so an ID of greater than 15, and I want to set the is_sale to be true. So if I run this, we can see all of the entries that it updated. So now all of these entries, which all have an ID of greater than 15, have all have the is_sale column set to true. And so that's how we update entries within a Postgres database. At this point, I think we have a good enough foundation when it comes to working with Postgres. We're able to successfully query a database, insert new rows, delete rows, and update rows. So I think it's time we finally started to go back to our code and figure out how we can actually work with a database within a Python or a FastAPI application. But before we do that, I want to do a little bit of cleanup. So with our database, we no longer need our products table. So what you can do is you can go ahead and delete it. So you can just right click and then hit delete or drop. Technically, if you don't want to delete this and you want to keep it for now just for reference, you don't have to delete your table. It's not going to impact anything else. So you can keep it, but I'm going to go ahead and delete it because we don't actually need it anymore. So we'll just do that, hit yes, and then it's going to delete that and we should no longer have tables. And I'm also going to move over to another machine. So when we go to the other machine, you will see a whole bunch of other databases, but those are all databases from my other project. Make sure you just focus on the FastAPI database. All right, I'm back over to my new machine. You'll see that if I take a look at my database, there's going to be a whole bunch of other databases, but I've got my main FastAPI database, so that's what we're going to be working on. Don't look at any of these other ones. And within here, it's going to be pretty much empty. I've got no tables. And so we're going to go ahead and create our table for our social media application. So, we've been working with posts, so I think it makes sense to create a table for posts. And before we do that, we have to figure out exactly what are the columns for our specific table. And to do that, I think it's best to actually take a look at what our application looks like at the moment. And so if we actually take a look at a structure of a post, we know that it's going to have a title. We know it's going to have a content. We know it should have a attribute called published to determine if it's published or not. We're going to get rid of this rating. That was just for demonstration purposes, so I'm going to remove that for now. So it should have a title, content, published. And like any other item when it comes to a database, we're going to have an ID column as well so that we can uniquely identify each entry. And then we're also going to have a created at field to see to track when the specific post was added to the database. So we've got essentially 5 columns. And then once we have that, we can go ahead and just do what we did before. We can go to tables. We can hit create table. And then we're going to call this table post because it represents our social media posts. And then we'll go to the column section and start defining our columns. The first one's going to be our ID column. And so with our ID, we want to do serial. So this is going to cause it to be an integer that automatically increments for us. And then that's going to be our primary key as it was before. We'll add in another column for title. This is going to be a varying character or character varying. Not null is going to be set to true. We don't want to be able to create a post without a title. Then we're going to have a column called content. I believe that's what we called it here. Content, yep. Once again, this is going to be character varying. And once again, this is going to be not null. Then we're going to have a published column. And this is going to be a Boolean. This is also going to be not null. However, I'm going to provide a default value. So if I do leave it blank, it's going to default to true. And then finally, we're going to create the created at column. And this is going to be a timestamp with time zone. This is also going to be not null. And then just like we did before with our products, we're going to add a constraint so that it's going to be now. So it's going to grab the current time whenever we add this entry, and it's going to automatically add it to that column. And so at this point, we've got our tables defined. We can go ahead and hit save. If we right click on posts and then go to view and edit data, we should have essentially what is an empty database. And for now, we know how to insert data. We can do it either through SQL or we can just do it here. I'm just going to do it through here just because it's a little bit quicker for now. So I'm just going to say this is my first post. And the content is, we'll say, some interesting stuff. So just go ahead and just create a couple of posts. And then I'm going to add my second post. All right, and then we can just hit save. And so now we have 2 posts in our database, so we can start working with that. When it comes to working with a Postgres database within a Python application, we're going to need a Postgres driver. And so there's going to be a couple of different libraries that are going to do that. We're going to use this library right here. And I believe in a couple months, a version 3 is coming out, but right now this is the latest version. So head on over to the documentation and it's going to show you how to just quickly set this up. And so if we go to basic module usage, this shows us how to set up a connection to our database. And so we're going to import the library, and then we're going to set up a connection. And hopefully this is big enough for you guys. So you just say connection, and then here we pass in all of the data for our Postgres instance. So, what's the IP address of the Postgres database? What's the Postgres database that we want to connect to? What's the port number? Things like that. And then we set up a cursor. So this cursor is what we use to actually execute SQL commands. And so you could just do cursor.execute. And then here we just say, create table. Well, you guys aren't familiar with that command yet, but you can do, insert into, you can do select star from test. And then at that point, we can then do fetch one, fetch all. And then if you ever want to make changes to a database, you just do commit. So it's fairly straightforward. So let's go to our code and set this up. And so the first thing that we want to do is we want to install that library. So we'll do pip install. And I'll just copy that name. All right, and now it's successfully installed. So let's set up our connection. And so a connection to a database can fail, right? Maybe the database is unreachable. Maybe the database is down. There's a lot of things that could cause issues with us being able to connect to it. We could put in wrong passwords or something like that. So anytime you have some kind of code within Python that could potentially fail, we're going to use the try statement. So I'm going to say try, and then we're going to say connection equals. And then I realized the first thing that we have to do is we actually have to import the library. So let's just copy this line right here. And then I'm going to say PSYCOPG2. I don't know if there's a specific way to actually pronounce that. That's why I'm not trying to pronounce it. And then we call the connect method. And so here we have to pass in a few properties. So the first property is going to be the host. So that's basically the IP address. We also have to pass in the specific database we want to connect to. We also need to pass in the username that we want to connect as well as the password. And for now, we'll just keep that as such. So let's fill in these fields. So what's the host? So since this host is just our local machine, for the IP address, you could just say localhost. That means our own IP address. I misspelled database. And I'm going to set this to be Postgres because that's it's not going to be Postgres. It's going to be FastAPI. All right, so that database is just going to match up with the name of our database right here. Username, we've been using the default Postgres username, and then password. I'm guessing you guys could have guessed what my password is. It is password123. All right, and then finally, there's one extra thing that we have to pass in. And so this library is a little bit weird. So when you actually make a query to retrieve a bunch of rows from the database, it doesn't include the column names. It just gives you the values of the columns, which, it's like, I don't know what value maps to what column. So you actually have to pass in an extra field to get the column names, which kind of seems dumb, but that's the way the library works. And so what we're going to do up here is we're going to import something else. We're going to do import, same library, .extras, import, and then real dict cursor. And this should be from. And then the last property we're going to pass in here, the last argument is going to be cursor factory equals real dict cursor. So like I said, all this does is it's also going to give you the column name. It's going to give you the column name as well as the value. So you know which value maps to what column, or then it's just trying to figure the order and then mapping it to columns gets a little complicated. So this will just make it a nice Python dictionary when it returns it. All right, and just like it had in the documentation, we'll say cursor equals con.cursor. So it's just calling the cursor method and then saving it in a variable named cursor. And so all this is going to do is this is what we're going to use to actually execute SQL statements. And if it's successfully able to connect, we're going to say print, and then we're just going to print out something like a database connection was successful. However, if we weren't able to connect to it and we get an exception, we'll say except exception as error. So we're going to get the error and store it in a variable called error. And then we can just say print connecting to database failed. And then after that, just for our knowledge, we can say the error was error. We'll just print out the error. So let's save this. Okay, and you can see that we were successfully able to connect to our database. So it looks like everything worked well, but just as a quick test, I'm going to change my password here. I'm going to put it as an incorrect value. So let's save this and let's see what happens. All right, we can see that the password failed. And so at this point, what the code does is it failed, it printed out the error, and then it just keeps going through the rest of our code. So then it starts up our FastAPI server. But at this point, our application is not going to work because the Postgres database connection failed. So really our application, our API, our web server can't do anything until we get a connection to our database. So just having it fail and then kind of gracefully handling that error doesn't do anything. We need to wait for that connection to actually go through before we do anything else. Or then at that point, there's really no point in having our server up and running if we can't access our database. So what I like to do is we're going to set up a while loop. And I'm just going to say while, and I want this loop to just continuously run until we successfully get a connection. So we'll say while true, which means we're just going to keep doing this over and over and over again until we break out of it. And then I'm going to tab everything over. I put everything in that while loop. All right, and so while this is true, if we successfully are able to connect to the database, I'm just going to break out of the while loop. However, if we fail, then it's just going to go right back into that loop. And so now, one other thing is it's going to do this really quickly. And I would like for, after an error, I would like it to kind of wait 2 to 3 seconds before it tries to reconnect. So what we can do is we can import the time module. So I'll say import time. And here I'll just say time.sleep. And I'll sleep for 2 seconds, use whatever time you want. And so now if I hit save, check out what happens. So it failed to connect because of wrong password, and then it's just going to keep retrying every 2 seconds. Now for a failed password, it's never going to connect. However, if it's an issue with your internet, if it's an issue with the database having not fully initialized, then having it just kind of redo this until the database fully comes up is a nice way of kind of handling that. So if I change this now back to the correct password, we see that we're now successfully able to connect. So this is our code for actually connecting to our database. And at this point, we can start working on actually writing our SQL code and then, being able to manipulate our database from our FastAPI. And I do want to point out one thing. Generally, when you're working with your code, what we did right here is very bad. We hard-coded all of our database information right into our code. This creates a problem because, first of all, when we check this into Git, now our database password is stored in there. And then we run into some extra issues because this is the connection for our development environment or our development Postgres server. Our production Postgres server is not going to be running on a local host, maybe. The database might be called something else. The username and the password are for sure going to be different. So if we hard code it in, we won't actually be able to change it in the future. We need a dynamic way to kind of have our code change based off of if it's in our development environment or our production environment. So later on in this course, we'll figure out how to do that. However, for now, we're just going to work on keeping things simple and just learning how to interact with the database before we start moving into things like environment variables. All right, so the first thing that we're going to work on is retrieving all of our posts from our posts table. And so what we're going to do is we'll go to our specific path operation for that, which is the app.get/post right here. And let's figure out how to do this. So if we go back up to our connection, right, you'll see that we have access to this object right here, which is cursor. So we're going to use that to actually make a query. So we'll say cursor.execute. And then this is where we are going to paste in our SQL statements. So I'm just going to put in 3 quotes right here, and then we just put in our SQL statement. So in this case, right, to retrieve all posts, we just do select star from posts. Okay, and let's save this as a variable. So I'll just say these are my posts. And then let's just do a print post to see what we get. And so I'm just going to go to my Postman, and we'll just find my get posts request. We'll send it. All right, and let's see what happens, right? We could see that it printed out none. So this doesn't actually do anything, right? This is just passing in our SQL statement. However, to actually run it, we have to do cursor dot, and then we have a couple of options. We can do fetch all, fetch many, fetch one. So when it comes to retrieving multiple posts, we're going to always use fetch all. Don't worry about fetch many. I don't think we're ever going to use that. And then if we ever want to find one individual post, like finding a post by an ID or something, then we can use fetch one. Because I believe if you want to fetch a post by an ID and you do fetch all, it'll technically get it, but it'll just keep searching through the database for another post with that ID. However, we know that only one post can have that exact ID. So it's inefficient to kind of search through the entire database when we know there's only ever going to be one result. So for those, it's always better to use fetch one. But since we're retrieving multiple posts, we're going to use fetch all. And at this point, we don't actually need to save this in a variable because it's never going to return anything. We can save the output of this to be posts. So now if we save this, run this again, and I realized I forgot to actually call it. Let's try that again. Right, you can see that we got all of our posts from here. And so now, instead of returning my post, which is our old array, which we're not going to use, we're going to return what we just fetched. So we're going to return posts. And we'll go rid of that print statement. It's not needed anymore. And hopefully this works. So let's hit send. All right, and so now you can see we've got our 2 posts from our database. And it's got all the extra fields. So it's got the published, which is the default value, and then it's got the created at timestamp, which Postgres added. So now we've actually successfully been able to retrieve posts from our Postgres database, and you can see how easy it is to actually work with that. In fact, it was actually a little bit easier to do this than to actually work with just an array stored in memory. It really just comes down to understanding SQL, and since we spent the last half an hour or so really drilling into how SQL works, you'll see that SQL is pretty easy. And then once you know SQL, fetching, retrieving, updating, deleting posts from a SQL database, even within your Python code, is dead simple. Okay, so let's now move on to creating a brand new post. And so if we just quickly take a look at the code that we have right here, you can see that we have our schema. We're going to save that in our Pydantic model. And so we'll be able to access the properties from the body within this post object. So I'm going to clear this out and just delete all of that code for now. And for now, I'm just going to hard code some value. I'll just say created post. And so let's work on inserting a new post into our database. So once again, we're going to access the cursor object. So we're going to do cursor.execute. And then once again, we're going to use the 3 quotes. And we're going to use typical SQL. So to insert something into our database, we do insert. And then we say insert into. What table do we want to insert it into? We'll say the post table. Right? And then here we have to pass in the columns of all the fields that we want to enter in. So if we go look at our database, we have to pass in a title and a content. And then everything else is optional. So we can also provide published as well. And then the database creates the created at and the ID. So it's really just these 3 columns that we're going to pass into here. And so it's going to be title, content, and then published. Yep. And then we have to pass in the values for those columns. And this is where things get interesting. You never want to do any kind of string interpolation and then pass in the values of post directly into this. Instead, what we want to do is we're going to parameterize or sanitize all the data that we put into the SQL statement. So what you should do is do %s. And so this kind of represents a variable. And then we're going to do %s. and then %s. And so this variable is going to be the value that gets passed in title. This variable is going to be the one that gets passed into content, and this variable is the one that gets passed into the published column. And what we want to set these as, we're going to actually use a second item that we pass into the execute command, the execute method. And so here we pass in the actual values. So this first %s, what do we want that to be? That's going to be post.title. So we're grabbing the title from the body. Then we want to pass in post.content. And then we want to pass in post.published. All right, and this may seem a little confusing, and let me correct that, because I'm sure a lot of you thought we could just do cursor.execute, and then here we pass in just an f string, and then I can just copy all of this, and then pass in here. Oops, in the values we can just do, post.title, and then post.content, and so on. And this would technically work. However, this makes you vulnerable to SQL injection. So if the user for the title decided to, if we go to the create post and for the title, he decided to pass in some kind of weird SQL statement like insert into blah, 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 right? He puts in SQL instead of a valid title. This is what is a SQL injection attack, and he could potentially manipulate data within our SQL database. That's why it's never good to do it, to pass that data in directly into here. Instead, all of these, SQL libraries, like our Postgres library here, they actually can sanitize the inputs. So when we do this %s method and then pass it in as the second field into the execute statement, it'll actually make sure that there's no, weird SQL commands in there. And it's going to make sure that we're not vulnerable to SQL injection. So that's why we never do it like this. And we always do it like this. And just keep in mind, right, these are just variables or placeholders. And then the values we want to pass into that will be passed into these parentheses right here as the second parameter into the execute method. So post.title, since it's the first one in this list, is going to go to the first %s. And then post.content is going to go to the second %s, and then post.published will go to the third %s. So the order matters. They match up with whichever %s comes first. So if I took, post.published, right, and then moved it all the way to the front, well, now post.published would go to the first %s, post.title would go to the second one. That would cause issues because it doesn't line up with that. So that's why we want to make sure that the order really does in fact matter. And just like we had before, anytime we create something in our database, we want to return the created result. So we can use the returning keyword. And we'll return everything. And so you're probably thinking, we can just save new _ post equals that. And then since we're returning it, it's going to get stored into that variable. And that's not exactly correct. Instead, what we have to do is to get that returned value, we have to do a new _ post. And then we do cursor.fetch1. So that'll get whatever we returned from here. And then what we're going to do is we're going to say new _ post is going to get returned to the user. So let's save that and let's see what happens. So go to our create post, and then I'm going to clear that out and just say, hey, this is my new post. And let's hit send. So it looks like everything worked, right? 201 created. You can see it's got all of these values. Let's go back to our SQL database. I'm going to just do a quick query. So I'll just say query tool, and I'll just say select star from posts. Let's run it. And if we take a look at the values, and the title should be, hey, this is my new post with an ID of 3, you could see it's not in there. And so you might be wondering, well, the output of our API looks perfect. It sent it all back. Well, when you're working with Postgres or any of these libraries, you have to actually do one last thing. You actually have to commit the changes. Just like when it comes to working in our database, if I create something here, pass in some data into the content, it's not saved in there. I actually have to finally save it. So to save that data, we have to reference, instead of the cursor, we're going to reference the connection, and then we have to do a commit. So if we go down here, we just say con, which is my connection to my database, and just say commit. So that's actually going to push those changes out. So we'll save that. Now I'll try this again. All right, and so now we got, it looks like it has an ID of 4. If I go to my Postgres database, I'm going to do another search. Sure, it's okay if it deletes it. And so now we can see ID of 4, hey, this is my new post. So now it worked. So keep in mind, anytime you want to insert data into your code, make sure you do a connection.commit to actually save it into the Postgres database, because these are all staged changes. So we're staging it, we can see the result of the stage, but we have to commit it to the database to actually finalize those changes. All right, so now let's move on to fetching an individual post by an ID. I want you guys to take a crack at this, see if you can try to figure it out. It's going to be relatively similar to the 2 other previous ones we've done. So we'll start out by referencing the cursor object as usual, and then we'll execute. And then here we're going to pass in our SQL statement. And so we're going to do a select star from post. That's going to grab every post, but we want to grab just one post based off of the ID. And so you guys already know how to do that. We can say where ID equals, and then whatever ID that you want. And so let's take a look at our database. I have an ID, a post with an ID of 1. So right now I'm just going to hard code it. So I'm going to say post with an ID of 1. And at this point, this is not going to return anything. To actually return something, we'll say cursor.fetch. And then we're going to use not fetch all, but fetch 1, because there's only ever going to be a post with an ID of 1. And so this is going to make it a little bit more efficient. And then I'm going to save that as post. I'll just say test post, not to get confused with the other post. And then we're going to print that out just to see if it worked. So let's get one post. And it doesn't really matter what we send it as. If I take a look at this print statement, you can see that we were able to get just that one single post. So it looks like that worked. So now let's clear out all of this other code. I'm going to remove the print statement. Actually, before we do that, first of all, let's not hard code the value anymore. Instead, we want to use the ID that we passed in from the path parameter. So how do we do that? Remember this, we want to always make sure that we're not vulnerable to SQL injection attacks. So we'll do %s. So that's going to be the placeholder for the value. And then the second thing that we pass into the execute method, this is going to be the ID. So we take the ID, and then that's going to get pushed into this value. So it's essentially doing the same exact thing. So let's see what happens when we try to run this again. And I'm going to try to grab a post of 1, and let's see what happens. All right, so it looks like we got an error. So let's take a look. And it says that int object does not support indexing. So it's not very helpful. However, I'll tell you exactly what's happening. Because this is a string, we need ID to be a string as well. Right now, it's an integer because we validated it as an integer and we converted it to an integer. But we need this to be a string, or then it's not going to work. So we have to convert it to a string. It's pretty simple. You just do string. And that's all. And at that point, that should fix the issue. And I'm sure you guys are a little bit confused because when it comes in as a path parameter, it's going to come in as a string. We then convert it to an int to then only convert it back into a string. And so you might think, well, maybe we should just change this to a string. But if you change that to a string, then it could potentially open up us to issues where the user could type in something like this, which isn't a valid ID. So we do have to validate it as a number, convert it to an int, and then convert it back to a string once again. So let's save this. Our error should go away, and let's try this. All right, no errors, so it looks like everything's good. And so now it's just a matter of cleaning up our code and getting rid of all of the other code. So I'm going to rename this. So this is just going to be post. So we can keep everything else the same. So if we didn't find a post, right, which means the database returned nothing, it's going to be set to none, and then we can raise the usual exception. But if we did find a post, we're just going to return it. So now if I get a post of 1, you can see that we've got that post, which is clearly from the Postgres database because it has the created at field. And then if I try to grab a post if I try to grab the ID of a post that doesn't exist, try 5, we can see that post with the ID of 5 was not found. And let's just double check to make sure that there is no post with an ID of 5, and there isn't. So perfect. And, guys, one interesting thing Later down in some of the next path operations that we work on, I did run into a weird issue where if I didn't have a comma right after this, even though there's nothing that comes after it, it led to an issue. I'm not sure why it did that. But keep in mind, if you do run into some weird issues, just put in this extra comma. For some reason or another, it potentially fixes some issues. Okay, so just keep that in mind. I don't have an explanation for it. Maybe it's listed somewhere within Stack Overflow, or I'm sure someone eventually or occasionally asked this question, and I just couldn't find it. All right, so now let's work on deleting a post. I'm going to remove these comments just to clear up some space. We're going to do cursor.execute. You guys should already know the exact SQL statement that we need. So it's going to be delete from post table. And then we're going to delete by ID. So we'll say where ID equals. And then remember, we don't want to pass in the user input directly. We want to do that placeholder again. And then we also want to do a returning. So we'll see what that post was before it was deleted. And then we'll pass in the value of the post. So this is going to be ID, but we want to convert it to a string so we don't hit that error again. And then I'm going to do that empty comma just to avoid any potential issues. And then we have to do a cursor.fetch1 to get the deleted post. And I'm going to save this as a variable. So I'll say deleted underscore post equals that. We can remove this. And then for this exception, when we try to grab the ID of a post that doesn't exist, we can just say if deleted underscore post, which is the post that we fetched, wasn't found, we're going to throw an error. We can delete this. And remember, there's one last thing, right? Anytime we want to make a change to a database, we have to commit to it. So we'll do connection.commit. And then everything else, we can keep our code exactly the same. And then I'm just going to run this just to get, so we have a post with an ID of 1, 2, and 4. So let's go ahead and delete one of those. So if I delete the post with an ID of 4, what do we get? Oh, sorry, we're still under the get. Let's go to our delete. This is our delete. And then we're going to delete with an ID of 4. 204, no content, so that's good. And let's double check our Postgres database to see if it got deleted. We can see that it's now gone. And then let's try to now grab the same one. Let's try to delete the same post, which no longer exists. We should get a 404. Post with ID of 4 does not exist. Perfect. And last but not least, the final path operation we need to update is the update post path operation. We'll grab the cursor object and we'll execute our SQL statement again. And so here we'll do update posts. And then here we want to set the title. And what do we want to set our title to? Well, that's going to be passed in from the user. So any kind of data we get from the user, we have no idea if they put in, very suspicious SQL data. So we always want to put the placeholders. And so all the fields that they can update are going to be the title, the content, and published. So then the next one's going to be content. And the last one's going to be published. And then we'll pass in those values, and that's going to come from our post object. So we'll do post.title, post.content, and finally post.published. And just like we had with inserts and delete, we can do a returning. So we can actually get the returned, we can actually return the updated object, do returning star, so we can get all the columns. And then to actually fetch that updated post, we have to do cursor.fetch1. And then we'll save that in a variable called updated post. And then we can remove this. This is our previous code. And then for the little check to make sure that we actually got and updated a post, we can get updated post. If we didn't, if it returned none, then we're going to send a 404 because a post with that ID didn't exist. And then we can delete all of this nonsense. And then what we return back is going to be updated post. Make sure you get updated with a D, or then if you just do update post, it tries to call it this own function, which doesn't work. And I'm just going to see what I have in my database. So I've got a post with an ID of 1. So we're going to update him. You can see currently the title is first post. So if I go to my update post, I'm going to send it with the ID of 1. We're going to update that post, and then it's going to have an updated title. So if we see that get updated, then we know it worked. So we'll do a send. We can see what we got back. And so it looks like it updated, but let's actually double check with our database. And it did not update. And I'm sure you guys can take a guess as to exactly what went wrong. Remember, anytime you want to make changes to a database, we need to do the connection.commit. So let's try this again. All right, so we got the same result. Let's take a look at our database, run this, and then we've got updated title. It looked like it updated both, and that looks like a bug. So what did we do wrong? Well, if you look at our code, we're updating every single post because I didn't provide a where condition. What post do I need to update? So that's a mistake on my end. So we have to do where, and then we'll say ID equals, and that ID is going to come from this value. So we're going to put another placeholder there. And then that last value is going to be the ID converted to a string, just like we did before. So simple mistake. I'm going to save that. And before I do that, I'm just going to change this back to first post. And I'm going to change this back to second post. And then it's going to have some random text. And then we'll save that. Then let's update this. All right, so we updated our code. And then let's take a look at our database. We'll run this again. And we can see that it was updated. And you'll notice how that first post then moved down the list because it was most recently updated. But we updated just one post this time. And then last but not least, let's try to update a post that doesn't exist. So I'm going to search for an ID of 23, try to update that. And then if I do that, we can see that we get a little bit of an error. So what happened here? We got data equals null. And so it looks like this didn't work. And it looks like it changed back to update post. So make sure you reference this variable. So I need that D. Now let's try that. And now we get the correct 404. When it comes to working with a database within a Python application, or really any application across any language, there's a couple of different ways of interacting with the database. And so we saw how we can use the default Postgres driver to talk to a Postgres database by sending SQL commands. And this is my preferred method of working with databases because I'm fairly comfortable with SQL. And so it just makes sense to use raw SQL and send that directly to Postgres using whatever the default Postgres driver is for your specific programming language. However, there are other methods. And so you'll see that one of the popular ways of really working with databases is using what's referred to as a object relational mapper, or an ORM. And so an ORM is a layer abstraction that sits between the database and our FastAPI application. And so we never actually talk directly to a database anymore. Instead, we talk to the ORM, and then the ORM will actually talk to our database. And so some of the benefits is that we don't actually have to work with SQL anymore. So instead of using raw SQL, what we'll do is we'll actually use standard Python code, calling various functions and methods that ultimately translate into SQL themselves. So let's see what that actually looks like. And so with our traditional application, which is what we have now, we've got our FastAPI server, and it's going to talk to our database by sending SQL using the default Postgres database driver. However, with an ORM, what we can do is FastAPI no longer has to talk SQL. Instead, FastAPI will actually use regular Python code to send specific commands to an ORM. And then the ORM will take that Python code, convert it into regular SQL, and then using the same database driver that we're using for, it'll actually talk to the database. And then it'll eventually send that result back to us because the databases, they can only talk SQL. However, by doing like this, we can kind of abstract away that SQL complexity and make use of very common Python objects and various other Python features to actually generate and build queries, as well as to create and define tables. So let's take a look at what an ORM ultimately allows us to do. So one of the first things is, instead of us going into PgAdmin and creating the tables and all the columns ourselves, what we can do is we can define our tables as Python models. And so if you take a look at the code down here, what we can do is we can actually define what our tables in Postgres are going to look like. And so you can see here, we give it the table a name, and then we could specify each of the columns. You'll see a lot of the common fields that we already worked with. So the type, so this is an integer, this is a string. We can also see if a field is nullable. We can see that the ID is set to be a primary key. So we're using standard Python classes to define our table so that we don't need to do it ourselves using PgAdmin. And on top of that, queries can be made using regular Python code. So we can actually chain on different methods to construct various SQL queries. And so if you take a look at one of the queries down here below that I provide as an example, you can see we just do query. We provide the specific table that we want to query, and that's going to be based off of the specific models. And then we can just pass in whatever filter commands and then grab the first entry. So you can see that there's no SQL anymore. It's just standard Python code. And so that makes it a little bit easier for some people who may not be as strong on SQL. And so they don't have to worry about writing these complex SQL commands. They can just chain on specific methods to a DB query to generate their final SQL commands. And so there's a couple of different ORMs. I'd say the most popular one within the Python world is Sqlalchemy. And one of the things to keep in mind is that this is a ORM that's a standalone library, right? So this library has nothing to do with FastAPI. We're going to use it in our FastAPI application, but I want you guys to understand that it actually has no relationship with FastAPI. It's not part of FastAPI. It's its own library, and you can use Sqlalchemy with any web development framework. You can use it with any Python application, even if it's not a web application as well. So in the next video, we'll start taking a look at how to work with Sqlalchemy and how to set up a database connection using Sqlalchemy instead of using the default Postgres driver. Okay, so in this lesson, we're going to start taking a look at Sqlalchemy and get that set up in our project. And so there's a couple of things that I want you guys to take a look at. So the first thing is, I want you to go to the SQL page. So if you just search for SQL, you'll get to the main page. And then if you want to go to library and then references and then version 1.4, which is the one we're going to use. However, I believe they're going to come out with a version 2.0, which is going to be pretty different. So if you are watching this video in the future, you definitely want to install version 1.4 so that you can follow along with this course. So you can click on that. And so there's a nice little tutorial you can follow. And then there's also some reference documentation when it comes to setting up the ORM. So if you click on session usage, this will show you how to set up a session. However, if you go to the FastAPI documentation as well, FastAPI, they've got great documentation. So if you go to the documentation and then select SQL Relational Databases, this is going to show you how to set it up with Sqlalchemy. Okay, so first things first, let's go ahead and do a pip install for Sqlalchemy. So we'll do pip install and then Sqlalchemy. Now, guys, I want you to remember that, well, first of all, I'm running 1.4.2.3, but the thing is, Sqlalchemy doesn't know how to talk to a database, right? It has all the code for us to write Python, define all the models and things like that, but it doesn't actually know how to talk to a database. It actually needs a database driver. And so if you take a look at all of the packages that we already installed by doing a pip freeze, right? In the last video or in the last section, we installed our Postgres database driver. So whatever database you guys plan to use, so if you want to use a MySQL database with Sqlalchemy, you have to make sure that you install the underlying driver as well, because ultimately that's what's used to talk to the database. Since we're using Postgres, we need to install this as well. But since we were using it originally in the previous sections, we already have it installed, so we don't need to worry about doing that. But keep that in mind, right? SQL has no way to talk to a database. It still needs the underlying driver to communicate with it. And that's usually how all ORMs work. But now that we have that, inside our app folder, I'm going to create a new file, and I'm going to call this database.py. So this is going to handle our database connection. And from here, what I'm essentially going to do is just really follow this documentation. So if you take a look at it right here, we can just copy all of this code right here when it comes to importing statements. So this is just going to import all of this Sqlalchemy code that we want. All right, and then we have to specify our connection string. So where is our Postgres database located? And so if you take a look at how we had this set up before using the default Postgres database driver, right, we passed it into this connect function. However, a lot of times when it comes to working with databases, there's a unique URL that you create to connect to any kind of database. And there's a specific format for that. And the format for that is actually pretty simple. So go to database py, and then I'm going to create a variable called Sqlalchemy _database _URL. So this is going to be a regular string. And the structure of the URL for a Postgres database, it's going to be PostgreSQL, because that's the type of database, ://. Then we have the username that you have to put in, : Then we have the password. And then we do @, and then this is going to be the IP address. I'll say IP-address / host name, whichever one you're using. In our case, that's going to be localhost. And then you have to provide the database name that you want to connect to. So that's the format of a connection string that we have to pass into Sqlalchemy. And then what we do is we say we have to create an engine. So the engine is what's responsible for Sqlalchemy to connect to a Postgres database. So you do engine equals, and then we're going to reference this create engine. And then we pass in our connection string. So we'll say Sqlalchemy database URL. However, this is not filled in yet, so we're going to fill in this data. So go ahead and put in your username. So if you haven't created a custom user, it's going to default to Postgres. Put in your password. So we'll do password 123 for me. The IP address / host name. This is going to be localhost. And then the database name, this is going to be FastAPI or whatever you created your database as. So that's our connection string. And like I mentioned before, it's never good to hard code this value somewhere in your code, because now you've got your password stored in your code and it's going to get checked into GitHub and then anyone can see it. So this is bad practice. However, we will change this in the future. All right. So like I said, the engine is responsible for establishing that connection. However, when you actually want to talk to the SQL database, we have to make use of a session. So we do session local equals session maker. And then we just pass in a couple of values. So auto commit false, auto flush equals false, and then bind equals engine. All right, and all of these values, these are just some default values. Now keep in mind when you're creating the when you use the create engine function, if you are using a SQLite database, you have to pass in this option as the second parameter. So you do the database URL and then you do connection args equals check same thread equals false. This is something that's exclusive to SQLite because I guess it's just running in memory. You don't need to do this for Postgres. You don't need to do it for any other SQL-based database. And then you can see in the documentation, this is what the connection string will look like. So it's just confirming what I already showed you guys. And so we can just kind of keep scrolling down, and we don't really need anything else except for this last line right here. So we have to define our base class. And so all of the models that we define to actually create our tables in Postgres, they're going to be extending this base class. So we could just copy this and then paste it into here. And when I was first doing all of this, it was a little confusing and overwhelming. Just think about that. Just for now, I want you to assume that it's more of just a cut and paste job. It's just a copy and paste. The only thing that really matters that you're going to be changing is going to be that Postgres URL. But everything else, for pretty much every project, you can just copy and paste to this entire code. And now within our database.py file, that's all we have to do. The next thing that we want to do is define our tables. Like I said, with an ORM, we no longer have to create tables within PgAdmin or any CLI utility. We can define it as a Python model. So what we're going to do is we're going to create a new file, and this is going to store all of our models. We'll call this models.py. So every model represents a table in our database. And what we're actually going to do is, let's take a look at our database, and let's see how we can define this as a model within Python. So the first things first, we got to import a few things. And the main thing that we got to import is from our database file, we have to import base. So let's do import.database. Sorry, that should be from.database import base. And then we can go ahead and define our model. So right now we've been dealing with only working with posts. So we're going to create a model for posts. And like I said, this is going to actually create the table within Postgres. So what we're actually going to do is I'm going to delete this table eventually. And then we're going to have Python and SQL and my FastAPI application and Sqlalchemy create it for us on the fly. But I'm going to keep this table for now just so we can take a look at all the fields that we have. So here I'm just going to call this post. And keep in mind when it comes to classes in Python, you always want to make sure that they're capitalized. And then this has to extend base. So this is that base model from Sqlalchemy, and we just have to extend it. And there's a couple things that we have to pass in. The first thing is, what do we want to call this table within Postgres? Because we have this class name, which only Python knows, but we can specify a specific name within Postgres. Now, our table name right now is called post, so I think we should just keep it at that. So we could say __ table name __ equals, and then the name of the table you want. So here we're going to name it posts. And then now we have to define all of the columns, right? So just like we went within PgAdmin and went column by column, creating it, specifying all of their constraints and things like that, we're going to do this within our Python code. So we'll say the first thing is we want an ID. So we'll say ID equals. And then how do we actually create a column? Well, we have to import something from Sqlalchemy. So we'll say from Sqlalchemy import column. So now I can create a column. And then there's a couple of different fields that we have to pass in. So the first thing is, what type of column is it? And so if you go back to our post table and go to properties, right? When we went into columns, the first thing they have to specify is what is the data type. And so we have access to most of the ones that we see in here, but we have to import it from Sqlalchemy first. So the ID column is going to be an integer. And so we have to actually import that. We'll do integer. And now I can pass in integer. And that was a mistake. Let me delete that. And then if we take a look at our ID field, we did say that this was a primary key. So we'll say primary key equals true. And then if you want to, you can also say nullable equals false. All right, so that's the equivalent of doing the not null. All right, then we can define the next column, which is going to be title. And then we call column. This is going to be a string now, but we have to import string from our Sqlalchemy. And once again, this is going to be nullable set to false. So we can't leave that blank. The next column is going to be fairly similar. We've got content. This is going to be a string, and nullable is going to be set to false. Then we got published. This is going to be a Boolean, but we got to import that from the library. And this one can be left as empty. And if you remember, we set a default value for our publish, so it's always going to be by default set to true if we don't pass in a value. And I believe that's how we do it. However, I'd have to double check just to make sure that's what it is. Now, the last column that we'll need to add is the timestamp, but we're going to hold off on doing that for now. And we're going to leave it as such, and then later we'll come back to adding that timestamp in. All right, and so we're pretty much done with our model. And what we want to do is in our main file, we want to copy this command right here. So this create engine, so this is going to create all of our models. So we'll go to our code. I'm going to go to my main file, and somewhere up top, I'm going to create that right there. However, we have to import the right commands. And so the first thing that we want to import is our models. So we'll do from * import models. And then from our database file, we'll say from dot, which is current directory. So we're going to grab a file from our current directory. We're going to import, from our database file, we're going to import engine. And so at that point, that is good to go. And then finally, if we go back to our documentation, the last thing that we have to do is we have to create this dependency. So just go ahead and copy this for now and just paste it in here. And we want to import session local as well. And we should no longer get any errors here. And so what this ultimately is going to do is the session object is kind of what's responsible for talking with the databases. And so we've created this function where we actually get a connection to our database or get a session to our database. And so every time we get a request, we're going to get a session. We're going to be able to send SQL statements to it. And then after that request is done, we'll then close it out. And so it's as much more efficient doing it like this by having one little function, and we can just keep calling this function every time we get a request to any of our API endpoints. And so now that we've got our dependency to actually get that session, for all of our path operations where we want to perform some sort of operation on the database, what we're going to do is inside the path operation function, we're going to pass in another parameter, and it's going to be session equals depends, and then we're going to call this getDB function. So what that's ultimately going to do is this line right here. Don't worry too much about it, but like I said, it's going to create that session to our database so that we can perform some operations and then close it once that request is done. And then we can repeat that process for every single one of our path operations. So anytime you send a request to any API endpoint, you're going to have this being passed into the path operation function so that we can create that connection and then close it out. And like I said, a lot of this is just copy and paste. So once you write this down, even if you don't really understand it, you don't really have to touch it ever again after that. All right, so let's copy this. And what we're going to do is I'm going to create another route or another path operation just for testing purposes because I don't want to mess up any of our other code. And so I'll just say at app.get. And this is going to be at /Sqlalchemy. So this is just to test to see if it works. And I'll say def test posts. And then we want to pass in that code that we just copied right here. However, we don't have a session or depends in this case. So we're going to have to import those. So from our database file, our session is going to be from there. Actually, sorry, that's not actually coming from there. Is it? Do we have a session in here? We actually do not have session here. So instead, this is not going to come from here, actually. Instead, we're going to import that from Sqlalchemy. I'll say import Sqlalchemy.orm import session. And I realize this should be a from. And then we also have to import the depends method from our FastAPI library. And so now if we go down to our route, we should get no more errors and it looks good. And then here we're just going to return status success for now. And then finally, the last thing that we're going to do is we're going to delete our post table. I'm going to do a delete, drop, hit yes. And we have no more tables now. I can close this out. Sorry, I didn't mean to save that. Close that. Don't save it. All right, now we've got nothing. So let's save everything. And pray to God that there's no errors, and so it doesn't look like there's any errors. And just by saving that code and restarting our application, what should have happened is once our code ran and we run this, I believe this should actually create the tables within Postgres. So let's refresh this real quick. I'm going to just right click here, hit refresh. We go under tables. Look at that, guys. We now have our post table, even though we deleted it. So if we take a look at our post table and go under properties, columns, you can see it's got the 3 columns that we defined, well, 4 columns that we defined. And that all comes from our models.py. And so we've got the 4 columns that we defined here. And so whenever we start our application, Sqlalchemy will check to see if there's a table called posts. If it's there, it's not going to do anything. If it's not there, it's going to go ahead and create it for us based off of what we defined in the model. Now, there's one last thing that I want to do just to kind of clean things up. In our main.py file, I don't like having this getDB function within here. I want to keep all of my database code, all of my database initialization code within my database.py file. So what I'm going to do is I'm going to actually cut this out, paste it into my database.py file, and then we're going to import this into my main file so that I don't have to have that in my main file cluttering it up, because our main file is already fairly large. So for my database file, I can import get_db. And now we no longer need session local because it's showing us it's grayed out, so we can remove that. And at that point, everything should still be working. So just to double check, I'm going to delete this once again. And then I'm going to save this, which is going to trigger a reload of our application. And then once our application reloads, if I refresh my database, it should have created another post table. And it looks like it did. And let's just double check that all of the columns are there. And it looks like they are. So everything looks good. In the next video, the one thing that we do need to change is that we have to add the created@ column. So we'll tackle that in the next video. In the last video, we were able to get Sqlalchemy to generate our own post table. However, if we actually poke around with it, we'll see that there's a couple of issues. So if I go to right-click on it and select Properties, and I go to Columns, all right, we can see that all of these fields are set to not null, and the primary key is set to the ID field. So everything looks good so far. However, when I go to the Published column and I go to Constraints, I can see that the default isn't set. And so if we go back to our code, I actually made one little mistake, right? This default is not going to give us what we need. Instead, what we need to do is we need to set this to server default, because it's ultimately the Postgres server or the database server that's going to actually send the default. So I'm going to put it in quotations as a string. We can just set this to be true. And then if you haven't added this, go ahead and add nullable to false. I'm going to make all of my columns not allowed to be empty. That's because the server is going to add the default to true for this. So let's try this out. Now, if I hit save right now, and I go to my Postgres database, and then we can just right-click on this, hit refresh, and then we do properties again, and I go to column, and then we go to go to the publish column. We'll see that there's no constraints. And so this is kind of a limitation of Sqlalchemy, because Sqlalchemy will generate your tables, but it does it in a very simple manner. What it actually does is, if I go to my main.py file, and then it runs this code, I believe this is the code that actually creates the tables. What it does is it'll go through all of our models and it will look for a table named called post. If it doesn't exist, it will then create one based off of these rules. However, if the table already exists, even though we've changed the different attributes, the columns and things like that, if it finds a table with that name already in there, it's not going to touch it. So it's not going to help us modify tables and things like that. In fact, if you actually take a look at the documentation, I've got so many tabs open. Let's see if I can find it right here. I search for Alembic. And so normally when it comes to creating your tables, when it comes to handling migrations, which is a term that's used for changing the columns and the schema of your tables, then you want to use another software called Alembic. Sqlalchemy isn't really meant for handling database migrations or making changes to it. So that's why we don't see it automatically make those changes. So for now, what we're going to do to get around this limitation is I'm just going to cancel out of this and we're just going to delete the table. So we'll drop the table and then we'll go back to our code and then I'm just going to hit save. And so now that it runs again, it's going to look for a table called post. Since we deleted it, it's not going to see it. It's going to then go ahead and create our table. And now if I just right click on tables, hit refresh, we should see that we have a post table. And if I go to properties, we can then go to columns, published, And then if we go to constraints, we can see the default set to true. So it looks like that fixed that issue. Now, the second thing I want to do is I want to add our timestamp column, because that's very important. We need to know when a post was created. So let's create a field called created _@ column. Now, what's the column type going to be? Well, we're going to use a column type of timestamp. So type in timestamp. We can let VS Code automatically import it. But all it's going to do is it's going to import it from SQL, Sqlalchemy.sql.sql types. And then within here, we have to pass in a property of time zone equals true. So this is going to also add in the time zone. And that's going to be a capital T. And the next thing we want to do is provide it's going to be nullable set to false. So it can't be left empty, but we're going to give it a default value if the user doesn't provide it, which they never will. And so we'll do server default. But we have to do something a little bit different. Here I have to import a function or a method called text from Sqlalchemy. So from this right here, Sqlalchemy.sql.expressions, I'm going to do text. And then here we're going to do now, right? Just like we typed in within our Postgres database, if we wanted to manually do this, we would just go under the column. Let's say we had to create that column. We can just go in there, go into constraints, and then type in now like that. And that's going to generate a timestamp. So we're doing the same thing, but we're just doing it through Python code now. So once again, we'll save this. I'm going to drop this table so that we recreate it. And then we'll save it one more time. This is going to trigger a reload and then a refresh of the table. We should now see it. So let's go into properties. Let's take a look at our columns. We've got the created at column. And then if I go under constraints, we can see the default is now set to the current time. So we've got that working. Let's just quickly test this out. So I'm going to go into view, edit all rows. And I'm just going to create a post. We'll save this and let's make sure all of the default values get set. Looks like that's good. And then looks like the time is set just right as well. So now that we have verified that Sqlalchemy has created the proper tables within Postgres, it's time to go ahead and create our first query. And like I mentioned in a previous lesson, with Sqlalchemy or really any ORM, the way we do queries is going to be a little bit different. We're no longer going to rely on regular SQL. Instead, we're going to use basic Python methods. And so go to your main folder, your main file, right? And we saw this test route that we defined. So what we're going to do is we're going to run our first query within this test route. And then afterwards, we can go ahead and delete it. And then we can update all of our pre-existing path operations. And so like I mentioned before, anytime you want to perform any kind of database operation with Sqlalchemy within FastAPI, we want to make sure that we pass it as a parameter into our path operation function. So you just call db. So we're saving it inside a variable called db. And then we're just calling the session object. And then we're calling the getDB function within depends. So this makes it a dependency. And so if you already forgot what that is, just go to your database. You can see that it's this function right here. So this is going to actually create a session towards our database for every request to that specific API endpoint. And then it's going to close it out once we're done. Right, and then within main, there's one thing that we have to import, and that is models. So you just do from.import models. That's going to import this specific model so that we can actually make queries to it. Right, and to make a query, right, we're going to access that database object, which is getting passed into our function. And then here we want to tap into the query method. And then we have to pass in the specific model for the table we want to query. We only have one model in this case, which is our post model. So that when we use this specific model, it's going to allow us to make a query to our post table. And here, so we'll call models.post. So that's going to allow us to access that model. And then from here, what we can do is we have a couple of different methods that we can run, but since we want to query all of our posts, we just do all. So this is going to grab every single entry within the post table. And then here we could just save this as a variable called posts. And then for the return statement, I'm just going to say we're going to return data. and then posts. So let's test this out now. And I'm going to go to get posts. Actually, I'm just going to create a new test route, so a new request. And I'm just going to copy the URL. And then this is stored in Sqlalchemy. So let's try this out. And this should result in us getting just one post. So let me just double check my Postgres database just to make sure that we only have one post. So I'm just going to open up the query tool, and we'll just do select star from posts. Yep, and it looks like I only have one post, and so that's why we only got one post in our request. And if I add a new post, and save that, and we make a new request, we should get 2 posts. So that verifies that we are successfully connecting to our database and we are successfully retrieving those posts. And so I want you to stop and really take a look at how the queries vary when it comes to working with an ORM versus working with regular SQL. Because if we actually see the path operation for getting posts at /posts here, this is where we're using regular SQL. So here we do select star from posts. But if you take a look at this, there's no SQL here, right? We're just tapping into the database object, and we're going to call a query. And then from here, we have to tell it what specific model, which in this case, remember, these models represent tables. And then we just say, I want all posts. Now, what's even more interesting is if I remove this, and then for now, I'm just going to hard code, successful, just some random data. I'm going to do a print posts. So right here, we're calling the database object, and then we're calling query. So what actually happens when we just do this? Well, I'm going to save that. We're going to send a request. We're not going to get any data back. That's to be expected. But take a look at this, right? We're actually taking a look at what the query object returns. And you can see that it's just returning a regular SQL statement. So it's saying, I want you to return post.id, and then it's just renaming it post_id. Then I want to grab post.title. We're renaming it as post.title. So it's grabbing all of the columns, and then we're going to grab it from our post table. So it's really no different than just running, select star from posts, essentially. That's all it's doing. But it's just renaming all of the columns to be a little bit more easy to read. So you can see that these queries, this query object is just performing SQL. So it abstracts all of the SQL away from you, and it handles all the logic of generating the SQL so that you don't have to know, or you don't have to have as solid of an understanding of SQL. And this allows you to really focus on building out the API. This allows you to focus on working with Python and less with SQL and the databases themselves. So now we know when we call query, this actually creates the query. However, to run the query, we have to run a specific method. So there's a couple of methods that we can run. But if you want to grab everything, then you just call all, and then it's going to take this SQL query, and then it's actually going to run it against the database and then return it. But until we call this last method, it's nothing more than just a SQL query that hasn't been run yet. All right, so now that we know how to fetch all posts, let's just go down here, right, and let's just put in this logic. So this is our actual endpoint for retrieving posts. This is our get posts. And what we're going to do is I'm going to comment this out just so that later down the road, if you guys want to just take a look back how you do it with regular raw SQL, you still have that within the code base. And anytime you want to work with the database, remember, you have to pass it in to the path operation function. So this is going to make it a dependency. And you'll see by doing it like this, it'll make testing a lot easier. And then we can just copy this right here. And then we're going to return the post. So let's test that out. So now if I go to get posts, hit send, you can see that we successfully retrieved both of our posts. All right, and it really is as simple as that. And then in the next video, we'll start taking a look at how we can create posts and so on. In this video, we're going to start tackling how to create a post using a ORM, or specifically Sqlalchemy. So once again, I'm going to copy out or comment out all of the SQL code. And what we're going to do is we're going to see how we can actually create a brand new object, or a brand new post in this case. So first things first, anytime any of your path operations need to work with the database, we need to make sure that we copy this exact input argument into the path operation function. This is going to give us access to our database object so that we can actually make queries and make changes to our database. And by passing it in like this, it's going to make it a dependency, and it's going to make it a lot easier for testing and things like that. Technically, you don't have to do it like this. You could just import it directly in there. However, by doing it like this, like I said, testing becomes a little bit easier. All right, so we've got our models, right? And we have one specific model. So this model represents our posts. And so to create a brand new post, we have to reference this model and pass in the specific fields that we want to create a new entry with. So first of all, we have to make sure we import that model. And you can see that we are importing all of our models by doing from.import models. So we can access models.post in this case to access that specific model. And so here I'm going to do models.post. And then we have to pass in the properties of the brand new post that we want to create. And so what are the properties, right? If you take a look at our SQL statement, we need the title, the content, and the published Boolean, right? And that's all going to be derived from the request that we get, which is going to be stored in the post object. So I can reference all of those fields. So I can say the title for the brand new post is going to be set to whatever the title the user sent it. And that can be accessed with post.title. The content of the brand new created post is going to be content equals post.content. And then the same thing is going to be for published. So it's going to be post.published. Right? And if you take a look at this code so far, this doesn't look too different from the SQL statement, right? This says insert into posts, and then we pass in post.title into the title, post.content into the content, and then post.published into published, right? And so this is pretty much exactly the same thing. We're not doing anything different. We're just having Sqlalchemy handle all of that logic so we can do everything in just standard Python code, and there's no SQL anymore. All right, and the next thing that we want to do is, well, let's save the result as new post. And let's see what happens. So I'm going to save this. And then we're going to set a little query. So first of all, I'm going to create a new post. I'm going to call this Welcome to Funland. So much fun. Okay, and so then we will send a request. And we got some data back. And so it looks like it worked. However, take a look at our data. We've got a title, we've got a content, and then we've got published, but where's the ID? Where's the created at field? All of the fields that the database creates. So this makes me suspect that this didn't actually work. So let's go to Postgres and then go ahead and make a query to your table. So select star from post, that's going to grab all of them. And you'll see that based off of the title, Welcome to Funland, I do not have that in there. So it looks like this was not successfully able to create a post within our database. So let's take a look and see what went wrong. And if you actually take a look at the previous method, right, you could see that we actually have to commit something to the database. So we can create an entry, but it doesn't actually get pushed to the database until we do a commit. And so I'm suspecting that we probably have to do a similar thing. So when it comes to Sqlalchemy, what we need to do is, first of all, we have to tap into the database object now. We want to say db.add, and then we're going to add this newly created post. So this is going to add it to the database. However, just like with the connection.commit, we have to commit those changes. So we do db.commit. And then the last thing that we need to do is, if you take a look at our SQL statement, we have this returning star. So that's going to return back the newly created post. With Sqlalchemy, it's a little bit different, right? Because we don't really have access to that underlying SQL code. We can't add a returning statement to this. So the way that you do this in Sqlalchemy is you do db.refresh, and then you pass in the new post object. So what this is going to do is we create a brand new post, we add it to our database, then we commit it, and then what we're going to do is we're going to essentially retrieve that new post that we just created and store it back into the variable new_post. And so all of this code should be identical to this code. And so now if we will just return back new post, and I think that should fix our issue. So now if I hit send, right, we do see an ID and we do see a created at field. So it looks like it worked, but we want to double check within Postgres. So if I hit run, and we can see welcome to Funland. So it looks like it's now successfully working. And before we wrap up this video, there's one thing I don't like about the way we've done things, right? And this isn't necessarily going to break or cause any issues. However, you're going to see it's very inefficient depending on what your models look like. Now, our model has only a couple of fields, and the user only has to really pass in 2 to 3 fields, which is title, content, and published. So it's not that big of a deal, but imagine if we have a model with 50 fields. There's no limitation, right? You could put as many fields as you want. Well, then things are going to get a little bit more difficult because if you see, we have to extract all the fields from our schema, right? And then we have to kind of pass it in. So we have to say, oh, title equals post.title, content equals post.content, and then published equals post.published. Now, if we have 50 fields, we're going to have to do that 50 times, and that's a little inefficient. And there's actually a much easier way to do it. And the way to do this is we have access to the post object, which is, this is a Pydantic model, so it's going to ensure that it matches the schema that we set. And we want to say post.dict. Now, we know that's going to convert it to a regular dictionary. So if I do a print, save that, and then just send a request, right? Take a look at this. We've got a regular Python dictionary. However, we need to be able to automatically take that dictionary and convert it to this format where instead of having, title like this and then welcome to Funland, it's going to be title equals and then post.title, content equals post.content. So how do we do that? Easy. All we have to do is unpack the dictionary. So you just do **, and it's going to put it into this exact same format. So we can remove all of this and just say ** post.dict. And that should ultimately do the same exact thing, except now if we go back to our database or our model and add in extra fields, it's going to automatically unpack all of those fields for us so we don't have to manually type it out. All right, we'll save that. I'm going to just put in some extra text just to make sure we can verify that. And I realized we got to remove this print statement. It's going to throw an error. Then we'll hit send. It looks like everything worked. Let's go to our database, search, and it looks like it worked. So you can see that if we go back to our code, a lot cleaner than having to type out each one of those fields. And we can put this all in one line, so it looks a little better. All right, so now it's time to handle querying for an individual post. So a post by a specific ID. So once again, we will comment out the SQL code. And we will do this using Sqlalchemy. So once again, copy the database dependency right here, and then just pass it in. And this should actually be an integer. I don't know who changed that. I may have left that in from the previous video. Yeah, it should be an integer. Okay. And now what we want to do is, just like we saw when it comes to querying all posts, we have to do db.query, pass in the specific model that we're interested in. And then we're not going to do a .all because we don't want all the posts. So we're going to have to take a look at a different query operation. So I'll say db.query models.post. And then we want to filter. So we want to pass in a filter. So this is the equivalent of doing like a where. You can see that we filter by doing where ID equals, and then we pass in the ID. In this case, we're going to filter. And then here we say whatever the models.post.id is. So this is going to look through all of the posts in our database, and it's going to take a look at all of their IDs. And we want to see whenever that is equal to the ID that the user requested. So the ID from this query parameter or this path parameter. So we say when they're equal, that's the one we want to return. And if I do a print of, first of all, let's save this to a variable. So I'll say post equals, and then I do a print of post. Save that. I'll open up the terminal, and then we'll send a request for an individual post. So I'll hit send. We get a whole bunch of errors. That's okay. Let me see. And that's fully expected. All right. And then we can see the exact SQL statement that this query actually made. And so here we're doing db.query and then filter, and we can see that we got the select statement. And then here it's just grabbing all of the columns, right? But then you can see from posts, and then it says where post.id equals ID_1. All right, and so this pretty much looks exactly like we wanted, right? If you look at our SQL statement originally, it doesn't look any different. And so at this point, I think this should be good to go. However, right now it's still just raw SQL, right? We could see what the SQL statement is, but if you recall from the previous one, we had to do a .all to actually send the query. So for us, we can do a .all technically, and this would work, right? It would grab all the posts who have an ID of whatever ID we passed in. However, there's one little issue with doing it like this, and that is that once it finds one post, it's going to keep looking through all of the posts to see if there's any other ones. But we know that only one post can have this specific ID. So it's a waste of Postgres' resources to continue looking when we know there should only be one. So anytime you know there should only be one, instead of doing a .all, it's better to do a .first. So it's going to find the first instance and going to return that. So it's going to save us some little time. It's going to be a little bit more efficient in that case. All right, let's save this and let's try this again and let's see if this works. All right, it looks like it worked. We got a post back. No errors. So I think everything is good to go. Let's go back to our Postgres database. We do see that there's one with an ID of 4. So it seems to work, but let's test this out with a random ID of like 666. And we should get the 404. So looks like that's all we need to do when it comes to fetching an individual post. And I'll remove this print statement. We don't need that anymore. And then we can just conclude this video. All right, so let's move on to handling our delete path operation. So I will comment out the SQL code once again, and then we're going to make sure that we pass in the database dependency into our path operation function. And so for our delete operation, what we're going to do is I'm going to do a query. And this query is going to look exactly like this query. So I can actually copy this one in this case. So all we're doing is we're grabbing the posts model, and then we're going to filter based off of ID. So we're going to look for the ID of the post that we want to delete. And I'm actually going to remove this first. So I'm going to save the query by itself. And we'll save this as a post underscore query. I'll just save it as post. It's okay. We'll understand that that's a query and not an actual post. And then our if statement to check if there actually is a post with that, what we're going to do is we're going to say if post dot, how do we actually run this query? Well, we do first. So that's going to query it. And so if this returns back nothing, then we're going to raise a 404. So really, we haven't done anything different from what we did here. However, if it does exist, so outside of this if statement, I'll do a post dot delete. And then we'll just say synchronized session equals false. I believe that's the default config anyways. I don't want to spend too much time going over this. It doesn't really matter too much, but if you want to read about it, just take a look at the documentation. And if you go under, session basics, you could see them kind of describe all of them. But this option is the most efficient and reliable, so I just went ahead with that one, and it seems to work just fine. So this is going to delete the post, but remember, to actually make changes, we have to do a db.commit. So that'll delete it, and then everything else should and can remain the same. I'm going to go back to my Postgres database. We're going to delete a post with the ID of 6. So we'll go to our Postman. We'll go to our delete operation, and then we'll do an ID of 6. All right, seems to work, but let's double check with Postgres. All right, and now we can see that there's no longer a post with an ID of 6. And then let's test this out with a random post number that doesn't exist. We should get a 404. Perfect. Okay, so it's time to tackle our final path operation, which is for updating posts. This one's going to be fairly similar to, deleting a post or even getting a post by a single ID. So first of all, comment out the previous Postgres code. And because we're going to be interacting with the database, let's make sure we copy the dependency in this case. And then what we're going to do is we're going to do the same thing. We're going to say db.query. I'm going to query models.post. And then we're going to filter on the same thing. We'll say filter models.post. .id, and if that equals to the ID that we're passing here, then we're going to find the specific post we're interested in. So I'll say I'm going to save this as post_query. So right now, we're not actually running the query. We're just saving the query because I haven't run .first or .all. And we'll say the actual post equals post_query.first. So this is going to grab the post if it exists. If it doesn't exist, so we'll say if post does not equal none, or if post equals none, then we're going to send a 404. However, if it does exist, then we'll grab the query again. We'll say post query.update. So we can chain an update method. So we're basically taking this query right here, and then we're chaining the update method, which would be the equivalent of doing an update right here. So say .update. And then what we want to do is we want to pass in the fields that we want to update as a dictionary. So in this case, what I'm going to do is I'm going to hard code the values and just to show you what that looks like. So we'll say title is going to be set to, hey, this is my updated title. And then the next one's going to be the content. We can update that to be whatever we want. And I'll say, this is my updated content. Then we're going to do that same synchronized session equals false as the second property into the updated method. Go to synchronized session equals false. And that should handle the update. And then we would just want to do a db.commit. And right now, this updated post doesn't exist anymore. So we're just going to return successful or something. Doesn't matter. We're going to change this a little bit later on. All right, so let's go to our update. Where's our update post? It doesn't really matter what data we pass in because we're hard coding the values. And so I'm going to update the post with an ID of 1 if it still exists, and it looks like it does. So you can see right now the title is new post. So we'll update this, send, says successful, and then let's go back to Postgres, do a query, and we can see that, hey, look, it got updated. Hey, this is my updated title, and the content, this is my updated content. So that's all we have to do. We just have to pass in a Python dictionary with the updated fields. And so instead of passing in a Python dictionary, right, we can pass in our post schema, right? So that's going to have all of the updated fields, and we can just say post.dict. That's going to return a Python dictionary. So that should be exactly what we're looking for. And then finally, when it comes to returning data, what we're going to do is we're going to run another query. So we're going to say post_query. So we're going to grab this exact query object right here. And then we're just going to get the updated post. So we just grab the first one with that specific ID, and then it should return that. So hopefully you guys understand. And I'm just going to quickly recap exactly what we did. We set up a query to find the post with a specific ID. Then we're going to actually grab that specific post. So we run that query by grabbing .first. If it doesn't exist, we're going to run a 404. But if it does exist, then we can chain the update method to this same query object so that we can update it. And we pass in the fields that we want to update. We'll commit it to our database. Then after all of that's done, we want to make sure we get the updated post and send it back to the user. So we do post_query.first. So let's test this out. And I'm going to put in values because these values now matter. And I'll say, my name is Sanjeev. Python is fun. So let's try this. What happened here? Okay, I forgot to save. Hit send. We get an error. And I realize we have a little bit of an issue. So the schema that we get, where we extract all of the body fields, is named post. But then we also save this as post as well. And so this leads to issues because they're both named the same thing. And so I'm trying to convert this to a dictionary, which only works on the Pydantic model. It does not work on our Sqlalchemy model. So we're going to have to rename these. I'm going to name this updated_post. And then here, this is going to be updated_post. Now let's try that again. Seems to work. Let's check our database though. And we can see that it was successfully updated. And then let's try to update something that doesn't exist. And we get a 404. Perfect. Before we proceed any further, I do want to provide some clarifications on what are the difference between a schema or pedantic model and our ORM or Sqlalchemy model. And I think it's important that you guys understand that. And I do realize that there could be potentially some confusion as to what's the difference between them. Ultimately, what are they trying to accomplish and why do we have both of them? So I've created a couple of slides and hopefully that helps sort things out and hopefully it provides a little bit of clarification if you guys were confused at that. But just to look at our code, you'll notice that in our main.py file, we have one class called post here. And this is extending base model, which actually comes from the Pydantic library. And you can see we're importing Pydantic right here. So this is what's referred to as our schema. We also have and I don't even want to explain it yet. Hopefully you guys already know what it is, but I have a couple of slides that hopefully make it a little bit more clear. But just to kind of show you where this is being referenced, it's being referenced in our path operations. So if you go to our create posts, wherever that is, right here, you can see that we're passing that in right here and then saving it into a variable called post. So we're referencing it right here. This is all about defining the shape of a request. And so that's the Pydantic model. The other model is the one that we have in models.py, which is the Sqlalchemy model. So this Sqlalchemy model defines what our database, our specific table looks like. But let me pull up the slides just to show you guys, with some nice diagrams. So hopefully you guys get a better idea of what that is. All right, so let's start off by going over the schema models or the Pydantic model. So the schema or the Pydantic model defines the structure of a request and a response. That way, when it comes to creating a post, we can define exactly what the request should look like. So when we create a brand new post, we need the user to provide what's the title of the post, what's the content of the post, and optionally, they can also provide if it's published or not, but we've provided a default value so they don't actually have to send that. So what we do is we take the request and then we pass it through the Pydantic model. The Pydantic model will perform a little bit of validation to make sure that all the fields that we need to actually create a brand new post are there and that they are of the proper type. So if it's a title, it shouldn't be an integer. And if it's the published property, it shouldn't be a string or anything. It's just a simple Boolean. So that's what the Pydantic model or the schema model does. It's just there to provide some validation to ensure that the body, all the data fields provided in the body of a request match up to what we want. And that's important because we don't ever want to give the clients, which is the web browser or the mobile phones or anything like that, freedom to do whatever they want. We want to tell them exactly what we need for each specific path or route. And that's for the request. However, we can also do this for the response. And we haven't actually done that yet, but we can actually define exactly what that response should look like. So, as our models get more complex, as our database gets more complex, there's going to be a lot of fields when it comes to your posts and your users that you may not want to send back to the client when we send a response. So we can actually define a model to dictate FastAPI exactly the data fields that we should be sending back. And so that's what your schema and your Pydantic models do. They just ensure that the request and response are shaped in a specific way. Now, the other model is the Sqlalchemy model. So this is the one that we've been working on with the past couple of lectures, right? And these are responsible for defining the columns of our posts table within Postgres, right? So it's going to define all the different attributes within a specific table. And then we use that post model to perform queries to our database. We use it to create, delete, and update entries within our database. But this model is fundamentally different than the Pydantic model. So that's why I created this video. I just wanted to make sure that you guys understood what were the differences between those and understand why we need them both. Technically, we don't need the Pydantic models, but when it comes to building out APIs, you want to be as strict as possible when it comes to what kind of data can we receive and send to the user. And so Pydantic just ensures that everything just matches up with what we expect. So in the last video, I described the difference between a Pydantic model and a ORM model. And there's a couple of things I actually want to do with our Pydantic model. So we've just got one right here where we define what a post should look like. And we use that in a couple of places. So if we go down to create post, we can see we use it there. So it's going to define the structure of the data that we receive from the front end when we want to create a post. And I think we also provide it for maybe updating a post. Yep, we also use it for updating a post as well. So what I'm going to do is I want to create the schemas, or I want to move the schema in this case. Remember, this is what's referred to as a schema. I want to move that to its own file just so that we don't clutter up our main.py file. So I'm going to go under app, I'm going to do new file, and I'm going to call this schemas.py. And then within schemas, if I go to my main.py file, I'm just going to cut this out. And we can paste it in here. And there's going to be a couple of things that we have to import. And so if we go to our main.py, we definitely need Pydantic. That's really all we need, actually. So if I go there and then paste that into there, we should have no issues. And then, this is going to actually break our application because we need to actually import this specific schema. So if I go into main.py, we can see here I'm doing from.import models. So that's going to import everything from the models file. But we can also then import schemas as well. And so now to actually access this specific class post, we just have to go in our main.py file and then reference schemas.post. And so anywhere we use post, which should be right here, we can do schemas.post. And then in our update post as well, we can do the same thing. This is going to be schemas.post because now we're importing it from another file. And what I'm actually going to do is we're going to restructure this a little bit. So what I'm going to do is, remember, these are regular Python classes. And so we get all of the abilities that we have when it comes to inheritance, when it comes to working with these classes. So what I'm going to do is we could define a couple things, right? We could have one for, we could create a class for create post. Actually, that should be capitalized. So create post. And then that's going to extend base model. And then this is going to have all of the fields that we need from the user when it comes to creating a post. And so that's what this would be in this case. And then remember, we also need to handle updating posts. And so we could create another model for that. So in this case, I could call it update post. And once again, that's going to extend base model. When it comes to the fields that we use for an update post, it would be the same exact thing, right? Whoops, that should be right here. And I don't know why it keeps doing that. And in this case, there wouldn't be a default value for published because we want them to explicitly provide each column. And so at this point, right, we could then have two different classes for each specific request. And that's a perfectly valid use case because when it comes to creating, they should provide a certain amount of fields, and then updating it might be completely different, right? Because, let's say in our application, we wanted to make it so that the user can't ever update a post. They can only update one property, and that's the publish. So they can just change whether it's published or not. We could remove this, and this is going to make it so that the user isn't allowed to provide any other fields. They can only pass the published field. So that's why we would want to create different models for each of the different requests. But what I like to do is instead of having one for create post, one for update post, and then one for the, we have to eventually create models for the response, what we're going to do is we're actually going to delete all of this, and we're going to create a class called post base. So I'll do class post base, and then base model. And so this is a regular class. We can just copy all of these fields. And then we can extend that class. So I can take this post base class and I can extend it and say class post create. I want to extend post base. We can say post base. And so it's going to, by default, automatically inherit all of these fields. And so we can just say, for creating, we could just say pass, which means it's just going to accept whatever post base is. So post create is essentially the same thing as post base. But then we can create a brand new one called class, post update. And that's going to extend post base. And we can say that for updating, we can pass in whatever specific fields we want to add in as well. So that gives us flexibility because we can make use of inheritance. So for now, I'm going to remove post update, and we're just going to keep it as post create because updating and creating is going to be fundamentally the same. And that way we can just kind of piggyback off of this post base model and then just create brand new models based off of this. So what I'm going to do is go into my main.py file, and then for schemas, actually, let me save this. Then my main.py file, there's no longer a post. It's going to be post. Actually, it's going to be create post create. I'm going to do the same thing for update as well. That was the update actually. So then the other one is for create post, and then this is going to be schemas.post create. All right, and then the last thing that I want to do in this video is we're going to just delete this test route that we had defined when we were learning about Sqlalchemy. We don't really need that anymore. And then in the next video, what we're going to do is we're going to tackle sending a response back. All right, and as I mentioned within the slide deck, right, just like we can define what a request should look like, we can also define exactly what a response should look like. So we're going to do the same thing. We're going to define a Pydantic model for a response for what a post should look like when we send it back to the user, so that it stricts to a very specific schema, and then we don't end up sending data that we don't actually need to send to the user. In this lecture, we'll take a look at how we can define a Pydantic or schema model to define the exact shape of a response. Because right now, if you actually see any of our path operations, what we do is we just return a post or multiple posts or an updated post. And whatever data we get back from the post, we just send it back to the user. And there may be times where maybe you don't want all of the properties or all of the attributes and columns from our post table to get sent back to the user because, potentially that could be sending him back information he shouldn't know about. Especially when it comes to, like your user account, right? When a user logs in, we don't want to send him back his password. He already knows his password. We don't want to continuously transmit information like that. So there can be times where you do want to remove certain fields or properties. And before we actually get to performing that, we're going to do a little bit of cleanup. Because if we go to really any one of our requests, like if I go to get posts and hit send, you see that we have, within data, we then have the list or array of all of our posts. And then if we look at create posts, right, you can see we always have data and then the actual post. I'm going to get rid of the data field just because I think it's unnecessary and it kind of clutters things. So what we'll do is within all of our path operations, we're going to just remove data. And instead of returning, a dictionary, we're just going to return posts. And so FastAPI will automatically be able to serialize that and convert that into JSON. And I'm going to do that for all of these. We're just going to remove that data keyword for all of them. We don't need to do it for delete, but we do need to do it for update. And so now, if we actually take a look at what this is going to look like, if I hit send, you can see we just get back the post and we don't get that data keyword. Same thing for get post. What does that look like? Perfect. So we don't have the data keyword. Now let's actually define what the response should look like. And we do that with our schemas. We do that with our Pydantic models. Just like we have a Pydantic model for creating posts, which happens to just inherit from Postbase. So post create is just saying that we expect a title, we expect a content, published is optional. And if you don't provide one, it's true. And so we already know how to work with that. Let's create a brand new class for the response. So, this handles the direction of the user sending data to us. And now we want to handle us sending data to the user. So I can create a brand new class. We can call this post response, because it represents the response, or we could just call it post. It doesn't really matter. I'm going to call it just post. And then we're going to extend base model because all of our Pydantic models have to extend base model. And then from here, what we have to do is we have to specify all of the fields that we want in the response. So we want to send back the title because that makes sense. So we'll send back the title. We'll send back the content, which is going to be of a type string. And then we'll send back published as well, which is going to be a Boolean. And let's see what that looks like. All right, so this still looks exactly the same as the other ones. But if you actually see right now, for any of the requests that we sent, we get back the ID as well as the created at field. But since we didn't include those two fields, we shouldn't actually send it back to the user. So let's actually try this out. And so I'm going to save this. And then to actually define the response model, under a specific request, we'll start off with the create request or create posts. And then within the decorator, we just pass in another field, and this is called response model. And then you can just let VS Code automatically select it. And then here we just reference schemas dot and then the name of the class. So let's try this out and let's see what happens. So now if I create a post, okay, we get a 500 error, and let's see what happened. It says value is not a valid dict. So it looks like Pydantic is saying that, when we try to send the response, the data we got back was not a valid dictionary, right? And because Pydantic the Pydantic class works with dictionary. It takes a dictionary and then converts it to that specific model. So what exactly happened here? Why is this causing an error? Well, if you look at the documentation, and where is it? Right here. If you go under SQL Relational Database, it says that for your models, your Pydantic models, we have to add this extra config called class config ORM mode true. And it explains exactly why we need that, right? Because by default, the Pydantic model will only read it if it's a dictionary, right? And that's what it's expecting in our code because we see that error. It's not a valid dictionary. And that's because when we actually make this query, right, new post, this is actually not a dictionary, it's a Sqlalchemy model. And so Pydantic has no idea what to do with the Sqlalchemy model. It only knows how to work with dictionaries. So we have to tell it to actually convert this Sqlalchemy model to be a Pydantic model. And we do that by passing in this specific text right here. So this is going to say ORM mode true. This is an ORM model, and it's going to tell Pydantic to ignore the fact that it's not a dictionary and go ahead and convert it. So we can just copy this text and add this to our code for our post model. And that should be properly indented. So now that should be good. And let's see if we still get an error now. Let's hit send. Look at that, we got it. It seems like everything worked okay, 201 created. But take a look at the fields that we got back. We just got title, content, published. And that's because our model explicitly specified title, content, published. Now we know if we go to our Postgres database, we do have an ID field and a created at field. So if we wanted to add those, we can say ID, which is going to be of a type int. Let's save that and let's see what that looks like. Right now we get the ID back. Perfect. Well, do we want the created at time? I think, your front end code probably wants that as well. So let's go ahead and add that. So here we'll do created at. Now, what should the type for created at be? Right? It is ultimately, a date and time. Well, we could do, something like a string, but what we can do that's better than that is we can import from datetime, import datetime. And so now we can say that the time, the created at, is going to be of type datetime. And so this is an extra little bit of validation to make sure that what we send back is a actual valid datetime. Just make sure that you import it in this file. And so now if I send this back, we now get created at as well. Right? So this is how we ultimately define the data that we send back. We can specify exactly the fields we want, and that way we can ensure we don't unnecessarily send data that shouldn't be getting sent. Right? And we can do this with anything. I can just send back the ID if I really wanted to. Now we just get the ID, right? You see there's a lot of flexibility and a lot of power when it comes to defining your responses, just like we had when it comes to defining our requests. And with APIs, like I always say, make sure you explicitly define the exact data you want to receive and the exact data you want to send back to the client. Now, before we move any further and wrap up this video, you'll see that there's a lot of duplication, right? Because this post model for the response, right, it needs title, content, published, and then we're just adding ID and created at, right? And like I said, when it comes to a real application, you're going to have so many more fields, so many more columns. It would be such a pain to have to repeat both of them. And so that's why I ultimately created this post-based class, because I can extend the post-based class. And what that's going to do is that's going to cause me to inherit the title, content, and publish fields because they're already defined in here. And so I can just remove that. Right? And so then I can just specify ID and created at, and then it's going to inherit the other three from the previous class. And so now if I try this again, I send it, you can see that I get the same exact result, but I only had to specify the new columns I wanted to add in the response. So this is really no different than working with any other model in Python. We get access to all of the usual features like inheritance, so we can help reduce the amount of code that we actually write. All right, and so now let's go ahead and update all of the other path operations as well, because we can see that we only did it for create post, but let's go ahead and do it for get an individual post. So this is going to be the same exact response model. And we can just reference schemas.post. And we'll do the same thing for our update post as well. We'll say response model equals schemas.post. And then let's just, double check. So get one post. This should work just fine. Perfect. And then update post. And it looks like that works as well. And the last thing that we need to do is get all posts, right? So right now, if we do get all posts, where is that? Right here. We still haven't sent that. So let's do response model equals, and then we can say schemas.post. And then let's try that out. We hit send, we get an error, and this is expected. And I want you to stop and, think about what exactly is happening, because we are returning a list of posts, and it's trying to shape that into one individual post, right? We got a list of posts. We should be sending back a list of our schema post. So how do we do that? Can we just put a bracket or something like that? Will that work? Let's try this. Well, it looks like there's an error. So this doesn't seem to work. So how can we specify we want a list of posts? Well, we have to import something from the typing library. So we have an optional from the typing library. We can also import list. And so now, if I go back to our get posts, I can say list. And so now if I hit send, we should get back all of our posts. So here we're just specifying we want a list of our specific schema post model. And that's just going to allow us to get a list of posts. Very simple. In the next couple of sections, we're going to focus on creating user functionality. And what I mean by that is having users be able to actually create an account within our app, being able to log in, as well as being able to create posts that are associated with their specific account. And so the first thing that I want to tackle is handling user registration. So we need to be able to provide a way for users to create a brand new account. And the first thing that we have to do is we have to define our model, or more specifically, we have to create a table within our Postgres database that's going to hold all of our user information. And so since we're using Sqlalchemy, we're going to create a new ORM model, just like we did for Post, so that we can define what our Postgres table ultimately looks like. Let's create a new class, and I'm going to call this class user. And this is going to extend base. That's just a requirement for any Sqlalchemy model. And then here we're going to provide the table name within Postgres. So I'm going to say the table within Postgres should be called users. Then let's go ahead and figure out what are the different columns that we need. And so we're going to handle registration by having the user provide an email address. So we should have a column for us to be able to store their email. So we'll say email equals column. This is going to be of a type string. And we're going to say that this is nullable is set to false. So they have to provide an email. And then on top of that, we shouldn't allow someone with a specific email to register twice with that email, right? There should only be one account with one specific email. So we're going to say that the unique constraint is set to true. That's going to prevent one email from registering twice. The next thing that we need is for us to be able to store the user's password. So we'll create a column for password. This is once again going to be a string. And then once again, the nullable is going to be set to false because we shouldn't be able to let them create an account without a password. And we don't need a unique constraint because I don't care if two users have the same password, it's up to them. And then finally, just like we had with the posts class, we're going to have a column for ID. So every user is going to have a unique ID. So I'm just going to copy and paste that. And so at this point, I think that's all we need for our user class. If you save it, it's going to reload the application. And it looks like I got an error. And I realized this should not be str. This should actually be string. That's my mistake. And then actually, before we do anything else, I want to create it at column as well. So we can just copy this and then paste that in there. Like I said, pretty much anytime you create something in your database, you want to make sure that you record when it was created. You never know when you'll need that information. And so we've restarted our application. Let's go to Postgres. And under my tables, I'm just going to do a refresh. And it looks like it went ahead and created our users table. And if we do our users properties, we should see that it created all 4 columns, and all of the necessary constraints should be set there as well. And so let's just play around with this in Postgres just to make sure it works, because I don't really trust Sqlalchemy ever. So let's do right click, and then we'll do view edit data. So right now there shouldn't be any users. And let's create a new user. So I'll say this is john@gmail.com. Password, just put whatever you want for now. And then if we save that, right, it then successfully created a user. We got the generated ID as well as the created at timestamp. And then let's create a new user. So I'm going to use the same exact email. So this should throw an error because we shouldn't be able to register again, some random password. And then if I try to save this, we should get a unique constraint on user's email error. So perfect. So that worked. And I'm just going to change this to be cindy@gmail.com. We'll save that, and it should create those users. So perfect. So we've got the first step done when it comes to defining our table. The next thing that I want to do is we will create a new path operation so that a user can actually send his username and password to our API, and then we can actually generate that user. Just like we did with posts, we're going to create a new path operation for creating a new user. So we'll go to the bottom of our main document, and I'm going to create a new function. We'll call this create user. And so just like we have for creating a post, I'm going to copy this decorator and we'll rename it. So it is going to be a post request, but it's going to be sent to the URL of users because we're no longer working with posts. And keep in mind, you get to select whatever URL or path you want to use. If you want to call this, it's bad practice to call it create user, but you can choose whatever you want. I think it makes sense to call it users. And anytime you create something, remember the status code should always be the default 201. And I'll get rid of the response model for now, just to keep things simple. Now, we're ultimately going to be using our database to create a brand new user. So let's go ahead and copy this DB right here from all of the other path operations, because that's going to have to go in there. And then anytime we want to, receive data from the user, because the user is going to have to send the email he wants to register with, as well as his password in the body of the request, it always makes sense to define a specific schema so that we can ensure that the user does provide both of those. So just like we did with posts, we're going to create a brand new schema. And I can call this user, or we can call this user. I think this one, it makes sense to call this user create. So this is going to handle just for creating users. And we're going to inherit from base model. And for the user create, there's going to be an email field, which is going to be a string, as well as a password field, which is going to be of a type string. And when it comes to validating the user, right, it's going to check to make sure that an email is provided and a password is provided. However, we can get a little bit more granular than that. If you actually go to the Pydantic documentation, we also have a field called email string. So this is going to validate that the email property is a valid email. However, we need to have the email validator library installed, but that should automatically have already been installed for us when we installed FastAPI with the all flag. And so if you do a pip freeze, right, we should be able to see that we have our email validator already installed. If you don't have it installed for some reason, just go ahead and do a pip install email validator. And that should install that library. And so what we'll do is from the Pydantic library, we're going to import email string. And then we can say this is going to be email of type email string. So that's going to ensure that this is a valid email and not just some random text. Then back in our main.py file, just like we did before, we can say user, and then this is going to use schemas.userCreate. And so the email address and the password is going to be stored in an object called user. There's going to be a Pydantic object as well. And if you forgot how to save data to the database or create something with Sqlalchemy, just go ahead and take a look at the create posts. And we can essentially just copy this. And we're just going to rename a few things. So we'll say new user. And then we're going to grab models.user now. And then once again, what we want to do is we want to take the user that we get back from here, from our schema. We want to convert it to a dictionary and then unpack that dictionary. Then we're going to add it to our database. We're going to commit it. Then we're going to refresh it so we see the brand new user. And then we can go ahead and just return new user. All right, let's give that a shot. And then within our Postman, we can right click on this, select add request. We're going to name this create user. This is going to be a post request. And then in the body, we'll go to raw once again, and then JSON. And then here we can pass in the email. We'll give it some random email. So I'll call this carl@gmail.com. And then password. This will be password 123. All right. And then for the URL, just copy posts. And then here we'll just change this to users. All right. So let's give this a shot. Let's see if this works. And it looks like it worked, right? We got the email, we got the password back, we got the created at, and we've got an ID. But just to double check like we always do, go ahead and go to your users table, select query tool, select star from users now, because we're now querying no longer the post table, we're querying the users table. If I run this, we can see that we do get the new email that we created, or the new user that we created with carl@gmail.com. Now, as a quick test, just to make sure that email validator works, I'm going to change this, and we'll just say some random text. This is obviously not a valid email, so let's see if it properly creates that user. And it looks like our schema validator worked and says value is not a valid email address. So you can see the powerfulness of the Pydantic library being able to automatically check to see if that's a valid email address. All right, but one thing I didn't like about creating the user is that if we change this back to a valid email, I'll just call this new user@gmail.com. We create that user. You see that he gets his password back. Now, why in the world would he want to see his password back? There's no reason to ever send the password back to the user at any point. And so one of the things I want to do is I want to define our response model so that we never send back the user. And I think you guys should already be able to do that, but I'll walk you through how to do that. So let's go to our schemas. We've got our user create. Let's create a new class, and I'll call this user out. And so this is going to be the shape of our model when we send back the user to the client that requested it. It's going to extend base model as well. And here we're going to send out a couple things. So there's going to be an ID now. The user should know his ID. Email. That's going to be of email string again. And then we'll just leave out password. So by leaving out password, we won't ever send it back. But just like we did with the post model, remember, this is going to be a Sqlalchemy model that we get, and we need Pydantic to convert it to a regular Pydantic model. So we need this config right here. And then in our path operation, we can set the response model to be schemas.user out. All right, and then now if I just change the fields up a little bit, just create a new email, you can see that we get the ID and the email as well, but there's no password. And that's exactly what we want. And so now you guys should be fairly comfortable with being able to define a response model as well as a request model so that you can pick and choose whatever field you want. One last change I want to make is I want to go ahead and just add the created at field as well. And we can just copy this right here. So now just create another email, right? And now we get the creative field. So we got all the fields that we want. In the last lesson, we handled the logic for creating a new user. But for a lot of the people that are familiar with security, I'm sure you guys may have had a little bit of a heart attack because we did something that's very, very frowned upon. We took the user's password and we just stored it as plain text within our database. And some of you might be thinking, well, what's the problem with that? Right? It's in our secure database. Well, right, our database is secure for now, but there are hacks. There are things that can happen. You know, all of these records could potentially get leaked in some fashion. And it's very dangerous to just have a user's password just stored in plain text like this that anyone can read. So when it comes to working with passwords and databases, what you always want to do is you want to hash the password. So we never store the actual password in our database. We just store a hash of it so that if it does get leaked, well, no biggie because it's ultimately just a hash. You can't really reverse engineer that hash and get the original password back. So in this lesson, we're going to focus on hashing the password when a user first registers so that we never actually store the raw password within the database. And within our FastAPI documentation, they have a good article that kind of covers how to do that. So if you go under security and then OAuth2 with password, it'll show you what we actually need to do when it comes to hashing. So there's two libraries that we need to install. Right? We need passlib. And so that's going to kind of handle the hashing. But we need to actually specify a specific algorithm because passlib can work with different algorithms. One of the more popular ones is bcrypt. So we'll need two different libraries. We'll need the passlib and then the bcrypt library. And we can just do that by running pip install passlib bcrypt. So I'll just copy this. We'll go to our application. And I'm just going to run that command. All right, and then let's just do a pip freeze just to make sure it got installed. And we see passlib there now. And then do we see bcrypt? And we see bcrypt in there as well. So we've got both of the libraries that we need to actually perform the hashing. So let's go to our main file. And somewhere up at the top, I'm going to import from passlib.context, import crypto context. And then what we need to do is, someplace below that, we have to define this setting right here. So we do pwd_context equals, and then we reference that crypto context. And then here we say schemas equals brackets bcrypt. And then we'll do deprecated equals auto. All right, and so basically all we're doing is, and this should actually be a string. All we're doing right here is we're telling passlib what is the default hashing algorithm, or what hashing algorithm do we want to use. In this case, we want to use bcrypt. So that's all this is doing. Now, when we go to our user registration down here, we have to do a couple things. And so before we actually create the user, we need to actually create the hash of the password. So the first thing is, whoops, we're not in JavaScript land. We're going to hash the password, which can be retrieved from user.password, right? Because that's going to be stored inside this object. And so how do we exactly do that? Well, what we can do is, all we have to do is reference that password context, right? If you forgot what that is, just go all the way up to the top. That's this command right here. So we reference password context. And we call the hash method. So that's going to perform a hash. And then we just pass in user.password. And then we can store this in a variable called hashed _ password. And then what we're going to do here is we're going to take the user.password and we're going to set that now to the new hashed password. So that's going to update the Pydantic user model. And then at that point, we can just leave everything as is, right? So we hashed the password, so we got a hash, and then we stored it under user password, and then everything else can just be kept the same. So let's actually try this out. And let me just double check to see there's no errors, and there isn't. So let's create a brand new user, and I'll call this mark@gmail.com. Same password, that's fine. Send it. Looks like everything worked. And then let's just run this. And then if you see that most recent user, you can see that we no longer store the raw password. We store a hash of it. And so that's going to help it be a little bit more secure, because if it does leak, then the hackers will only get access to a hashed password and they can't exactly convert it back to the original password. That's the great part about hashing. It's a one-way street. We hash it, we only get the final password. You can never put it back into a function to convert it back to a password. Now, one thing I want to do is I want to extract all of the hashing logic and store it in its own function. So I'm going to create a new file. I'm going to call this utils.py. This file is just going to hold a bunch of utility functions. And what I'm going to do is I'm going to go to our main file, and I'm going to remove this line or cut it. And we're going to paste it into my utils file. And then we're also going to cut this out. And we're going to move all of this logic into here. And then we're going to define a function that we can call. And I'm going to call this function hash. And it's going to take a password, which is going to be of type string. And all it's going to do is it's going to return pwd context dot hash of whatever the password the user passes in. And that way we really extract and place all of the hashing logic into one file or one function, so we don't have to import all of this nonsense into other files. And then in our main.py file, we can import utils. And then down here, what we can do is, instead of calling this, I can just call utils.hash. And then we'll pass in the user.password again. And this shouldn't really change anything else in our code. Let's try this again. I'll just add a 1 here. Send. Seems to work. Let's just double check. And the second user, the password was properly hashed. The next thing I want to do is I want to set up a route or a path operation that allows you to fetch and retrieve information about a user based off of their ID. And there's a couple of different reasons why I want to do this. One of them is it can be part of the authentication process. So depending on how you set up the front end, if you decide to, set up JWT tokens to get sent as cookies, then the front end may not actually know whether it's logged in or not. And so a lot of times you'll see some APIs have an endpoint to let you kind of retrieve information about your own account. And so if you're able to access it, that means you're logged in. If you're not, then you know that you need to fetch a new token. Also, there's other reasons why you want to do this too. If you're taking a look at something like Twitter, right? You need to retrieve a user's profile if you want to view it. And so in your API, you're going to have to set up a route so that people can retrieve someone's profile information. And so that's why I want to set up this route. I haven't really decided what we're going to ultimately do with it, but for now, I just want to set it up so that you can retrieve information about a specific user based off of their ID. So let's go to the bottom of our code here, and we'll create a new path operation. And I'll call this get user. And before we do that, I'm also going to set up the decorator. So this is going to be a get operation because we're going to retrieve the information about a specific user. And the specific path is going to be /users and then /ID. So kind of like how we did when it comes to retrieving a specific post, we're going to pass in the ID in the URL. And then we have to extract the ID. And I'm going to make sure that we validate it as an integer. And the next thing that we have to do is, since we're going to be interacting with the database, we need our DB right here. So we'll copy that. And then in our actual function, we're going to do a quick query. So we'll do db.query. And then we'll grab models.user. And I'll say I want to filter and then look for something with models.user.id equals, and then it's going to match up with the ID that they requested. And because there should only be one user with a specific ID, we're going to just grab the first one so we don't spend extra resources looking through the rest of our database. And we're going to store this in a variable called user. All right, and then just like we did for fetching a specific post, if a user was not found, so if not user, we'll say we want to raise an HTTP exception. And we'll say the status code equals 404, whoops, HTTP status dot, and then we'll grab 404. And the detail is going to be user with ID, and we'll pass in the ID. Does not exist. But if the user is properly found, we will return the user. And it looks like there's some kind of weird issue with my formatting. So, all right, there we go. And so let's just quickly test this out. So once again, I'm going to create a new request, and we're going to make sure to save this one. And I'm going to call this get user. Copy this URL. It's going to be the same route. It's just going to be a get operation, and then we want to send a specific ID. So take a look at your database and then see if you can grab an ID that does exist. So we'll just say 1. We'll hit send. And it looks like there's some kind of issue because I'm not getting a response yet. So let me cancel out of that and let's see what we did wrong. And I realized I forgot to do app.get. Great. So we actually got the user. Everything seems to be working. However, there's one little issue. First of all, we should not be getting the password, right? We never want to return the password to the user. The user already knows his password. And also, if this route is so that you can retrieve a user's profile, kind of like you can on Twitter or Instagram, then we're sharing someone else's password. And that's a little bit of an issue. And the reason why this isn't a hashed password was because I didn't clear out my database before we implemented the hashing of the password. So that's why it's in clear text. But whether it's hashed or not, you never want to send this out, right? You don't want anyone else to see your password. You don't even want the user to see their own password because someone else could intercept it and potentially do malicious activity with that information. So what we're going to do is we're going to filter out that specific field, just the password field. I want them to be able to get the ID, the created at field, and the email, and any other fields outside of the password. And fortunately for us, if we go to our schemas, we've actually already defined a schema for the user out. So this is going to be any information about the specific user, except we're extracting out the specific password. And so we can just set the response model to be user out. And we'll go back to main.py and we'll say response.model equals schemas.userout. All right, we'll save this and we'll try this again. So we'll retrieve this user and we still got the password. So what happened here? And this could just be an issue of me not saving. So let's try this again. Still a little bit of an issue. And let's just make sure I imported schemas. I did. And let's go to our schemas. And I've set just these fields, so this should be good to go. I'm not sure why it's giving us errors. And I made a stupid mistake. This should not be within the function parameters. This should actually go inside the decorator. So it wasn't actually doing anything. And now if we try this, we can see that the password field has been successfully removed. Now that we've added a couple of path operations for users, if you take a look at our main.py file, it's starting to look a little cluttered. And you'll see that we've got all of our path operations for handling CRUD operations for posts. And then you'll see that we also have all of our path operations for working with users. So that's creating users as well as retrieving a user by ID. And as I said, this is a little messy. And as we keep adding more and more path operations, it just seems almost unmanageable to keep everything in a main.py file. And instead, what I want to do is I want to break it out. And I want to create 2 separate files. And one file is going to be for all of the routes or path operations that work and deal with posts. And then I want a separate file that will handle all of the path operations for working with users. And, it's not quite as simple as just, moving these path operations to different files. We do have to learn about something specific to FastAPI. And this is nothing unique about FastAPI. You'll see that every single web framework is going to have a way to kind of accomplish this. And it usually involves something called routers. So we'll take a look at routers in this section and how we can use them to actually split up all of our path operations so that we can organize our code a little bit better. And so what we're going to do is we're going to create a new folder, and I'm going to call this routers. And then within here, I'm going to create two files. I'm going to create one called post.py, and I'm going to create one that's called user.py. So all of our path operations dealing with users is going to be put into this file, and all of our path operations dealing with posts is going to be put into this file. And what I'm going to do is we're going to go to our main.py file, and I'm actually just going to copy all of my specific routes that deal with posts first. So we're just going to keep going up, and I went too far up. Oh, this thing moves quickly. Here we go. All right, this is going to grab all of our posts. And I'm going to just cut that out, and we're going to just paste it in here. And there should be plenty of warnings and errors within VS Code. That's to be expected. Don't worry about that. We'll fix that in a bit. I'm going to do the same thing for the users. So let's go to our main.py file and just grab the last two path operations that we have for users and then paste it into this specific file. All right, so we've got a bunch of errors. And let's go ahead and actually fix those first before we actually start working with routers. And so now that all of the path operations are within these files, we're going to have to import, things like app. We're going to have to import, well, we'll come back to that actually. We'll have to import status. We'll have to import our schemas. We'll have to import the session object. We'll have to import all of our database related things, our utils. So all of these things that we see little squiggly lines, we have to import them because we had already imported all of these in the main.py file. And so we'll start off by importing the models, the schemas, and the utils folder if we need it for one of the specific files. You'll see that we only need this for the users file. And so the way we did it in our main.py file is we say from, and then this dot means current directory. So we say, hey, from this current directory we're in, which is, if I kind of close that out, you can see that everything is in the app folder, sorry. And we're saying from the current app directory, I want to import models, which is right here. And then I want to import schemas and utils. However, in our user.py file and our post.py file, the models, schemas, and utils folder is not in the same directory because we actually have to go up a directory to the app folder to access them. So instead of doing one dot, if you want to go up a directory, you do two dots. So that's all we have to change. So in our user.py file, we'll say from ... import, and we'll say models, schemas, and utils. And so right there, we cleaned up some of our errors that we're getting. And let's see, we also have to import status from the FastAPI library. So what we can do is we'll just go up here, and I'm just going to copy this. And right above this line, we're just going to paste that in there. And the last thing that we need to import is from the database. From the database.py file, we're going to have to import getDB, and then from Sqlalchemy, we have to import session. So if we go to our main.py file again, the Sqlalchemy code right here, we can just copy that, and I'm going to import that as well. So that's done, and then finally we have the getDB, and if we take a look at our main.py file, the way we got that is, so we're saying from the current database file, we want to import engine and getDB. And keep in mind that the database file is not in the routers directory, it's in the app directory, so we have to go up a directory to access this file. So we just put two dots. Pretty simple. So from ... database, import getDB. And we actually don't need to import engine. We're going to leave that here in our main.py file. All right, so now that we got all of that, the last error that we see is that we don't have access to the app object. And so your instinct is to go to our main.py file and then import this. And that's not exactly correct. Instead, what we're going to do is we're going to make use of the routers that I mentioned. And so from the FastAPI library, we're going to import something called API. First three letters, actually the first four letters, API router. And then from here, we're going to make use of the API router object. So we'll say router equals API router. So we're basically creating a router object, and then what we can do is we can replace the keyword app, because we don't have access to that in this file, and we just use the word router. And you'll understand why we do this in a bit. So we've got those updated. And then we're going to do the same exact thing for our post.py. So we have to get all of these imports. I'm actually going to copy most of these because most of them are going to apply here as well. The only thing we don't need utils for sure. So we'll remove that. And then you'll see that list is still getting errored out. And that's because if we go to our main.py file, that's coming from this typing import. So I'm just going to copy that and paste that in there. And it looks like we don't need optional because it's kind of grayish. So that's just VS Code telling us that we're not using it in this file. And I think that should clear up all the errors except for, once again, the app object. And so we'll do the same thing. We'll say router equals API router. And then what we're going to do is replace the word app with the word router. All right, and then finally, we have to go to our main.py file and actually make use of these routers because you'll see that in our main.py file, there's no reference to anything in here. So our API won't work if we try to run it now. So in our main.py file, what I'm going to do is I'm going to say from dot routers. So from this folder, we're going to import post and user. And this should be plural routers. And then I'm going to show you some magic that we're going to do. And so above this route, we're going to say, we're going to grab the app object, right? This is once again our FastAPI object that we kind of do everything with. And we're going to say include router, and then we'll grab the post.router, right? That's what we just imported. We imported post, which is coming from here, and we're importing this router object. And so what we've basically done here is I have basically said, as we, when we get a HTTP request, before we had all of our path operations in here, instead, what's going to happen is, we go down the list like we normally do. And so as we go down our list, this is our first app object that we kind of reference. And in here, it just says, I want you to include everything. I want you to include our post.router. And so the request will then go into here, and it's going to take a look at all of these routes, and it's going to see if it's a match. Right? And if it finds a match, it's going to respond like it normally does. So that's kind of how we break out our code into separate files. We use these router objects. And we can do the same thing with the user.py. So we're going to go to main, and then here I'm going to type out the same thing. I'm going to say app.includeRouter. And this time we grab the user, and then we do router again. And so once again, all we're doing is we're just grabbing the router object from the user file, and that's essentially going to import all of the specific routes. And so if we save our code and then we just quickly take a look at the terminal just to make sure there's no errors, it looks like everything's working. Let's test this out now. So I'm going to get all posts. Let's see if this works. It looks like it works. Great. Let's create a new post. Looks like it works. Get one post. Well, it looks like that post doesn't exist anymore, but if I try one, looks like it works. We'll delete post with the ID of 3. Great. We'll update post. Create user, just put in a new unique email, and then get user. So grab that user, and we can see that every single route works perfectly. So we didn't change the functionality of our project at all in this video. Instead, all we did was we used a router object to be able to split up all of our routes or our path operations into different files, and then we import them just by calling app.includeRouter and then the specific router object of that file. And you'll see that our code looks so much cleaner now. And as our app and our API continues to grow, we can just add new files into the routers folder so that we don't continue to clutter up our main.py file. In our 2 router files, you'll see that we use the same URL for almost all of our specific paths. And so you'll see for the get route, we'll use /posts. For the post, we use /posts. From the get specific post, we do /post and then the ID, and then the same thing goes for delete and put as well. And I think it's kind of annoying having to continuously copy and paste the same exact path when it's pretty much just a copy from each one. So is there a way we can kind of remove this unnecessariness? It doesn't seem like that big of an issue, but keep in mind that our API is very simple, right? Other APIs could have very long, complex, routes that, may not look as simple as ours. So they could have, multiple things, right? So it could look something like that. And then having to kind of copy and paste all of that on every single route can seem a little unnecessary. And so anytime you're working with routers, what we can actually do is we can pass in a parameter into the API router function or method. And so what we can say was prefix. And we're going to say that since every single route in this file always starts with /posts, we can say prefix equals /posts. And so now, anytime you see a /post, we can just remove that and just put in a slash. So this is just going to be a slash. And then when it gets to /post/ID, this is where it gets a little tricky. But once again, we just remove everything but a slash. And so what this is saying is that we're going to take /posts, and then we're going to append it with ID, right? Because that's what this is saying. We're saying /ID, so it's actually appending it with /ID. So the final thing actually looks like, it's going to look like /posts/ID. So nothing actually changes. It's just a simpler way to do things so that we don't have to write /posts everywhere. And so we can remove this and just do /ID. And we can just do /ID here as well. And we're going to do the same thing in the users file as well, because both of them start with /users. And so we're going to put in a prefix here. And we're going to say /users. So this can just be removed to /, and this can be removed to just /ID. All right. And once again, we're going to test this out. We're just going to test a couple of routes. So if get post work, and if create, well, we'll try a get one post. That works perfectly. And then let's try creating a new user. We have to give it another unique email. Looks like it works. And then finally, get user. We're going to try this again. And it looks like it all works. So, this is a completely optional step. It doesn't change the functionality of things, but I think it does make it a little bit easier to read because we've put the prefix up here so that we don't have to keep copying and pasting. Now, as I mentioned, one of my favorite features of FastAPI is the automatic documentation that comes from Swagger UI. And so if you actually navigate to the URL, but just go to /docs like I have, that's where you're going to see the documentation. And like I said, this is interactive documentation, so you can actually make requests from here. So you didn't technically have to use Postman for a lot of things. You can just test it out right here, and it's going to do the same thing. However, I did also want to teach Postman. But the reason I bring this up again is that you'll notice how we've got a couple of routes for dealing with posts, and then we've got a couple of routes for dealing with users, and then we've got this random test one that we created when we were first learning about path operations. And what I would like to do is I would like to structure this documentation so that instead of kind of grouping them all together, we can kind of group them based off of their responsibility. So I would like to create a group that handles all of the post operations, so all of these 5 right here. And then I would like a separate group that handles all of the user-based operations so that it's a little bit easier for your clients and your users to understand what each one does by grouping them accordingly based off of their specific action. And so I want to have a group that actually is titled posts and a group that's titled users so that when they see that, they say, oh, the users section is going to be dealing with users and the post section is going to be dealing with posts. And getting this fixed or updated in our code is super simple with FastAPI. So let's go to our FastAPI, go to our routers. And if we go to the post.py, to add a specific group name, what we call, it's actually called a tag. So we say tags equals, and we just say posts. And I forgot that comma right there. And we do the same thing for users. So we'll say tags equals users. And you can see that this is a list, so you can pass more than one. But we'll save that. And then I'm going to refresh this page. And so now you can see that we now have these little titles so that we can now group our specific requests into categories. And so the readability of our documentation has improved tremendously with essentially one line of code. In this section, we're going to start tackling one of the most important topics when it comes to building out an API or really any application, and that is authentication. Now, when you're working with authentication on an API or any application, there's really 2 main ways to tackle authentication. There's the session-based authentication, and the idea behind a session is that we store something on our backend server, or our API in this case, to track whether a user's logged in. So there's some piece of information whether we store it in the database, whether we store it in memory, that's going to keep track of if the user has logged in and when the user logs out. So that's one way of doing things. The other way of doing things is using JWT token-based authentication. And the idea behind JWT authentication is that it's stateless. And what I mean by that is that there's nothing on our backend. There's nothing on our API. There's nothing in our database that actually keeps track or stores some sort of information about whether a user is logged in or logged out. And you're probably thinking, well, how do we know that they're logged in? Well, that's the power of JWT tokens, is that the token itself, which we don't store in our database and we don't store in our API, it's actually stored on the front end, on our clients, actually keeps track of whether a user is logged in or not. And when I first started learning about JWTs, it was a little bit of a complex topic. It seemed like there were so many pieces that were in play, but then when I actually stopped to really understand it, I realized it's one of the simplest solutions. So hopefully I can make this as easy as possible for you guys. I hope this doesn't end up kind of confusing you like it confused me at first. It really is simple, and there's really only a couple of steps, but you got to really understand what a JWT token is and what we're doing on the front end and the back end to make it so that we can actually use it as an authentication solution. So let's take a look at the flow for how a user logs in, how a user is essentially authenticated, and then how a user accesses a specific path operation, resource, or endpoint by using the JWT token to ensure that the API knows that we're logged in so that we can actually provide them that important information. And so what's going to happen is the client or the front end, whoever it is, they're going to try and log in. So what we're going to do is we're ultimately going to create a path operation called /login. And the client is going to pass the username, and they're going to pass in the password. So whatever their credentials are. So it doesn't technically have to be username and password. It could be email and password. It can be whatever information that you want. So technically in our application, it's going to be email and password because we don't have usernames, I guess. We mostly just have emails. But they provide their credentials. And so after we get their credentials, what we're going to do is, first of all, we're going to we're going to verify if credentials are valid, right? So if the credentials are correct, if the password matches, if the username and password match with the account, we're going to create this JWT token. And we haven't talked about what the JWT token is, so don't worry too much about it. But I've created an example token right here. And so you're probably thinking it just looks like a bunch of gibberish. And for the most part, it is. So moving forward, I want you to think of this as nothing more than just a string. Just a regular string in Python. That's kind of fundamentally what it is, but there's a little bit more information embedded in it. But think of it as a string from the perspective of the client. The client doesn't know what the token is, and it never cares. Really, only the API cares what's actually in the token and what it means. And so we'll send a response back with the token. And so now the client has the token, and so he can start accessing resources that require authentication. So anytime he wants to, let's say our application requires a user to be logged in to retrieve posts, what he can do is he'll send a request to the /posts endpoint, but he also provides the token in the header of the request. And you may not know what the header of a request is, but I'll show you guys. It's very simple. You can just think of it's somewhere in the payload of the request. And so he sends that. And what the API is going to do, our FastAPI, is first of all, it's going to verify the token is valid. And there's a couple of different steps needed to actually verify if a token's valid. And we're going to cover that in the next slide. But just know that the API just checks, hey, is this a valid token? And if it is, well, then he just sends back the data. And that's it. Right? Our authentication system is dead simple. You provide your credentials, you get a token, and then anytime you want to access anything that requires you to be logged in, you just send the token in the header, and that's it. So hopefully this wasn't confusing. Hopefully you guys see the simplicity in this solution. The API doesn't actually track anything. There's no information being stored on the API. Instead, the client just holds onto the token, and he provides it to us, and if we verify that the token's valid, that's all we have to do. So let's break down what exactly a JWT token is and what are the components that make up a token. And so I've got an example token right here, and this is kind of the same piece of text that we saw in the previous slide. And so it, once again, just looks like a bunch of cryptic characters just jammed together. And that's kind of what it is. It looks like it's encrypted, but keep in mind, it is not encrypted. This is important to understand, and we're going to make sure I drive home this point. It is not encrypted. But the token itself is made up of 3 individual pieces. The first thing is the header. So the header includes metadata about the token. And so we're actually going to sign this token. So we're going to think of it almost like hashing the token. And so we have to specify the algorithm that we're going to use. So in this case, the default is HS256. So we've included that in the metadata. And then you can see the type is set to JWT. So this is a JWT token. So that's why the type has been set. So the metadata is going to be the same for all of our tokens. This is just kind of fixed. Don't worry too much about it. It's not really that important. We don't really ever touch it. Now the payload is a little bit more interesting. So the payload of a token is ultimately up to you. You can send absolutely no payload. You can send any piece of information that you want to send within the payload. You can include anything that you want. However, you want to be careful with what you put in the payload because it's important to understand that the token itself is not encrypted. And so that means anybody else in the outside world can take a look at a token and they can see what's in the payload. So you don't want to put any confidential information. You don't want to put any passwords or secrets or anything like that. Instead, you want to stick to some very basic things. So very common things that we put in the payload are, what is the ID of the user, right? So when I log in, right, normally our API is going to create a token and then embed my user ID into the token so that when I ask to get all of my posts, the API will be able to take a look at the token, verify it's correct, extract to the payload, and it'll automatically know the ID of the user that requested this. But we can include other things. We can include the user's role. So are they an admin, or are they a privileged user? Are they a regular user? We can technically include any information. One thing to keep in mind is that anytime we need to access anything authenticated, we have to include this token. So if we jam a lot of information in there, well, it's going to increase the size of our packet. And that's going to be a waste of some bandwidth. So you don't want to jam too much information, just a couple of small things here or there. And then finally, we have a signature. So a signature is a combination of three things. We've got the header. So we take the header that's already in the token. We take the payload that's already in the token. And then we add our secret. So there's a special password that we're going to keep on our API. This is only on our API. Our clients will not know it. No one else will know it. And it's probably the most important thing to our whole authentication system. So you don't ever want the secret to get out. But we take those three things, the secret, the header, the payload, and then we essentially take that information, pass it into the signing algorithm, which is the HS256, and then it's going to return a signature. And this signature is important because we're going to use this to determine if the token is valid, because we don't want anyone else tampering with our tokens. We don't want them changing data. I don't want some user to log in and then just start changing numbers in here to make it seem like it's a different user, because then they can potentially access other users' information. And so that's why we have this signature. It's just to make sure that no one has tampered with our specific token. And so, I just want to drive home that same point. First of all, there's no encryption. So anyone can see the data. The signature is just there for data integrity. And what that means is no one has changed it. That means all the data that we have in there is still what it should be. No one has messed with the data. All right. And if you're still confused as to what a signature is, we're going to take a look at how signatures work, why we use them, and how they ultimately help us detect if someone changes any of the information in our token in the next slide. And then I think at that point, you guys will see it's not really a complex concept. And once you get that, you'll see that the whole authentication process is fairly simple. Okay, guys, so we're going to do a deep dive into why we need the signature within the token. And you'll see this slide may look a little complex. There seems to be a lot of boxes, a lot of things going on. But as soon as I explain this, I think you guys will see that it's not too complex of a concept. So let's break this down step by step. Let's say a user has logged into our application, he's sent our credentials, and our API has created the token, and it's in the process of sending it back to the user. So this is going to be our token that we create on our API, and it's going to have three things. The same three things we discussed in the previous slide. We've got the header, that's got all the metadata. It's got the payload, right? And this is going to have whatever information we want to put in the payload. And in this case, we've decided to embed the user's ID as well as his specific role. In this case, he's a plain user. He's not like a special privileged user or a staff user or an admin. He's just a regular user of our application, so he can only do very specific things. And then we have to generate a signature. And our signature is going to be a combination of three things. It's going to be a combination of our header. And remember, this header is the same thing. So even though our token already has the header, what we do is we take that header, we take the payload with the specific pieces of information we've included in there, and then we include, finally, our special super secret password. Remember, this password only resides on our API servers. Nobody else has access to it. Our clients don't have access to it. The front end doesn't have access to it. Only we have access to it on our API server. And this is very important because this is the special password that no one should ever have access to. And so we take all of these three things, we pass it into a hashing function essentially, and then we create a signature. And so we take these three things, and that's going to make up our token. And so we send that back to the user. Now, let's say that we've got a user who decides that he wants to do a little bit of shady things, and he wants to kind of hack our application and do some bad things to our application ultimately. And so what he's figured out is like, hey, look, this token, right? It's not encrypted. I can see all the data. I can see that I'm a user. And so what he's decided to do, he changed a few bits in the token to make it now read admin instead of user. But he could have really done anything, right? He could have changed the ID so that it's someone else's ID and he can potentially have access to someone else's information. It doesn't really matter, but he's changed a few things. And so now he's got this token, which has the header, signature, and payload, and he's now a admin user, or the payload says he's an admin user. Now, the reason he can't actually do this is because ultimately, remember, the signature that's currently in the token was generated by having a header, the same header, and then you pass in the payload with this specific ID and a role of user. And then you pass in the secret. And so this signature is no longer valid. He can't use this same signature because it's not going to match up with the data that he has. So if we actually try to create a signature from this, it's going to look different. And so what he has to do is he has to create a brand new signature so that it matches the data he's sending. However, he can't create a brand new signature because he doesn't have this super secret special password. This only resides on our API server. And so if he tries to create a brand new signature, he can only pass in the header and this payload into the hashing function to generate a new signature. And so that, once again, is not going to be a valid signature because when he sends, let's say he does create that signature with only the header and the payload and no secret. Well, we now have this token, right, that's made up of these three things. We send it to our API. And what our API is going to do is to verify if the token is valid, he does a super simple test. He takes the header, he takes the payload, and he takes the secret, and he creates a test signature. Because remember, that's what we did in the first place to actually create the original token. We take the header, the payload, the secret, and we pass it in to our signing function, and we pass it into our hashing function and create the signature. So we do the same thing, and then we take the signature in the token that was sent by the user, and we just compare them. If they don't match, which they won't, because remember, he doesn't have access to the secret. And since we use the secret in our hashing function, right, the signatures aren't going to match. And we know that this token is not valid. So this signature, once again, only ensures that the data integrity is still valid, that no one has tweaked any of the bits, no one's changed any of the data. That's all the signature can do. It can just verify that it hasn't been changed since we created the token in the first place. But once again, and I can't stress this enough, anybody can change the data of a token. Anybody can see the data of the token. They just can't generate a brand new signature because they don't have access to the secret. And so that's why the password's so important, because that's how we ensure that the token hasn't been manipulated or changed in any way, shape, or form. So hopefully that made sense. I didn't understand this at first. It took me a while to actually grasp why we needed the signature. I just kind of was like, I'll figure this out later. But after a year or so, I was like, oh, this is actually a super simple concept. And hopefully I can do a slightly better job of explaining it than some of the documents that I read when I was first learning it. And hopefully this kind of, gets rid of some of the unnecessary stress that kind of comes with learning about JWT-based authentication. So once again, let's quickly take a look at how we're going to handle logging in the user. More specifically, how do we actually verify that his credentials are correct? Because it's not going to be exactly the same way that you would think. So the user is going to hit the login endpoint, and he's going to provide the email and the password. And I've colored the word password in red because this password is going to represent what the user is trying to log in as. This is his attempted password. That's what we're going to call it. And that's going to be in red. And keep in mind that when he sends this password, it's in plain text, right? It's just the regular password that he typed out. And so when it gets to our API, the first thing that we're going to do is we're going to hit our database to try to find the user based off his email or his username. And the database is going to send back all of the information about that user, which includes the password. However, if you remember how we actually created the password and stored it in the database, we actually stored a hashed version of the password in the database so that if anyone hacks our database, the user's passwords aren't actually in plain text, so no one can really hack their passwords. But this creates a little bit of a problem because we have the attempted password for the login attempt in plain text. However, we've got the password in our database as a hashed password. So how exactly do we check to see that they're equal? Because right now, a hashed password does not equal the same as the regular password. And your first instinct is to, hey, well, let's just convert this back to a plain text password. And we can't exactly do that because remember, a hash is only one way. So if we hash a password, we can't get the original password from the hash. That's what's great about hashing a password. And if you think you can do that, that's actually, well, I guess what we would refer to as encryption, but we're hashing in this case. So what do we do to verify if the passwords are actually equal? It's pretty simple. We take the hashed password, and then we take the raw, and once again, this hashed password is the correct password in our database. Then we take the password attempt, and we hash it again. So we hash this password, and so then we get a hashed password. And so if we have the correct password, then if we put it through the hashing function, these two should be equal. And so if they're equal, that means the password they provided us is the correct password in the database. If it's not, if they don't match, that means he gave us the wrong password. And so if they're correct, we'll then go ahead and we'll create a token first, and then we'll send it to the client. So it's as simple as taking the attempted password, hashing it, and then comparing it with the hashed password in the database. Because if the passwords are correct, then the hash should equal the hash in the database. Okay, so we're going to create the login path operation. And what I'm actually going to do is, you're probably thinking that we can just store the path operation in the users.py router. However, I think it would make more sense to actually store this in a authentication router. So we're actually going to create a brand new router for this so that we can keep the user routes versus the authentication routes in two different files. However, if you really wanted to, you could store it all in one file. So I'm going to call this auth.py. And the first thing that we have to do is from the FastAPI, we're going to import a few things. We're going to import the API router. We're going to need depends, status, HTTP exception, and maybe we need the response. I haven't decided. And then we're going to define our router. So we'll say router equals API router. And we're going to pass in a tag, just for the documentation. So we'll say tags equals authentication. All right, and then we're going to create our login. So we'll call this, well, first of all, this is going to be a post request because remember the user is going to have to provide his credentials. So generally when you want to send data in one direction, it's going to be a post request. And we'll send it to the login endpoint. You can call this whatever you want. You can call it authenticate. However, I like login. And then we'll define our function, and I'll just call this login as well. And because we're ultimately going to have to fetch the user from the database, we're going to have to import our database session. And so from Sqlalchemy, we'll say .orm import session. And so we'll do the same thing that we did with every other path operation. I'll say db session equals depends. And then we're going to have to actually import our getDB function. So from here, we'll do from, and we have to go up a directory, and I'll say database import session. Sorry, not session. Actually, you know what I'm going to do? I'm just going to say from ... import database. And then I can just reference it as database dot get underscore DB. Right? And since the user is going to be providing the login information, I think it makes sense to set up a schema so that we can ensure that they provide the exact pieces of data that we ultimately want. And what we're going to do is we're just going to create a new class, and I'm going to call this user login. And this will extend the base model as usual. And the two pieces of information that we want are email, which is going to be a string, and then we can do password, which is going to be a string. Actually, I'm going to use an email string like we did before. And then from our auth.py, I'm also going to import schemas. And here I'm going to store the schema as a user credentials. This is going to be schemas.user login. All right, and so now we can access all the user information or the attempted login information with the user credentials variable. And we're going to make a request to our database specifically our users table to retrieve the user based off of his email. So we'll say db.query, and we have to import models now so that we can access it. And we'll say models.user, and then we have to filter based off of the email. We'll say models.user once again, .email equals user underscore credentials dot email. And then there's only going to be one user with that specific email. So we'll do first. And we'll store this result in a variable called user. Now, if there's no user with that specific email, then we're going to return an error, or we're going to raise an exception. So we'll say if not user, we're going to raise an HTTP exception. And the status code is going to be status dot, and I'm trying to remember what code will, oh, it's going to be a 404 because that user doesn't exist. And then the detail field, we're just going to say invalid credentials. Because normally with authentication, you don't want to say, hey, this is the wrong email or this is the wrong password, because you don't want to make it a little bit easier for them to kind of guess other people's information. Just say this is invalid credentials, let them figure out whether it's the email or the password. And then after this, once we verify that we did actually get a user object, we have to verify that the passwords are equal. So this would be, performing that logic of hashing the password that they gave us and seeing if that it compares to the password from the database. And so what we're going to do is we're going to create a new function in the utils folder that's going to be responsible for comparing the two hashes. Or actually, it's going to take in the raw password, the password attempt. It's going to hash it for us, and then it's going to compare it to the hash in the database. So we'll create a function, we'll call it verify, and it's going to include the plain password, which is the password the user is trying to attempt, and then the hashed password, which comes from the database. And all we have to do is just return, and then we can reference the PW context, right? So if you want to hash a password, you just call the .hash method. However, it's also got another method for us, which is verify. So it's going to perform all this logic for us. So we just pass in the plain password, and then we pass in the hashed password, and it's going to figure out the rest. Now you're thinking, well, what is the point of such a tiny function? Why don't we just include it in our auth.py? Well, we 100% could, because it's really 2 lines of code. It doesn't really make sense to store it in another file. However, then we also have to import all of the bcrypt code, and I like to have everything kind of separate. So keeping all of the bcrypt logic in one file just makes things a little bit easier to manage. But in our auth folder, we can import utils now. And we're going to run the utils.verify. And we're going to pass in the plain password, which is going to be stored in user credentials. So we'll say user credentials.password. And then we pass in the hashed password from the database, which is stored under user. So we'll say user.password. All right. And if they are not equal, so if they do not equal each other, which means they provided us the incorrect password, then we're going to raise another HTTP exception. And this is going to be the same thing. We're going to send a status code of 404. And the detail is going to be the same thing. We're not going to tell them that it was the wrong password. We're just going to say invalid credentials so that it's not easy for them to kind of keep guessing passwords or emails. All right. And then at this point, what we would do is we would create a token, which, we haven't really gone over how to do that. And then we would just return token. But once again, we haven't done that. So I'm just going to return, and we'll just say token. And I'm just going to say example token, right? Because we haven't implemented that logic, but I do want to make sure that the rest of the code looks good. So we'll try that out. And I'm going to go in, create a new request. This will be login user. It'll be a post request. I'm going to copy this. Actually, this is just going to be /login. And then in our body, we're going to provide some JSON. And here we're just going to say email is whatever, and password is whatever. And before I actually do anything, I'm going to run a query on my database because if you see, I've got a couple of users that don't have hashed passwords. So I'm actually going to delete everything just so I can clean up some mess. And I'll just say, and what I'm actually going to do is I'm just going to delete everything. I think that's going to just make things simple because I don't even remember these guys' passwords. So it's going to create some issues for us. So we'll just say delete from, and I'll say users, and then I just won't provide any condition. So this should delete everything. We'll run that, and you can see that it looks like it deleted all 12 results, and that's perfectly okay. And I'll add my original query back, select star from users. And what we're going to do is we're going to just register a new user. So I'll do create user, and I'm going to call this Sanjeev@gmail, and then the password is going to be password123. So let's create that user. Let's take a look. All right, we've created that user. And now let's log in this user. So we'll go to login, and I'm going to provide my Sanjeev@gmail. And then we're going to provide a password, which was password123. Let's try this out. And it looks like we ran into an issue. So what? Well, first of all, that's the wrong error message. I'm not sure why it gave me that. It should say invalid credentials. So where is this actually happening? And guys, I made an absolute silly and stupid mistake. I forgot to actually wire up this router in our main.py file. So it doesn't even know about it. So let's import this. We're going to say import auth. And all we have to do is just one skin. I'm just going to copy this. And we'll just say auth.router. All right, let's try this again. All right, and we've got our example token, which means that we verified that the passwords are correct and everything was good to go. We just haven't implemented the logic for the token, but let's just make sure that when we put in the wrong password, it still works, or it shouldn't work. And we get invalid credentials. Let's put the right password back in, and then let's use the wrong email. And we get invalid credentials as well. So, so far, we are almost done with the whole login process. The next thing that we got to do is handle creating a token. It's not going to be too difficult, but I do want to save that for the next video. Now, if we head on over to the FastAPI documentation under security, there's going to be OAuth with password. And so most of the things I cover are going to be coming from this documentation right here. Now, the first thing that we have to do is we have to install a library that handles signing and verifying JWT tokens. And so we're going to use this python-josie library, and then we have to provide a cryptography backend. So we're just going to copy this line right here, and we're going to run this in the command line. And what I'm going to do is when it comes to authentication and anything with JWT tokens, I'm going to create a new file, and I'm going to call this OAuth2.py. All right, and the first thing that we're going to do is we're going to import from Josie. We're going to import JWT error and JWT. Now, there's going to be three pieces of information for our token. Well, actually, there's three pieces of information, but there's three other things about the token that we need to provide. So we're going to say we're going to need the secret key, right? That's that special key that I mentioned that ultimately handles verifying the data integrity of our token, which resides on our server only. So we're going to have to provide that secret key. We're also going to need to provide the algorithm that we want to use. We're going to be using HS256, and then we're going to need to provide one other thing, which is the expiration time of the token. So we haven't really discussed the expiration time. If we just give a plain token without an expiration date, that means that user's logged in forever. And there's no application that just lets a user log in forever, I don't think. So we're going to provide a expiration time so that we can dictate exactly how long a user should be logged in after they actually perform a login operation. And so we need an expiration time. And what I'm going to do is I'm going to just save these as variables. I'm going to say secret key equals, and then this is just going to be some arbitrary long text. I'm just going to paste that in here. And if you're just wondering why, if you just follow the documentation, actually, you'll see that they do the same thing. So we just need to give it some really long text in this case. And it even gives you a command to kind of get a string like that for your password. Because you could theoretically just put, hello or something here, and that's going to work just fine. However, it's not quite as secure, but for learning purposes, it doesn't matter. Just provide some kind of string, right? And then the algorithm is going to look like this, and then the expiration time is going to look like this. So I'm just going to copy this from the documentation. And then we're going to define our function. So this is going to be create access token. And what we're going to do is, remember, the access token is going to have a payload. So whatever data we want to encode into the token, we have to provide that. So I'm going to pass that in as a variable called data. And this is going to be of type dict. And what we're going to do is we're actually going to make a copy of this data because I don't want to actually change it. I want to make a copy of it because we're going to manipulate a few things, and I don't want to accidentally change the original data. So we're going to say data dot copy. So this is going to make a copy, and I'm going to store it in a new variable. And it's going to be 2_code. So this is all the data that we're going to encode into our JWT token. And then now we're going to create the expiration field. So to actually do that, there's a couple of things. First of all, right now we have it set to 30 minutes. And so what we need to do is to provide the time of 30 minutes from now, right? So we have to provide the time that it's going to expire in. So we have to grab the current time and then add 30 minutes. And so anytime you're working with dates and times, we have to import the datetime library. So we'll say datetime, import datetime and time delta. And I'm going to say expire equals datetime.now. So this is going to grab the current time. And I'm going to pass in time delta of, and then since this is in minutes, I would say minutes equals access token expire minutes. And then what we want to do is we want to grab the toEncode, which is a copy of a dictionary. So this is also a dictionary. And I want to update it. And here we're going to pass in expiration, and then we're going to provide the expire time. So we're just adding that extra property into the into all of that data that we want to encode into our JWT. And so now our JWT will tell us when it's going to expire. And what we're going to do is we're going to call JWT, coming from the, is it Jose? I guess it's the Jose library. So JWT.encode, so this method is actually going to create the JWT token. And we'll say the first property is everything that we want to put into the payload. The second one is going to be the secret key with the signature. And then we have to specify the algorithm. So the algorithm equals algorithm right there. And then at this point, we're just going to return, well, we have to save this in a variable. And here we just encoded JWT. And then now we can go back to our specific path operation. And since we're already importing, actually we have to also import OAuth2. And then here we're going to create an access token. And we're going to call the, sorry, not utils, OAuth2 dot create access token. And we're going to say the data equals, and then we're going to pass in a dictionary. So here, the user ID field. Remember, this is the data that we want to put in the payload. So I have decided that I'm going to put in the user ID and pretty much nothing else. I don't really care about anything else. We could give it a role. We could give something else. But for me, I just want to encode the user ID. So that's what I'm passing in here. However, if you wanted to provide some extra information about the user, if you wanted to provide their scope of different endpoints they can access, you can put all of that information in here. And so I'm going to say the user ID is going to be set to user.id. And so now what we can do is we're going to return a few things. I'm going to say we're going to return the access token, which equals access token. And then we're going to tell the user what kind of token this is. So this is token underscore type. And this is what's referred to as a bearer token, and I'll explain how to actually configure that on the front end. But literally in the authorization header, we just write the word bearer and then we provide the token. So nothing special there. All right, let's try that out. And it looks like I got an error. I don't know why I put an equal sign there. And let's try this out. So we've got the login endpoint. Let's put in the correct email this time. And let's see what happens. Look at that. We got an access token. And this kind of looks like a JWT token, right? It just looks like a bunch of random text. And then it tells us it's a bearer token. So let's actually copy this. And what I want you guys to do is go to your web browser, and I want you to search for JWT. And then go to go to jwt.io. And then here, what we can do is we can paste in our JWT token. And what's really cool is it's going to decode the token for us. And so you can see this is the algorithm we used. It is a JWT token. But take a look at the user ID. Right? This is the actual user ID that we passed into the token. So all of the data that we encrypted into the token are all sitting right here. So we also got the expiration time and then the signature somewhere in here as well. But isn't that pretty cool, right? It was able to decode that. And it's important to understand that, none of this is encrypted. Anybody can see this information, but by being able to sign it, we know that no one can kind of mess with it. And we can also specify an expiration time. So we know that how long this token is valid. So when our API gets it, it's going to just verify that nobody touched the token. It's going to verify that, hey, the expiration time, isn't before the current time, which would mean that it's already expired. And at that point, it already knows the token's valid. And then we can assume that everything is good to go. We're going to make one small change when it comes to retrieving the user's credentials in our login route. Instead of passing it in the body, we're going to use a built-in utility in the FastAPI library. So if we do from FastAPI.security.OAuth2, we're going to import something called OAuth2 PasswordRequestForm. And so what we can actually do is instead of just doing the usual here with the user credentials, we're actually going to delete that. And I'm going to provide a dependency. Well, actually, I need the user's credentials because we have to store it someplace. But here we say this equals OAuth2 PasswordRequestForm equals depend. So we're setting up a dependency kind of like we do with the database. And so this is going to require us to retrieve the credentials, and then FastAPI is automatically going to store it inside this variable called user credentials. However, we have to make one small change. So the username when you retrieve the user's attempted credentials from here, what it's going to do is it's going to store it in a field not called email, but it's going to store it in a field called username. So when we compare the models.user.email when we're querying the database, we can't compare it to user_credentials.email because there's no field called .email, right? It's going to only return two things. It's going to return, it's going to return something. It's going to return our username, which equals whatever, and then it's going to return our password, which equals whatever. And so we don't have access to email. We have to use user_credentials.username because well, this is actually a bad example because you have to think of it as like a dictionary, right? It's coming in like this, and then there's going to be a user field. You're going to have username. Oh, why is that capitalized? Username, which equals blah. You're going to have username, which equals, blah. And then you're going to have password, which equals blah, right? And so we'll just tag user credentials dot, and then we'll grab the username, which in our case will happen to be the email. The OAuth2 PasswordRequestForm doesn't really care what the username is. It could be a username, it can be a email, it can be an ID. It doesn't really matter. It doesn't really care. It's just whatever the user actually sends. It's just going to store it in a field called username. So those are all of the changes that we have to make from our backend side. Now, when it comes to testing things, we no longer send the credentials in the body like we normally do. Like if I try to send this now, we're going to get an error, right? Because it says username is field required value error missing. So and the password is also missing. So what it's doing is it no longer expects it here. Instead, it expects it inside form data. So here I'm going to say username, and this is going to be my email in this case. And then my password here. And so let's try this now. And now it successfully works. So those were the couple of changes that we have to make. But you'll see that it makes life a little bit easier by setting up that dependency and using the built-in functionality of FastAPI. In the last lesson, we learned how to log in a user by sending a request to the login endpoint and providing the username and password. And our API will then return an access token, which the user can then use to retrieve data from our API. So anytime he needs to access a endpoint or path operation that requires a user to be logged in, he'll just send this JWT token in the payload, and then our API has to actually validate the token. So in this video, we're going to handle the logic for verifying that the token is still valid, then that they didn't tamper with it, as well as verifying that the token hasn't expired. Now, before we do anything, what we're actually going to do is we're going to define a schema for the token because we know that the user has to provide the access token. So just like any other piece of data, if we expect them to send something, it's best to set up a schema. So we're just going to set up a schema for access token and token type and just make sure that they match accordingly. And so here we're going to do class token. And we'll say the access token is going to be of type string. And the token underscore type is going to be of type string as well. And then we can also set up a schema for the token data. So the data that we embedded into our access token. So we can say token data base model. And then here we did embed the ID. But I'm going to say this is optional for now. And it's going to be a type of string if it is set. So it can be optional, and we got to import optional as well. And so that's going to come from the typing library. And then in our OAuth2 file, we created an access token function, and then we have to create a function to verify the access token. So let's create that function, and it's going to just be called verify access token. And what we're going to do is we're going to pass in a token, which is going to be a string. And we're also going to pass in the specific credential exception. So we're going to pass in what our exception should be if the credentials don't match or if there's some issue with the token. So we'll just store this in a variable called credentials underscore exception. And I'll explain this a little bit later. And so here I'm going to say JWT, right? So we're going to access the JWT library. I'm going to say JWT dot, and then it's going to have a function. And if you take a look at our options, I'm sure you have an idea because creating a token, we did encode. I'm guessing you can figure out what is the specific method for decoding. It's going to be decode, obviously. And here we're going to pass in a couple of things. First of all, the token. Then we have to pass in the secret key so that we can decode it. And then we have to pass in the algorithm that's used. So we can just pass in algorithm. Once again, both of these are coming from these variables right here. It's obviously not a good idea to store the secret key within your actual code. But like I said, we're going to have a later section where we'll turn these into environment variables so that it's not hard-coded into our code. And we're going to store this in payload in a variable called payload. All right, and so this will just store all of our payload data. And to extract the data, what we can do is we can say payload.get, and then we have to get the specific field that we put in. So if I go back to my auth.py file in my routers, and you take a look at my data, you can see that we have a field called user underscore ID, and that's going to get the ID of the user. So here we just say get, and then we just pass in that same exact name, users underscore ID. And we'll say that this is going to be stored in a variable called ID, and this should be of type string. And if there's no ID, then we're going to raise a credentials exception, right? So whatever exception we provided into this function, it's going to raise that. And then we're going to say token underscore data equals schemas dot token data with the ID equals the ID that we extracted out of here. And I see that we didn't import schemas, so I'll import that real quick. So we'll say from dot import schemas. Right, and so all this is going to do is just going to validate, that it matches our specific token schema. Now, if you look at our schema, right, it's literally one thing. So it's not super exciting, and I made it optional. So we shouldn't actually make it optional, but we'll come back to fixing this in a bit. But this is just going to ensure that all the data we pass in the token is actually there. And so that's why I'm using a schema for that. However, for one actual variable, you don't actually need to do that, especially since we're checking to see if it exists right here. But it's good to always make sure so that in the future, if we do add extra fields, we can also validate the schema here. Now, we're almost done with this function. However, there's one little issue because we can run into an error in any one of these lines. And so anytime you're working with code that can error out, you want to do a try except block. So we'll do try. And then I'm going to indent these. And then here we'll say except. And then we're going to pass JWT error. And this should not be capitalized. And remember, this is coming from the Jose library. And once again, we're just going to raise a credentials exception if there's any kind of error that we didn't account for. All right, and the next thing that we have to do is define one last function. And this is going to be called get current user. So what this is going to do is, what this is ultimately going to do is that we can pass this as a dependency into any one of our path operations. And when we do that, what it's going to do is it's going to take the token from the request automatically, extract the ID for us. It's going to verify that the token is correct by calling the verify access token. And then it's going to extract the ID. And then if we want to, we can have it automatically fetch the user from the database and then add it add it as a parameter into our path operation function. So here, all we're going to do is we're going to pass the token. And so this is going to be a type string. And then here we just say depends, which has to be imported from the FastAPI library. So we'll say from FastAPI import. We're going to import depends, status, and HTTP exception. So here we'll say depends, and then we'll pass in a OAuth2 schema or OAuth2 scheme. So what we have to do here is, it's going to be a little bit confusing. We'll say OAuth2 underscore scheme. And this is going to be equal to, and we have to import one more thing. So we'll say from FastAPI.security import OAuth2 password bearer. And then here we just reference OAuth2 password bearer. And what we have to do is we have to provide one field called token URL. And so this is going to be the endpoint of basically our login endpoint. And so if you go to your auth.py, you just grab whatever name this is. Keep in mind, you don't have to name it login, but you just have to pass this into here. Actually, sorry, you remove the slash. So it's just login. And then we're going to grab this variable, and I'm just going to pass it into here. And this is kind of just tying everything together. And then we have to define our credentials exception that we're going to pass into the verify access token function. So when the credentials is wrong or there's some kind of issue with the JWT token, what exception should we raise? So here I'm just going to say HTTP exception. And we'll set the status code to be a 401. So unauthorized. Detail. Here I'm going to pass a string. Once again, could not validate credentials. And then we have to set some headers as well. And so just go ahead and just copy this in. And then finally, we're going to return a call to our verify access token function. And since we have the token passed into the get current user, we can pass it into our verify access token. And then we also can provide the credentials. All right, so just to quickly recap, because I know we did a lot and I think some of it may be confusing, but what's going to happen is anytime we have a specific endpoint that should be protected, and what that means is that the user needs to be logged in to use it, what we're going to do is I'm going to, well, as an example, let's say that users who want to be able to create a post, they need to be logged in. What we can do is we can just add in an extra dependency into the path operation function. So I can say here, I would just say get current underscore user, which would return an int. And then we'll say this equals, and then we pass in a dependency. So we'll say depends on OAuth2.get underscore current user. So this is going to add a dependency, which is going to be that function that we created called get current user. So anytime anyone wants to access a resource that requires them to be logged in, we're going to expect that they provide an access token. And then we provide this dependency, which is going to call this function get current, get current user. And then we pass in the token that comes from the request. We're going to then run this verify access token in this case. And then it's going to provide all of the logic for verifying that the token is okay and that there's no errors. And if there's no errors, then we go ahead and return nothing essentially. And that means that they were successfully able to be authenticated. If we do return some kind of error with the credentials exception, then they're going to get that appropriate 401 response back. So that's how our login works. It's nothing special, but there are a couple of different components that are involved. And in the next lecture, we'll start to take a look at starting to protect our specific endpoint so that it forces users to be logged in to actually perform that operation. All right, guys, I made one little mistake. In the verify access token function, I forgot to return something. And so if you ran into any issues, it's because of this. So what we're going to do is here, we're just going to do return token underscore data. And so what's really happening here is, once again, we're going to decode the JWT. We're going to extract the ID. If there's no ID, then we're going to throw an error. And then we're going to validate with a schema the actual token data, which in this case is just an ID. So that's the only field. But if you had extra properties or extra information, you can pass that in. And then we want to make sure we return the token data so that we can actually make use of that data. And keep in mind, remember, the get current user is what actually calls the verify access token. So when it calls verify access token, it expects us to return the token data. And then when we get the token data, we return it to whoever calls this function. Okay, guys, so I found a few extra bugs that we need to fix. Now, the first thing that I messed up was when we actually set the expiration time under the create access token function, instead of datetime.now, it should be datetime.utc now. This is important because as I was testing it, I kept getting an expiration error, and that's because this should be a UTC now. And the second thing is we want to put this in brackets because I guess it expects a list of algorithms maybe. We'll put that in there. And then finally, this is also a bug right here because if you take a look at the payload, when we create the token, which I believe should be in the auth.py, when we log in, we pass in the data as user underscore ID and not users underscore ID like we did here. So remove that. And this should prevent us from running into any other potential issues in the upcoming lectures. Sorry about that. I know we ran into a couple of bugs, but that's what happens when you try and copy and paste really quickly. Before we wrap things up, there's one last change that I want to make. Inside the login route in the auth.py router file, I noticed that for the response or the exception that we raise if either the user's email is wrong or if their password is incorrect, I used the wrong HTTP status code for the exception. And I can't remember what I actually had it before because I went ahead and fixed it. But I want you guys to go ahead and change the two exceptions here in both of those cases to a 403. I think that's a better representation of what we should be sending when the user doesn't provide proper credentials. So just update it here and then update it here as well, and then you guys should be good to go. Okay, guys, we're pretty much done with all of the authentication side of things. The only thing that we have to do is require the user to authenticate. Because right now, if we perform any operation like creating a post, you can see that I could just create a post And that's it. I don't have to log in first. I don't have to do anything. So anyone can create posts, anyone can delete posts, anyone can do anything they want. Obviously, that's not how your API is going to work. You're going to want to ensure that users are logged in to perform certain operations. And there may be certain operations where they don't necessarily need to be logged in depending on how you want to structure your application, right? Because, if it's like a Twitter-like application, right? Anyone can see anyone's tweets. I just can't delete anyone else's tweets, right? And to create a tweet, I have to be logged in. And so it depends on what you want to do for your application. But what we're going to do is we're going to start off by forcing the user to be logged in before they can create a post. And doing this is actually really simple. So let's go to our post.py and let's find our create posts. Now, the first thing I want to do is I'm going to import OAuth2, which is coming from this OAuth2 py file. And then in our create posts path operation function, we're going to add an extra dependency. And this dependency is going to be the get current user function that we defined in our OAuth2 file. So we'll say is depends, and then we'll say OAuth2.get_current user. And then we're going to store this in a variable called, we'll say user_ID. And this is going to be a integer. Okay, and so all this is saying is that this function is now going to be a dependency. So this is what forces the users to have to be logged in before they can actually create a post. And so when this function is called, whenever they hit this endpoint, the first thing that we're going to do is we're going to call this function. And this function, all this function does is really just call the verify access token and passing in the token which comes from the user. And so it takes the token. We first decode the token. We extract the ID from the payload. And if there's no ID, we throw an error, and then you can see we validate the schema. And then this is something I actually added in off camera, so we can just delete that and then go back to what you guys have. But we ultimately return the token data, which is nothing more than the ID, right? So we could rename this as ID for now, but like I said, in the future, you may want to add extra fields into the payload, and then it's no longer just the ID, it's going to include extra information. So we're going to return the ID, which then gets returned by the get current user function. And then in our post.py, in our function, we're going to return the ID and store it in a variable called user ID. And so then we can ultimately access the user ID by just calling user_ID. That's it. And we can do whatever we want with this user ID, and you'll see we'll eventually add some more logic. But for now, I'm just going to print it out just to see what we see. And let's go ahead and try this. So first of all, I'm going to create post, and then we're going to see what happens now when I try to create a post. Look at that, not authenticated. So by putting in that extra dependency, we have ensured that the user has to be authenticated before they can use this post. Now, how do we actually provide the token so that we can actually use the create post? Well, first of all, let's get a token. So we're going to go to the login user. I'm going to hit send. I'm going to get a brand new token. And then what we want to do is we want to go to create post, and then we want to go to headers. And then we want to create a header, and you can see I created one already, but I'm going to type this out for you from scratch in the line below it. So we say authorization is going to be the key. And then the column is going to be, and you type the word in bearer because it's a bearer type token. So you do bearer with a capital B, space, don't forget the space, and then paste it in. Okay, and so now this is included in our header, and so we should be able to send a request. And so now look at this. We were now successfully able to send our token. The API was able to validate. It was a valid token, and it was able to then allow us to create a post. And just another little Postman tip. You can uncheck this for now so that it's not authorized for you. If I try to do it now, you see I get an error. You can go into authorization and then just type in go to bearer token and then paste it into here. Does the same exact thing. It's just you don't have to type in the word bearer for yourself and then have to do all of that. You could just hit send now, and it does the same exact thing, whichever method you prefer more. Now that we've protected our create posts route, Let's go ahead and do this with some of our other routes. So it's just a matter of just copying the dependency for get current user. And then for retrieving a post, well, remember, this part is up to you. You decide ultimately what routes you want a user to be logged in to actually perform an operation. But for delete posts, I'm definitely going to force a user to be logged in. And for update post, I'm going to do the same thing. And then finally, like I said, for getting posts, it's really up to you. We'll say that you have to be logged in to do anything. So for get posts or getting all posts, we want to make sure that they're logged in. And then for getting an individual post, we want to make sure that they're logged in. And then finally, the last thing that well, it's not the last thing, but one of the things I forgot to do is under auth.py, when we send our access token after they log in, if you remember under schemas, we actually created a token model, token schema. We never actually used it. So let's actually use that by setting the response model here. And this is going to be schema.token. Schemas.token. So let's save this. And this should be capitalized. Sorry about that. And so now if we log in a user, we should still get no errors. So perfect. Okay, so just in case in the future we accidentally change something, we're still going to perform that validation to ensure that the token, we only send those two fields when we return a token. Now let's quickly just test all the other routes. So if I do get posts and I hit send, you can see, well, let me save everything. Sorry about that once again. Now if I hit send, you can see I'm not authenticated. So I have to do the same thing. So once again, you can do authorization bearer, or you can go to authorization and then just select bearer token and then paste in the token. And now if I hit send, oh, sorry, I got to recopy the token again. Now if we send, it works now. Get one post, let's try this. Not authenticated, we'll go into authorization, bearer token, send, that works. Deleting posts, go to once again to authorization. There's no post with an ID of 3, about 4. All right, that worked. And then finally, update post. We're going to do the last thing and bearer token. All right, and that works. And then let's just double check to make sure that if there's no token, what happens? Error, perfect. Okay guys, so I think that's going to wrap up this video for now. We've pretty much done all the authentication that we need to do up to this point. There's one last thing that I want to test to verify that everything works the way it should. And we probably should have tested this in one of the previous videos, but I forgot to do it. And I want to make sure that we test the expiration process, because a JWT has an expiration time that we set ourselves. And this just ensures that a user is logged in only for a certain amount of time. Now, we set the access token expiration time to be 30 minutes. And so that means that if a user logs in and he keeps his token for more than 30 minutes, after that 30-minute mark, if he tries to use that token to access any of our endpoints, it should throw an error because it's already expired. So let's test this out. And the easiest way to test this is, first of all, we're not going to wait 30 minutes. That's ridiculous. So what we're going to do is we're going to set this to 1 minute. And we're just going to test this real quick. And so I'm going to log in this user. So this token is valid for exactly 1 minute. And so we'll go to create post. Actually, we'll just do get post. It doesn't really matter. And I'll paste this in here. And you'll see this works. And we're going to just wait for 1 full minute. And after 1 minute, let's just verify that we get a unauthorized error because the token has expired. Okay, so it should be about 1 minute now. And so if we test this, we should now get an error. So after 1 minute, it says it could not validate credentials. Now we could set up a log message to say that, hey, this token is expired, but we don't need to worry too much about that. As long as it throws an error and it gives them a 401, I think that's good enough for now. And so this confirms that our expiration functionality works. And the last thing to do is, well, let's make sure we change this back. So once again, it doesn't matter what time you choose. It's up to you. I'm just going to do 30 minutes. Actually, I'm going to do 60 minutes just for testing purposes. Moving forward, I don't want to have to continually get a new token after every 30 minutes. So 60 minutes is a good number. Now you might be wondering, why exactly do we have this get current user function when all it really does is just call verify access token? We could completely just remove this and just call this directly whenever we want to authenticate a user. And you absolutely could with the current implementation. But the idea behind the get current user function is that once the verify access token returns the token data, which is the ID, the get current user function should actually fetch the user from the database. And so that way we can attach the user to any path operation, and then we can perform any necessary logic. Now you don't actually have to fetch the user here. It's up to you how you want to implement this. If you want each of your path operations to fetch the user themselves, they have the ID, so they can do it themselves. However, if you wanted to automatically do it here, you 100% can do that. And so I'm going to show you guys how you can do that in this lesson. And so keep in mind, we get the token data back, which is going to be nothing more than an ID. And what we're going to do is, first of all, we need access to our database so that we can fetch the users. So from here, I'm going to import database. And within this function, we can pass in the dependency so that we can actually get access to the DB object. So I'll say depends, and then we're going to access database dot, and I already forgot the name of the function. What is it? Get underscore DB. So get underscore DB, and we'll say DB session equals. And then we have to import session from Sqlalchemy. And so now we can make requests to a database. And what we're going to do here is, first of all, I'm no longer going to return that directly. And I'm going to say token equals, and then we're going to call this function right here, verify access token. All right, and since we have access to the token, what we can do now is we can say db.query. And then we have to import models. And I'm not sure if we've done that already. We haven't, so I'll import models. I'll say models.user.filter. And then we want to filter based off of the ID. So I'll say models.user.id equals token. And then we just grab the ID field. And then we're going to grab the first one. And then we can return the user, which I forgot to save it. So user is going to be equal to the result of that. And if you want to, you can print user here, but I already know this is going to work. So we can just go and save this. And then in our post.py, right, when we call this dependency right here, it's no longer returning the user ID. So I don't think it's a good practice to call this user ID anymore because it represents a user. So I'm going to say, I'm going to call this current underscore user, and we're going to rename this everywhere. All right, and then here within the function, I'm going to print out current underscore user. And so if I try to create a post now, and then open up my console, you can see that it printed out the user object, which not very helpful, but what we can do real quick is, I'll just say current.user.email. So we can see the email of that user, just to verify that we are actually getting the user. And we can see that it does print out the email. So that's ultimately why this function exists, because normally here, this is where you query your database to grab the user, and then you return the user. And then whatever you return here is ultimately what allows any of your other routes to get whatever you're returning. So since we're returning a user, we're going to store it as a variable called current user. In this video, we're going to take a look at some of the more advanced features of Postman. And we're going to start off by taking a look at environments. So select the environments tab, and you'll see that Postman just gives you a quick description of what an environment is. It says an environment is a set of variables that allow you to switch the context of your request. So we can set up some variables that change depending on what environment we work in. And you're probably thinking, well, what exactly is the point of that? And let me give you a great example. If you take a look at all of our requests, you can see that we hard-coded them to be 127.0.0.1, port 8000. And this is our development environment. Now, when we ultimately go to deploy our app, it's not going to be deployed on 127.0.0.1. It's going to be deployed on some server. It's going to have a public IP somewhere on the internet. And so when we want to test out our production server or make some changes to our production server, make some test requests to it, we would have to change the IP address, the port number, as well as we probably are going to be running HTTPS instead of HTTP. So all of our requests, we'd have to change all of them and then continuously flip back and forth every time we move from dev to prod and then from prod back to dev. And so instead of having to hard code these values and then change it constantly, we can actually create a variable that changes depending on what environment we use within Postman. So let's go to environment and let's create an environment. And I'm going to call this environment, we'll say this is dev, and then our project name, which is FastAPI. So this is our environment. And what we can do is we can define a variable. And I'm going to call this one URL. And then here, I'm going to actually just copy this URL. And then go to our environment again. And then I'm going to give it an initial value. All right. And then our current value should update. And then we can just hit save. Okay. And so we've set this variable to be this specific IP in our dev environment. And so if we go back to collections and then go to our Git posts, first of all, now moving forward, you want to make sure that you're working in some kind of environment. So we'll select the environment we just created. And then instead of hard coding this value here, I'm going to change this. And I'm going to just say, to actually use a variable, you do curly brace, the name of the variable, and then curly brace, curly brace. Okay, and it should be orange instead of red. If you get a red, it's going to mean that it wasn't able to resolve something and there's some issue. So just double check what you did. Orange is good. And then if you see this result when you hover over it, that means that everything's working. And so just to quickly test this, you can see that it says could not validate credentials. That's perfectly fine. I didn't set up the access token or anything, but this does confirm that we're able to resolve that variable. And so that way, you know, if I go and then create a new environment, and I'll just add here, and then we'll say this is prod FastAPI. We can then give a different URL for the production environment. So this could be like, you know, https:// I don't know, you know, some domain name that you buy. I'll call this sanjeev.xyz/. And then I can save this. And so that way, if you ever are testing your development environment, you just go to dev. And then when you want to quickly switch to your production, you just change to that. And then the URL will automatically update so you don't have to change anything yourself. And it's super handy to set this up. And we're just going to do this for all of our requests moving forward. So I'm just going to copy this. And we're going to do this for all of them. Okay, and if you go ahead and test this yourself, you should ultimately not run into any issues. I'm not going to bore you through, you know, individually testing these. You can do this yourself. And if you run into errors, it's just you probably pasted in something wrong. Now that we've set up authentication on our API, testing our API has gotten a little bit more challenging. And that's because I can no longer just go to create posts and then just hit send, because I have to be authenticated first to be able to actually create a post. And so what I have to do in Postman is I have to hit send. I have to log in and then get the access token. I have to copy the access token and then go to the specific endpoint I want to test. And then I want to paste that in there and then hit send. And then I can finally create post. And this is a little cumbersome and tiring. And it gets really hard if you have a short expiration time on your token. Imagine if you had an expiration time of 5 minutes. Then every 5 minutes, you'd have to repeat this process. But luckily, Postman has a way to actually do this through an automated fashion. Right? We're all developers. We all want to do things automated. So let's take a look at how we can do this. And I had to make sure that you guys understood environments and variables beforehand, because the method that we use actually makes use of environment variables. So let's go to the login user endpoint, and we're going to hit send and get a new access token. And so we've got this access token. And what I want to do is through code, I want Postman to automatically set an environment variable. So how do we do that? Well, let's go to tests. And here we can put in whatever code we want. And so we can read the documentation on how to do this, but the ultimate goal is to set an environment variable through code. So how do we do that? Well, there's a little snippet here that kind of gives you examples. What we want to do is we want to set an environment variable. And so to set an environment variable, you just do environment.set, provide the key, and then the variable name. And so just like we did with environments, right? If you go into your environment, you've got the URL, which is the key, and then the value. And so we're just going to do the same thing, but just through code. So here I'm going to set the key to be JWT. And I'm going to set the value to be this access token. So how do we actually retrieve the access token from the response of the request? Well, we can do pm.response. That grabs the response object. Then we'll convert it to JSON, and then we need to get the token. And the token sits on a property called access_token. So whatever this field is called, this is what you're going to pass in. So we'll say dot access_token. All right, and so now if I send this again, we'll get the token. The code should have run, and it should have set a variable called access token. And so now under create post, instead of hard coding this, what I can do is I can actually just reference the JWT variable. And so I set minus capitals. There looks like there's one from a previous project maybe, but we want this one right here. And if you want to just double check, you could see that this ends in WYD30. And if you want to go back into login user, you can see that this ends in WYD30. So it looks like it did set that and update it accordingly. So we'll set that in there. And so now if we send, you can see that we can now create posts. And so anytime you log in a user, it's going to update that token. And we can verify this. If you take it the last three letters, Q0A is the new token. And then I'm going to just remove that so we can see the value. And we can see that Q0A is the last three letters as well. So this updates it dynamically so that all you have to do is now just hit login user, and then you can start testing all of your other endpoints. And we're going to update all of the other endpoints as well. So for get posts, I'm going to put that in there as well. And then for getting an individual post, deleting a post, updating a post. We don't need it for create user. We might want to do it for get user if we set up authentication for get user, but we haven't done that yet. So we'll hold off on doing that for now. Now, currently, our application doesn't work like a traditional application would. And the reason I say that is, if you take a look at how everything's been set up, not just in our API, but in our database, we've got two tables, a user table and a post table. So we can create, modify, delete users however we want. We can log in. And then we can create, modify, and delete as many posts as we want, right? And you're probably thinking, well, that sounds perfectly fine. Yes, however, think about any other application. Think about any social media type application. When someone creates a post and you see that post on your feed, what are you going to see next to the post? You're going to see the user that created it, right? So every post is ultimately associated with the user account that created that post. But we have no way to actually do that in our application at the moment because there's nothing that ties a post to the user that created it, right? Take a look at all of the columns in our database. We've got an ID, a title, content, published. Technically, there's a created at column that I didn't draw in this diagram, but that's okay. So how do we know what post was created by what user? And this is where relational databases really start to shine because the main idea behind a relational database is that you set up these relationships between tables. So we need to set up some kind of special relationship between the users table and the post table that will allow us to associate a post with a specific user that created that post. So let's take a look at how we can do that within Postgres or any SQL-based database. And the way we do that is we actually create an extra column in our post table. So we've got a column, you can call it whatever you want, but I'm going to call it user ID and I'll explain why. And what we're going to do is we're going to set up a special foreign key. And a foreign key is how we tell SQL that this column here is connected to another table. And what we do is we specify two things. We specify the table that it should be connected to. So here I'm saying, hey, this should connect to the users table. And then we specify what specific column it should use from that table. And here we're saying the ID column because this connection is connected to the ID column of the users table. And so that's what we set the foreign key on. And all this does is this is really such a simple concept. Whatever user creates this post, we just embed the ID of that specific user. So for the post with the ID of 621, the user that created this has an ID of 212. So if we take a look at what user has an ID of 212, we go here and we can see that clay@gmail.com created this post. And so that's all we have to do to set up a relationship between these two tables. And so now moving forward, any post we create, we'll easily be able to tell what user created it because we're going to embed the ID of that user into this column called user_ID. And if you take a look at the second one as an example, we can see that this was created by a user with an ID of 378. So we go into the user table and we can see that this user is mike@gmail.com. And it really is as simple as that. And this is what's referred to as a one-to-many relationship within SQL or any relational database. And the reason why they call it that is because one user can create as many posts as they want. However, a post can only be associated with one user. Two users can't create a post. And so that's why this is referred to as a one-to-many relationship. One user can create many posts. And that's all we have to do. It is actually that simple. We just create another column, and then we have to specify this special foreign key constraint where we just tell SQL, hey, what table do we look for and what column? And keep in mind, in this case, I'm using the ID of the users table. But when you get a little bit more advanced with SQL and setting up relational databases, you'll find that sometimes you don't have to always point to the ID of another table. There's going to be a lot of instances where you set up foreign keys to other columns that aren't necessarily the ID column, depending on how your relationships are set up and how your application should work. That is a perfectly acceptable thing. There's no specific restriction saying that it has to point to the ID column of another table. And so I think that's enough theory behind foreign keys and relationships. So we're going to connect to our Postgres database in the next section, and we'll start creating that extra column, adding the foreign keys, and then we'll start learning about how to actually work with these relationships. All right, guys, go ahead and open up PgAdmin. And before we get started, I'm going to do something a little unusual. I'm going to delete everything from our post table. Now, when it comes to creating an extra column and creating a foreign key, that's not a requirement. You don't need to do that in a production database. I'm just going to delete everything just to make things a little bit more simple moving forward. Because if we don't delete anything, when you start to add columns that especially have a not null constraint, we have to do a little magic to kind of get that to work. And I want to keep things as simple as possible. So what we're going to do is we're just going to delete everything from the post table just to make things as simple as possible. So we could just say delete from posts, and that should delete everything, and everything's gone. And we should be pretty much good to go to actually start setting up our foreign key. So right click on your post table and then click on properties. And the great part about these foreign keys is that, we just have to do this on the post table because it's a one-to-many relationship. There is nothing in the users table that we have to do. So what we're going to do is we're going to go to column, and then we're going to add a new column. And I'm going to call this user_ID. And you can once again name this anything you want. The actual name doesn't have to make sense. But, I think naming it user_ID makes sense because this is a column that's going to represent the ID of the user that created our post. The data type. Now, this is important because the data type of this column needs to match whatever the data type is of the ID column from the users table. So we always set the ID up to be integer, so you want to match this. However, keep in mind that sometimes when you're working with databases, it might be some other data type, right? If you use big int, you definitely want to make sure that this is also a big int. If you use a small int, make sure this is a small int. If you use UUIDs, make sure that this is a UUID as well. You just want to match up with whatever that column is in that respective table. Now, we have the options to set this as not null. So right now, we can create a post with a null user, which means there's no user that created this post. And to figure out if you should set this to be not null, it just depends on how you want to set up your application. Should the database allow you to have a post without a user? It's up to you to decide. I'm going to say no for now. I'm going to say not null because I don't want to be able to create a post without a user. It doesn't make sense. All right. And then after that, what we can do is we have to set up our foreign key constraint. So let's go to constraints. And then we want to go under foreign key. So this is where we set up that magical connection between the two tables. Hit the plus sign and then give this foreign key a name. The name of the foreign key doesn't matter, right? It doesn't impact the functionality of anything. This is more just for you as a user to be able to read it a little bit more clearly when you see it on the CLI. But there's a standard convention that we like to use when it comes to naming our foreign keys. What we like to do is we like to take the table that we're working on. So it's going to be posts. And then we do underscore, then the table that we want to set a foreign key to. So it's going to be users. And then we just do underscore F key. Once again, this is just nothing more than a name to describe the foreign key. It's not actually doing anything at the moment. To actually set up the logic of the foreign key, we have to open this up and we have to go under columns. And so this is how we actually set up the relationship. So here we're saying, what is the name of the local column? The column in our posts table. Well, we created our brand new user underscore ID. Then it's going to reference what table? Well, we know it's going to reference the users table. So we select the users table. And then what column from the users table is it going to reference? Well, it's going to reference the ID column of the user table. And then at that point, you just hit plus. It gets added up here. And before we move on, there's one last thing I want to cover because we're almost done. We have to go under actions. And because we're setting this relationship up between two different tables, we have to figure out, what happens when a user gets deleted, right? Because right now, a post is going to have the ID of the user that created it. What if we delete that user? What do we do? So if you go to the on delete section, we have a couple of different options. One of the more common ones is Cascade. And so what Cascade does is, let's say I have a couple posts that were created by a user with an ID of 7. If I delete that user, then Postgres will automatically go into my post table and delete any posts that were created by that user. And so that's one option. That's what I'm going to use. However, we have other options as well. We can set it to the default value of the column. So if we give the column a default value, maybe we create like a random ID of 0 or something, then it's going to assign all of those posts that were created by the deleted user to 0. We can set it to null. So if we did set null, then it's just going to set the user ID column to null if that user gets deleted. Keep in mind, if you want to be able to use set null, then you have to go back to columns to make sure this is not set to allow you to set it to null. So we'd have to set it to no, or then it would throw an error when you try to delete someone. And then there's a few other options, but we're going to stick to Cascade. And then keep in mind, you can do the same thing with on update. So what actions do you want to perform when you update a specific user in that case? But we'll leave it as no action for now. I just mainly care about the on delete. At this point, that's all you have to do for foreign keys. You just specify the column of the other table it should point to, and you're good to go. We'll hit save. And then we're going to go under posts. Well, actually, before we do that, we're going to go under users. We're going to view all rows. And let me clear out some of these. There's too many windows open, right? And these columns got a little squished. But right now I have 3 users. It's got an ID of 17, 18, 19. So go ahead and remember that. Obviously, your database is going to be different. So just remember the IDs of a couple users. And what we're going to do is we're going to go under our posts and we're going to view edit. And so right now I have no posts because I deleted everything. So I'm going to create a brand new post. And I'll just call this, this is my first post. And the content is just going to be some random content. I'll leave published blank because we've got a default value. And then right now, if you take a look, we've got this new user ID column. So if I try to save a post right now, take a look at what happens. It gives me an error. It says null value in column user ID violates not null constraint. So because we said that user ID cannot be null, we have to provide a user ID. So let's give it an ID. And if we go back to users, I can see that there's going to be, I can use 17, 18, or 19. So whatever user created this, I'll just say John created this. So we'll grab an ID of 17. And I'll say that this is going to be an ID of 17. And then if we save this, look at that. We now have a relationship between the users table and the post table. Let's create another entry. I'll call this second post. And it's going to have some random content. And I'll say that this was created by the user with an ID of 18. And that should work just fine. Now, what I'm going to do now is, what happens if I create a post and I give it an ID of a user that doesn't exist? So I have IDs of 17, 18, 19. What happens if I set the user ID column to be a value of 20? Well, let's try that out. So I'll just call this third post. And then we'll set the content to be something random. And if I set this to 20, let's see what happens. If I hit save, look at this. Insert or update on table post violates foreign key constraint. There's no user with an ID of 20, right? So that doesn't exist in that table, so it's going to throw an error. So that's the magic behind foreign keys, that it's going to check to make sure that that user actually exists. And so this isn't going to work, so we'll just set this to 17 as well. No, save that. Right? And that's it, guys. And when it comes to, kind of querying these users, right, let's go back to our database and let's just set up a query. Now, let's say I want to get all of the posts created by user 17. Well, we can do select star from posts where, and now instead of, searching for based off ID, we grab the user ID column and we set that equal to 17. So this is going to get me all of the posts that were created by user 17. If I run that, you can see that this got the 2 posts from user 17. And then if I change this to 18, we're going to get the 1 post created by user 18. So from a SQL perspective, right, nothing's really changed. You just specify what column you want to match on and then provide a condition. Now, what I'm going to do now is I'm actually going to delete this user. So I'm going to go and just say delete from users where ID equals 17. So we're going to delete John at Gmail. And we're going to actually do that here. So I'll say, first of all, select star from posts. All right, so we've got all 3 posts. And I'm going to run another query, except I'm going to say delete from users where ID equals 17. So what is going to happen when we delete those users, because we have posts that have relationships to them? Well, since we set the onDelete to cascade, it should delete these posts automatically for us. So I'm going to leave this down here, so it's going to run another query so we can see exactly what our table looks like after we delete this user. And so if I run this, you can see that when I run a select star from posts, there's only 1 entry left, and that's the one with the user ID of 18, because it automatically deleted all of the posts created with an ID of 17. All right, and so from a database perspective, I think this is all we really need to cover for now. Eventually, we'll start taking a look at joins, which is how to run these complex SQL commands that allow you to jam the columns of multiple tables into one result to make it a little bit easier to retrieve information. Because right now, if I try to get all of the posts, like send me every single post in my database, right? It's just going to give me the user ID. But if I need the information about the user, like what's the name of the user, what's the username or the email, then I would have to individually query the IDs of these users. So I'd have to go then, I'd have to do, a select, whoops, make sure I don't delete anything. I'd have to do a select star from users where ID equals 18. And I'd have to do this one by one for every single post so that I can get this specific user. And so that's when we start to make use of things like joins. But that's a little ahead of us at the moment, and that takes a little while to explain. So we're going to come back to that. But before we actually kind of move on from this database side of things, because we pretty much covered everything, we're going to delete that column for now, because we're going to make sure that Sqlalchemy actually sets up all of these constraints for us automatically so that we don't manually have to do it. So let's go to our properties, go to columns. We can just delete this column. And then I think this should automatically delete the foreign key. It does not delete the foreign key, so make sure you delete that as well. And then we can save that. And it looks like it's throwing an error. So let me cancel out of that. And I think we're going to have to do this in a 2-step process. So we'll say constraints, we'll delete the foreign key first. We'll save that. And then properties, we'll delete the user ID. There we go. And so now if I do a select star from posts, right, there should no longer be a user ID column. So this put our database back into the state it was in before we started playing around with it. So now that we know how to create and set up a foreign key within Postgres and PgAdmin, we're going to see how we can do this through code using Sqlalchemy. Because ideally, since we're already using Sqlalchemy to generate all the tables, generate all the columns for each table and all the different properties, we should also set it up to generate the foreign key for us as well. So we're going to go to the models.py file. This is where we define what the tables are going to look like with the different classes. And we're going to add a new user ID or owner ID column to the post class. And that's going to create a specific column within the post table. And so we can just go here and, call it owner ID, user ID, whatever you want. I'm just going to call this owner ID. And this is going to be column. And then here we have to specify the data type of the column. And as I mentioned, the data type should match up with whatever the data type of the foreign key is. So since this column is going to point to the ID column of the user table, it should match up with whatever is here. So since this is integer, this has to be integer as well. Then to set up a foreign key constraint, you just type in foreign key and then go ahead and auto import that. If you don't know where it's getting imported from, it's going to get imported from Sqlalchemy. So if you didn't automatically do it, you can go ahead and just manually type that out. And then there's going to be two fields that we're going to pass in. So the first of all, we have to pass in the exact column and table and column that we want to reference. And so we want the users table and then grabbing the ID column. And so your instinct would be to use the class name, but we don't actually reference the class name. Instead, we want to reference the table name. So it's going to be lowercase in this case. So you say users dot, and then what's the column name? It's called ID. So we say .id. And then the second thing we need to do is, if you recall, we have to set up what the policy is for when we delete the foreign key or the parent table. And so we always used cascade so that if the parent object gets deleted, all of the child objects get deleted as well. So we can do that through Sqlalchemy as well. And we'll say on delete equals, and then we just say cascade. And then finally, we want this field to be nullable equals false. So it has to be filled in. All right, and now if we save this, restart our application, we'll take a look at Postgres. And if I actually refresh this, and this is actually an old panel, so I'm going to remove that. And then if I just do, we'll go to our post table, go to query tool. I'll say select star from posts. Run that. You can see that there is no actual owner ID column. And so the reason for this is that Sqlalchemy, when we start our application, Sqlalchemy will check to see if there's a table called posts. And if there is, if there isn't, it's going to then create a table based off of these rules. However, if there's already a table named posts, it's not going to do anything. So if we update any properties for a pre-existing table, it's not going to change that. That's not exactly what Sqlalchemy is meant for. Instead, we would have to use a database migration tool, kind of like Alembic, which we haven't covered yet. So instead, for now, what we're going to do is we have a couple of different options. We can manually just do it, go into PgAdmin, add the things yourselves, or we can just take the easy way out. Since this is a development environment, we can just drop our post table. And that's one of the luxuries of working in development. So you can then hit save again, and that's going to cause it to restart the application. And then if we go to Postgres and we just hit refresh, it's going to create a new post table, and then we can go into properties and we'll go into columns. And we now see that we have an owner ID column, which is set to not null. That's good. And then if we go to constraints, foreign key, you'll see that we've got our foreign key, and you can take a look at the details down here. And the main thing I want to check is for actions, we do have on delete cascade. All right, and so now that we have everything set up, if I just run this query again, we should see the owner ID show up. So let's create a few entries. And before I do that, I need to make sure that I actually have some users because I kind of went in and deleted a few things. So I've got two users with an ID of 20 and 21. And so what we're going to do is we're going to make sure that the foreign key points to one of those IDs. So we'll grab a post. I'm going to just set this to be post1 as the title. And it's going to be some gibberish. And then we can set the owner ID to be the ID of a user that we already have in our database. We'll save this, and we can see that it's successfully created. Now, if I create a new post, and this time leaving the owner ID blank, if I hit save, you can see that it throws an error because this can't be set to null. And if I try a ID of a user that doesn't exist, like 57, it should also throw an error. And so it's saying that, hey, the owner ID of 57 does not exist in the users table. And I'll just change this to 21, and then it should work. Great. Now let's quickly check out the on-delete functionality just to make sure that it works. And what we're going to do is let's go to, well, I'll just run the query right here. So we'll do delete from, and we'll say users where ID equals, and we're going to delete the user with an ID of 20. So if everything works, we should see just this entry also get deleted in the post table because the owner has an ID of 20. And since that owner is going to be deleted, then we should only have this one left. So if I run this, yep, we can see that the one with the owner ID of 20 is now deleted. All right, and so that kind of handles all of the database side of things. At this point, if you try to test the rest of your application, you're going to probably run into a couple of issues. But that's just because we've hard-coded our schema to match a certain number of properties. And so since we've added this new property to our posts, it's going to throw a few errors. So we're going to have to update a few things in the next video, but you'll see that updating your schema is very simple. With the changes we made in the last lecture, it's inevitably going to cause some issues with our application. So there's going to be a few things that we have to update within our app. And so let's just quickly run through a couple of our requests just to see what they look like, see what changes we need to make. And so if you haven't already done so, log in a user. And so once we're logged in, we should update the variable. And now we can retrieve our posts. So if I hit send here, you could see that we retrieve all of the posts in our application. I just have one in this case. But the first issue that I see is that we're not returning the owner ID. Right? This is a brand new column, and I would expect this information to get sent out to the user. And the reason why it's not included in here is that we have to actually update our schema, because our schema probably doesn't have that owner ID because we never added that in. And you might be thinking, well, do we actually need to send it? Yeah, I think it makes sense for us to send it because in any application, the user should know who creates a post. So ultimately, they're going to have to get that information. And so we should provide the owner ID. So let's go to our code. And if you actually go to the posts router and take a look at the get all posts, you'll see that the response model is going to reference schemas.post. So let's go to schemas.post. And you can see that this is what we're using to return. This is the schema that we're going to use for returning posts to a user. And so this actually inherits from Postbase. So Postbase has title, content, published. And then we extend that and we're going to add the ID, which gets created at the database level, as well as the date and time, or the created at field, which gets added by the database. So we can add it here. However, I'm sure you're thinking, well, could we add it at Postbase? Should we add it at PostCreate? Well, let's think about this. Right, the first thing that we have to think about is when we create a post, should we be passing in a owner ID? Well, that we 100% absolutely could do that. And that actually does kind of make sense. So in that case, if we did want it to be available or require it for creating a post, then we would add it under post create here as well. Or we could just add it under Postbase so that both of them inherit it. However, what we're going to do is we're actually not going to require the user to provide the owner ID. Instead, what we're actually going to do is we're going to let the logic of our route to actually just grab the ID from the token and then use that as the field. So we don't actually need the user to pass that into the body. So we're not going to use that field or apply that field to either one of these classes. We're just going to do it for the post class, which is the one that's responsible for sending the post out. So I'll add a column here, and we'll call it owner ID. And I'm going to say that this is going to be a type of int. All right, let's save that, and let's see if that makes a difference. So let's hit send. And so now we can see that we get the owner ID. And that's really all the changes we have to make. So if we actually go to get one post, and we look at our code here, and if you look at the post.py, for getting an individual post, you can see that we're returning the same exact model. And if we take a look at creating a post, we return the same model. So all of those will be updated accordingly. And same thing with the update post. The update post also uses schemas.post. So since we're using the same schema for all of them, we don't have to do anything else. And we could just quickly test that out. So I'll do get one post. And I realized we have to actually get, what was the ID? ID is 4. So we're going to update this to be an ID of 4. You can see that we now have the owner ID there. If we update it, right, we can once again get the owner ID. And at that point, it looks like everything else is good. However, if we go to create posts real quick, and we create a post, right, we get a crash actually. So there is an issue with creating a post, and I'm sure you guys can guess exactly what it is. Take a look at the error when we try to create a post. Right, it's saying there's some kind of SQL error, and it says there's a null value in column owner ID. And that makes sense. And that makes sense. So we'll actually tackle this in the next video, and you'll see that it's going to be pretty straightforward to actually get that resolved. So in the last video, we learned that the create post functionality is broken now, because if I try to create a post, you can see that it sends back a 500 status code. And if we take a look at the logs, we can see that it looks like there's some issue with the SQL, and it's saying that the null value in column owner ID violates the not null constraint. And so looking at our model, we obviously set the owner ID right here. And this is set to be nullable false. So we actually have to provide who the owner ID is for this new post. So how do we do that? Well, let's go to our post path operation, and let's go to the create post path operation. And so it's right here. And so nowhere in this code are we actually providing a user ID or owner ID into this new post that we're creating. We're just grabbing the post, which comes from post create, the schema. And if we look at that schema, you can see that we do not provide a owner ID. And like I said, we're not going to actually pass the owner ID in the body. What we're going to do is whoever is logged in and creating the post should automatically be the owner, right? If you're logged into Twitter and you post something, Twitter knows that you're the one creating the post. So whatever ID is associated with your account, it's going to set that automatically. So we shouldn't have to pass that in the body. We should automatically retrieve it from your authentication status. So within post, right, you can see that we have the current user. And so we should be able to get the current user or the user's ID. So if I do current_user.id, and we can remove this, I don't need the email. And if I try to create a post, it's still going to error out. That's okay. I just want to see what it prints out, though, before the error. And you can see we got a lot of errors. That's okay. And you can see that it printed out the ID of my user, which is 23. And just to double check that that's actually my user, I'm going to select star from users. And you can see that 23 is Sanjeev@Gmail. So we could just take that and just add that into the new post object. And so we're creating the new post right here where we reference models.post. And what we're doing is we're just spreading, we're just spreading out the schema that we got from the body. And so to actually add the ID property, it's very easy. All we have to do is just say owner_ID is going to be set to current_user.id. So we're just grabbing that from the get current user function, just like we did right here. And I think we probably need a comma there. And that should be all that we have to do. So I'm going to remove this code. And let's test this out now. So if I do create post, look at that. No errors. You can see that the owner ID was automatically set to the ID of my user, which is 23. Currently in our application, we do have authentication set up for delete post and update post. However, there's no check to make sure that a user is only deleting his own posts. Right now, if you're logged in, you can delete anyone's posts. And no application works like that. You should only be able to delete your own post. No user should be able to come in and delete one of my posts. That doesn't make sense. So let's implement the logic for setting up a quick little just if statement just to check, hey, is the person that's logged in trying to delete a post that he owns? If he doesn't, then we're going to return an error. And so right now, if you take a look at our delete post path operation function, we query the post that he's trying to delete, and we check to see if there's no post. If there's no post, then we send a 404. That's expected. But if we did find a post, the next check is just going to be another simple if statement. And we're going to say if post.owner_ID does not equal get current user .id. So these two things have to match for the user to be able to delete it. If they don't match, then we're going to send another HTTP exception. So we'll say raise HTTP exception. Now the exception, we'll set the status code to be a new one. So this one's going to be a 403. So this means forbidden. That means it's a resource that they specifically aren't able to access, because we could send a 401, but they are, I guess a 401 could also work, but I'm going to do 403. I think that makes more sense. And then we can set the detail. And I'm just going to say not authorized to perform requested action. And this exact same check can be used for updating posts as well, because it's the same exact logic. And I'll just do that right here, right under the same check. So same logic, right? First thing we're going to do is we're going to check to see if that post exists. And then the next thing we're going to do is we're going to make sure that the owner of the post is whoever the user is logged in as. Now let's test this out. So right now, if I do a get posts, you can see that the owner, okay, so we've got a post created by both owners. And I'm currently logged in as, I actually can't remember who I'm logged in as, but we can see that I used Sanjeev at Gmail, and that's going to be user 23. And what I'm going to do is go back to get posts, and I'm going to try to delete the post with an ID of 4, because that's the owner ID of 21. And keep in mind, right now, I'm logged in as user 23. So let's try this. We're going to delete post with an ID of 4. Okay, it's already set there. So we should get an error in this case. And it looks like I got a server error. That's a problem. And I already see the issue. And right now, post is actually not the post itself. It's the query. And to actually get a post, I have to do post.first1. So what I'm going to do actually is I could change this to post.first and then grab the owner ID, but I'm going to actually perform the query right here. I'll say post. Actually, I'll change this to post_query. I'm going to make a few changes actually. And I'm going to set this to be post equals post_query.first. And then I'm going to set this to be post. And this is going to be set to query. All right, and just to kind of quickly recap, we define the query here. We'll then find this post. We'll check to see if it's not there. And then we'll check to see if the owner is, if the user who's logged in actually owns this post. And then we're going to grab the original query, and then we're just going to append a delete so that we delete it. That's all. And let's just make sure the update is set up the same way. And it looks like the update one was already working that way, so it should be good to go now. Hopefully there's no errors. And let's try this. And once again, we got an error. And it looks like function object has no attribute ID. And I realized my mistake again. First of all, this is getting stored as current user, not get current user. So we need to change this to be current user. I'm not sure why I did it like that. It seems pretty goofy. And then this also should be current user, right? Because we're calling that function and we're storing the result in current user. So we want to reference the variable. I'm not sure if that was like an autocomplete that did that, or I just had a brain fart. Either way, hopefully it's the last of our issues. So let's try this. All right, perfect. Look at that. Not authorized to perform that requested action. That's to be expected because we don't own that post. However, if I do a quick search again, I do own the post with an ID of 8 because we can see the owner ID is 23 and that's who I'm logged in as. So let's try to delete post with the value of 8. Send. And we get a 204, so that means it's successfully deleted. We'll do get post just to verify. And we can see that we get those, just the one post now. So that seems to be working. I'm going to go back in. Actually, let me create a post real quick because I no longer have a post. All right, so we created a new post. And so you can see that this is my post right here. And I'm going to just update it. So let's go to the update one. First of all, I'm going to try to update a post that I don't own. So we're going to try to update the post with an ID of 4. We should get a not authorized. And then let's grab the ID of the post that we do want to change, which is 9. Let's hit send. And it looks like it updated a little bit. Let's check our database always. So we'll say select star from posts. And the post with the 9 got the updated entry. Oh, wait a minute. It looks like it may have updated both of them. Only one way to find out if that's actually what's happening. I'm just going to create a quick new post. I'm just going to set the ID to be 23. All right, and I'm going to update post with 9 with an ID of 9. Okay, and then let's refresh this. Okay, so post with an ID of 10 is still the same. So, okay, it wasn't a bug. It looks like maybe I had changed this earlier. And I'm not exactly sure why when I updated this post, but that's okay. And so I think that's going to wrap up this video. We've handled the update and delete so that we can only update and delete our own posts. All right, before we proceed any further, I do want to talk about one last thing. And that is that when we do get posts, which is an authenticated route, so it requires you to be logged in to retrieve the posts. If I try to retrieve the post, you'll see I get posts from every user. Now, this may or may not be the result that you want, right? It's going to depend on what your application is going to look like. If this is like a note-taking app or something where all of your posts and things like that are all private, then you wouldn't want to return everyone else's posts. You'd only want to return the user's specific post. However, if this is some kind of social media app, right, then obviously your posts are public. So when you do get post, you would want to return everyone's posts. And so it really just comes down to how you want your app to function. I'm going to show you guys what you would need to change if you wanted to make it so that you returned only your own posts. But afterwards, we're going to actually delete those changes because I want to leave my app like this. This is kind of how I wanted it to work, more like a social media app. But I do want to make sure that you guys understood how to make this change. And the same thing would go for get one post. We want to make sure that only the user that created a post can retrieve that specific post. And so if we go back to our path operation for getting all posts, you could see that we just do a db.query.all. And so if you only want to return the posts for a specific user that's logged in, it's very simple. All we have to do is do a filter. And here we'll say models.post.id equals, and then we just get the current user's ID. And it looks like I still left this as user ID, so this should actually be updated to be current_user. And if you notice, you can see that the type is set to int, even though it's actually returning an entire user object. I found that whatever type you put here doesn't actually impact the code. So put whatever you want. You can put in some sort of dictionary that actually correctly matches it, but you could just leave it as well. So I'm just going to leave it like that. It doesn't break any logic. And then at this point, I believe I'm still logged in as user 23. If I try to retrieve all posts, looks like I got nothing. And that could be a little bit of a problem. So let's see what we broke. And the easiest way to kind of troubleshoot this is what I'm going to do is I'm actually going to remove the .all. So that's going to return the query. It just won't actually run the query. And I'm just going to print the query. Let's see what that looks like. Sometimes it helps to see the raw SQL. So let's hit send. All right, we should get an internal server error. That's to be expected. But I just want to see my print statement. All right, so let's see our print statement. So select, we're getting all of the columns, that's expected, from posts where posts ID equals this value. So that looks like it's perfect. Well, let's just quickly see before we move any further, what exactly is my user ID? And we'll just check our database. Okay, and we'll run this again. And then we're going to check. All right, so 23. And then if we go to our database, and I realized the exact mistake that I made, and this is a stupid mistake, right? This is looking for a post with an ID, with this specific ID. We don't want the ID of the post. We want the owner ID. So we'll do owner_ID equals current user ID. All right, let's test this out now. Once again, an error, but I just realized I forgot to update this to be .all. And then we'll try this again. And now we get all the posts with an ID of 23. If I log in as a different user, let's say this is Sanjeev1, I'll log in. That should update the token. So now if I do a get all posts, it should return all posts with an ID of 21. And so that's how that works. And then if you want to see how that looks like for retrieving an individual post, we'll go to get _post. And to actually handle this logic, it's going to be the same thing as a delete. So you can just copy what we did for the delete one. And here I can just say post.owner. And this should do the same exact thing. So now if I do get one post, well, first of all, let's take a look at all of our posts. Actually, I'm going to do it in our database. So I'm logged in as user 21. So I should be able to access a post with 4, but I can't access a post with an ID of 10. So let's try 10. Am I able to access him? Not authorized. Let's try ID of 4. And I can get that one. So that's how that works. But like I said, I don't want my application to work like that. So I'm going to remove that functionality. I'm going to make all posts essentially public. And then we're going to remove this filter. And I'll remove this print statement and this print statement just to clean things up a bit. And let's just double check that we didn't break anything once again. So let's get all posts. We get all posts. And let's get an individual post, regardless of who owns it. And that's all fine and dandy now. Now, just kind of thinking ahead of what our front end would look like, even though we're not going to build it, taking a look at any social media type application, when we retrieve the posts, we usually want to embed the user's ID. So we want to know who actually created the specific post. We wouldn't just put the owner ID because none of your users understand that ID. They want to see what is your Twitter handle, what is your email, whoever created that. We want to see their user ID. So it looks like for all of the posts that we retrieve, we would have to then send a second query to retrieve, hey, what is the information for user with an ID of 23? And then once we get that, we would then have to kind of combine all that data so that we can figure out what post it belongs to what user and what is their specific username. Now with Sqlalchemy, we can kind of set it up so that it automatically does this for us. And so if we actually go to our models, what I'm going to do is I'm going to set up a relationship. And so this relationship isn't a foreign key. It does nothing in the database whatsoever. But what it does is it'll tell Sqlalchemy to automatically fetch some piece of information based off of the relationship. And so here I could say, we'll create a owner. And I'm going to say owner equals relationship. And we probably have to import this. And so it did. So it imported relationship from sqlalchemy.orm. And so if you haven't done that, go ahead and do that. And what we'll say is, this is going to return the class of another model. So here I want to return the user. And this is going to be a capital U because I'm not referencing the table. I'm referencing the actual Sqlalchemy class. So what this is going to do for us automatically is that it's going to create another property for our post so that when we retrieve a post, it's going to return a owner property. And what it's going to do is it's going to figure out the relationship to user. So it's going to actually fetch the user based off of the owner ID and return that for us. And there's nothing else we have to do. It actually is that simple. This is one of the great parts about Sqlalchemy is that these relationships will automatically make it so that it fetches that data for us so that we don't have to manually do it ourselves. So let's test this out. Let's see if this actually works. I'm going to go back and I'm going to retrieve all posts. And it looks like nothing's changed. We don't get any user information. We do, once again, just get the owner ID. So what happened? Well, you probably can guess we need to update our schema. And so if we go to our post, we're now going to return a user. And so here, what we would do is we would just add another property called owner. And then here it would, instead of returning an int or a string or anything like that, we can actually return a Pydantic model. So I can say, I want you to return a user. Whoops, a user, but it looks like we don't have a user class. We have user out, and then we have user create. So which one do we actually want to return? Probably user out, because that's what we're returning. The user create is for creating a user. And you notice that we get an error actually here. And that's because this user out hasn't been defined at this point in the code. So you have to read Python top down. And so user out is actually defined all the way down here. So if you wanted this to work, we would have to move all of the user stuff up a level. So I'm going to cut this and I'm going to just put it right above post. And so this should remove the error. And so now it looks like it's good. And so once again, all we did was we added a new property called owner, and this is going to return a Pydantic model type called user out. And so that's all this is returning now. So let's see if this fixes our issue. And now I'm going to retrieve all posts. And so now take a look at this. It automatically fetched the owner. It got the ID, it got the email, it got when their account was created at. We may not want that, but for now, I think this makes sense. We could create another class to kind of narrow down the exact fields that we specifically wanted for this situation, but I think this is good enough. These are all the informations that I want actually returned. So this is perfect. It's going to do this for every post. And if I try to get one post, it's also going to return that specific owner. And so in reality, to get this functionality, right, once again, all we had to do was just create this relationship. And so once Sqlalchemy understands the relationship, it's going to fetch that piece of information for you from the user model. In this lesson, we're going to take a look at query parameters. And if you've never worked with an API, you may not know what that is, but I guarantee you, you have worked with them before and you have seen them. You just had no idea what they were. And so I'm on Yelp.com, and I'm just doing this for demonstration purposes, but I'm just going to do a quick search here. I've just picked a random city. In this case, it's Miami. We're going to search for that. And I want you to take a look at the URL. And so our URL is, first of all, we have the domain name, which is kind of like the IP address. And then we have the specific endpoint that we want to reach. So this is the /search endpoint. And so in their API, they've set up, some sort of endpoint that probably is allows you to search for restaurants. And then we have a question mark. And I know you guys have seen this before because pretty much any website you've ever used, you'll see that question mark whenever you're searching for things. And any results you get, you'll see that in the URL. And so everything to the right of that is what's referred to as query parameters. So all of this is query parameters. And a query parameter is an optional key value pair that appears to the right of the question mark. And these query parameters allow us to kind of filter the results of a request. So, if we're trying to retrieve posts, maybe we don't want all posts. Maybe we want to get posts that were created in the last 2 hours. Maybe we want to get posts that, if it's a social media type app, maybe we want to get posts that have received over 100 likes, right? These are all things that you would do using query parameters where you can say, hey, you could just pass in a key and a pair, and you can say, I want to find posts, that are less than 2 hours old. And so a lot of other operations that are necessary in an API, things like pagination, those are all going to be done with query parameters. And if you take a look at this one, since we searched for Miami, right, it looks like it passed a query parameter called find_loc, which probably means location. And then it says Miami, Florida. And so it's going to basically talk to the API and say, hey, listen, I need you to get me all the restaurants, and I want you to filter down based off of restaurants in Miami. And so that's kind of how query parameters work. And so for us, it's up to us to define what query parameters we want to allow and what we want them to do. And it's going to vary from app to app, but you'll see that most APIs have a couple of query parameters that they all use. So let's go to our app real quick. And what we're going to do is we're going to go to our post router. And in this case, we've got our path operation for retrieving all posts. And what I want to do is I want to let the user be able to kind of filter down on the posts that they want to see. And the first thing that I'm going to do is I'm actually going to allow them to specify how many posts they want to retrieve altogether. So I want to give them the option to say, hey, I want 10 posts, or maybe I want 100 posts, or maybe I want 50 posts. We should allow the user to define that. And so to allow a query parameter, we could just go into our path operation function and just pass in another argument. So I'm going to do question mark. Then we give it the name of the query parameter. So this is the key, essentially. And I'm going to call this limit. So this is going to limit the number of posts they get. And this is going to be of type int. And we're going to give it a default value. So we'll say that, by default, if they don't provide a limit, we're going to say the limit by default is 10. And now all I'm going to do is I'm going to print out limit. All right. And I'll show you guys how to actually send that query parameter. So let's go to our get all posts. And so to send a query parameter, it's very easy. You just type in a question mark. Then you grab the name of the query parameter, which once again is limit. So we'll grab limit. And then you say you set it equal to whatever value you want it to be. So if I want to get a limit of 3, if I hit send, right, nothing should have changed in our code, but you can see that we were able to print out the limit. So that's how we access query parameters in FastAPI. It's pretty simple. You just pass it in as another argument into your path operation function. But let's actually set up our query so that it now takes into account the limit. And with Sqlalchemy, anytime you want to, perform another operation, you usually have a built-in method. So I'm going to remove this .all for now. And so if I want to limit the number of results, I just do dot, and then let's see what methods we have at our disposal. Since we're looking for something that limits something, let's maybe check to see if there is a limit method. And looks like I don't see one here, but there actually is. We can do limit, and then here I'm just going to pass in the limit variable. And then after that, we can just do the dot all as we usually do. All right, and so now, well, first of all, in our database, we don't actually have that many posts. So I'm just going to create a couple. Well, actually, I could just do this through our API a lot quicker. So I'm just going to create a whole bunch of posts. And so that should give us 5 posts. Well, let's create a few more. All right, so we've got 11 posts now. And we'll go back to our API and we'll say, I want a limit of 3. So let's send that. And let's see if we only get 3 posts. So we get 1, 2, 3. Perfect. And if I don't provide a limit, well, actually, let's try a different number. Let's try 5 now. All right, we get 1, 2, 3, 4, 5. Perfect. And if we don't provide a limit altogether, it should return 10 because our default was set to 10 posts. So a limit of 10. And so we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 11 results, so there's one result that it didn't provide. So we've got the limit functionality down. What I want to do now is allow the user to skip results. So it grabbed, depending on however Postgres has decided to return, 10 posts, it grabbed the first 10 based off of some criteria. And if we actually take a look at how it did, it looks like we got ID of 10, ID of 4. So it's kind of just all over the place. So it's probably not sorting based off of any specific field. We may want to specify that. But what we're going to do is I'm going to actually set the limit equal to 2. And so we'll get the first 2. However, Postgres determines what are the first 2 it should send, we get 2. But let's say we want to skip over a couple of them. Maybe we want to skip the first 2. Maybe we want to skip these 2. Well, I want to be able to send another query parameter called skip so that we can specify how many we want to skip. And if you want to send more than one query parameter, we just do the and keyword, and then we provide the next key value pair. So it would be like skip equals 2. And so just taking a look at the IDs here, we've got one with an ID of 10 and one with an ID of 4, and we want to skip both of those. So going back to our code, we're going to provide another path operation function. Another argument into the function, and we'll call this skip. This is going to be of integer, and the default is going to be, let's say 0. We don't want to skip anything by default. And to add this to our query, we use the keyword offset. So we do offset. And then here I'm going to say offset equals skip. All right, and so we should be able to skip over both of these. And so if I provide a skip of 2, you can see it first starts out at 9 and then 11. If we do skip 0, right, it shouldn't skip any, right? 10 and then an ID of 4. If we skip 1, it should just skip the 10 and then start off on 4. And we can see that the first one is 4. So it allows us to skip over posts. And so that's ultimately how we're going to implement pagination on the front end, is because the front end should be able to skip based off of what page they're on. So if each page returns 20 results and you want to go to page 2, then you want to skip 20 results. If you want to go to page 3, you would skip 40 results. Now, the last query parameter I want to set up is a search functionality. I want the user to be able to search based off of some keywords in the title or maybe even the content, depending on how we want to implement searching. For now, we're just going to say we'll be able to search based off of the title. And the way that the search will work is we'll have another and we'll say search equals, and then, some random text. And so once again, we're going to provide another argument called search. And this is going to be of type string. However, this is, we can't exactly give a default search. So I'm going to say this is optional. It's going to be an optional string. So we don't have to provide this. And the default is just an empty quotes. And it looks like I have to import optional from FastAPI or from typing. And so here I'll just say import optional. And this is going to give us an optional query parameter. And so what we're going to do here is I'll say filter. And to filter this, and just kind of like how we filtered based off of a specific user ID or a specific post ID, I can say models.post.title. And then we can use a method called contains. So we can say contains and then the search keyword. So this will allow us to provide some kind of string, and it'll just search for the entire title of a post, and it'll see if the search keywords are anywhere in the post title. It doesn't have to match completely. It just has to be somewhere in the post. So this will give us a little bit of flexibility so that we don't have to match the exact name of the post. We could just provide some keywords like hot dogs or beaches or whatever, and it should be able to just see if it's contained in there. So let's take a look at our database. You can see that we've got a lot of ones that say top beaches in Florida. So I'm just going to do a search. And if I just search for beaches, it should return all of these because they all contain the word beaches. And I'm just going to do a search, and I'll get rid of the limits and the skip for now. We don't really need that. And all of the results should be, actually, I don't think I saved it. Let me save that. And now if I do this, you can see that every result is going to have the word beaches in the title. And when it comes to query parameters, you can string as many as you want. So if you wanted the limit as well, and we'll set the limit to 2, and we can also provide a skip equals 1. You can add as many of the query parameters that you want. So now you can see that we set the limit to 2 and we skip the first one. Now, the last thing I want to show you guys is how to use spaces in your search query. Because right now we just have the word beaches, but let's say I wanted, just going into our Postgres database, let's see what I've got. Maybe I want to search for beaches, hello, or something beaches, right? How would I search for that in a URL? I can't put a space in the URL. I can't say, something beaches. So how do I do a space? Well, I can do % and 20, which is which means space in your URL. And then you can do beaches. So then just to verify that that's actually returning what we want, I'm going to do a print, and we're going to print out the search keyword. And we're going to test this out. So if I hit send, you can see that it returned the one result that has the word something and then beaches, but it doesn't return anything else. What I would like to do now is do a little bit of cleanup on our main.py file. You'll see that there's a lot of unnecessary imports that we don't need, especially since we moved all of our routes into their respective folders. So you'll see that a lot of these are grayed out. And so anything that's grayed out, we can move. But before we actually do that, what I actually want to do first is I want to take this code for connecting to our database using the regular Postgres driver. And I'm going to move that to our database.py file. And keep in mind, we could just delete this because we're no longer using this, and we're using Sqlalchemy to actually connect to our database. So you can actually delete this. But just for documentation purposes, I'm actually going to just cut this out, and I'm going to move this into our database.py file. Just so that you guys have this for reference in case you ever want to, run raw SQL directly using this Postgres library instead of using Sqlalchemy. I want to make sure this course covers as many different, possible situations for you guys. But moving this here, obviously we're going to get some errors because we have to import all of these. And I'm just going to go to our main and I'm going to import them from here. So here, I'll just copy these two. And we'll actually just cut it out. And then it looks like we also need time. Where is that coming from? It's just coming from the time. Okay. All right, that should remove any errors. And we can just comment this out actually, because we're not going to use that anymore. And then going back to our main, you can see that both of these are grayed out. So we're not even importing anything from typing anymore, or we're not using anything from typing. So I'm going to remove that. You can see that we're no longer using status. So we're no longer using all of these. So I can remove all of those. And I'm not using the body here anymore. I'm not using anything from Pydantic. And I'm not using anything from random. We'll just get that a little bit closer. We're not using session anymore either, so I'll remove that. This, whatever that is, I'm going to remove that. And then we'll remove schemas and utils. We can remove getDB as well. And then obviously the posts array or list, that's no longer needed. These two functions, they're no longer needed. They were before we started working with databases. And then, I mean, we don't actually need this route anymore, but I'll just leave that in there. But you can see that our code is a lot cleaner now after removing all of those unnecessary imports. I'm just going to structure this a little bit better so all the code's a little bit closer together. And I think that's all the cleanup that we need to do for now. I just wanted to make sure there wasn't too much garbage building up in our application. When we first started working on databases, I mentioned that we should never hard code our database information or the database URL into our code, because this creates two issues. First of all, we're exposing our username and password right there in code. So anyone can see it. If we check it into GitHub, anyone who has access to it can see our password now. And at that point, we've compromised our application. But on top of that, the other big issue is that right now we've set this URL to go to our development Postgres instance, which is running on our local machine. When we actually deploy this to production, our Postgres server is not going to be running on this machine. It may not even be running on the machine that our application is actually deployed on. It could be on a completely different system. So we would need a way for the code to automatically update in a production environment to point to the actual production Postgres database instead of using the one that's hard-coded in here. And so we need a way to do that. And keep in mind, this isn't exclusive to just working with the databases. Any kind of confidential information, any passwords, secrets, anything that needs to get updated based off of the environment that it's in, needs a way, we'll run into this same exact issue. Right? And if we go to our OAuth2 file, you can see that we have our secret key hard-coded in here. This is something that we don't want to do. We don't want to expose this, and we need this to get updated between our development and our production environment because they may not be the same on both. So how do we do that? Well, we're going to make use of something called environment variables. And so an environment variable is just a variable that you configure on a computer. Doesn't matter what operating system, they all support it. And when you configure an environment variable on your computer, any application that's running on that computer will be able to access it. And that includes our FastAPI. So your Python app will be able to access any environment variables on the machine. And so instead of hard coding the values in our code, what we'll say is, hey, retrieve an environment variable named, whatever. Like we might have an environment variable called Postgres_URL, and that's going to contain the URL of our Postgres database. And so we don't need to hard code the actual value. We hard code just the name of the variable, and then Python will automatically pull in that variable. So let me show you guys how to do that. And I'm going to show you guys how to do this on Windows first, and then we'll take a look at this on a Mac or a Linux machine. Mac and Linux are the same steps. So I'm going to search for environment, and you'll see this edit the system environment variables. And what we want to do is we want to go to environment variables under the advanced tab. And here you'll see two sections. You've got system variables. This is going to be environment variables that are system wide, which means any user can access them. And then we have user specific variables. So these are variables that only I can access. And you can just kind of, go through these and just take a look at them. But you can see that we have an environment variable called path. Don't worry about what it's used for. This is something that gets set up when you install your machine. But we're going to take a look and try to access this. So you can see that this is the key, the variable name path, and then the value is some sort of path in our operating system or in our file system. So how do we actually access that? Well, let's open up a terminal. And here I'm just going to type in echo. And then we want to access an environment variable, just do % and then the name of the variable. So I'll say path with a capital P. And if I run this, you can see that it prints out that specific path. And so that's how you access an environment variable on the command line. With Python code, it's going to be a little bit different, but it's still pretty simple. I'm going to open up a new file just for demonstration purposes. You don't have to actually follow along on this. And to actually access a environment variable, we have to import the OS module. And then to access that variable, you say os dot get env. And then within this method, you just pass in the name or the key of the variable. So in this case, it's path. And I'm just going to store this in a variable, and we can call this anything. I'll just call this path. Why not? And then I'll print out path so we can see if it actually works. So now if I do pi-3 and then run example.py, you can see that it printed out that same exact path. Now to set a new environment variable, we would go to new, and maybe I create a URL, a variable name called Postgres, or we can just call this, how about my_db _URL. So this is going to have the URL to access our database. So I'm going to say this is at localhost :5432. I think that's what our database is running on. And I'll hit OK. And so here we can see that this is our new environment variable that we created, my_db_URL, and it's set to localhost 5432. I'll hit OK. And then I'll hit OK here. And then what we're going to do is we're going to try to access that variable. So I'll do echo my_db_URL %. And actually it should be %%. And you can see that it does not print out what we said. It just prints out exactly what we wrote. So what gives? What happened here? Well, anytime you set a new environment variable, what you got to do is you got to close out your terminal and open up a brand new one. So I can close this out, or I can just open up a new one. And this new terminal, well, actually, I don't want a PowerShell. I want a command prompt. So this new terminal will be able to access newly created environment variables because they get set as soon as the terminal opens. So once the terminal's open, I can't change them. So I have to open up a new one so that it can reread and import all of those environment variables. So now if I do echo %my_db_URL %, it looks like I may have mistyped this. So hold on, let me see what it's called. And that looks like it's correct. So what's happening? Well, I'm going to close out all of them. That's probably what's the issue. So let me open up a new terminal. And I'll open up a new command prompt. And now I'm going to try echo %my_db_URL. And now we can see that we can read it. So we have to close out our terminals and open up a brand new one. It's kind of annoying, but that's just the way it works. Now, on top of that, there's an even bigger issue, and I think this is exclusive to Windows. And that is that VS Code, the terminals here, it's whenever you set a new environment variable, they never have access to it. So you could try deleting all of these terminals and then creating a new terminal and then accessing that new environment variable, my_db_URL. And if I try to run this code, you'll see that it just says none. And if I just try to run the same echo command here, you'll see that it just spits it out. So it's not able to read it, and it's a little bit of an annoying issue with VS Code in Windows. You have to close out every single VS Code window that you have and then reopen them. And sometimes even then that doesn't fix the issue. So know that this is just kind of a limitation with Windows. But ultimately, don't worry too much about that because you're going to see that, especially in a development environment, going into and actually setting all of these variables yourself is unnecessary, right? I don't want to have to go in and set one for my database IP, my database port, as well as my secret key, my password, my username. That's just too many to manage yourself. And you'll see that more complex applications could have 10, 20, 30 environment variables that need to be set. So instead of going into your system and actually changing it, I'm going to show you guys in the next video. I'm going to show you guys how we can get around this by using what's referred to as an environment file. And so you don't actually need to worry about the limitations we're running in here because we're never actually going to set our own environment variables on our local machine, especially in our development machine, because it's just too slow of a process and it makes things unnecessarily difficult to troubleshoot. So before we wrap things up, if you want to delete that environment variable, feel free to do that, which we can just go here and I can just select that and then hit delete. And let me show you guys how to do this on a Mac. To set an environment variable on a Mac machine, the command that we run in the terminal, there isn't a GUI kind of like in Windows. We actually have to use a terminal, which I actually prefer. What we do is we just type in the command export, and then we provide the name of the variable or the key. So I'll say my underscore db underscore URL. Then we say equals, and then we just provide the text, the value. So in this case, maybe this is localhost 5432. All right, and then to actually read the environment variables that have been set, you type in print env. And here we can take a look at all the environment variables. Most of these have been set by the machine itself. And you'll see that nowhere in here do we see, well, actually we do see my DB URL right here. However, just like I said in Windows, sometimes, depending on the terminal you're using and a few other things, sometimes you actually have to close out this terminal and open up a new one to actually get the new environment variable. But here we can just access it by typing echo, and then we can just say $my underscore db underscore URL. And you can see it prints it out. And then within Python, just like we did on the Windows machine, accessing it is the same exact way. It shouldn't matter which operating system you're on. It's the same exact thing from your code's perspective. With any project, there's going to be a certain number of environment variables. And as I said, as your project grows, you're going to have more and more of them. And one of the issues that you can run into is that you could potentially forget to set one of them, either on your development environment or your production environment, and it's probably going to cause your application to crash. And so what would be good is to perform some sort of validation to ensure that all of the right environment variables have been set for your application to actually run properly. And on top of that, it's important to understand that when you read an environment variable, it's always going to come out as a string, which is fine, but it just means that you have to do all of the validation in code. So if you're setting an environment variable for your access token expire minutes, right? We needed this to be an int, not a string. But when we read the environment variable, it's going to come out as a string. So we have to convert this to an integer. So when it comes to verifying that all of the properties are set, as well as performing validation, we might have already kind of addressed this issue with a different part of our application, right? And that's our schemas, right? We do the same thing with all of the data we send in the body by using Pydantic to perform all of that verification to make sure that every single property that we need is there, and to also perform all of the typecasting. So if we set it something to be an integer, it'll automatically convert it and validate it that it is a valid integer. And what's great about Pydantic is we can actually use Pydantic to perform all of that validation for our environment variables. And let's see how we can actually do that. So I'm going to go to main.py, and as an example, I'm just going to import from the Pydantic library something called base settings. And so just like with any other Pydantic model, right, we can set up a class, and I'm going to call this settings, and this is going to extend base settings. And I didn't mean to accidentally import base. And here we can basically just provide a list of all of the environment variables that we need set as properties on the class itself. And so, maybe I need something called database underscore password. And this needs to be of type string. And we can even give it a default value, which is localhost. And then maybe I need a database username, which is going to be string. And we can give it, once again, a default password. We don't actually have to give it a default value, but if you want to, you can. And I'll say this is going to be Postgres. And then maybe we want the secret key. And this is once again going to be a type string, and we can just give it, some arbitrary default. And let's say these are the only environment variables that we need for our application to run. By setting it like this, it's going to automatically perform all of the validation for us to ensure that all of these have been set. And an important thing to understand is that when you set environment variables, if we just quickly go back to the environment variables on my machine, normally best practice for environment variables is to do all caps with underscores, right? It doesn't have to be all caps, but this is just kind of standard convention. You can see I've got some that aren't like that, but in general, you want to do it all caps. And you can see here, we reference it all in lowercase. So Pydantic will automatically handle all of this from a case insensitive perspective. So it doesn't matter if you capitalize this or lowercase everything. It'll take all of your environment variables and it'll convert it to lowercase just to simplify everything. Then we create a variable called settings equals, and then we say settings. So right here, all we're doing is we're creating an instance of this settings class. And so at this point, Pydantic will read all of these environment variables. And once again, it'll look for them from a case insensitive perspective. So it doesn't matter if they're capitalized or not. And then it's going to perform all of the validation. It's going to ensure that they're properly a string and so on. And then finally, it's going to store it in a variable called settings. So then we can access all of these variables by just saying settings dot and then the name of the property. So if I want to get the database password, I just do settings.database password. And so we can print this out. And I'll just start my application. Right? And you can see that it printed out localhost. And if I want to grab maybe the username, I just say username. Actually, sorry, it should be database underscore username. And you can see it prints out Postgres, which is the default values because I haven't actually set my system environment variables to be any of these values. So it's going to use the default one. And like I said, we're going to run into that Windows issue where I can't exactly update it without closing everything. So I'm not going to bother doing that. But what I will do, just to show you how this validation works, is let's remove this. Let's say there's no default password. And so if there's no default password, then it's first going to check my system, my system or user environment variables to see if there's something called database password. And since I didn't provide a default one, if there is no environment variable with that name, it's going to throw an error because the whole point of this is to validate that all of the environment variables that we have are configured here. And so after I save it, if we take a look at this, you can see that we get one validation error for settings. So settings, database password, and we can see that it's missing. Right? And so having that quick check makes our life so much easier so that we don't have to figure out, which environment variable is missing, which one's not. Because like I said, you could have 10, 20, 30, 40 of them. There's going to be a lot of them, and managing them does become a little bit of a challenge. Now, one quick thing, let's say I go to my environment variables once more, and I've got something called path, right? So path is, the path to a specific directory. And what I'm going to do is I'm going to say, I want to access the path, but we're going to say that this needs to be of type int. So Pydantic is going to perform some validation. It's going to read it, and every environment variable is always read as a string, and then it's going to try to typecast it into an int. And if it fails, it's going to throw an error. And so since this is clearly not an integer, it should throw an error. So let's try this out. And we can see that value is not a valid integer. Now, for all of the settings and the environment variables, I usually like to create a separate file to hold all of this information. So under app, I'm going to create a new file called config.py. And I'm going to move all of that code into that file. And then in our main.py file, I'll just import from .config import settings. Right? So ultimately, we're just importing that final class, the instance of the class that we created. Right? And so once again, it's able to perform the validation and it's going to report an error with the path variable. All right, so having it in its own file is going to make things a little bit easier because then we could just go to the config.py file and we'll know exactly where to look for all of our environment variables and all the configs related to our application. The last thing I want to do is let's go ahead and actually figure out what environment variables we want to use moving forward and actually set this up. So we're going to clear out all of these, and I'm going to create one for all of the database related stuff. So database underscore hostname. This is going to be a string by default. We're going to have database underscore port. Once again, a string. We'll have a database password. And then we'll have a database underscore name. So that's the database within Postgres that we're connecting to. We'll need a username. All of these will be strings. And you may be wondering why the port is set to a string, but the reason why it's going to be set to a string is because if we actually take a look at our database connection, it just goes into a URL, so we don't actually ever need to have it be an int. I guess you could make sure that it's a valid port number and then convert it back to a string, but that seems a little unnecessary at that point. Then there's a secret key for our JSON web tokens. We've got the algorithm for assigning our token. And then we have the access token expire _minutes, which is going to be an int. All right. And if we save all of this, we should get a whole bunch of errors, and that's okay because none of these have been set. So at this point, you could technically, whether you're on a Windows or a Mac, set these on your machine and get everything to work. But like I said, that is an unacceptable thing to do because that's a lot of work. And we want to simplify things. So what we can actually do is within our FastAPI directory, we're going to create a new file called .env. So this is kind of standard convention, but this file, and don't forget the dot, this file is going to contain all of our environment variables, so we can set it much easier just by having a file do all of the work. Now in production, you're not going to use this. In production, you're going to actually set it on your machine, but in development, it's perfectly okay to just set everything in here. And so what we're going to do is we're going to take all of those environment variables that we defined, and we're going to provide values. And so like I said, in real life, you generally want to capitalize everything, but luckily Pydantic automatically looks at everything from a case-insensitive perspective. And so our database right now is running on localhost, so we can just say localhost. Our database port is going to be 5432. The password, that's going to be whatever you chose to use as your password. It's going to be password123. And we've got our database name. Mine happens to be FastAPI, but yours is going to be something different, probably. The username, I'm guessing everyone's probably going to be using the default Postgres. The secret key, I'm just going to grab whatever I used in my file, so I'll just grab this. The algorithm is going to be HS256. And then the access token expiration time is going to be set to 30. So we've got all the values set here. And one thing to note, I didn't provide any default values, and you could 100% go ahead and add default values into yours if you want to, but I'm going to leave them as such. And now we have to tell Pydantic to actually import it from our .env file. And the way to do that is inside this class, we just say class config, and we say env_file, and then the path to our specific file, so we say .env. So we'll save this. And I forgot to save my env file. And then I'm going to run this again. And our application should start up with 0 issues. And so hopefully you guys see how easy it is to work with environment variables, especially when you're allowed to set it on a file, so that we don't have to worry about setting it either in the terminal or on a Windows machine having to go through the GUI to do that. But one thing to keep in mind is that you never want to check this env file into Git, right? Because this has all the credentials for your development environment. Maybe you don't want those to get out, and there's no need to ever check it into Git. So if you create a git ignore file, which is .gitignore, you want to make sure that you put in .env. And we'll come back to the git ignore file when we start working with Git in this course. But you also want to make sure you remove anything with __pycache__, which is all of these, as well as your virtual environment folder. So you want to make sure none of those get checked into Git so they don't get uploaded to your GitHub repo. And just to make sure that everything's working, let's go ahead and just test this out real quick, just to make sure that nothing's broken. And that seems to work. And then if we try to get all posts, everything seems to be working. So we have now successfully moved everything over to environment variables. And actually, sorry, we forgot to do one very important thing. we're not actually using the environment variables right now, because if I actually go to my database, you can see that it's still just a hard-coded value. So we have to make sure we actually update that to use the environment variables. So we're going to change this to be an F string. And then here, this is going to be the username. This is the password. This is the host name. And then this is the database name. And then there's also going to be the port number, which would be right here, which is 5432. I believe that's, yeah, and that's going to be the port number. So what we have to do is, since we're using an F string, I can just remove this and I can say, well, first of all, we have to import our config file so we have access to it. Or we can do from config import settings. Just put a dot there. And now I can just say settings dot database, and then we'll grab the username here. And then for the password, I'm going to do the same thing. I'll say settings dot database password. And the host name, this is going to be settings dot database host name. And then this is going to be the port number. And then finally, we've got the actual database name. And I think everything should still work. Just to test this part, let's just quickly log in now. All right, everything still works. So our access to our database is now working just fine. But there's a few other things that I want to update. And keep in mind, if you're using the Postgres driver to actually connect and make queries, then you would just update it here with the settings dot whatever. But if we go to our OAuth 2, we can, well, first of all, let's import our config. And we'll change the secret key. This is going to be settings dot secret key, not schema, secret key. The algorithm is going to be settings dot algorithm. And then finally, this is going to be settings dot access token expire minutes. All right, let's reload this. Let's just double check a few things. So let's create a new user. All right, we are able to create a user. Let's log in that user. We're able to log in, and then let's get posts. And we're able to get posts. And let's just double check that there's no errors. So everything looks good. And so now we have successfully migrated all of our code to using environment variables. And so when we move to production, we can just, on the machine, set all of these values that we have inside our config.py file, and it's going to automatically import it and then update those values wherever we reference them. In any social media type app, there's going to be some sort of voting or likes system. So Facebook has likes, Reddit has upvotes and downvotes, Instagram has likes, Twitter has likes as well. And so we're going to implement a simple like system as well, and we're going to quickly go over the requirements for it. So the first thing is a user should be able to like a post. A user should only be able to like a post once. We shouldn't be able to like a post 10 times and then artificially cause the number of likes for that post to go up. And then finally, anytime we retrieve a post from our database or from our API, we should also fetch the total number of likes for that post. Now let's take a look at the requirements for our voting model or our like model. And so naturally, just like we have a table for users and a table for posts, it makes sense to store the votes in another table, just like we always do. And if you think about the requirements or what we should do for the columns, well, we need to have a column that's going to store the ID of the post that we're ultimately going to like. And then we're also going to need a column that references the ID of the user who liked the post. So those are the two absolute minimum number of columns that we need to get our voting system in place. Keep in mind, if you wanted to do an upvote, downvote type thing like Reddit does, then you might want to have a third column for the direction of your vote. But we're going to keep this nice and simple, and it's just going to be a very simple like system. So it's just one direction. But the most important thing of the vote table is that since a user should only be able to like a post once, this means that we need to ensure that every entry, every post ID and voter ID is a unique combination. So what do I mean by that? Well, take a look at this. We have a post with an ID of 12, and this post was liked by a user ID of 4. So this is what an entry would look like. And that's perfectly fine. And if we go, here we've got a post ID of 28, and it looks like a user with an ID of 9 liked this post. And if I go all the way down to here, you'll see that post ID of 12, which you could see that there was already a row with the post ID of 12, is liked by a different user, 9. So it's perfectly okay to see a repeat in this column. And under the user ID section, it's perfectly okay to see a repeat in this column as well, because we can see that a user of ID 9 voted and liked a post with an ID of 28, as well as a post with an ID of 12. And then obviously, one post can be liked by different users. So a post with an ID of 12 was liked by a user with an ID of 4, and a post with the same post was also liked by a user with an ID of 9. Now, what we can't have is a user liking a post more than once. So you could see here, user 2 liked a post with an ID of 55. We can't have him do that again, right? It's a duplicate. This isn't allowed, or this shouldn't be allowed in our system, because we don't want users to be able to like a post more than once. And so there's a couple of different ways of setting up this requirement, but we're going to take a look at the simplest solution. And we're going to learn about something called composite keys. So we've already covered what a primary key is. It's a column in your table that's going to ensure that every single entry is unique. And we always used a column called ID, which had a auto-incrementing integer. However, what we can also do is make use of something called composite keys. And a composite key is nothing more than a primary key that spans multiple columns. So we've only worked with one column primary keys, but we can actually have it cover more than one column. It can have 2 columns or 3 columns. And since a primary key must be unique, this will ultimately ensure that no user can like a post twice if we make sure that both of these columns are part of the primary key, right? And so when you have a composite primary key, it does not care if there's duplicates in one row. It does not care in one column, and it does not care if there's duplicates in the other column. All it cares about is, are both of the columns the same in 2 different rows? So once again, for a post of ID 12, we have a user of 4 who likes it, as well as a user of 9 that likes it. And so with the composite primary key, it sees that as 2 different entries because it needs both of them to be the same to be considered a duplicate. So we can uniquely identify this row by saying, hey, I want the row with the post ID of 12 and a post ID of 9. There's going to be no other rows with that combination. And the same thing goes in the other direction. The user, 9, can like post 28, and he can also like post 12. And so once again, we can uniquely identify either one of these rows because we can say, hey, post 28 with the user ID, that's a unique combination, and a post ID of 12 with a user ID of 9, once again, a unique combination. However, we can't have a user with the ID of 2 like 55, and then once again, the user ID of 2 like 55, because the combination of these two is now a duplicate, because one is 55 and 2, and the other one's 55 and 2. And so that's all a composite key is. It's just a primary key that spans 2 columns and ensures that across both columns, we have unique combinations for things. So let's figure out how to create our new votes table. And I'm going to first show you guys how to do this within PgAdmin, so just with regular Postgres, and then we'll take a look at how to do this with Sqlalchemy. And I'm just going to go under tables, and I'm going to create a new table. We'll call it votes. And then under columns here, I'm going to add a column, and this is going to be post_ID. So this is going to be the column that referenced the ID of the specific post. This should, and then actually before we do anything else, I'm going to add the other column in as well. And then we're going to have the user_ID. And so these are both going to be integers. And then we can just select primary key, primary key. And that's going to create that composite key. And then we have to set up the foreign keys as well. So these are going to reference other tables. So for the post ID, we can go into constraints, And then we'll go into foreign key. We'll add a new foreign key. And I'm going to call this votes underscore posts underscore primary, whoops, not primary key, foreign key. And actually, sorry, I didn't mean to do that. And then we're just going to go into here. For the columns, we're going to select the local column, which is going to be post ID. Sorry, it's not post ID. Yeah, post ID. And then for the referencing table, it's going to be the posts table. And then we're going to grab the ID of that. And for action on delete, we're going to make sure it's set to cascade so that if the post gets deleted, we're going to delete this entry. And then we'll add that in there. Oh, it looks like it's got deleted. Let me just redo this. We'll add that. And so we've got that in there now. And that should be it for the first foreign key. Let's add another foreign key. And this is going to be called votes underscore users underscore foreign key. Columns, this is going to be user underscore ID of the local table. This is going to reference the users table, and then it's going to reference the ID. We'll hit that. Actions. This is going to be cascade as well. And we'll save that. And then I'm going to right click on the votes table, and then we can go to view, edit data. We'll go to all rows. You can see it's a very simple table. So let's create a new vote first. And so I'm going to, first of all, I've got way too many of these windows, so I'm going to just quickly delete those. All right, so I got those deleted. I'm going to open up a new query. And I can just go into database. We'll do query. And I'm going to do select star from posts. And then select star from users, just so I can get a list of post IDs and user IDs. So I got user ID of 21, 23, 24. And for the post, we got 1049. So let's try those out. And I already forgot them. So let's get that post ID again. So we'll just grab a post ID of 10. So this is going to be 10. And then the user ID, well, I'm going to open up a new window so I can just switch between them. So now we have both of these windows for querying, and I can do select star from users. 21. Okay, so we'll do. And it looks like we hit a bug in PgAdmin because I can't write anything here. So I'm just going to do view, edit data, all rows again. And that looks a little bit better. So let's get a post 10 and a user of 21. So 10, 21. And let's see if we're successfully able to get that. And looks like that worked. And then if I grab a post ID that doesn't exist, so let's say like 99, and then a valid user, let's see what happens. It's going to throw an error. That's good. And then if we grab a valid post number, but a ID of a user that doesn't exist, we should also get an error. And then if any of these are blank, hit save, it should throw an error as well. Okay, so our table looks set. That's pretty much all we have to do. There's nothing else for these tables. You'll see that once you can create one table, you can really create them all. So I'm just going to drop this table for now. And in the next video, we'll take a look at defining our model in Sqlalchemy so that Sqlalchemy actually generates the table for us. In our models.py file, let's create our model for our votes table. And we'll call it votes, or just vote. It's going to extend base. And then for our table name, I think it just makes sense to call it votes. Then let's set up our two columns. So we're going to have a user ID, and then we're going to have a post underscore ID. So for the user underscore ID, it's going to be a column, and it's going to be of type integer. We're going to set up the foreign key. And this will be users. So it's going to reference the users table and grab the ID field. And then the second property is going to be the on delete, which is going to be set to cascade. All right, then we'll set the primary key to be true. And that's pretty much it. And then I'm just going to copy this, paste it here. We're just going to change this to be, instead of user's ID, it's going to be post.id. And I don't know why I got auto formatted to a different line. Okay, it looks like that's what it prefers. And so save this, and assuming there's no errors, our application should restart. And then if we go to PgAdmin and then refresh, we should see a votes table. And I'm just going to go and take a look at the properties. And you can see that we've got the user ID and the post ID. We've got the primary key set, so it's a composite key. And since it's a primary key, not null is going to be set to yes. We go to constraints. We've got, once again, both the primary keys. We should have 2 foreign keys. And then if we just take a look at one of them real quick, we should see cascade on delete. And so if we go and view and edit data, let's test this out. 10, 21 again. Oh, sorry, it should be 21 and 10 because the user ID is the first column now. 21, 10, let's try saving that. Good. Let's try doing 21 and 9 or 21 and 88. Should error out, perfect. And then let's try 10 and some random number. Error, perfect. Now there's going to be a couple things that we need to take into consideration when setting up the vote route. So first of all, what is the path we're going to use? And I think it makes sense just to set up a new path called /vote. Just like we have for /users when it comes to handling anything with users, and we have /post for handling anything with posts, we're going to have the /vote for handling voting. Now the user ID, the user who's trying to vote on or like a post, the ID of that user is going to be extracted from the JWT token, so we don't actually have to extract that from the body. We don't need to include it in the body. However, the body itself is going to contain 2 pieces of information: the ID of the post we're trying to like, as well as the direction of the vote. And what I mean by direction is, do they want to vote on the post or do they want to remove a post? Because like any application, maybe you accidentally clicked on a post to like it, but you realize you don't want to like it, so you click on it again to remove that. So vote direction of 1 means that we're going to like the post, and then a vote direction of 0 means we're going to remove our like of the post. Now in our routers folder, we're going to create a new file, which is just going to be vote.py. So this is going to handle all the routing for our voting URLs. And what I'm going to do is I'm just going to copy the import statement from one of the other routers. And we'll set up our route. So let's set up the decorator first, and this is going to be a post. And I actually have to import router. We got it. Let's create our router instance. So we'll say router equals API router. And we'll set up the prefix to be /vote. And the tags, we're going to give it its own section, which is going to just say vote. And so now we can do @router.post. This is going to be a post operation because we have to send some information to the server. And the URL is just going to be /, so it's just going to be /vote then. And since we're going to create a vote by default, we're going to send a different status code. We're going to send a 201 instead of the default 200. Then we'll define our function, which I'll just call vote. Now there's going to be a couple things that we have to pass in. So since we expect the user to provide some data in the body, it usually means we want to define a schema just so that we can ensure they send us the exact information. So let's set up our schema for voting. We'll create a class called vote. And so the first field should be a post ID, which is going to be of type int. And then we're going to have a direction, which is going to be an integer as well. So it's either 0 or 1. However, I would like to be able to validate it to ensure that it's only 0 or 1. I couldn't exactly figure out if there was a way to do that in Pydantic, but one thing we can do is we can use conint. So we'll import that from Pydantic automatically. So if you want to see the import, that's what it's going to look like. And we can say less than or equal to 1. So anything less than 1 is going to be allowed. The only problem with this is that it allows for negative numbers, but that's okay. If you guys figure out how to just specify 0 and 1, then go ahead and replace that, and definitely leave that piece of information in the comments so that anyone else who wants to set up that specific restriction, then we all know how to do that moving forward. And let's import our schema now. So we'll go up a directory. And let's also import database, models, and we're going to have to require the user to be logged in before they can vote on something. So let's import OAuth2. And so here, we're going to set up the schema. And we're also going to set up the database so that we can make queries. And then lastly, we'll get the current user. So once we get all of those dependencies, looks like we have to import session as well. And I'm actually going to move this right below the first import. Not that it matters, but. And so we're going to set up logic for when the vote direction is 1. So if vote.dir, so we're pulling the direction from the vote schema, equals 1, then we're going to perform some logic. Else, if it's 0, then we're going to perform some other logic. So if we want to create a vote, the first thing we're going to do is query to see, does the vote already exist? And so what I'm going to do is I'm going to say db.query, and we'll grab models.vote. And I'm going to filter based off of models.vote.post_id. And we're going to say it equals vote.post_id. So we're going to see if there's already a vote for this specific post ID. However, this isn't enough because remember, multiple people can vote on the same post. So we actually have to do a second check. And we can add in a second condition by just doing a comma and then providing the second condition. So we have to say models.vote.userid equals current user.id. And I'm going to save this, and we're going to call this vote_query. So this isn't going to actually query the database yet. This is just building out the query. And it's going to check to see if this specific user ultimately has voted for this specific post already or liked this post. And I'm actually going to move this above the if statement. And you guys will see why we're going to do that in a bit. And we're going to then perform the query and just save that result under found vote equals vote_query dot first. All right. And so if the user wants to like a post, but we already found a post, that means he's already liked this specific post, so he can't like it again. So what we're going to say is if we already found a vote, then we're going to raise an HTTP exception. Now the status code, we're going to use a new status code. I'm going to use status dot, and then this is going to be a 409 for conflict. And there's other status codes you could potentially use. I just decided that this is probably going to be the best fit. And then for detail, we're going to just pass an F string and say user, and then we pass in the user, which is get current_user.id. Has already voted on post with an ID of vote.post_id. All right, but if we didn't find a vote, then what we're going to do is we're going to create a brand new vote. So I'll say models.vote. And so the post ID field is going to be set to vote.post_ID. And then we can grab the user ID field from current user.id. So this will set the two properties, and we'll save this as new_vote. And as usual, to actually perform these changes or to add this to our database, we have to do db.add new_vote and then a db.commit. And we don't actually need to send the created vote back to the user because it doesn't really provide any useful information. We're just going to send a message that says successfully added vote. Now, if the user provided a direction of 0, that means they want to delete a pre-existing vote. So first of all, we'll say if not found vote, right? We can't delete a vote that doesn't exist. So we'll raise an HTTP exception. Status code, I think we could just send a 404. And for the detail, I'll just say vote does not exist. But if we did find a vote, then we have to delete it. So I'll say vote_query. Remember, this is the query all the way at the top. I'll say .delete. And then we can just do our synchronized session false. And we'll do a db.commit. And we'll just return a similar message. Successfully deleted vote. Okay, and this should kind of sum up all of the logic in our path operation function. And at this point, we can just go ahead and test this out. So we'll go back to Postman. First of all, let's log in. All right, so we've logged in. And what I'm going to do is create a brand new request. We'll call this vote. And this is going to be a vote. And in the body, we have to pass in the specific data. So let's actually grab a post or an ID of a post. So in this case, there's an ID of 10. Actually, first, let me double check who I'm logged in as. Okay, that's fine. So I'm going to grab a post with an ID of 10. So here we'll say post_ID 10. And then we'll say dir. Actually, is that what we called it? I actually forgot. Let's go to our schemas. Yeah, it's just dir. And this is going to be, this is going to be a 1 so that we can actually like the post. And remember, this should be a post request. So let's try this out. Let's hit send. And it looks like we ran into an issue. So let's check. And it says that this specific route was not found. And so that's obviously because we didn't wire up this specific router. So let's go back to our main.py and let's import vote. And then we can just copy this and wire up vote.router. Yep. And once again, another typo. All right, let's give this a try now. So we'll hit send. It says we're not authenticated, so let me log in user. All right, now let's try this. And it says that I'm still unauthenticated. And guys, I realized why we're getting not authenticated. That's just because we have a new request and we have to make sure that we set the authorization to be bearer token And then we want to pass in our JWT variable. So it wasn't actually retrieving that. So now if I try this, we can see that we successfully added vote. And, just to make sure that it actually did that, let's actually go into our database and take a look at our votes table. And so we liked a post, and it looks like I have some previous ones. So what I'm actually going to do is I'm going to delete everything from our votes table just so we can make sure it works, because I forgot who I'm even logged in as. So let's go to properties. Okay, sorry. Let me just do a query. And I'm just going to say delete from votes. That's going to delete everything in our votes table. Perfect. And then we could just say select from votes. All right, we have nothing in there, and let's try this again. All right, and so now run this. We can see that we did like post 10, and I guess our ID is 24, but we can just quickly verify that. If I do select star from users, and I'm logged in as Sanjeev123, so we can see that that has an ID of 24. So that works. Now, what I'm going to do is let's test to see what happens if I try to vote on a post that I've already voted on. So I'm going to keep the vote direction to be 1, and I know I've already voted on this post. So we should get user 24 has already voted on post 10. Perfect. Now let's go and try to delete a post. So I'm going to set the vote dir to be 0, and let's see what happens. It says I successfully deleted the post. Or the vote, and let's just do a quick query. We can see nothing is there. And then if we try to delete a vote or a like that doesn't exist, we can see that vote does not exist. All right, guys, so we've actually implemented all of the voting logic right there. The only other thing that we need to do is when we retrieve a post, right, whether it's through the get all posts or even a get one post, I want to have my FastAPI send the number of votes as a property, as a field here, so that when we load up posts on our front end application, they can see the number of likes that a post has. That's usually how most applications work, and I would like it to have it automatically send that information instead of having to send another query to our backend to see, what is the total number of votes. I want it to do it automatically anytime we retrieve any post. And that's going to be a little bit more complex. We're going to have to learn a little bit more about SQL, start digging into some of the weeds of SQL and Postgres. And then once we learn how to do it with regular SQL, we have to see if we can do this with Sqlalchemy. After I finished recording all of the voting logic, or at least the router that handles voting, I realized there's one tiny bug. And that is that right now, there's no logic to actually detect if the user's trying to vote on a post that doesn't exist. Because if they want to vote on a post that doesn't exist, I want to ideally send a 404. So what we're going to do is we're going to implement that logic, and it's going to be really simple. We're just going to query for the post based off of the ID first. If it doesn't exist, we're going to throw an exception. So just like we've done with pretty much all of our other routers, whenever someone tries to access a post that that doesn't exist, then we're just going to simply send a 404. So let's start off by making our query. I'm going to do db.query. We'll say models.post. And then what we're going to do is we're going to filter based off of the post ID. So we'll say models.post.id equals vote.post_ID. And then we're going to grab the first one. And we'll save this in a variable called post. Then we'll say if not post. So if the post doesn't exist, then we're going to raise an HTTP exception. And the status code is going to be a 404. And the detail will be the usual F string that says post with ID, and then we'll pass in the ID. Does not exist. And that's all we have to do, and that's going to fix that little tiny bug. And you'll see that when we get to the testing section, we can now test to see if the post doesn't exist as well. Up till now, we've been working with very simple queries. We've just been querying a single table. However, now that we have more than one table, and all of these tables have built out these relationships, you're going to see that eventually you want to be able to get information from two tables at the same exact time. And this gets a little complicated, but the way we actually do that is by using something called a join. So we join two tables together. And as an example, let's say I want to get all of my posts. So I do a select star from posts. That's great and all. However, when we're sending back the posts to the user, right? Our front end has no idea what a owner ID of 23 is. He doesn't know what that is. And we ultimately want to display the username or the email of the user that created that post on our front end. So what we would have to do, if we could only retrieve data from one table at a time, is we'd have to then individually go and then fetch all of these users from the user table one by one so that we can actually get the email or the username. And that's a little inefficient, having to do multiple queries. If you ever get a chance to, it's better to just do a single query and get all of the pieces of information that you're interested in. So I'm going to show you guys how we can join information from two tables, because I would also like to get all of the user information based off of the owner ID field that's on the posts table. So how do we do that? Well, we start off a query just like this. And actually, before we go into this, what I would like to do is show you one of my favorite websites. So if you go to Postgres tutorial, just search for that in Google, you'll see that there's a website called PostgresQLtutorial.com. This is one of my favorite sites. And I want you to go to joins right here. So this is how we get information from two different tables. And this page does an absolute marvelous job of explaining how to actually join two tables. And it goes over the different types of joins, because there isn't just one method. You've got left joins, you have inner joins, you got outer joins, you got right joins. And I strongly suggest you guys quickly just kind of read through this just to get an idea, because I don't want to cover every single join. I'm just going to show you the ones that we need to get the data that we're interested in. So let's go back to Postgres and let's create our first join. So here I'm do select. I'm just grabbing all of the fields and I'm going to grab it from the post table. And what we can do is I can say left join. And then we specify the other table we want to jam into my query. So now I want to get data from the users table. So I do users. And then we have to find a field in both tables that we need to match on or join the table on. And since we want to find the specific user associated with the person who created this post, we need to join on the owner ID. So what we say is on. So this is how we specify what it should join on. And we want to say, we grab the first table's name, right? The posts table. So we grab posts and then we say dot, and then we grab the specific column we want to join on. So owner_ID. And then we just say it equals to, and then we grab the second table, which is called users. And then we grab the specific column from the users table we want to join on, which is users.id. So now if I run this, take a look at that. It took all of the user data and it jammed it right into one single query with the posts. And so now I get the entire post, and I also get information about this specific user because we joined on owner ID and the user ID together. So I was able to kind of take that information from the other table and match it right up to here. Because we did a star, it's going to grab the columns it's going to grab every single column from both of the tables. And there may be times where maybe you don't want that. Maybe we just want a couple of columns. So let's say we want the title column, maybe we want content, and maybe we want email. Right? And this should allow us to grab the title, which comes from the post table, and the content, which comes from the post table, and then email, which comes from the user table. So let's see what happens when I run this. Right? You can see I got the title, content, and email. Now, if I remove this and go back to everything, just real quick, let's say I want to get the post ID and the email. Well, let's see what happens. I'm going to do ID and then email. Well, it looks like we have an error. It says column reference ID is ambiguous. So what exactly is happening here? Well, I'm going to remove this and show you exactly what happened. The problem is that the post table has a column called ID, And the user table has a column called ID. So when I just say ID, it has no idea which column I want. So that's why it's saying it's ambiguous. So what we need to do is anytime there's a potential for confusion, we always have to specify the table name before it. So I can say posts.id, and then I could say email. Now I don't have to say, user.email because only the users table has an email column. However, if there was an email column in the post table as well, then we would have to append the table name first. So you only need to do this when there's confusion. However, if you want to just kind of stick to a certain convention, you can just set up every single property to have the table name beforehand so that you know which table it's coming from. Makes it a little bit easier to read. And so now I got just the ID and the email. Now let's say I want to get every field from one of the tables. I can say posts dot star. That's going to grab every field. So it's grabbing the post table, and then the star means, hey, grab every single column. And so I could do that. It's going to grab everything from the post table, and then I can grab maybe just the email in this case. And so this kind of ultimately does what we had wanted it to do, because I told you guys we want to be able to get the email or the username information for each and every single post. And if we want to, we can add in some of the other fields, maybe the user.id. So the user ID, however, that's just going to match up with the owner ID. But just to show you guys, there is some flexibility. And as I mentioned before, there are different types of joins. There's left join, there's right join, inner join, outer join. I don't want to spend too much on it, but I do want to cover just a few things. All right, so the direction references which table. So right now we're working with two tables. There's the first table that's referenced by from, and then the name of the table. And then there's the second table, which is referenced after the join, which is right here. And so the first table that's referenced is always referred to as the left table. And the table on the right, the second table that's mentioned is always going to be the right table. So you got the left table and the right table. And so when we do join, what it's actually doing is, well, I think this page actually gives us the best explanation. So a left join selects data from the left table. And I don't know if this is big enough for you guys, but I'll zoom in. So it's going to select data from the left table. It's going to compare the values between the two columns that we have selected. And for us, in this case, it's going to be post.ownerID on the left side and then users.id on the right side. And it's going to find where those values match. And if they are equal, the left join creates a new row that contains the columns of both tables and adds this row to the result set. And what's important is in case the value does not equal, the left join also creates a new row that contains the column from both tables and adds it to the result set. However, on the right side, the value is going to be set to null. So if we ever had a post that didn't have an owner ID, then what would happen is we would see the user information all set to null in that case, or the email would be set to null. However, since the way we set up our table is that every single post must have a owner ID, we're never going to run into that situation. Now, before we move any further, just to show you guys what a right join is, it's the exact same thing, but in the opposite direction. And so let's take a look. And things look a little bit different now, because what's happening is that we're going to go through the two tables and find if the owner ID and the ID of the user match. And we're going to join it on that. And we're going to do this for every single entry. And then at the end, you could see that user 24 has no information on the left side. And that's because user 24 didn't create any posts. So the right join will show you instances where something exists in the right table, but it doesn't exist on the left table. The left join will show you something that exists in the left table, but doesn't necessarily exist on the right table. But I'm going to change this back to left join. And now what I would like to do is, it would be great if we can get the number of posts by each user, right? How many posts has each user created? So is there a way to do that? Well, there is actually. So what I'm going to do here is I'm going to grab the users.email, actually users.id, and maybe we want the users.email as well. Actually, we'll just get the ID. And here at the end, I'm going to say I want to group by users. post.id. So we're going to find all of these entries in our join and then group them based off of the user ID field from the user column. And so once we group them, we can then actually count up all of the columns. All of the entries on a per user basis. So if I say user ID, and then we say we can use a built-in Postgres function. And here, if I put in star, and I'll come back and explain what this means, we can hit run. And we can see that the user with an ID of 21 has 11 posts, and the user with an ID of 23 has 2 posts. The only issue is, if I actually do another query right here, and I do select star from users, there's actually 3 users, right? And one of them hasn't made any posts, and so that's why we don't see it in that list. And if we want to be able to see it in that list, we need to actually change our query. And like I mentioned, the right join, if I actually remove the count column right here, and we just do a star, this is going to actually list every single user, even if the user has no posts. And so if I remove the group by ID real quick, right, you could see down here, I have user 24 with no posts. That's exactly what we want. And so now I can say group by users.id. And then here I'm going to say select users.id, and then we grab the count. So let's see if this works. And notice how all of the post fields are completely empty. So that's perfectly fine. And then we can run this. And you can see that it seems to have worked, right? User 21 has 11 posts, user 23 has 2 posts, and then we got user 24. But it says that there's a value of 1. And the reason for that is that when you do star right here, that means it's going to count null entries. So since we have that 1 null entry, it's going to count that as 1. So instead, what we're going to do is we can actually pass in the name of a column. And so once again, I'm actually going to copy this, paste it into here. We're going to remove the group by. And then just do a star. So we're going to get every entry, except because we did count star, it always ends up counting this as 1. So that user 24 is always going to have 1 entry, but that's not accurate because he doesn't actually have any. So instead of doing count star, we can actually pass in a column that we want to count. And so in this case, we can pick any of the posts column that we're trying to retrieve. And so I can just say post.id. And so when you pass in a column name, it does not count columns that have a null value. So if the user doesn't have any posts, he won't have anything under post.id. And then if I just remove this query and then run this, you can see that now I have successfully gotten the exact query that I want. And I can rename this column as user underscore post underscore count or something. That's a little bit more readable. And then, I can grab any other field that I want. Maybe I also want the users.email. And so that way we get just the information that we ultimately want. So you can see that doing these queries, they do get a little bit more complex, and you have to practice this a lot. And so I definitely recommend you actually just read through this document, set up a few example tables, and just practice doing your queries. But we're going to spend just a little bit more time on these queries so that we can figure out how to get the total number of votes. It is a little bit longer of a process, but I want to make sure that you guys understand exactly what we're doing. All right, guys, so let's move on to working with our posts table and our votes table. So I'm going to do a join on those two. So let's start off by doing select, and then we'll just do star for now. And we'll say select star from, and then in this case, posts. And keep in mind, guys, I mentioned that the first table you reference is the left table, and the second table that you reference is the right table. It doesn't actually matter which one is the left or right. The only thing that matters is that you set up the right direction of the join. So if we set up posts as the left table, and we want to do a left join, then if we ever rewrite our SQL query and set up our votes table to be the left table instead, then we would just have to flip the join to be a right join. So it doesn't matter which table comes first. Keep that in mind. So you don't have to start your query on just the posts. You could do this on votes as well, and you just change the direction of the join. But I like to do posts. And then we're going to try a left join once again. And we'll say the other table is going to be votes, and we're going to join on, well, if we take a look at our votes table, which I'm actually just going to cut this out real quick. and save that in my Scratchpad. I'm going to just say select star from votes. We'll run that. Right, so there's going to be a user ID and a post ID. And then if I do a select star from posts, we have all of these fields. So I think you guys can guess the exact column that we would need to join on. So we need to join on post.id and then votes dot post underscore ID. So whenever those match, we need to get a result. So I'm going to go into my application and just run a few, I'm just going to vote on a few posts so that we actually have some data. So I'm logged in as a user and I'm going to vote on post 10. All right, we successfully added votes. I'm going to get a whole bunch of other posts. I'm going to vote on post 4 and 9. All right, and I'm going to log in as a different user now. Let's see who else I got. All right, I'll just log in as Sanjeev, I guess. My login. All right, we've logged in. And I'm going to vote on post 10 as well on this guy. And then we'll grab some random vote, 15. Okay, and so we should have a decent number of votes now. And I purposely made it so that one of the users didn't vote, just so that we can take a look at what complications that add. All right, so we have all of these votes. We've got the user ID and the post ID. So now let's set up a join. So I'm going to do select star from posts. And I'm going to start off with the left join. And we'll say we want to join with the votes table. And the field that we're going to join on is on the posts. We're going to grab the .id and wherever this is equal to votes.post underscore ID, we want to join the table. So let's run this. And let's see what results we get back. All right, and so you can see that, hey, look, a post with an ID of 10. It looks like it does have a vote. So this is one join right here. But then you'll notice that if I go down, you'll see another entry. So this doesn't mean in our database that we have 2 posts with an ID of 10. It's just saying that since we joined them, we have to go down the list, see where they match, and then print out a row. So it's going to print out a row for every single time the post ID matches the post underscore ID of the votes table. And so since we have 2 votes for the same exact post, that means we're going to get 2 different entries. Doesn't mean there's actually 2 posts in our table. It's just the way that the joins work. And I strongly recommend, like, if this is still a little confusing, keep reading that document and play around with it. If you want to see the opposite, actually, before we take a look, let's just take a look at a few other things. You can see we've got post with 4, and we can see that there's 1 vote for that because there's no other entries here for an ID of 4. And then we could see all of these posts that have no votes whatsoever. So that's what the left join gives us, because anytime we have a post, which is the left table, since we do a left join, it's going to list those posts, and it'll just put null on the right side. Whereas if we change this to a right join, it's going to do the exact opposite. With the right join, right, once again, it's going to look for any time the ID here matches the post ID, and it's going to spit out a row. And then the same thing goes for the post with an ID of 4. And then once again, you can see 10 shows up twice because 2 users voted on it, and then 15 and so on, but then you'll see nothing else. And the reason for that is we did a right join. So it's going to show us all of the votes and their corresponding post. However, it's also going to list out any votes, because it's a right join, that aren't associated with the post. Now, all of our votes have to be associated with the post because we put in that constraint, that check. So that's why we don't see anything with the null on the left side, because that's just the way our tables have been set up. So hopefully that didn't confuse you guys. We're going to change this back to a left join. And what we're going to do now is we're going to do, I want to be able to count the total number of votes for each and every post. So we're once again going to do the group by. So we're going to group by posts.id. So we'll group them together and then count them. And for columns, I'm just going to say, we'll say post.id, and then we want the count. So we'll start off with the star, and let's see what happens. Okay, so we can see that, post with an ID of 10, we know it has 2 votes, but then everything else has a value of 1. This is not correct. We know that a whole bunch of posts don't have a value of 1, but like we covered in the previous lesson, anytime you have a value of null, then it's going to count that as 1. So I'm going to run the previous query, remove the group by, and I'll show you guys exactly what I mean. So now if I run this, oops, this should be a star. All right, look at all of these posts that have a value of null. It's going to count them all as 1 in this case. And we don't want that. Right? And that's what happens when you do star in the count field. So instead, what we're going to do is we're going to provide a specific column to count on so it doesn't count the null values. So what column should we use? We can really use any column. I think it makes sense just to do, we have to grab one of the columns that are null in this case. So we'll get votes.post_id. So now, look at that. We get the post ID, and then we get how many votes they have altogether, or how many likes. And instead of just grabbing the ID, I'm going to actually grab everything from the post table. We can run that. And this is the exact query that we're looking for. We get the post information, and we get the number of votes. And we can rename this, because I don't like calling it count. We can rename it as, votes or likes. It doesn't really matter. And there you go, guys. And if you guys want to query for an individual post and get the total number of votes, it's actually very simple. It's the same exact query. We're just going to provide a where condition. And so here I can just say where post.id equals 1. Well, actually, I don't have a post ID of 1, so I'll grab a post ID of 10. And so now I get my 1 post, and we can see that he should have 2 votes. All right, and so that's how we do this with raw SQL. Hopefully this wasn't too complicated. Like I said, I strongly recommend you spend a little bit of time going over joins and practicing it with your own tables. Don't just use posts and votes. If you can probably come up with simpler tables to work on this and understand it a little bit better. But I think that's going to wrap up this video. And so go ahead and just save these queries for now so that we can reference them later. In the last video, we saw how we can gather information from 2 different tables by making use of joins. And so we saw how to do that with raw SQL, and now we're going to see how we can perform joins using Sqlalchemy. And if you go to your post router, we're going to go to the get posts path operation. And so we're going to kind of just take this step by step and see how we can slowly build out this query so that we can actually perform a join. And if you take a look at the current query, what we can do is just ignore all of the filter stuff first. And so really the meat of this query is just db.query, and then you pass the model, and that's going to get every single post that we have in this table. And then we perform all of these filters to kind of drill down. So we're going to start off with the same thing, and I'm going to save this new query as results. Or we could just say posts_votes maybe. We'll just save it as results. And so we're going to start off with the same exact query. We're going to do db.query models.post. And then we're going to perform .all. Actually, remove the .all. And the reason I don't want to do the .all is I don't actually want to query the table. I just want to actually see the raw SQL that it's generating. And now we can do a print results. I'm going to bring this up a bit, and we're going to just send a query to the get all posts. And you can see the raw SQL that it generated. So it's going to select and then basically select every column and then rename it accordingly. And then it's just going to get that from the post table. So it's getting every single post. That's all. So everything is pretty straightforward at this point. And if we go back to our PgAdmin, let's actually take a look. Let's take a look at what our SQL query actually looks like. And so you can see here, there's a whole bunch of things going on. But the next thing I want to do is I want to actually start to perform the join. So I want to join on the votes table. So let's take a look at how we can do that. And to perform a join with Sqlalchemy, I can just say join. And then we have to specify the table we want to join. So this is going to be the models.vote. And then the second thing is what is going to be the column that we perform a join on. So in this case, you can see that we're performing a join on post.id and votes.post_id. And we're going to do the same thing here. I'm going to say models.vote.post_id equals, and then we'll say models.post.id. Whenever they're equal, we're going to join the table. Now, the thing about this join is, by default with Sqlalchemy, this is going to be a left inner join. And the word inner is going to be a little bit new for you. And that's because there's two different types of left joins. You've got left inner and you have left outer. And I don't want to spend too much time kind of diving into what's the difference. Just know that if you ignore the keyword, it's going to by default be an outer. So what we want is an outer join. However, Sqlalchemy by default uses inner joins. So to actually set this as an outer join, we have to pass one more thing, which is going to be is outer equals true. So this is going to make this a left outer join. So we've got our join at this point. And what I'm going to do now is save this again. And let's take a look at our query. So we'll send something. And now we'll take a look at our query. We can see that, okay, we're going to select everything from our post table. Then we're going to perform a left outer join with votes on the table votes whenever votes.postid equals post.id. So we're almost there. The next thing that we have to do is we have to group by post.id, and then we have to perform the count on votes.post_id. And so if you can take a guess as how to do group by, we can just do .group_by, and then we specify the specific column. So we'll do models.post.id. And then we have to get the count. So we'll go here, and I'm going to say, well, first of all, we have to import a function. So what you're going to do is from Sqlalchemy, import func. And so this is going to give us access to functions like count. I'm going to say func.count. And then we'll say models.vote.post_id. We'll save this, and I'm going to send this, and let's take a look at the query once again. And so we've got select posts, all of the post columns. Good. And then we get to count, right? And it's going to perform the count. That's all right. However, we're naming it as count1. I don't like that. I want to name this something that I will understand. So maybe something like votes. So we have to figure out a way to rename this column. And if you want to rename this column, you just say dot label and then the name that you want to give that column. So we're going to call this votes. And so let's test this out one last time. And now we can see that the column is called votes. So this is exactly what we want. This is the exact query that we generated in PgAdmin manually. We're just doing it through Sqlalchemy. And what we're going to do is, well, let's actually perform the query. We'll do .all. Don't need the print anymore. And we're going to actually return results, and let's see what happens. So now if I send a query, it's giving me a whole bunch of errors. And if we scroll to the top of the errors, we can see that these are all Pydantic validations. And so it's saying that, hey, there's no title, there's no content, there's no ID, there's no owner ID, there's no owner. All of these fields seem to be missing. And why exactly is that? Well, let's take a look at the response model. So the validation's happening because we use this response model of schemas.post. And so if we go to schemas and we find our post object, or post class, you can see that it expects an ID, a created at, an owner ID, an owner, and all of that good stuff. And it's saying that none of these have been set. So it looks like there's something wrong with our query. But just to make this a little bit simpler, what I'm going to do is I'm actually going to remove the response model. So I'm going to just comment out that. Remove the response model so we're not actually performing any validation. And we're going to see what this looks like now. So when we retrieve the data, I want you to take a look at what this looks like. So this right here is one specific post. And so after our changes, we can see that we've got a property called post, and then within there we have ID published and so on, and then we've got a property of votes. And I'm actually going to copy this as an example. I'm just going to create a new file. And I'm just going to say, we'll just call this example.py. That's fine. It doesn't really matter. We'll delete this in a bit. So this is what it looks like. And when we go back to our path operation, I'm going to return posts. And we can actually return the response model just to see what that looks like. And so now if I do a query, I need to save. Right, if you take a look at the query, this is what it looks like in a working state before we set up the joins. And if I go down to my example, where's my example py file? So this is what Pydantic expects. It expects to get an object with a field of title, content, published ID, and so on. However, after our join, something odd happens. We have a field called post. And that breaks everything because it doesn't expect the ID and the published and the owner to be under this essentially this dictionary right here. And that's why it's throwing all of these errors. So how exactly do we fix this? Well, what we're going to do is I'm actually going to go to my schemas, and I'm actually going to create a new schema. So we'll call this, you can call this whatever you want. Maybe post vote, or I'm just going to call this post out. And it's going to be a post base. It's going to expand post base. And what we're going to do is we're just going to try to match this as close as possible. So this is going to represent a post object, and then we're going to have a field called votes, which is going to be an integer. So here I can just say we have something called post, and don't forget to capitalize it because our query, for some reason, returns it with a capital P. It took me a little while to figure that out. I was running into a few issues. But we can go here and we could say, I want to return, I want this to be of type, and then we'll reference this post. Right? So all of these fields will be under a field named post. And then we expect something called votes, which is going to be set to an integer. So let's try this out, and we'll go back to our post.py, and I'm going to reference post out. And we're going to return results again. And let's just make sure there's no errors. It looks like it's good. And let's see what happens now. All right, we got a little bit of an issue. And it looks like there's a title, content, a whole bunch of errors. And so the title and the content are missing for both. So what did we do wrong here? This should have fixed our issue. Well, let's try adding this class config ORM. I think that might actually be what's causing this problem. And now let's try this. That didn't look like it fixed it. All right, guys, so I was playing around with it, and then I don't know what exactly fixed it, but all I did was I had changed this to a lowercase p. And this led to, us seeing this specific issue where it says, hey, this post doesn't exist. And then as soon as I recapitalized it, all of a sudden it started to work again. It starts to work now. So I'm not really sure why it broke in the first place. I didn't change any other code. Just looking back at my path operation, you can see that I'm now changing my response model to be schemas.postout. And then we're performing the same results query and then returning it. For some reason or another, it's now properly working. I have no idea what changed. I have no idea exactly what changed, but it's working now. So hopefully you guys don't run into any issues, and hopefully it was just some kind of issue on my machine. But if you do run into the same issue, just try moving it to a lowercase, try restarting the application, then changing it back. I have no idea why that would fix it, but it seems to have done something. And so now our results are perfect. We get the post information. We still fetch the owner, which is fantastic. And then we have the votes. And then just double check to make sure that all of your votes are all okay. And so it looks like they all look good. I know that one had 2, and then the rest should all have 0. So everything's looking pretty good. The next thing that we need to do is actually go ahead and add our filters back in. So let's see if I can still filter on all of these. And so I'm just going to copy this. And then before I perform the .all, I'm going to paste that in there. Oops, I forgot to copy. All right, and then let's test this out again. All right, things are still working, but let's just add a few extra query parameters. So I'll say search equals beaches. All right, and then it looks like it should only return post with the word beaches. And then let's try limit equals 2. Remove the search for now. And that works too. So it looks like we get to keep all of the same functionality that we had before. So I'm going to just write this as posts. We're going to comment this out just for reference. And then we're going to return posts like we normally do. Send it one more time. And it looks like everything is still working just fine. Perfect. So we finished the get multiple posts path operation, or get all posts. And I noticed that we do have to go ahead and update the get individual post, because right now, if we go to get one post, you can see that we do not actually get the vote count for that. So we definitely want to see that in here. And we're going to have to perform the same exact join. So I'm just going to copy the previous query all the way up to before the filter. So just copy that part. Say post equals, paste that in there. And then we can filter, copy this filter at the end. And that should ultimately get us what we want. I'm going to comment this one out. And keep in mind, we have to return post out instead of post now, because we want the new format with the votes. So now if I hit send, name post is not defined. Oh, okay. Misspelled that. And looks like we fixed that one. And then it's really up to you to see if you want to, kind of worry about creating posts and updating posts to make sure that, when they create an update that they return the number of votes, but it's ultimately up to you. I think we don't need it in those. This is more of just kind of returning back just the main information about the post, and then, the queries for updating a specific post and then grabbing the votes gets a little complicated. So we're going to ignore that for the update and the create post functionality. Now, when it comes to building out the tables or the database schema, Sqlalchemy has a little bit of a limitation, and that is that Sqlalchemy doesn't allow us to modify tables. It doesn't allow us to create extra columns, delete columns, add foreign key constraints. And that's because when we define these models, what Sqlalchemy does is it checks to see if the specific table name already exists in our Postgres database. And if it does, it's not going to touch it. So if we make any changes, it will never push out those changes. It'll only create these tables if it doesn't already see a table with that specific name. And so we've had to resort to dropping all of our tables and then restarting our application so that Sqlalchemy builds it from scratch. And it's something we can't obviously do in production. That would be an unacceptable thing to do. And just to show you guys, in case you've forgotten, if we go to our Postgres database and we go, we can see that we've got our 3 tables. Now, if I add a phone number class, a phone number column to our user class, and I'll set this column to be just a string, and this is really just for demonstration purposes. You guys don't have to do this. If I save this and reload this, Sqlalchemy will not go into Postgres and actually create that column. If I refresh this and then go into users properties, you can see that it is not here. And so that's the limitation of Sqlalchemy. And so in this section, what we're going to do is we're going to take a look at another tool that'll allow us to do a couple things. First of all, it's going to allow us to automatically update the columns based off of the models that we define here. So moving forward, when we add this phone number column, it's going to automatically update our Postgres database. And this tool is called Alembic. It is what we refer to as a database migration tool. However, it's much more powerful than that. Right? It's able to allow us to create incremental changes to our database and actually track it, kind of like we do with code. So in this lesson and in the next coming lessons, we're going to take a look at Alembic. We're going to see everything it has to offer. And I'm going to hopefully get you guys at least a solid understanding of how to work with Alembic so that when you guys work on your projects, you can immediately get Alembic installed running and then manage your databases using Alembic instead of having to either do it manually or use any other kind of unusual workaround. Now, one of the motivations for a database migration tool came from the fact that developers can track changes to their code and roll back their code easily with Git. And they wanted to be able to do the same thing for our database models and our database schema. And so they went about implementing what is referred to as database migration tools. And so a database migration tool just allows us to incrementally track changes to our schema and roll back those changes to any point in time. And so as we go through our project, we kept adding new tables and new features. What a database migration tool is, it's going to allow us to track those changes. And so if we ever want to go back to a specific point in time so that we can kind of troubleshoot code at that point in time, it's so easy. It's just one simple command and it's going to automatically update our database so that the schema matches what it was at that specific point in time. And so that tool that we're going to use, like I mentioned, is going to be Alembic. And what's great about Alembic is that it can also automatically pull all of our Sqlalchemy models and generate the proper tables based off of them. All right, so this is the documentation for Alembic. So it's just alembic.sql.com.org. And if you want to kind of follow along, just select the tutorial right here. And this is just going to give you kind of a quick walkthrough of how to get Alembic set up. But I'm going to show you guys this so you don't actually have to follow the tutorial. So we're going to do first of all, we have to install the library. So we'll do pip install Alembic. And so that'll get Alembic installed. And what it does is it actually gives us access to the Alembic command. So if I do alembic --help, and actually before we proceed any further, I want you to go ahead and delete phone number. We don't actually need that anymore. And then go to your application and actually close that out. Stop it so that it doesn't automatically restart for any other reason. And then also what we're going to do is I'm actually going to delete all of our tables so that we can actually take a look at how this works. So do delete drop. And if you try to drop this table, it's going to say we can't drop it due to the foreign key constraint. That's okay. We could just do drop cascade and that's going to delete it. And we're just going to do that for all of them. All right, so now let's get back to Alembic. I'm going to make this bigger for you guys. All right. And so we'll do alembic --help to see what commands we have. And the first thing that we have to do is we have to initialize Alembic. And what that's going to do is it's going to actually create an Alembic directory for us. So we'll do alembic init. And then I'm just going to do --help to see if we need to pass in any extra flags. And then we have to give it a directory name. So when we run this command, it's going to create a directory. I'm going to name the directory Alembic. You could call it DB, database, whatever you want to call it, but I'm just going to call it Alembic. So it's going to create a folder called Alembic. And so you can see that we've got this folder called Alembic, and notice how it gets installed outside of the app folder, which is what we want. And it also created this alembic.ini file. So we'll take a look at both of those. And the first thing that we want to do is go up into Alembic, and there's really one main file. It's the env.py. So this is kind of like the King Kong configuration file. And there's going to be a couple of things that we have to add to this file to make sure that things work. Because Alembic works with Sqlalchemy and the models that you build with Sqlalchemy, we need to make sure that it has access to our base object right here. So we have to import this base object into the env.py file. So I'm going to just go right here and we're going to say from, and what we're going to do is, how do we actually get to that database file, that base object? We have to go into app, and then we go into database, and then we'll import base. All right, and so this is kind of give us access to all of those Sqlalchemy models. And then for target underscore metadata, instead of saying none, what we want to do is we want to get base. So we're accessing, this should be a capital B. Actually, let's just double check that it's capitalized. Yep, it's capitalized here. So we'll go to base, and then we want to make sure we grab metadata. So that's all we have to do to rig this up to Sqlalchemy. The next thing that we have to do is if we go to alembic.ini, we have to pass in one value here, which is the Sqlalchemy URL, which is basically what's the URL to access our Postgres database. And so just to show you what this is going to look like, this is going to be fundamentally no different than the URL that we used within database.py, which is this one right here. And so I'm just going to write this out. Just going to copy this first part right here because I can never remember that. And so here, just going to copy that. So we say PostgreSQL. And optionally, with the URL, you can do a plus and then whatever driver you're using. So if you don't provide the driver, it's going to use whatever the default driver is. But we're using, let's see, which driver? What is our driver? If I do pip freeze, it's going to be this one right here. So this is the default driver for Postgres. So you don't actually need to provide it. But if you did, you could just say plus psy copg2. But like I said, it's the default one, so it's optional. Right, then we have to give it the username. So what's the username that's going to be using to log into your Postgres database? For me, it's just Postgres. The password is going to be password123. It's going to be running on localhost. And then if you want to, you can provide the port, which is 5432, and then your database name, which is FastAPI for me. So this is ultimately what the URL is going to look like. And at this point, Alembic is set up and ready to run. However, just like we did before, I don't like the fact that we're hard coding this data in here. It's gross. We're saving our password. And if we move into our production server, it's not going to work properly because they're not going to use these credentials or this IP. So instead of doing this, what we're actually going to do is we're going to override this value that's stored in this file within the env.py file. And so under this config right here, I'm going to set a new option under the config object. I'm going to say config.set_main_option. And then here we can override any options that we have in here. So I'm going to override this Sqlalchemy URL. So no matter what I put in here, we're actually going to override it. And here you just pass in a string. So Sqlalchemy.url. So that's the value we're going to override. And then we're going to pass in our string. So I can just cut this out, and it's okay to just leave this blank here. All right. And so we've hard-coded this string here, so we haven't technically fixed anything, but what we're going to do is, just like we have in our database.py file, you can see that we're using the settings object, right? That comes from our config file, which is making use of this Pydantic class, where we can grab it from our environment variable. And so what we're going to do is we're going to do the same exact thing we did with main, right? We imported settings, and we're just going to do that in our env.py file so we can access all of our environment variables. So I'm going to say from app.config import settings. And so now I have access to the settings object. I can override all of these. So this is going to be the username. So I can say settings.username. And actually, I don't think that's what it is. It's database_username. And then we'll override the password, which is settings.database_password. And in reality, instead of just typing this all out myself, we actually have this written out in our database.py file. So I can just copy this here. And that way we don't waste too much time. Okay, so we've got our URL set and we're not hard coding any values. And at this point, Alembic should be set to actually connect to our database and modify any of the tables, generate tables, and be able to really perform any actions that we wanted to moving forward. Hey guys, I made one tiny little mistake. If you take a look at where we're importing base, I wrote app.database. And if we take a look at that, it looks like we are grabbing our base right here. But this is not the one we want. Instead, what we want to do is we want to import it from models. So we want to import base, which is technically getting imported from that same file. But by doing it from here, it'll allow Alembic to read all of these models. And if we do it directly from database, it's not going to work. So what I want you guys to do is go to your env.py file and just change this from app.database to app.models. and that should fix any potential issues that you could have. Okay, so just to quickly recap, we have cleared out all of our tables, so there's nothing in our Postgres database. We don't have any tables defined, and we're going to do this all through Alembic. But what I want to do is I want to kind of go through this like we would have if we had already known about Alembic from the start of our project. And so we're going to take this step by step, right? Because when we first started creating tables in our Postgres database, we kind of went along with what we were working on in our app. So the first thing we did was we created a post table. And that's because we didn't learn about how to actually create users. We didn't learn about hashing passwords. We haven't gotten to the user section. So we originally just had a post table with a couple of fields. And then after working through our code, once we finished all the CRUD operations for posts, we then learned how to register users. And at that point, we had to create a table for users. And then after that, the next logical step was, hey, how do we set up the relationship between posts and users? Then we had to modify that and set up a foreign key. And then finally, after that, the last thing that we had to do was we created a voting table or a votes table, and then we set up all of the necessary foreign keys for that. So we're gonna do this step by step, just kind of like how we did it with our project, but we're gonna do this with the database so that you can see how we would have done it if we had already known how to work with Alembic. All right, so first things first, do Alembic --help, just to see what commands we have. And so there's a few different commands, but the first one that I want to focus on is revision. So when we want to make a change to our database, we create a revision. So the revision is what really tracks all of the changes that we make on a step-by-step basis. So we're going to do Alembic revision --help, and we'll see the different options that we have in our disposal. The first one is that really the only one that I care about is the -m flag. So it's kind of like when you do a git commit, you can add a -m, a message, so that you can kind of have a human readable name associated with each revision. So I'm going to say Alembic revision -m, and I'm going to say this is going to be create post table. So this revision is going to be responsible for creating a post table. We'll run that. And I want you to notice something, right? You could see that it created this file under the versions. So the versions folder under the Alembic folder is going to contain all of our changes. And if we take a look at the revision, there's a couple things to note. So you'll see that we import OP from the Alembic library, and then we import SA from the Sqlalchemy library. And then you can see the revision ID that it gives it. And then there's going to be two different functions that are empty at the moment. So these functions are pretty important. What they are is the upgrade function. When we run the upgrade, what it does is it runs the commands for making the changes that you want to do. So in this case, we want to create a post table. So what we're going to do is we're going to put all of the logic for creating a post table within this function. And then if we ever want to roll back, right? If maybe I create the table and I realize I messed it up and I don't want it anymore, then we have to put in all of the logic in the downgrade function to handle removing the table. So the upgrade just handles the changes and the downgrade handles rolling it back, but it's all manual. You have to define how to do all of that. So let's go ahead and set up the upgrade function, and let's configure all of the necessary columns for our post table. All right. And if you ever want to take a look at the documentation for this, what you want to do is select documentation here, and then you want to go down, 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 all the way down to API details, and then you want to go to DDL internals. So this is going to show you how to actually perform the various operations. So if you want to create a column, if you want to add a column, this is the command that you're going to run. If you want to alter a column, if you want to modify a table, drop a column, create a table, all of these are all listed here. So this is the sheet that you're going to reference on a fairly frequent basis when you're working with Alembic, because I can never remember each of the things. But we're going to go ahead and create our post table. And so we access the OP object from Alembic. I'm going to say OP. And then if you look at the documentation, the way to create a table is you do create_table. And there's going to be a couple of properties we have to pass in. So what's the name of the table in Postgres? Well, we're going to call it posts. And then we have to define our columns. And I'm not going to do all of our post column because it's going to take a little bit of a while, and we might do it later on, but we're just going to define two columns. So the first one is going to be, well, first of all, we do SA column. So we're grabbing the Sqlalchemy object. And so this column is going to represent the ID. So the name of it's going to be ID. It's going to be type of integer. And I may have accidentally imported. Nope, we're good. So integer. And then we can set nullable equals false, which means it's required. And then we also want this to be the primary key. So you just do primary key equals true. All right, fairly straightforward, right, guys? So we can then go in and create a second column. And so this is just going to follow the same exact pattern, sa.column. And then this one will be the title. It's going to be a type of sa.string. And this is going to be nullable equals false. And I'm just going to stop it right here. So we're going to just create two columns. I don't feel like creating all of the columns that we had for posts. And so the upgrade function is done. However, we also have to provide the logic for undoing these changes. So if we create a table, how do we undo that? Well, we delete the table. So we do op.drop_table, and we just give it the name of the table. So it's going to be posts. All right, and so now we should be able to make these changes, and then we can roll back because we put the logic in for downgrading. So how exactly do we make these changes? Well, let's go to Alembic --help. And let's see what commands we have. So we've got a couple branches. That's probably not it. Current, that's going to show us what's the current revision, like what version are we on. And if you actually want to see that, we'll see Alembic current. And it looks like it's giving me an error. Hold on. Let's go back to my env.py file. And I made a very silly mistake. This should be an F string, so it wasn't actually doing anything. That's why it was kind of highlighted weird. So let's try this now again. We're going to do Alembic current. And it's not going to actually really give us any useful information at the moment because we haven't run any migrations, right? We're kind of starting from a clean slate. So let's go back and let's just do a --help and see what else we've got. So we've got a downgrade. Well, we don't want to downgrade. Edit, not really. Heads, we'll come back to that. History, that's not going to be useful because we haven't done anything. But if we go down, we want to get to upgrade. So this is what's important. So if we do Alembic upgrade, we can just do --help and we'll see what options we have. And so we have to provide a revision number to tell Alembic, like, hey, what version of our database do we want to go to? And so if you actually take a look at this specific revision, it provides a revision number. So if we actually want to get up to this point where it runs this upgrade, we provide this revision number. So I can say Alembic revision and then paste that. So let's run this and see what happens. Sorry, I didn't mean to type revision. I meant Alembic upgrade and then not Alembic revision. So that's going to upgrade it. And so you can see it did a couple things. It said running upgrade and it said it created post table. So let's go to Postgres and let's just refresh this and let's see if it actually did something. Right? And it looks like it created two tables. So that's interesting. So we see our post table and let's just quickly inspect this. We'll go to columns. You can see that it created these columns and this one got set to the primary key and both are not null. So it looks like it did everything it was supposed to do. But what is this Alembic versions table? Well, this is what Alembic uses to kind of keep track of all of the revisions. And so if we just go to view, edit, data, all rows, you can see that it just has one column at the moment, which has the revision number. You can see it's D18 and that's going to match up with this file D18. So that's all that's doing. So it will create a table for you automatically so it can keep track of all of the revisions, but make sure you don't delete that. Okay, so that's cool. We just got our first table created through Alembic. And I think at this point, you probably still don't understand the brilliance of a database migration tool. And that's okay because we haven't really done much with it yet. So let's say that, as we're coding out our application, we realize we want to add a new column to our database. Specifically to our post table. Well, we can create a brand new revision to add a new column. So let's say, if you take a look at our models, we have a couple other fields that are missing. So let's say we want to add the content column now. I can type in Alembic revision. So this is going to create a brand new revision. We'll give it a name and I'll say add content column to post table. All right, and it's going to create a brand new revision for us. And once again, we have to put in the logic for upgrade and downgrading. And you can see that now that we have more than one revision, we can see that there's also a down revision. So if you want to go down a step, it's going to go to the revision of the previous one. So let's put it in the logic for creating or adding in a brand new column for content. And the way we add a new column is we do op.add_column. And then we specify the table we want to modify. So it's going to be the post table. And then we do sa.column to define this column. So what's the column name? It's going to be content. And it's going to be a type of string. And we're going to make sure that its nullable is set to false. All right. And remember, every time you set up the upgrade function, you have to set up the downgrade function. So if we add a column, how do we undo that? Well, we drop the column. So it's just op.drop_column. And then from the post, we have to provide the table that we want to drop the column from, which is the post table. And then we need to provide the actual column we want to drop, which is going to be content. So we'll do content. Okay, and so let's test this out. First of all, we'll run a few new commands. So Alembic. All right, and let's see what the current revision is. So if I do Alembic current, right, we could see that we are currently on 2D18. That's the revision. So this is the revision where we created the post table. And if I type in the Alembic heads, we can see that the latest revision is actually 298A5, which is that new one we just created. So if we ever want to get to the latest revision, that's what's referred to as the head. So I can say, if we want to, upgrade to that revision, I can say Alembic upgrade like we did before. And I can grab the revision number like this. Or because it also happens to be the head, I can just say Alembic upgrade head. And it's going to do the same thing. So let's try this. All right, it said it added a content column. We'll go and check this in Postgres. And I'm just going to refresh this table. And we'll go into properties. And we can see that we added the content. Now, let's say that after working on this for a bit, we realize we want to undo these changes for whatever reason. Maybe we no longer want the content column. So how do we actually roll back? Well, since upgrading makes the changes, downgrading is going to do the opposite. So we can do Alembic downgrade. And then if you want to just roll back this revision, we can see what the down revision is. So we can just say this and just paste that in there. But we can also do a few other things. We can also say -1. So when I say -1, that means I'm going to go back to one revision earlier. And we can even go as far back as we want. So if I say I wanted to go back to -2, it's going to go back to 2 revisions earlier. But we just have one, so I'm just going to say -1, or I can just paste in the revision number. And so if I run the downgrade, you can see that it ran this downgrade. And if I go and refresh this, and then go to properties, columns, we can see that we no longer have a content column. And that's how easy it is to downgrade or roll back your database using a database migration tool like Alembic. Okay, so we got our post table. We're not going to worry too much about that. The next part of our application was, hey, let's implement user functionality. Let's make it so that users can sign up and log in. So now we need to create a users table. How do we do that? Well, let's set up a new revision. We'll do Alembic revision -m, and I'll say add user table. All right, so we've got our brand new revision, and we have to set up the upgrade and the downgrade. Now for this, I don't want to just type this out, one by one. It would be kind of slow and boring for you guys. So I'm just going to copy and paste this from my notes. And if you want to follow along, just, pause the video and just write this out. But we'll just quickly walk through exactly what's happening. So once again, we're using the create table method. We're going to create a table called users, and then we're going to set up all of our columns. So we've got a column called ID, which is an integer, set to nullable equals false. You notice how I haven't set this to be the primary key here? That's because there's two different ways to set the primary key. If we go back to the previous one, we set this to be primary key equals true. But on this one, if you actually go all the way down to the bottom, you can see that we can add in a constraint, SA primary key constraint, and then we pass the name of the column. That's going to be the primary key. So they both do the same thing. It's just whatever method you prefer. Now we've got the email column, which is going to be set to nullable equals false. Same thing with password. Then we've got the created at. And so here it's going to be of type timestamp. And you'll see that this is all coming from Sqlalchemy essentially. Because if we go to our models and we go to our user table, it's the same thing. Type timestamp, time zone equals true, nullable equals false, server default equals text. Well, that's created at, but yeah. And we're just doing the same thing. So server default, and then we grab sa.text. Now nullable equals false. And then you can see that we added a unique constraint under the email field to ensure that we can't have duplicate emails. And then to downgrade, we just do op.drop_table users. All right. And so once again, if you want to see where we currently are, because remember, we had originally upgraded, added the content column, but then we downgraded. So where exactly are we from a revision perspective? Well, let's do Alembic current. You can see that we're on 2D18. So we're back on that first revision. And we can also do an Alembic, I believe it's history. And you can see the history of our revision. So we created post, add content column to posts, and then add user table. And this is the head. So if you want to go all the way to the front to the latest, you would just do Alembic upgrade head. And I think there was one more I want to show you. Yeah, that's okay. So we're going to do an Alembic. And let's say that we just want to go and go up one revision. So adding one revision is going to add that column back. We can do Alembic upgrade, and we can either put in the name of this revision, or we can upgrade one level. If we want to go all the way to the latest, which is going to be adding the user table, we can say head. We can also go up 2 revisions. So if I do +2, that's going to go up to add content column 1. That's the first revision. And then one more, which is going to go up to the latest in this case. So there's a lot of different ways to get there. I'm just going to go to the latest. So this is going to add the column back in the post table and then add the users table. And you can see that it went ahead and added the users table. So if I refresh this, we can now see that we have a users table, and hopefully all of the properties are there. You can see all of these have been set. Constraints, primary key is set, and everything else looks good. I guess one thing just to check is the created at. So if we check the constraints here, you can see that we're going to grab the current time. Perfect. All right, so after we had added the user functionality, the next thing we had to do was we had to implement the relationships between users and posts. So we had to set up that foreign key that linked the user table to the post table, or the post table to the user table. So once again, we're going to do an Alembic revision -m. And I'm just going to say add foreign key to post table. All right, we got our new revision. And what we're going to do is first of all, we have to add a column to our post table called owner ID. And that's going to be the one that has the foreign key constraint. So we have to do op.add column. And we have to specify the table we want to add the column to, which is going to be the post table. And this is going to be sa.column. We're going to call this owner_ID. And it's going to be a type of SA integer. And nullable is going to be set to false. All right, so we've created the column. Now we have to set the link between the two tables, which is going to be the foreign key constraint. And so to do that, this is a little bit confusing at first for me because the documentation is a little bit hard to read sometimes. So you do create foreign key Then you have to give it, some arbitrary foreign key name. I'm going to call this posts_users_fk. So this is the foreign key between the posts and the users table. And then we have to specify what is the source table of the foreign key. So this is going to be the foreign key for the post table. So we're going to say source_table equals posts. Then we have to reference the remote table, which they call a referent_table. And so this is going to be the users table. And then we have to specify what is the local column that we're going to be using. So the column in the post table. And that's going to be owner_ID, which is the table, the column that we just created. And then finally, we have to specify the remote column in the users table. And this is going to be set, and we're also going to set the onDelete to be cascade. And yeah, by the way, the remote column is going to be the ID field of the user table. And we want to make sure we have the onDelete as well. And that pretty much, what happened there? It's a weird way to format things. All right, well, it wants to format it that way, so I'm just going to leave it like that. Let's set up the downgrade now, so we have to undo those changes. We'll do op.drop_constraint. And then we just mentioned the name of the constraint, which is post_users_fk. We have to specify the table that we're removing it from, so it's on the post table. So we do table name equals posts. And then we have to drop the column, so we do op.drop_column. And where does this column sit? It's in the post table, and it's called owner_ID. All right, and so if I do an Alembic current, we're on F52 and Alembic heads. Let's see what the latest one is. It should be 296, which is this one. So let's do an Alembic upgrade head. Go to the latest. And I have a typo, so this should be integer. All right, looks like it ran with no issues. Let's double check that the foreign key is there now. So if we go to posts, properties, constraints, foreign key, you can see that we have our post user FK, and we can see that it points from owner ID in the post table to ID in the users table. And if you want to, you can go under actions and see that cascade has been set to onDelete. Now in our post table at the moment, we didn't implement all of the columns that we actually have in our application. So I figured, why not just go in and add it? Might as well. So I'm going to create a new revision. All right, and then we go to that revision. There's really only 2 more columns that we have to add. And this is, I'm once again going to just copy and paste from my notes just because I don't want to waste your guys' time too much. But you can see here, we're going to do an add column, and we're going to add it from our add it to our post table. And then here we're going to specify the parameters of the column. So this is going to be called publish. It's going to be of type Boolean, and nullable equals false. And that's not correct. It should actually be nullable equals true, right? It should be, actually, no, it was false. And then server default is set to be true. So if we don't provide it, it's going to assume it's true. And then the next one is the column for created at. So once again, at the post table, we're going to create a column called created at. It's going to be of type timestamp, nullable false, and then the default means we're going to grab the current time. And to downgrade, we're going to delete those columns. All right, and let's do a Alembic upgrade. And we'll just go, instead of doing head, we can just do +1 just to show you guys how it's going to do the same thing in this case. And so it looks like it ran that. And if we go back to Postgres, refresh this, and then go to properties, we should see we've now got our published and our created at columns. All right. And once again, let's say that maybe we want to roll back, right? Maybe we want to roll back all the way to back when we just created the post table. We can once again do Alembic downgrade and just provide the revision number of the specific revision you want to go to. So we can go down to add user table. We can go down to create post table. We can go down to any section we want. And it's really up to you. And so let's say this time, let's just go all the way down to, let's go down to add user table. So whatever revision this is, we can do that. All right. And so it deleted a whole bunch of stuff. Looks like it deleted the last few columns that we just added, as well as the foreign key constraint. And so now if we refresh these tables, you can see that posts, it doesn't have the extra columns we added, and the constraints, foreign key, no longer exist. But fortunately, we can upgrade to a newer version, to one of the more recent versions. So I can do Alembic upgrade +1. So if I do this, it's going to go up one newer revision. So right now we're at the add user table. And if you forget wherever you are, you could just do Alembic current. All right, so we're on 32F52. And so if I do an upgrade, all right, we're going to go up to, I think it's this one. Because you can see that in this one, this revision is 296, but the previous revision is 252, which is the one we're currently on. So I can do Alembic upgrade +1. All right, and so now we've added the foreign key. If I do Alembic current, we can see that we're on 296. And then if I just do Alembic upgrade, well, Alembic heads, it's going to show us whichever one's the latest one, which is 5B7. So we could just go upgrade directly to that by doing head. The last thing that we have to do now is generate the votes table. But I'm not going to manually create it myself this time. Instead, I'm going to make use of the auto-generate feature. So this is what I was talking about earlier, how we can use Alembic to be intelligent enough to figure out what exactly is missing from our Postgres database and figure out what needs to be created. And the way it actually does that is it takes a look at all of our models. So it's going to import all of our Sqlalchemy models, and based off of the columns that we have set here, it's going to figure out what our Postgres database is supposed to look like. And regardless of what our database is in its current state, we don't need to actually delete everything and build it from scratch. Instead, Alembic is going to be intelligent enough to figure out what columns are missing, what tables are missing, what extra columns do we currently have that we may need to remove, and it's going to figure out what's different between Sqlalchemy's models and our Postgres database, and it's going to make the necessary changes for us. And so the way to do that, and first of all, I guess just to kind of reiterate, the reason we can do that is because we imported the models and then we passed it into this target metadata. So let's run Alembic and we'll do revision. But if we do --help, you'll see that we're going to use one of the flags that we have never used before, which is the --auto-generate. So we'll do --auto-generate. And then we will send a message once again. We'll say add votes. How about auto vote? Maybe. Because it's auto-generated and I know it's going to add the votes table because that should be the only difference that we have. So we'll run that. And so if I go to auto vote, let's take a look at the changes it's going to make. And so you can see here, the changes where it looks like it's going to create the votes table like I had predicted. It's creating the 2 columns, and then it's going to add the primary key constraint as well as the 2 foreign keys as well. And it's going to even add in all of the on-delete properties and things like that. All right, and so all we got to do now is do an Alembic upgrade head. And now if I refresh this and go to votes and properties, right? We should have the 2 columns, and then our constraints and foreign keys look pretty good. Everything looks set. And so that's how easy it was. So no matter what state your database is at any point in time, you can always do the auto-generate functionality to get it back to a state that your code expects it to be. And the best part about this is moving forward, let's say I want to go back to my models and I want to change something. So I've got my user model. This time I'm going to add that phone number column. And this is going to be string. All right, so any changes we make, even on a table that already exists, what we can do now is I can do a revision auto-generate. Here I can just call it add phone number. All right, and then if we go take a look at that, we can see that, hey, look, we added our phone number column. And so the only thing else we have to do is do an Alembic upgrade head, and it's going to push out those changes. So let's refresh this, and let's just double check. We go to users now, properties, we can see phone number column is now set. And I think that's pretty much going to wrap up everything I wanted to cover from Alembic. So moving forward, now that we have Alembic, we no longer actually need this command in our main.py file. This is the command that told Sqlalchemy to run the create statement so that it generated all of the tables when it first started up. But since we have Alembic now, you no longer need this command. However, if you want to keep it in, it's not really going to break anything. It just depends on how you want things to work, because if it does create the tables for you, then your first Alembic migration isn't going to have to do anything because everything is already there. But I'm going to leave this commented out moving forward because I don't really need it. And it's really up to you guys for what you guys want to do. For the most part, throughout this course, we've been testing our API by sending a request from Postman. And Postman's a great tool, but there's one thing to note, and that is that when you send a request from Postman, you're actually sending a request from your own computer. And it's important to understand this because your API can get requests from different types of devices. You can get a request from a computer or a server, whether that's through Postman or even through curl. If you've ever used curl, it's essentially doing the same thing that Postman's doing. It just doesn't have a nice little GUI. You can also get requests from mobile devices, but more importantly, you can get requests from a web browser. So when a web browser sends a request, using JavaScript's fetch API, there's going to be a slightly different behavior that we have to account for, which we can't take into consideration when sending requests with Postman because Postman isn't a web browser. So what I'm going to do is I'm going to show you exactly what happens when we send a request from a web browser instead of our own computer using Postman. So what I want you guys to do is open up your web browser and specifically go to google.com. It's important that you go to google.com, or technically this is going to work on any website, but I need you to actually go to a specific website like google.com. And then I want you to right click on the web browser and just hit inspect. So this is going to open up the Chrome developer tools. And if you aren't too familiar with it, don't worry. It's just it's a built-in tool that we have in Chrome or any web browser that allows you to makes it easier as a web developer to kind of troubleshoot things. But what we can do is if you go to console, we can actually send an API request to our API from google.com or from our web browser, which is on the google.com domain at the moment. And so I want you to just type this in. We're going to say fetch. So this is how you perform an API request from the web browser level. And we're going to send a request to our FastAPI. So that's going to be hosted on http://localhost:8000. And then just type in then. So don't worry too much about this, but it technically returns a promise. So we have to resolve the promise. So we just say res.json. And then do another then and just say console.log. And I forgot one bracket right here. And so all this is doing is it's sending a request to the root URL of our API, and then it's going to print out the contents of whatever we get back from the server. So when I run this, I want you to notice something. We get an error. It says access to fetch localhost:8000 from origin, and then it has google.com here, has been blocked by CORS policy. So what is happening here? Why is it that I can't send a request from the web browser, but if I go to Postman and I just create a quick new request, and we can just go straight to URL, it resolves just fine? Well, it has to do with this CORS policy. So in this lesson, we're going to take a look at what exactly this CORS policy is and what we can do to ultimately resolve this issue. So what exactly is CORS? CORS is short for cross-origin resource sharing. And so CORS allows you to make requests from a web browser on one domain to a server on a different domain. And by default, when you configure an API, whether it's in FastAPI or any other framework or language, you will only be allowed to send requests from a web browser running on the same exact domain as your server. And so what exactly do I mean by that? Well, if our API is hosted on google.com and our website is hosted on ebay.com, ebay.com by default cannot send a request to an API running on a different domain like google.com. It's going to get blocked by CORS. However, if our website was also running on google.com and our API was also running on google.com, then they'd be able to talk just fine by default. And just to prove that to you guys, if we go to our web browser and go to localhost:8000, which is the URL that our application is currently running on, you can see that I get a response back. So our web browser was able to make, and by the way, when I did this, right, it did the same thing as going into Chrome Developer Tools and actually sending a request. And just in case you don't believe me, I'm just going to actually just show you guys even on here. So if I paste it, you can see that it was able to resolve, and we can see the hello world. So the reason why it works on this website is because this is the same exact URL or domain name that our API is running on, right? Our API is running on localhost:8000. So by default, they're able to talk to one another only when the web browser domain is on the same exact domain as the API's domain. So to fix this, if you did want to allow people from other domains to talk to your API, what you can do is take a look at the FastAPI documentation and just search for CORS, cross-origin resource sharing, and you'll see that setting this up is really simple. So the first thing that we have to do is from FastAPI middleware CORS, we're going to import CORS middleware. All right, and then just copy this section right here. And I'll explain line by line exactly what each one's doing. And so under the app right here, we'll just paste this in. And it's going to throw a little error here, but we'll come back. You can actually delete that and change that to an array for now. But what we want to do is, first of all, we have to pass in the middleware. And middleware is a term that's used in most web frameworks because it's basically a function that runs before every request. So if someone sends a request to our app, and before it actually goes through all of these routers, it'll actually go through the middleware, and then our middleware can perform some sort of operation. But what we want to do is, first of all, we have to specify the origins that we want to allow. So what domains should be able to talk to our API? Because right now it's no domains. Only if it's running on the same exact domain are you able to talk to our API. So the way we can do it is we can put in we'll create a list called our origins, and I'll say origins equals, and it's just going to be a list. And here we're going to provide a list of all of the domains that can talk to our API. And before we fill that in, I just want to quickly talk about the other three as well. So our CORS policy can be pretty granular. So not only can we allow specific domains, we can also allow only specific HTTP methods. So if we were building like a public API where people can just retrieve data, we may not want to allow them to send post requests and put requests and delete requests. So we could potentially just allow get requests. And then we can even allow specific headers as well. But for now, we're just going to allow all headers and all methods. And we're going to just kind of drill down based off of what origins can talk to us. And so, if we want Google to be able to talk to us, I can just say https://www.google.com. And so now this CORS policy is set to allow people from google.com to talk to us. And so if I go back to google.com, I just hit the up arrow so I can run this command again. You'll see that I do successfully get a response back and there's no CORS error. However, if I go to a different website, so some website on a different domain like youtube.com, and then we go and then we send the same exact request from the console, right? We once again get the CORS error. And that's because in our in our list of origins, we're not providing www.youtube.com. So if you wanted to also allow youtube.com, then we'd have to do https://www.youtube.com. So now if I hit the up arrow, we can see that it properly resolves. So you just have to provide the list of URLs that can talk to your API. And if you want to set up a public API so that everyone can access it, then your origins would just be a wildcard. So this means every single domain or every single origin. But if your API is being configured for a specific web app, then you definitely want to make sure that you provide a strict list of origins. So just whatever domain your web app is running on, so that no one else can, accidentally reach our application for some reason or another. It's just security best practices to really narrow down the scope of the origins that can actually access your API. For now, I'm just going to leave this as set to everyone so that, when we actually go to deploy this, it'll be a little bit easier from a testing purpose. But feel free to update this accordingly. In this lesson, we're going to focus on setting up Git for our project so that we can start tracking our changes, as well as set up a remote repository to store all of our code. This is going to make the whole deployment process a whole lot easier. But before we set up Git, there's a couple of things that we need to do. Because when you check your files into Git, by default, it's going to check in all of your files. And there's going to be some files that you don't want to be uploaded to a remote repository or even into your Git in general. And so we have to create a file called a git ignore file. And so if you go to the main root folder of your project, I want you to create a file called .gitignore. And it's important that you put the dot in front of it. So it's .gitignore. And so this file is going to tell Git what are all of the files and folders we don't want uploaded to Git. And so some of the common things that you would not want to be tracked within Git is going to be your .env file. So this is going to be all of your environment variables. Obviously, you don't want to check those in, or then if this is part of a public repository, then anyone can see those. But also on top of that, you'll see all of these random PyCache, these __ PyCache folders. So go ahead and add that in there as well, because we don't actually need to check that into Git. And then finally, we have our folder which contains our virtual environment. We don't want to check that in as well, just because we have no idea if someone else who wants to clone our repository is going to be using a virtual environment. And if they are, then they can create one on their own. There's no need for us to actually upload our virtual environment. It just wouldn't make sense. And on top of that, our virtual environment contains all of the third-party libraries that we've installed. So all of the different packages we installed through pip, including FastAPI itself. So all of the code of FastAPI is within that virtual environment folder. And so there's no need to actually upload all of that, because that's a lot of files that actually take up a decent amount of space, and it just wouldn't be efficient to actually upload those to Git. However, this does create one bit of an issue, because if we clone the repository at this point, right, we have no idea what packages we need to install, because our virtual environment didn't get uploaded with it. So we need a way for other users, other people on our team, to know what packages and dependencies we need our application so that our application actually works. And so the way that we actually do this is, well, first of all, before we even proceed, go ahead and copy this into your git ignore file. And make sure you have this before you do anything else, because once certain files get checked in, it's very hard to get them removed. But after this, what we want to do is we want to create one more file. And open up your terminal. And what we're going to do is type in pip freeze. So pip freeze is going to dump out all of the different packages and libraries that we have installed, as well as the specific versions. And so this is the information that we want to upload to Git, so that if anyone else clones our repository, they'll know the exact versions of every package they need to install. So what we're going to do is we're just going to take this output and we're going to pipe it to a file. And the file name is going to be called requirements.txt. So this is standard convention with any Python application. You want to create a requirements.txt file that's going to contain the version of all of the different packages that you have installed. And so if we check this into Git now, then anyone else can just take a look at our requirements.txt file and then actually install dependencies based off of what's in this file. And so for anyone else that clones our repository, all they have to do, instead of going one by one and installing these, they can just type in pip install -r requirements.txt, and that's going to install everything that's in this file. So this does simplify the process and it prevents us from having to upload all of those third-party packages into Git. But we've got everything set up at this point. We've got the git ignore file and we've got the requirements.txt. So what we need to do now is actually set up and install Git on our local machine. If you don't already have Git installed, then in this lesson, we're going to focus on getting installed on your local machine. So just search for Git, and then you can either go to the main page or you can go straight to the downloads page. So I'm just going to select the downloads page. And then here you're going to see the different operating systems we can install Git on. And so just go ahead and select your respective operating system. I'm on a Windows machine, but regardless of your operating system, it's going to be a fairly similar procedure. So I'm going to select this. It's going to download that. All right. And then when the wizard opens, go ahead and select next. Next here. And you can leave everything default here as well. And here and here. Now, this is the one thing that we do have to change. So this is kind of a little bit of a nuisance at this point, but they used to call like the main branch the master branch, but I guess people are offended by that. So now the new term for the main branch is main. So go ahead and override the default branch and just change that to main. Because when you work on GitHub, they've already changed the default branch to be main. So we're going to want to do the same thing. So hit next. And then you can leave everything as default moving forward. There's a lot of windows to go through. And then it's going to proceed to install Git. All right, close that out. And then what you want to do is open up a new terminal. And just type in git -- version. And if it spits that out, that means you've got Git successfully installed. In this video, we're going to set up a remote repository so we can store all of our code on GitHub. And so if you don't already have an account on GitHub, go to the main GitHub page, just go to github.com and just click sign up and then follow those instructions. And then once that's done, just log in and you should see something similar to this, although you may not see an activity window if you just created a brand new account because you won't have any repositories. But just look for a new button to create a new repository. You can also go up here, I believe, and select new repository. So I'll select new. And then we have to give our repository name. You can give it any name you want. I'm just going to give it a dummy name. So this is going to be example FastAPI, but name it after whatever your project is. Technically, I've already set up Git for my project, just so I can track all the changes I've made throughout the course. But I want to make sure that I can walk you through this if you've never done it before. You can give it an optional description, and then you can choose whether or not a repository is public or private. If it's public, anybody can see it. If it's private, then only you can see it. We're going to keep it as public. Don't worry, if you decide to change it in the future, you can change it to private. However, it does make a few things a little bit easier when it's public. So I'm going to leave this as public, and then we're going to leave all of these unchecked. They don't really matter. And we'll select Create Repository. And then you'll see that it's going to give us a couple of steps to follow. So if we haven't already set up Git for our project, these are the instructions we're going to follow. And if we've already set up Git in our project folder, then we can follow these steps. However, we haven't set up Git yet, so we're going to, for the most part, follow along here, but we're going to modify it just a little bit because we don't need to run some of these commands. So go ahead and open up your project in VS Code like you normally do. Then open up your terminal, and we're going to follow these steps, but we're going to ignore the first one. We don't need a README for now, but we are going to do a git init, which is going to initialize Git for our project. And so make sure you're at the root directory of your project. So whatever this is called right here at the top, make sure that's where you're at. And just do a git init. That's going to initialize Git. And you may not see anything different about your folders, but I think it's because VS Code actually hides the Git folder. But when you actually did a git init, if you open up this your project directory and you click on view here and then make sure you select hidden items, you'll see that it created a .git folder. So this is where it stores all of the Git information. Then we're going to skip this git add readme. Instead, what we're going to do is we're going to run git add -- all. So this is going to add all of the files that we have in our directory into Git. All right, and you'll get a couple of warnings potentially. Don't worry about that. Those won't create any issues. Then we have to commit our changes. So anytime you add a file, you then have to commit it. So we'll say git commit -m. So the -m means we're going to provide a message. So you usually give a message for each commit to kind of describe what changes you're making. So we're just going to call this initial commit. All right. And you'll see that we probably get an error if this is the first time you've ever worked with Git. And that's okay. It's just telling us, hey, we need to set up our user for our account on this machine. So we're just going to run this command right here, and then we're just going to provide the email that we use to register for GitHub. So I'll say git config -- global user.email. All right, we set that, and then it's telling us to also set our name. So we'll do that as well. Then we're going to run that same command, the git commit. So if you just hit the up arrow a couple of times, you'll get to that. All right, so we've committed those changes. Then what we need to do is we need to set what our branch is. So here, this is just going to set our main branch to be called main. And so we can copy that, paste it into here. Then we have to set up a remote branch. So this is what's going to allow us to store all of our code on GitHub. So we're just saying like, hey, listen, this is going to be the remote Git repository, and we just provide a URL to it. And so that if you take a look at the URL, it's going to match up with this. And in this case, we're naming it origin. You can technically call it anything you want. So we'll add that. And then finally, we need to do a git push -u origin main. And so this means we're actually going to push all of our code up to GitHub. And you'll see a pop-up asking you to sign in. And there's a couple of things we can do. We can get a personal access token, or we can sign in with our browser. So I'm just going to sign in with our browser. And we just select authorize right here. All right, and it says it's succeeded. So we should be able to go back, and we can see that a couple things changed. So it looks like, well, that's our authentication. And then you can see that we're pushing all of this stuff up to GitHub. And so at this point, you're pretty much done. All of your code is now stored in GitHub. And we can just verify that by going back to this page and just select the name of the repository again. And you'll see all of our code stored on GitHub now. So at this point, our repository is set up, and we can move on to deploying our application. In this lesson, we're going to take a look at the first of two deployment methods that we're going to cover in this course. So what we're going to do is we're going to deploy our application to a platform called Heroku. And the reason I wanted to make sure to have this as one of the deployment methods was that Heroku has a very generous free tier. And so we can create an account for free, and we can deploy our application absolutely for free without having to pay a single dollar, and we don't even have to provide our credit cards. And I wanted to make sure to add that just because I know for some of you guys that isn't exactly an option, and I wanted to make sure that you can still deploy your application and show off to your friends and family what you have created. And you'll see that Heroku has made it very easy to deploy your application, and it's very easy to push out changes to your application. It's a fantastic platform, and I think you guys will learn a lot on how to actually deploy an application by making use of a platform like Heroku. So we'll take a look at how we can, make use of Heroku, learn about the Heroku CLI so that we can push our application to the platform and ultimately have anyone be able to access our API. Heroku has a lot of really good tutorials on how to deploy applications on their platforms, and they've got one for Python as well. So if we go to Google, just search for Heroku Python, and the first result is going to be their tutorial. It's going to walk us step by step on how to actually deploy our application. But before we do that, there's a couple of things that we have to do. First of all, go ahead and create an account on Heroku if you haven't already done so. It's completely free, so just provide your email and so on. Then there's two other requirements. We have to have Git installed on our machine, which we've already done, and then finally we have to install Heroku itself. So if you go to the setup section right here, you're going to see the installers for all of the different operating systems they support. So just select whichever operating system you have and get the Heroku CLI installed on your machine. And after you get it installed, usually you have to close out any of your pre-existing terminals and reopen them to actually be able to access the Heroku command. If you have VS Code, a lot of times I've had to just close out VS Code altogether, not just close the terminals, but actually close out the entire application and then open it back up. But after you've done that, if you want to verify if Heroku was successfully installed, just go to your terminal and just type in Heroku -- version. And if it spits out a version, that means Heroku has been successfully installed. And after it's been installed, we want to log in. So we do Heroku login. And then you just press any key right here. And it's going to open up your web browser. You can just log in and then provide your credentials. All right, and then once you're logged in, you can just close out this window. We'll go back to our code, and you can see logging in is done, and we've logged in, and then that's my specific account right there. All right, and once that's done, we're going to go back to the tutorial, and we're just going to kind of follow along. So if you go to prepare the app, you can ignore this. So they give you like a demo application to kind of follow through the tutorial, but we already have our own app, so we don't need to worry about that. If we go to deploy the app, we have to run this command Heroku create. So we have to create an app within our Heroku account. So let's run that command. But before we run that, I'm going to do a Heroku create -- help. And we can see that one of the arguments is going to be the name of the app we want to create. And so if you don't provide a name, Heroku just gives you a random name, but I always like to use a more familiar name so I know that which app covers which one of my applications. And so I'm going to call this FastAPI Sanjeev. And keep in mind, these app names are global. So if I deploy my app as FastAPI-Sanjeev, you will not be able to create an app with the same exact name. And that's because to actually access our application once it's deployed, the URL is going to be the specific app name embedded in there. So it has to be globally unique. So if it says your app name is already taken, then just try a different one, maybe add a couple of numbers at the end. It doesn't really matter what the name is. All right, and once we've created our app, the next thing that we have to do is, well, actually, before we even do that, I want to show you guys what it actually did. So there's a couple things that happen behind the scenes. And the first thing is if we actually log into our account, I'm going to log in right here. Right, we're going to see our dashboard. So in the dashboard, you can see the application that we just created. Right now, there's nothing interesting. Nothing's been set up with it, so we don't actually see anything. But the second thing that it also did was if I type in git remote, this is going to show all of the remotes that have been set up for our Git. And we can see there's two now. So there's Origin, which is the one we set up originally, and that's GitHub ultimately. But Heroku added a second one. And so this is ultimately how we deploy our application, because instead of doing a git push origin main to push it out to GitHub, we can just do git push Heroku main, and that's going to push out our code to the Heroku platform, and then it will then create an instance for our application. So let's go ahead and do that. We're going to do a git push Heroku main. And this is going to take a little bit of a while because it's got to, set up Python. It's got to do a few other things. It's got to install all of our dependencies before it can actually get our app up and running. So I'm going to pause this video and then I'll touch base with you guys once that's complete. All right, so our application has successfully been deployed, and you'll see that in the logs, Heroku actually gives us the URL of our application. So I'm going to copy this URL and we're going to just open this up in the browser. And if you let this run long enough, you're eventually going to see an error. So it looks like something in our application is broken. And this is to be expected because there's still a few more things that we have to do to actually get this set up. Because if you take a look at what we've done, we pushed out our code to Heroku, right? But Heroku has no idea how to actually start our application. What is the command? It just knows that this is a Python app, but it doesn't know what it is. It doesn't know that it's a FastAPI app. It doesn't know that we're trying to build out an API. It has no idea. And when we deploy to our development environment, we ran uvcorn and then, app.main and then app, right? But we haven't given that command to Heroku. How does it have any idea that our code is in main.py and that within the main.py file, we have our app instance stored in a variable called app? It has no idea. So what we have to do is we actually have to create a file that's going to tell Heroku what is the exact command that we want to run. So inside your root directory, so just kind of collapse all the folders. Inside your root directory, so just right click here, create a new file, create a file called a proc file. So I've already got this in here. It's going to be in the GitHub repo, so you can take a look at it and make sure you capitalize the P. And actually, if you take a look at the tutorial and we go to the next one, which is define a proc file, this is going to just explain what the proc file is, but the proc file just tells Heroku what is the command that we need to start our application. And so here we give it a process type. So since this is a web application that's going to be responding to web requests, we want to use the word web, and then we specify the exact command that we need to run. And so in my proc file, a couple of things have been set up. So we run the command uvcorn app.main and then app like we've done before. We're not going to pass in the -- reload flag because this is production. We don't want it to automatically reload on changes because there should be no changes. We do have to provide the host IP. So this is just saying that, hey, we should be able to respond to requests to any IP. So whatever IP Heroku gives us, this is going to accept it. Then the next flag is going to be the port flag. So what port should we run this on? If we don't provide a port flag, then it's going to default to port 8000 like it always has. However, the thing about Heroku is that they're actually going to provide us a port. So we don't know what this port is ahead of time. So we have to be able to accept this port regardless of what it is. And so it's actually going to pass this down as an environment variable. So anytime you want to accept an environment variable or reference one, you can just say $ and then curly braces. So we're really just saying we want to take whatever value Heroku gives us with the environment variable of port, and we want to assign it here. And then this is just giving it a default value of 5000 if they don't provide one. However, Heroku will always provide a support, so I don't think we even need that. And so after you make this file, you're then going to have to push out these changes to Git once again. And since I already had this file, there's nothing to change in my Git, so nothing will get pushed out. So I'm just going to just change some random code. I'm going to delete this 1, 2, 3, 4 here so that I can at least have some changes in my code. You guys will already have changes in your code because you added the new file. So then go ahead and do a git add --all. So that's going to add all the changes. We're going to do a commit. And we'll give it a message of added proc file. And then we do a git push. And then what do we push to? Well, first of all, moving forward, we want to make sure that this is stored in GitHub. So let's do a git push origin main. This is going to push it to GitHub. And then now we want to actually push out these changes to Heroku so that we can actually get our application up and running. So we'll do a git push Heroku main. And once again, we have to kind of wait through this entire process. Okay, so it's now finished. Once again, we're going to go back to the URL it's deployed at. And I'm just going to do a refresh to see if we fixed our issue. And the fact that it's still spinning for this long most likely means that we did not fix our issue. But I already know the exact reason why this is. And so we will take a look at exactly what is causing our application to not successfully get deployed in the next lesson. Anytime your application isn't working on Heroku's platform, they have a really easy way of accessing logs. So we can say Heroku logs, and then I'm just going to do a -- help just to see what options we have. And so here we could specify the app, or we can just dump the logs for all of our apps. But what I'm going to do is I'm going to pass in the -t flag so we can tail the logs as things happen. So if I do a -t, and we scroll up, you can see that we've got a couple of different errors. And so it looks like there's some issues with settings, which is the Pydantic model that we've set up for retrieving our environment variables. And it's saying that there's a couple of validation errors for our settings model. And it says that, hey, look, we don't have a database hostname, we don't have a database port, password, or any of the other information. So there's some issue with our environment variables. And this makes sense because in development, we use our .env file to provide all of the environment variables into that settings model right here. And we pass that by specifying the env file. However, we did not check our env file into Git. Remember, in Git, we used the git ignore file to make sure we excluded that because we don't want to actually check that into Git. So how does Heroku know what all of our environment variables should be? Well, they have and so we actually have to add those environment variables either through the command line or through the dashboard. But before we can do that, we need to actually get a Postgres database. Because right now we don't have a Postgres database. So what would we even provide for database hostname and port and password and things like that if we don't have one? So let's create one. And once again, Heroku provides us with a free Postgres instance that we can have access to. And that's one of my favorite parts about Heroku is that now we have access to Postgres. So let's go to Heroku Postgres. And I'll just say tutorial. And this is going to take us to their dev center. So this is going to show us actually how to create a Postgres instance. And so Postgres is one of their many add-ons. If you want to actually go to their website and see all of the different add-ons they support a ton. If you want to read this add-on, you can get that added. But in this case, we want to create a Postgres a Postgres instance. So we do Heroku add-ons, create, then the type of add-on, which just means it's going to be PostgreSQL, and then plan name. So we are under the hobby dev, which is essentially the free one. And that's going to actually create a Postgres instance. So let's run this and just Control C out of this. And let's just do a -- help real quick, just to see what other flags we have. And that should be fine. We don't need to actually provide any other flags. So let's run this. And Heroku is actually going to create our Postgres instance. And keep in mind that for Heroku to spin up a Postgres instance, it does take a little bit of time, but we can actually monitor that in our dashboard. So if we go back to my dashboard and do a refresh, you can see that this is the new Heroku instance. And I can just click on this and we can see some more information. It's going to open this up in a new tab. And if you want to, we can go into these settings. And here we can take a look at our database credentials. So if I view my credentials, you can see that this is the IP address my database lives on. This is the actual database name. So we don't get to create our own database name or our own database within Postgres. They give us a fixed name, and that's perfectly fine. And then this is going to be the username that we're going to log in as. This is the port it's running on. And then this is our password. And they also provide us the full Postgres URL if we want to use that. So now that we have this information, feel free to save this real quick. And I'm actually just going to do a quick screenshot and save this in my notes so that I don't have to keep bouncing back and forth. And now let's go back to our application. And if we go under settings, this config vars is where we actually provide environment variables to our Heroku instance. And by the way, Heroku calls our instance dynos, but you can use either term you want. And so you could see all of the config variables that have been set, and there should be nothing except for one. So when you add a Postgres instance to your application, what happens is Heroku automatically adds an environment variable called database URL, and it's going to contain the entire Postgres URL. And so we could go into our application and then update our code so that in the database.py file, instead of breaking things down like this, we can just provide one specific URL and just put it in as settings.database _URL. However, I don't like to change my code. I like it just the way it is. So instead of using the default environment variable, we're going to actually break this URL out into multiple different environment variables. So just open this up and take a look at all of the environment variables that we expect by going into our config.py. So we need all of these set. So we're going to add one for database hostname. And from the URL, if you forgot what the hostname is, and actually, I'm going to just open this one up in a new tab and then open up, actually, I don't even need to open up this one. I just need to flip between these two. So the hostname is right here, but you can get it from this URL just by clicking on this icon and then just grabbing the IP address. But it's such a small little window. I hate having to do that. So I'm going to close that and just bounce between these two links. All right, so let's grab the hostname. And we'll add this one. Then the next one is going to be the database port, password, name, and username. So let's just write those out. Database port, database username, database password, and then database name. I think that's it. Database port, password, name, username. And then we have to add this stuff for our token. So we got secret key, algorithm, and then the last one. And then now we can provide in the values. So the database port, we can see from here, it's going to be the default 5432. the username. And then here we'll grab the password. And then the actual database name here. The secret key, I'm just going to use whatever we used in development. Not actually recommended, but I'm just going to keep things as simple as possible for now. But you can provide any secret key you want. And I'll say in production, it'll expire after 60 minutes. All right, and so now we've got all of our environment variables set up, and our Postgres instance is already up and running. So I think at this point, our app should work. So we'll try this out again. So now that we set those new environment variables, how do we actually restart our Heroku instance? Well, let's do a Heroku apps -- help. And let's see if there's a restart. So there's app create, destroy, and it doesn't look like there's a restart. So we can't actually use the apps argument to restart our application. Instead, we have to do Heroku ps -- help. So now we can see that we do have access to restart. So we're going to do Heroku ps restart. And that's going to restart our dyno, which is our Heroku instance. And once again, I'm going to do a Heroku logs -t to tail the logs. All right, and so now you can see those previous errors were gone, and we were now able to successfully run the startup command. And you can see that we actually got past a specific port of 34731. And so that's why we ultimately had to provide the port variable, because this will change every time we restart it. However, we don't actually need to use that specific port number in the URL that we need to access. So let's get our app URL, which I already forgot. And if you ever forget your URL, you can just type in Heroku apps info, then the name of the specific app. And then it's going to give you all of the specific information. So you can see this is actually where the Heroku Git is being stored. We can see that we have one instance in this case running the web. And then we have our URL down here. So I'm going to copy this. And you can see that we get message hello world. So it looks like things are working. If I actually go to /docs, let's test that out. And so now we have access to documents. I'm going to minimize that. So it looks like things are working. However, if I try to log in, whether it's either through the documentation or if I actually send a request from Postman, you're going to see that there's going to be some issues. So here I'm going to actually, I can't even log in. I have to create a user first because this is a fresh deployment. So let's go to users, and we're going to create a user real quick. And I'm going to just try this out and put in whatever name you want. So this is sanjeev@example.com. My password will be password123. We'll execute it. And you can see that we get an internal server error. So what is happening? Why can't we exactly create a user? Well, like usual, we're going to go back to our logs, and we're going to see what happened. All right, so we can see the SQL that's getting inputted in the logs. And it looks like there's some kind of error with the SQL. And I don't know if that's going to give us a more specific error that's going to actually help us. I think that's all it's going to provide us in this case. But I think you guys can guess exactly what's happening. We deployed a brand new instance of Postgres. But right now, if we actually connect to our Postgres, you're going to see a few different issues. So I'm going to actually connect to this Postgres instance. And to create a Postgres instance, just right-click here and then select Create Server. So this is going to allow us to connect to another Postgres. And I'm going to call this Heroku-Postgres. And then here we're going to provide the same exact connection information. So we'll go back to settings, we'll get our credentials. Okay, and so now we are successfully connected to our Heroku Postgres instance. And if I just drop this down and then go into databases, you'll see a ton of different databases. Keep in mind, we won't actually be able to access most of these. So the reason Postgres is able to, the reason Heroku is actually able to provide this for free is that they have one instance of Postgres, and then they give you one database within that instance that you can access, but only you can access that specific database. And so our database is D58, and I don't know if there's an easy way to search for databases. Let me see if I can right-click this. Nope, it doesn't look like there's an easy way, so I'm just gonna have to scroll down to D5. And then what are the next letters? D5, 8RE05. All right, so I finally found my database. You'll see it's the one that I have access to, so it's actually colored. And if I just open this up real quick and go into schemas, public, and then tables, there's nothing in there. So that's really the reason why our application is not working, is because we have a brand new Postgres instance, but we haven't actually set up our tables or our schema. And so this is where Alembic is going to come into play once again. You'll see that since we already have all of our revisions set up, getting our production database to match our development database will be as simple as just running one simple command. So we'll take a look at that in the next video. In our development environment, we used Alembic to manage our database schema. So Alembic was responsible for creating all of those tables. And since we have all of these revision files within the Alembic folder, we can essentially track all the changes that we make. And so to actually get our development database up to date, we just ran Alembic upgrade head. And that would go to whichever one of these is the latest revision and make sure that our Postgres instance matched whatever that is. In our production database, because in our production database, it's going to be no different. We're going to just run Alembic upgrade head on our Heroku instance, and that's going to ensure that our Postgres database gets updated to our latest schema. And because we've checked all of these files into Git, because all of the Alembic folders was added to Git as well, that then our Heroku instance has access to all of our revisions. And so when we run Alembic, Alembic can keep track of all of those changes as well in our production server. And it's important to understand that we never run Alembic revision on our production server. We only run Alembic revision on our development server when we're staging out these changes. In our production server, whenever we want to push out those changes, we just do a git push. So we push out the code, all of our code changes, as well as all of the Alembic revisions to our production server, and we just run an Alembic upgrade head. It's as simple as that. So let's do that now. The first thing that we need to do is we got to figure out how do we actually run a command in our Heroku instance. I think your first guess is probably going to be, do we add another line into this proc file that we can kind of call whenever we want to? Not exactly, although maybe you can do that. But if we go back to our tutorial and go to start a console, we can run a specific command on our Heroku instance by doing Heroku run and then the specific command that we want to run. So let's try that out. And you can even drop into the bash shell. So there's a lot of flexibility, but we're going to just do a Heroku run. And then we want to provide the command that we want to run. I'm going to put it in quotes. I don't remember if it's a requirement to put it in quotes, but I'm going to do that just in case. So we'll do Alembic upgrade head. All right. And you see that it's running that command right now. And take a look at the logs, right? You can see that not only did it get our Postgres instance up to the latest revision, it has all of the other incremental steps added in as well. So we can roll back to any of them just like we did in development. And if we go back to PgAdmin, I'm going to just refresh tables. And if we go to our tables, you can see that we have all of our tables here now. And just in case, because I believe we crashed our application maybe when we tried to, create a user without having a Postgres database or table set up, I'm just going to do a Heroku PS restart again, just to restart the instance, just in case. And now I want to go back to here, and we're going to just go back to the root URL to see if that works. And that works. That's perfect. We'll go back to docs. We can see that that works. Now let's try to create a user. And so I'll do try it out. And I don't even feel like changing any of these values. Technically, these should still work. So let's just try that. And we got a response back. And look at this. We got a 201, and we can see the user that was created. So it looks like our application was now successfully able to access our database. If we go into the users table, right-click on this and just do a view, edit, all rows, we can see the one user that we created. All right, and so that's pretty much it. We've successfully deployed our application. The last thing that I want to show you guys is how do we push out changes to our application? So let's say that I go into my app, and right now I go into main.py, and I see that this just says message hello world. And let's say I make some kind of change. And let's say I just add a whole bunch of exclamation points or something. Just keep it simple just to show you guys, regardless of what change you make, the steps are going to be identical. So we make some changes. The next thing that we have to do is we actually have to push out those changes. So first of all, you're definitely going to, push out those changes to your GitHub repository. So we'll do git push origin main. So that's going to push it out to GitHub. Oh, sorry, I forgot to do a git add -- all. So we actually have to add those changes and then commit those changes. So we'll do git commit. Then we'll do a git push origin main. So that's going to push it out to GitHub. And then finally, to actually push those changes out to our production environment, we'll do a git push Heroku main. All right, and so that's pushed out now. And if we go back to our application, I'm going to go back to the root URL, and we can see that we now have the extra exclamation points. So we have successfully pushed out our changes. All it took was just one simple command. And keep in mind that if you make changes to your code, that's all you have to do. However, if you make changes to your database, so you go into Alembic and you create a new revision, then we have to follow the same exact steps. But on top of that, we have to do the Heroku run Alembic, upgrade head so that we actually push out those changes to the Postgres instance. But there you guys have it. You have successfully deployed the application that we have spent building the past couple of days. And so feel free to show this off to your friends and family. Feel free to make as many changes and modifications, really start to play around with it. Try to expand on the functionality of our application and just keep learning, I guess. For the second method of deployment, we're going to see how we can deploy our application on an Ubuntu server. And it's important to keep in mind that it does not matter where you host your Ubuntu server. You can run it on any of the major cloud providers, AWS, Azure, GCP. You can run it on DigitalOcean. You can run it on your local machine. Yeah, if you have VirtualBox installed on your computer, you can run it on Raspberry Pi. It doesn't matter. The steps are going to be identical as long as you run it on an Ubuntu server. Now, what we're going to do in this course is I'm going to show you guys how to deploy it on DigitalOcean, just because it's $5 a month. It's cheap. It's a fixed price. If you deploy it on AWS, then the price is it varies. And if you run it all month long, then it could spike up well past $5. So this is kind of the cheapest solution. But keep in mind, like I said, the steps are identical regardless of where you deploy. I just want to focus on making sure that you guys understand the steps that needs to take place to actually set up your Ubuntu server to be ready to host your application. And so if you don't have a DigitalOcean account, go ahead and make one. And then once you log in, you'll see this window. And what we want to do is select Get Started with the Droplet. So we'll select that. And what we want to do is we want to select Ubuntu 20.0.4. That's the latest version at the moment. If you're watching this in the future, you could probably grab one of the newer ones. Most of these commands are going to be identical. But if you wanted to make sure that you don't run into any issues, select the same exact version. Then for the CPU options, you want to select regular Intel with SSD. That's going to be the cheapest. And then you want to select the cheapest one right here, which is $5 a month, or 0.007 per hour. What is that? 7/10 of a cent? All right. And then select your data center. So I'm just going to select whatever's closest to me. I'm on the East Coast, so I'm going to select that. And then nothing else for the most part really matters. We can leave everything as default. And then you have two options for authentication. You can use SSH keys if you're familiar with how to work with that. If you're not, then start out with password for now. It's just a little bit simpler. And you'll see that DigitalOcean has some strict requirements for passwords. So you're probably going to have to try this a couple times before you find one that actually matches their criteria. And then here we can just give this a specific host name. I'm just going to call this Ubuntu-FastAPI. It's nothing more than really just a tag. And that's all we have to do. We'll select create droplet and DigitalOcean will create our Ubuntu VM. All right, and once the loading bar finishes, you should see a public IP. This is the IP that we're going to use to connect to our virtual machine. And so we'll take a look at how to connect to this in the next video. To connect to our Ubuntu virtual machine, we need to open up our terminal. So just search for terminal on Windows. If you're on Mac, you can do the same thing. Just search for terminal. And then on Windows, you can select command prompt. I installed another terminal, so I'm actually going to use that, but you can use this one as well. You can even use the built-in terminal within VS Code. It's all going to be the same thing. Okay, and to connect to a device, we have to use a protocol called SSH. So we do SSH, and then we have to provide the username that we want to connect to the device. And so this is going to vary depending on where you're deploying your virtual machine. On DigitalOcean, they're going to create an account for the root user. So this is like the most privileged user. This is where you can ultimately do anything with the device. You have unlimited access. So we're going to do SSH root @ and then you do the @ symbol, and then we provide the IP address. So I can just hover over this, select copy, and then paste it in here. And at this point, you'll get this, fingerprint message. So just hit yes. And then it's going to ask you for the password. So this is the password that we provided when we created the virtual machine. And at that point, we are now successfully logged in. And so you can, if you run ls, this is just going to print out the contents of your current directory. And so it looks like we've got one folder in our directory right here. But this is our Ubuntu virtual machine. And anytime you get a brand new Ubuntu virtual machine, the first thing that we want to do is we want to update all of the installed packages. So we want to make sure that it's up to date, right? It's just like installing any other operating system. And to run that, there's two commands that we want to run. So we do sudo. So this is going to give you, well, technically we don't need to run sudo because we're the root user, but if for some reason you're not the root user, then you always have to use the keyword sudo. So we do sudo apt update. And then the second command, we can do two & and say sudo apt upgrade. And then we pass in a -y flag. The reason we pass in the -y flag is because if you don't pass in this flag, what's going to happen is it's going to do a few things and then a prompt will come up where you actually have to hit yes. And I always hate having to hit yes. When you pass in the -y, you can let it run and then you can just go do something else, go get some coffee because it is a fairly long process. If you get this pop-up, it doesn't really matter what option you choose. You can say keep local version currently installed or install the package maintainers version. I'm going to select this one, but it shouldn't make a difference. So once all of those packages are up to date, we need to install a couple of extra packages. And the first thing that we need to do is, let's actually check what version of Python we're running on this machine. So if I do Python -- version, all right, so it doesn't look like Python's installed. However, if I do a Python 3 -- version, we could see that we actually do have Python. It's just we have to use Python 3 because a version 3 of Python was installed. And so if you see anything that starts at 3.8.10 or later, you should be good. However, if you want to, you can always do a sudo apt install Python, and then I think you could just do a dash and specify the specific version that you want. But you can figure out how to do that by taking a look at the Python documentation. 3.8.10 or later is more than good enough for us. So we have Python. The next thing that we need to do is we need to install pip. And let's actually double check and make sure that it's not already installed on our machine. So we could just say pip -- version. We could see there's no pip here. However, let's try a pip 3 -- version. And it looks like we don't have pip installed, but it's giving us a little hint on how to install pip. So we can do sudo apt install python 3 - pip. And we'll hit Y for yes. And once that's done, we're going to use pip to actually install virtual env because we are going to make use of virtual environments on this machine as well. So we'll say sudo pip 3 install virtual env. And so now we should be able to use the virtual environment command. The next thing that we have to do is install Postgres on this machine. So we'll run sudo apt install, and then the libraries that we need are PostgreSQL and PostgreSQL-contrib. And then we'll do a -y so that we don't have to hit yes. Okay, so we've got Postgres installed. How exactly do we connect to it? So what we're going to first do is, before we try to connect to it from our local machine, I want to connect to it from the actual Ubuntu computer itself, the Ubuntu virtual machine. And so we're actually going to take a look at the CLI for accessing the Postgres database. And so the tool that we use to do this through CLI is called PSQL. Right? And we should be able to have access to it. So if you do PSQL-version, you should see that it should respond back with something. So that means PSQL is installed. And if I do a PSQL-help, it's going to show us the different flags that we can pass in. But the main flag that we want to pass in is the -u, so we can specify what's the username that we want to connect to. So let's say PSQL, then -U, and then our username. And we know that when we install Postgres, it's going to install a user on the database called Postgres. So that's what we always use to connect to it by default. And so we say Postgres. And if you want to, you can specify the specific database you want to connect to. I believe there's a flag. It might be -d. Yep, the database name. So you could technically say -d Postgres, but Postgres is going to be the default, so you can leave that off. And we're connecting to our local host, which is going to be the default as well, so we don't need to pass in that. And the port, we can also pass that in. The default is 5432, which is what it's running on. So we don't really have to touch anything else, and we're going to try and connect like this. So let's see what happens. All right, and we get this error. It says a PSQL error, fatal, peer authentication failed for user Postgres. So for some reason, it's saying peer authentication failed. And this is a special meaning, right? It sounds like a regular login failure, but it's not. And it's because Postgres, when you install it on Ubuntu, it has a special way of authenticating users by default. So when it comes to local authentication, and what I mean by local authentication is the Ubuntu VM connecting to the database itself. That's what a local authentication means. Whereas if I'm connecting from my Windows machine to the Postgres database on this Ubuntu VM, that is not considered local authentication. So since we are on the same machine that we're trying to connect to our database, Postgres considers this a local authentication. And on Ubuntu, we have a special configuration called peer authentication. Now, this is the default configuration for Postgres. And what peer authentication does is it actually takes the user that's logged in to the Ubuntu machine and it tries to log in as that user, essentially. So even though we pass in the -u flag, since I am technically logged in as the root user, all right, Postgres is going to error out because it will only allow a Ubuntu user called Postgres to be able to log in as the user called Postgres on the Postgres database. A little confusing, right? But it actually connects, it actually obtains the username from the Linux kernel. So whoever you're logged in as, that's the only person you can log in as. And so what we can do is, first of all, because this is the default configuration, Postgres understands that. So Postgres actually created a user on our Ubuntu VM called Postgres. So if you want to see the list of all the users on your Ubuntu machine, you can do a sudo cat/etc/passwd. And you can see all of the users that have been installed. And you can see that it actually created a user called Postgres on this machine. So I'm going to change that user. So we can do that by doing su dash and then the name of the user, so Postgres. Right? And notice how we changed to this specific user. And so now if I try to do PSQL-u Postgres, we can now log into the database. So if you see this, that means you're successfully logged into the Postgres database. And while we're logged in here, before we do anything else, because first of all, we're going to get rid of that peer authentication because I hate it. We want to create a password for our Postgres user. And to assign a password to this user, we can say \password, and then the name of the user that we want to assign a password to. So we're going to use the Postgres user. And then here we're going to provide our password. All right, and so now we should have a password. And I'm going to exit out of here. So to exit out of the Postgres console or terminal, whatever you want to call it, you just do / and then Q for quit. And then we're still logged in as the Postgres user. And so if you type in exit, it's going to take us back to the root user. There's going to be a few more things that I want to change to our Postgres installation. And so anytime you want to modify the configs for Postgres, what we want to do is we want to move to a different directory. So the command to move to a different directory is cd. And then we specify the path to the directory. So we want to go to /etc. So generally, any application you install on Linux or an Ubuntu machine, usually the configs for that package or that application is going to be in /etc. And then here I'm going to say Postgres /. And then if I hit tab, you can see that it's going to autocomplete. So you're going to specify whatever version of Postgres you ran. And so in this case, I have Postgres 12, but if you installed a version 13, then you would put in, it would be a folder called 13. And then we will go to main. And if I type in ls, we'll see all of the files that we have in this folder. And the two main files that we want to focus on are pg_hpa conf. So this is where we configure Postgres, as well as postgresql.conf. And so we're going to open up postgresql.conf. So I'm going to say sudo vi postgresql.conf. And we want to kind of scroll down. And we want to take a look at the connections and authentication section. And so if you take a look at the default configuration, we can see that under listen addresses, it's only going to allow localhost to connect to our database. That means only when we're logged into this Ubuntu VM can we then log in to this Postgres database. It is not going to allow me to take PgAdmin on my Windows machine and connect to it remotely. And so I want to change this. And technically, you don't have to do this, but if you do want to be able to connect to it remotely, then you want to change these configs. And so I'm going to put this config, we're going to say listen_addresses equals. And then here you would provide the IP addresses. And so, if you wanted to only be able to connect to this database from, your office, then you would put the IP address or domain name of your office. If you want to allow all IP addresses to connect to it, you would just do a star. So that's what I'm going to do. It's going to allow me to connect to this regardless of what computer I'm on or where I am on the network. However, it generally, when it comes to best practices, you want to really narrow down the scope of the different IPs and domains that can access your database, because that's the most important part of your application. You want to make sure it's as secure as possible. All right, so we'll save this. That's the only change we need to make in this file. Then the next file that we need to change is pg_hpa conf. So we'll do the same thing, sudo vi pg_hpa conf. And we're going to scroll down. And we're going to take a look at our default configuration. So I did mention that when we connect locally, it uses a peer authentication. So you can see that for local connections, and I forget what the second column is if we actually scroll up. Well, I got to go up. Actually, let's see what the second column is. Okay, so this is going to be the format of it. So this is going to specify what type of connection, then what database this connection should be associated with, or this rule should be associated with, what's the user, and then what's the method. Well, we also have address and method if you are connecting remotely. So we want to change this. So we want to say for local users, regardless of what database they connect to and what user they connect as, we want to make sure that we do not use peer authentication. We use regular password-based authentication, which is MD5 in this case. And so here, we're just going to change this. So this is saying for any database, this rule is going to apply. For the user Postgres, we're going to say, instead of peer, we want MD5 like we have here. We'll say MD5. And we're going to change this one to MD5 as well. And then lastly, for these two sections right here, these are going to be for remote connection. So if I want to connect from my Windows machine, this is the rule that's going to apply. So this is saying that for hosts, for any database, any user, right now the only IP addresses that can connect to it are going to be 127.0.0.1, which means localhost. So that's effectively blocking all remote connections. So I'm going to go here and we are going to change this. And I'm going to say 0.0.0/0. So this means any IP address. And then just to keep things nicely formatted, I'm going to move that over there. And then we're going to do the same thing for IPv6, which is what this line is doing. And I'm going to say this. So this is the syntax in IPv6 for saying any IP address. And that should be all of the config changes that we need to make. And so I'm going to exit out of here and make sure to save it. All right. And at this point, you probably think the changes have been made. However, generally, when you change any configuration file, you actually have to restart the application for the changes to take effect. And so to restart an application, you do systemctl restart, and then the name of the application. So this is going to be Postgres QL. All right. And it should be running at this point. So let's try this out now. Right now, we are still logged in as the root user. So remember, before we actually had to change to the Postgres user on our Ubuntu machine before we can log in as the Postgres user. So now instead, I'm going to do psql-u Postgres, and I want to see if I'm able to log in. And so now I actually get a prompt for a password. So it looks like things are working so far. So I'll try my password. And now we are successfully logged in to our Postgres database. That's perfect. Now let's actually try to connect to it using PgAdmin. And so PgAdmin, I've got my local machine, which is right here. If I want to add a new machine, I'm going to right click on servers. We're going to select create server. Give this a name. I'm going to call this FastAPI-prod. Call it whatever you want. Connection details. Here we're going to provide the IP address. So I already forgot what's the IP address of our machine. We logged in 134.122, whatever that is. We're going to provide this. That's the default port. That's the user we're going to connect as. And then if we want to, we can put in a password here as well. All right, and now we are successfully logged in to our production database. If I open this up, take a look at the databases, we just have the one default database that always gets installed. Till now, we've done everything as the root user, and it's generally frowned upon in the Linux world, regardless of what flavor of Linux you're using. It could be Ubuntu, CentOS, Red Hat. You generally don't want to be logged in as the root user because it opens the door for potential security vulnerabilities, and it opens the door for you to potentially break your machine. And so what we're going to do is we're going to create another user. This user is going to have root privilege, so he'll still be able to make any of the changes, but it's better than being logged in as the root user. And more importantly, when we actually install our API, our Python application, we're going to have our non-root user be the one responsible for starting it. We don't want the root user to start the application because then we're giving our application root access to our machine, and that is very risky. So instead, we want a non-root user to start our API. So on Linux, to create a new user, you type in the command usermod. Sorry, not usermod. We do add user and then the name of the user. So pick any name you want. I'm going to do Sanjeev in this case, but you can name it like FastAPI or whatever you want. And then it's going to ask you for a password. So put whatever password you want. And then you can provide your name, but none of that really matters. And just hit Y here. And so we've now created a user. And what we can do is, if you want to, you can do a su dash and then Sanjeev. And then it's going to move you to the Sanjeev user. Or what you can do is you can exit out of this connection and then exit out of here altogether. So now we're back on our local machine. And instead of when you do an SSH root at whatever, you can change this to the new user that you just created. And so that's going to log you in directly as that user. Now, this user by default doesn't have root access. So if I try to do, sudo apt upgrade, right, it's going to ask for sudo password for Sanjeev, and I'll put my password in and take a look at the error that we get. It says Sanjeev is not in the sudoers file. This incident will be reported. So anytime you create a user, you have to give him sudo access or root access so that he can actually perform operations that require root privilege. So we're going to have to exit out of here. Once again, I'm going to log back in as the root user. And to give a user root access, we run the command usermod, and then we pass in the flag -a and then capital G. Make sure it's capital. And we say sudo and then the name of the user. So I created a user named Sanjeev. So I'll just put that in. And so at this point, the user Sanjeev has root access. So let me exit out of here again, and we're going to connect back as the user Sanjeev. And so now I'm going to run sudo apt upgrade. And so if I try that, put my password in, you can see the command run. So we now successfully have root access. If you type in pwd, this is going to tell you the exact directory that you're in. So I'm in a folder called /home/Sanjeev. So whatever your username was created as, right, it's your default home directory is going to be /home and then your username. And so while you're in your home directory, and if you don't know how to get to your home directory, you could just say cd and then tilde. So that's going to take you to your home directory, or you can do cd/home and then your username. That's going to take you here. Whoops. All right, so once you're in your home directory, what we're going to do is we're going to create a folder for our application. Technically, you can put this anywhere on your machine. I'm just going to put it in my home directory. So I'm going to call this this folder app, or we could call it FastAPI. It doesn't really matter. So I'll say mkdir. This is the command to create an app. Create a directory. I'm going to call this app. And then to move into that app, we do cd app. And within this folder, what we're going to do is just like we did on our local machine, we're going to create a virtual environment. So I'm going to say virtual env, and then we'll call our virtual environment venv. All right, and then if I do an ls -la, let's just make sure I created the virtual env folder. Then to activate our virtual environment, we'll type in the command source. Then we go into that folder, the bin folder, and then the activate file. All right, and then we should see this little nugget right here. So this is going to let us know that we are currently in a virtual environment. And if you ever want to get out of the virtual environment, you can just say deactivate. Within our app directory, we're going to create another folder called source. So this is going to contain all of our source code. So we'll cd into the source. And now what we're going to do is we're going to copy all of our code onto this machine. And so how do we do that? Well, since we already have it stored on GitHub, all we have to do is just go to the URL for our repository. So this is my repository that I created. This is the main one called FastAPI-course. This is public, so any of you guys can access this. But you're going to go to your specific repository. And once you get to the repository, this is going to be the URL. Or you could just select code right here, and then this is going to give you a little link to copy. So we could just copy that. And then we can go back here, and we can say git clone, paste that in here. And then before you hit enter, hit space, and then dot. So that's going to install it in this current directory, and it's not going to create another directory that's the name of my repository, which is kind of annoying. I don't actually want a directory called fastapi.course. So we'll hit that. We'll run it. It's going to clone it. And at this point, if I do an ls, we should see all of our specific code. Great. Now, before we do anything else, let's reactivate our virtual environment. So we'll say source venv lib, not lib bin activate. All right, we've got our virtual environment set up again. And we're going to move into our source directory. And if you recall, remember, we don't have any packages installed. So we don't even have FastAPI installed. But we do have our requirements.txt file. So if I just cat that real quick, if you forgot what that was, that's going to tell this machine exactly what version of every single dependency we need to install for our application to work. And so we can just install all of those with one command by doing pip install -r requirements.txt. All right, so I got an error, and this was expected on my end because when I was running through this, I ran into this error. And so if you see this error right here, anytime you see red, it's never good. But what you want to do is you want to go right about here where it says include and then libpq -fe.h. This is implying that we're missing a package that's probably called libpq. If you actually search this error, you're going to get the same result. So if you run into this exact issue or even another issue, just look for the library mentioned right here, where it says that include line, right? And just search for that library and just see how to install it. Okay, so since it said we're missing this library, I'm going to do it's not actually a pip install. We actually have to do an apt install. So we do sudo apt install. And actually, before I even do that, I'm going to deactivate my virtual environment, and we're going to do a sudo apt install libpq-dev. All right, so now that we've got that library, that missing library installed, we're going to then go back into our virtual environment. And we're going to run that same command to install all of our requirements. And I have to move into my source folder. All right, and it looks like we have successfully installed all of our packages. The next thing that I actually want to do is let's go ahead and try to start our application. So we have access to uvcorn, so we can just do uvcorn app.main. So this is the same exact command that we ran on our local machine, and then app. We don't need to pass in the reload flag because this is our production server. So we would never want it to automatically reload on changes because no one should be making changes on our production server. So we'll run this and let's see what happens. Right? And it looks like we get 8 validation errors, which is to be expected because it looks like we are missing all of our environment variables. And that's correct. We never set our environment variables. So in the next section, we're going to take a look at how we can set up our environment variables on our Linux machine. Okay, so let's get started on creating our environment variables. So what we want to do is to create an environment variable on a Linux machine, we say export, and then we give the name of the variable. Here, this is just a demonstration, so I'm going to say my underscore name, and then we set equals, and then whatever value we want to give it. So you can give it anything. I'm just going to say this is Sanjeev. All right, so we'll hit that, we'll run that. And then to actually see if this worked, to see all of your environment variables, we just say print env. And so this is going to spit out a whole bunch of default environment variables. And then to see the one we sent, just kind of look down, look for my name, and we could see that it was successfully set. So at this point, we could just go one by one and manually set all of these. However, that is a very inconvenient process, and I wouldn't expect you guys to do that because we've got 7 or 8, and any other project could have 10, 20, 30. So it's not really realistic to do that, one environment variable at a time. So let me quickly remove this environment variable, which you can do with the unset command. And so I could just say unset my underscore name. And if I do a print env, we should see that it's no longer there. And what we're going to do is I'm going to go back to my home directory because I don't want to mess around in my application directory. I'm going to go to cd and then the tilde. Or you can do /home/ and then whatever your username is. I'm just going to do that. All right, so this is going to take me back to my home directory. And I'm going to create a brand new file. And if you want to create an empty file, you can just say touch. And then I'm going to just call this .env. All right, so we should, if I do an ls-la, we should have the .env file right here. And I'm going to open that up. And here I can provide a list of all of the environment variables. So I can say, and keep in mind, this has to be in the same exact syntax. So we have to say, just like we would put on the CLI, we would say export, then the name of the variable. So I'll say, my name again, which equals Sanjeev. And then let's do my underscore password, which is going to be password 123. So I can save this file and I can say, source.env. So this is going to set all of those environment variables. So if I do a print env now, we do have my name, and somewhere along here, yep, we've got my password. So that's another way of setting things. It's a little bit easier to kind of keep everything in a file. But what I don't like is that I have to put it in this format where I put export and then the environment variable. What would be awesome is if I could just somehow get it so that the environment variable file in my Ubuntu machine matches with the environment variable file on my local machine. I want to just be able to put the key and the value pair like here. And so that way I could just copy this, paste it into my production server, and just change the values there. And so we can actually do that. It just requires a little bit of a modification. So let's go back here. And I'm just going to unset both of these real quick. And we'll just double check it got removed. So they're removed. And we're going to open up the .env file. And I'm going to just delete everything. And what I'm going to do is I'm actually just going to copy this for now and just paste it in there. Let's just see if I can get all of this set from a file, and then we'll change the values later. And so when you have a regular file like the one we have right here, where we don't have the word export in front of it, it does require a little bit more of a complex command, but all you have to do is you run this command. So you do set -o all export, then source, and then you provide the path to the file. So this is going to be in my home directory, so it's /home/Sanjeev. Just make sure you swap it out with your specific username, and then we provide .env. And then we say set +o all export. All right, and so now if I do a print env, we can see I've got my database password, my database username, I've got my database port, hostname, and all of the variables that I set have now been set as environment variables. So that's what we're going to do. However, there's still one minor issue. If I exit out of here, or actually, sorry, not if I exit, if I reboot, and I actually have to do a sudo to actually reboot, but I'm going to reboot, and I'm going to show you guys that when you reload your machine, you lose your environment variables. So we'll give this about a minute or two to kind of boot back up. Although I find Ubuntu machines boot up fairly quickly, so let's just give this a shot, see if we can connect. Nope, not yet. All right, so I've logged back in after it rebooted. If I do a print env, you're going to see that all of the environment variables that I set are all now gone. So how can we get all of these environment variables to persist through a reboot? Because if our machine goes down and comes back up, then we lose those environment variables, then our application's broken. Well, there's a couple of different ways that we can have environment variables persist through a reboot. One of the ways is, let's go to our home directory. I'm going to do an ls-la. And what I'm going to do is we're going to go into this .profile file, and we're going to set that exact command that we had run to set my environment variables. Where is that command? This one right here in that file. So copy this, and then just do a vi.profile, and then go to the bottom of the file, and below the last line, just paste that command in. And then we can just wq. All right, and so this is going to cause, anytime we open up a session or a terminal, even through a reboot, it's going to run that specific command so that those environment variables are all set. Right now, if you do a print env, you will see that it's not set, and that's to be expected because we were already connected to it. But if I exit out of here, reconnect, do a print env, we can now see that our environment variables are set. And then just to prove to you that this actually persists through a reboot, we're going to reboot this machine. All right, so it's rebooted. Let's do a print env, and we can see all of our environment variables are still set. So this is the method that I'm going to go with. Keep in mind, when it comes to environment variables, there are 1,000 different ways to tackle this. And so people like to set their environment variables in different ways. This is just the way that I've done it. This is the simplest way, but there are, a number of different other methods. Some of them will probably be more recommended, better, but I want to keep things as simple as possible. The one thing I do want to kind of highlight is that our environment variable is stored in my home directory. It is not in the app directory where all of my application code is. And that's important to me because I don't want to put it in my application code because I don't want it to accidentally get checked into Git. I don't want anyone to accidentally see my production passwords or anything like that, because then my entire application is compromised. So I like to keep it separate by moving it into a completely separate folder so that there's no chance that it gets mixed up in my application code. All right, so since we can connect to our Postgres database, let's go ahead and actually create the database within this machine. So I'm going to select right-click here, and I'm going to say Create Database. Call your database whatever you want. I'm just going to call it FastAPI to keep things simple. And so now we have our database once we click on it, and so now it's up and running. And so since we have that information and we have the information for connecting to our actual Postgres instance on this machine, let's update these environment variable files so that they are accurate at this point, because I believe they're still pointing to whatever our production was set as. Sorry, our development environment. So here, the host name is still going to be localhost. The port, since I installed Postgres on the default port, we can keep that the same. You want to make sure you update your production password. I chose the same exact password just to keep things simple. The database name, we just created one called FastAPI. Here, this is going to be the database username. If you want to, it is recommended to create another Postgres user. However, I'm just going to keep this as the default Postgres user to keep things as simple. You definitely want to update the secret key. The algorithm, you can leave that as default. And then the access token, I'm going to make this a little bit longer. Let's do 300 minutes. All right, and now let's reactivate our environment. So I'm going to go into apps, and then we'll do source VNV bin activate. So it's going to activate our virtual environment. And right now, you probably notice a little bit of an issue, and that is that we don't have any tables right now. If you go to our schemas, and then we got no tables in here. Oh, sorry, we're in the wrong database. In the FastAPI, we've got no tables. Right, nothing here. And so we have to set up all of our models now. However, since we are in our production environment and since we've set up Alembic, you'll see that this is dead simple. And when it comes to Alembic, it's important that in your production environment, you never create revisions in your production environment. You only create it in your development environment and you check it into Git. And since we checked it into Git, if we go to source and then go into our Alembic file folder and do an ls and then go into versions, we have all of our revision files. And so what we can do is we can just, oh, sorry, I didn't mean to hit exit. Got to log back in now. All right, make sure that virtual environment's enabled every time. I'm going to go into source. And what I'm going to do is I'm going to do Alembic. Upgrade. And then head. So this is going to set up our database, and it's going to upgrade it to the latest revision. All right. And take a look at that. It created all of the individual revisions one at a time. So we can still roll back just the same exact way that we did in development. And with just a click of a button, we've got our entire database schema all set up. And we can just refresh this real quick and then go into our tables. And you can see that we've got our 3 tables plus the Alembic table as well. So now that we have our database all set, I think it's time we try to start our application again. So move into your apps directory. And if you haven't activated your virtual environment, do that again. Move into the source directory. And now we're going to run the same uvcorn command that we ran in our development environment. All right, so it says it's running on the local host IP address of this machine on port 8000, which is the default port. So let's try to connect to it. So what we have to do is grab this, and we're just going to paste the IP address into our browser, and we're going to do :port 8000. And let's see if this works. And it looks like it didn't work. So what happened? Well, the problem here is that we needed to make sure that it can listen on any IP address. So when you just set this to 127.0.0.1, that means only this machine can access it. So I'm going to Control C out of this, so we're going to stop it. And we're going to pass in one more flag. We're going to say --host, and then provide the IP of 0000. So we're going to listen on any IP that this machine is potentially running. And if you wanted to, if I did a --help real quick, we can also specify what port we want to listen on. So if I do --port, I can provide a different port so it doesn't go to the default port 8000, but I'm going to keep it as port 8000. You're going to see that it ultimately doesn't matter when we actually deploy, because we're going to deploy it in a way that it's always going to use either port 80 or port 443, which is the default ports for HTTP and HTTPS. So this is good enough. We're going to start it again. Now you can see it's listening on any IP, and we're going to refresh. And if you guys can't see that because it's tiny, we can see that I got message hello world, which is accessing that root path that we have. So it looks like things are working at this point. However, right now, if this program crashes, or if we reboot our machine, you're going to see that it doesn't actually restart automatically. And so what we're going to do is we're actually going to use a process manager. So we're going to use something called gunicorn. So Control C out of that. Instead of just starting our application with UVcorn, we're going to use gunicorn. And if you haven't already installed it, which you probably haven't, do pip install gunicorn. And make sure you're in the virtual environment. And so gunicorn is going to be responsible for starting our application. Now, I've already got this installed because I added it to my requirements.txt file a little bit earlier. But if you haven't done that, that's fine because I haven't told you guys to do that. So just do a pip install gunicorn. And if you get any errors, most likely you'll need two other packages. You'll need pip, you'll need HTTP tools. And so you could just do a pip install of HTTP tools. And you'll also need one extra library, which is UV tools. So if you hit any other errors moving forward, right, go ahead and install those two libraries, HTTP tools and UV tools, and that should fix any errors that you have. So those were some potential errors that I ran into when I was kind of doing a quick test run. But at this point, we should have access to a gunicorn command. So I can say gunicorn, and let's just do a quick --help just to see what options we have. And here, what's nice is that you can actually set the number of workers. So, if you're on a multi-threaded machine or you have a virtual machine with multiple CPUs, you could set up more than one worker so that they're all listening all at once, and then it's going to get load balanced across all of them. So we're going to set up 4 by default just to show you. You could set up 1. It doesn't really change anything. So the command is going to be gunicorn -w. So this is for the number of workers. We're going to say I want 4 workers. And then we're going to say -k. And we're going to say uvcorn .workers capital uvcorn capital worker. All right. And then now we just specify how to start our application like we normally do. So we go into our app folder, we grab the main file, and then we start app. And then, just like we did with uvcorn a little bit while ago, we had to start it with the --host and then do all zeros. Here with gunicorn, we have to use a --bind, and then we do 0.0.0. And then we specify the port we want to listen on. So let me drag this so it looks a little easier to read. So we do that, and then the port that you want to listen on. Let's start that. And it looks like I got a couple of errors. So let's see what happened. All right. And so if you get this error, UV loop, it means we're missing a library. And so, like I said, if you get any errors, make sure you do the pip install HTTP tools. I should have this one already installed. And then you want to do a pip install UV tools. And I realized I've been making a mistake. It's not called UV tools. It's going to be UV loop. All right, and so now it's successful. So not UV tools, UV loop. I guess I got it mixed up with HTTP tools. And so you can go ahead and if you actually wanted to, if you did a pip freeze, you could go ahead and copy this and make this your new requirements.txt file that you check into Git. This is going to have GUnicorn automatically in there because we already installed it. It's going to have UV loop, and it's going to have what is the last one that we needed, HTTP tools, which is right here. And so you could check this version into Git, and so that way it's all up to date. And so when you deploy to other Ubuntu machines or other computers, it's going to have all of these extra packages so you can deploy right away. All right, and now let's run the same GUnicorn command. And now it looks like it started. It says it's listening on this port. And notice something interesting. Look at this. It actually started up 4 worker nodes, and you can even see the process IDs. So this is probably the parent ID, and then these are the little worker IDs. So if you wanted to, we can open up another connection. And I can do a ps-aef pipe grep. We could probably just grep for GUnicorn. Yep. And so you can see all of the different processes that were started. And so there should be 5 of them. 1, 2, 3, 4, 5. One of them is the parent process, and then the 4 are the other child processes. All right, now that's working. Let's just do a refresh just to make sure we didn't break anything and it's still working. And so if we do a refresh, you can see that we can still access our application. And if I go to /docs, the documentation should still be there. Perfect. So it looks like our app is working. We can test it now by testing the individual endpoints, but we're going to hold off on doing that because we're going to make a few more changes. So the first thing is, right now, this is running on our specific terminal, and so it kind of locks up our terminal. I want this to be running in the background, and more importantly, I want this to automatically start up on boot, because right now if we reboot our box, right, we'd have to manually log into this device and run this same command. So we have to find a way to kind of automate it so that upon reboot, it's going to run the application, and we want it to run in the background so that we don't see any logs by default. And we'll tackle that in the next video. All right, guys, so in this video, we're going to figure out how we can have this command automatically run upon reboot, as well as how can we run this as a background process so that we don't hang our terminal. So what we're going to do is just do a Control-C to stop it for now. And what we're going to do is we're going to create our own service. And if you ever run systemctl and then, either status or start or restart, and then the name of some application that you wanted to run, that is an example of making use of a service. And so what we're going to do is we're going to make our own service, which starts this application here for us. And you'll see that it's actually pretty simple. If we go to /etc/systemd and then system, and I forgot to do a cd to move into that directory. If you do an ls, these are all of the services that have been installed on our machine. And we're just going to create a brand new one. So how do we create that? We have to create a couple of files, and I have actually created them for you guys ahead of time. So if you check my GitHub repo, you will see a file called GUnicorn.service. And there's going to be a couple of things that we have to change. So let me just walk you through what each one of these lines mean. So under unit here, we're just going to give a description of what this is going to do. So this is going to be a GUnicorn instance to server API. You can put whatever description you want. You can say demo, FastAPI application, doesn't really matter. After, now the next line right here where it says after network.target, what this is going to do is this is going to tell systemd or our Ubuntu machine when to actually start this service. And so it's saying that, hey, we need our network service running before we can start our API, because if the network's not up, then nothing else really matters. So we're going to wait for network to come up before we start this service. Then on the service, we're going to figure out, we have to specify what user is going to run this service. So we need this to be associated with the user. I created a user called Sanjeev, so I'm going to update this. And then for group, you want to just put the same exact name as the user. Then we have to specify the working directory. And so this is going to be the directory our service is going to be launched in. So go ahead and update this to point to the directory your app is running in. And if you don't know what that is, remember, just go home, then move into apps. And then you can go into the source folder if you want and just type in pwd. So that's going to get you the exact path that you want. And so I have to update this with my username. And then the environment. So because we want this service to run the gunicorn command, which is right here, we need it to run in a virtual environment. So to actually set the virtual environment through this script, we have to say environment equals, and then we set this path variable. And we just point it to the exact path to our bin folder. So once again, if you don't know how to get there, just go to your app folder, go into your virtual environment, go into your bin folder, and then just type in pwd, and that's going to get you the path. And so I just have to update this with my username, and you'll just do the same thing. You just have to update the username. Then we have to specify the exact command to run. So we have to provide the path to where the gunicorn command resides on. So it actually sits in the bin folder. So if you actually do an ls here, right, you can see the gunicorn command. And so that's going to give it the path to the command. And then after that, well, actually I have to update my username once again. Right, and after that, it's the same exact command that we ran before. So for workers -k, then we have this long command right here. And then we specify how to start our application, which is this command. And then we're going to bind it to 0.0.0. And then you can pick whatever port that you want. And this is just a default config. Don't worry too much about it. You need it, but I don't want to go too far into how Linux works to actually explain this. Just know that this is just a standard procedure for creating a service. So to actually create the service now, what we do is let's go to /etc systemd, then system. And let me deactivate my, we don't need to deactivate, it's fine. We're going to create our service file here. And so I'm going to do a sudo vi, and then the name of the service. So what do you want to call your service? So when you type in system CTL and then start, what's the name of the service you want to type in? You get to specify. I'm going to make it so that it's just called API. Very simple. You can call it FastAPI. You can call it social media app. It doesn't really matter. It's up to you, but I'm going to call it API. And since I want to call it API, I'm going to create a file called API.service. And then what we can do is just take this, copy it, and we will paste it in here. All right, and to test out our service, let's do a systemctl start API. And we're going to have to put in our password. And so this started our API. And if we do a systemctl status API, whoops, there shouldn't be a space, CTL status API, this should just give us the status of our service. We can see that it looks like it failed. That's not good. And it's going to provide us some logs. And if we take a look at the logs, you can see algorithm, field required, access token, expires, field required. So it looks like something is wrong with our environment variables, because we saw the same exact error when we were originally setting this up before we got the environment variable. So for some reason, it's not actually accepting these environment variables. And the reason for this is that the service file, the service that you create, doesn't have access to users' environment variables. And if you actually go back to our home directory, and then we go to ls, ls-la, remember we created this env file, and then we loaded it in the .profile. So the environment variables that get loaded from .profile aren't accessible within a service. And that's just the way services work. So what we have to do is we have to pass in another field in our service config so that it knows to pull the environment variables from that specific file. So what we can do here is in this file, we're going to go and just add another line. It doesn't matter where you add the line, but we want to say environment file. Make sure to capitalize the E and the F equals, and then you provide the path to your specific env file. So mine's going to be home/sanjeev.env. And I'll just copy all of this again. And we'll go back into etc systemd system. And then I'll just do a sudo vi api.service. And we're going to replace this file now. All right, so now we should be able to import all of those environment variables. And there's other ways to do this. You can also set up a config file for your your new service. However, I figured it's just easier because we already have our environment for our .env file, so we can just continue to use that. And now if I do a systemctl restart API, and notice you don't have to type in api.service. It's optional. You can technically do it like this. And it looks like since we actually changed the file, we have to run this command now. All right, and so now let's do a systemctl restart. Sorry, not restart, status API. And looks like we got the same exact error. Let's just do a restart one more time. And we'll do a status. And now it's up and running. Perfect. Look at that. So we've got our 4 workers. These are the process IDs. And let's just double check and make sure that we can access our specific website. So I'm going to just refresh on the /docs. And it looks like it works. Let's go to the root. And let's go to the root URL. So I'll just change this to the root URL and see if we get the API response. Perfect. So it looks like we've got our application up and running. There's just one last thing we need to do. And I wasn't sure if I had already covered this, but there's one last thing I want to do, and that is I want to make sure that our service automatically starts upon a reboot. So that way, you know, in case our machine goes down, whether it's because of a power failure or something like that, or maybe we perform some sort of upgrade, I wanted to automatically start this service so that our application is always up and running. If you do a systemctl status API, you could find out pretty easily whether this service is going to get started upon a reboot. So if you take a look right here under loaded, and then right here is the keyword that you're looking for. If you see disabled right here, that means that it's not going to automatically get started upon a reboot. If you see it's enabled, that means it will automatically get started upon a reboot. So to actually make sure that it actually does get started upon a reboot, just do a sudo systemctl enable and then the name of the service, which is API. And after that, if we do a status again, we should see that it moved to enabled. And so now if we reboot our machine, and you guys can go ahead and test this, you'll see that it automatically starts up the service. Right now, the way that we have our deployment set up is that when we send a request to our server, to the specific IP address of our server and whatever port we decided to configure our app to listen on, we send that request directly to the app or gUnicorn in general. And this is technically perfectly fine. However, you'll see that in more professional type deployments, what we'll have is a intermediary web server. So we'll have a web server running on our Ubuntu machine, and that web server will receive the original request and then act as a proxy and proxy that request to our specific application or gUnicorn in this case. And so one of the common web servers that can be used for that is Nginx. There's a couple others like Traffic and HAProxy. You'll see that Nginx is fairly popular though. And some of the benefits of doing this or in configuring our application ultimately to be deployed like this is that Nginx is optimized for SSL termination. So Nginx is a high performance server and it can perform all of the SSL termination. So when we send an HTTPS request, we can send it to our Nginx server. The Nginx server can process it and then forward it as a plain HTTP packet to our application. Because technically we could configure our application to handle HTTPS, it's not optimized for that, right? Our app is designed to just act as a plain API. When we start adding responsibilities like performing SSL offload, well, then you'll see that we start to see a degradation in performance. And Nginx, like I said, is a high performance web server. It's optimized for this, so it makes sense to kind of handle that responsibility on Nginx instead of our application. So that's what we're going to do. We're going to configure Nginx, and this is going to act as the gateway into our system. So any request we send to our system, whether it's HTTPS or HTTP, doesn't really matter. We're going to send it to Nginx. And if we send it as HTTPS, what Nginx will do is it'll then take it and send it and forward it as an HTTP packet to our application. And so I'm going to walk you through how to set up Nginx. It's not difficult. we do have one config file that we have to add, but outside of that, it's fairly easy to get this up and running. Let's install Nginx now. To install a package, we can do sudo apt install and then Nginx and then -y. So that installed Nginx. If we do a systemctl start Nginx, that's going to start up the Nginx service. And so now if you go to your server IP address, you're going to see that you get this welcome message. So this is just the default page that Nginx loads up for you. And we're going to change this. So in Nginx, what we want to do is we want to go to /etc Nginx sites and then available. It's important that you do available because there's also a sites enabled, which is not what you want. You want available. And there's this default config file, or technically this is a server block. And if we take a look at this, you can see the default configuration in this case. Just to show you what that looks like, you can see that this is handling HTTP traffic. That's why it's port 80. It's going to listen on port 80. And this is going to act as the default server. So all requests that come here are going to land on this server block. And we've got the same thing for IPv6 as well. And then this is the file that you actually see. So when you navigate to this page, it's actually loading up a file that's in /var/www/html. And then the server name. So this is going to be the actual domain name that's going to handle requests for. This is basically saying everything. Everything else, don't worry too much about that. But what we're going to do is we're going to change that file a little bit. And I've provided an example file here. And so this is what the example file looks like. We can leave pretty much everything in place. The only thing I want to change is this location block. And so this is what is going to allow Nginx to act as a proxy, specifically this line. This is the main line. You don't technically need the other ones. Those are more of optimizations. But all this is saying is that any requests that match the root path or beyond, essentially, is going to get proxied to localhost port 8000, which is what gUnicorn is running on. So you just specify the IP address and the port that you want to proxy traffic for. And so since gUnicorn was configured to run on port 8000, we're just going to forward it to gUnicorn in this case. So I want you to just copy these lines here, and we're going to go in, and I'm going to just open up that default file now. And we can delete these 3 lines. I'm just going to paste that in. And at that point, I can save this. And then we want to do a systemctl restart Nginx. So it's restarted. And if I refresh this, right, we can now see our API. And if I go to /docs, it should also work as well. So we got Nginx set up and running. The last thing that we have to do regarding Nginx specifically, well, it's not really Nginx specific, but in general, is that right now, if you take a look at it, you can see our web browser says not secure. And that's because I can actually copy this. If I paste it, right, we're using HTTP and not HTTPS. So we need to set this up for HTTPS. So how do we do that? Well, we're going to tackle that in the next video. But you're going to need a domain name if you want this to work with HTTPS. So I'll show you guys how to kind of grab a cheap domain name. However, if you don't have one, don't worry. You could just leave it as HTTPS for now, or you can create a self-signed certificate, whichever one works for you. For my application, I purchased a domain name called sanjeev.xyz. So if you've ever watched any of my other videos, this is always the default domain name that I use for demonstration purposes. You can see that I actually bought a .xyz because they're the cheapest. So if you just want to play around just for learning purposes, get a .xyz. They're usually like $1 for like an entire year. But if you get a .com, it's going to be a little bit more expensive. However, depending on what your domain name is, it at most is still, well, not at most, but you can still find plenty at $12 per year. So it's not too bad. And I happen to purchase my domain name from Namescheap. So this is my domain registrar. However, there's plenty of other options. If you want to use GoDaddy, if you want to use any of the other websites, you can even use Amazon if you wanted to. Feel free to use whichever one you want. You just need to get a domain name. I'm going to be using this one moving forward. So just keep that in mind. And what we want to do is we want to set up a couple of rules. And we actually have to point our domain name to DigitalOcean. And DigitalOcean has this excellent write-up, how to point your DigitalOcean name servers from common domain registrars. And they actually show you how to do this for a lot of the main domain registrars, and they have names cheap here as well. So if you get one of these, you can just follow along. But you'll see that, any domain provider, you'll be able to kind of relatively click around and just kind of navigate yourself and figure out what's the equivalent. Because for the most part, the UIs are all fairly similar. But if we go down to names cheap, you can see that what we have to do is under the name server section, we have to do custom DNS, and then we point it to the DNS servers of DigitalOcean. So ns1.digitalocean.com, ns2, ns3. So let's do that. And I've actually already set that up for us. So you just go under name servers, select custom DNS, and then you have ns1.digitalocean.com, ns2.digitalocean.com, and ns3.digitalocean.com. And there'll be a little check mark, so just check that there. And at that point, it's going to point everything to our DigitalOcean servers. Then in DigitalOcean, if you just select your name here in your dashboard, what you want to do is you want to go to Manage DNS on DigitalOcean. And then here you want to enter your domain. So this is going to be sanjeev.xyz. We'll add this domain. And the first thing that we have to do is we have to create an A record. So this is the root of your domain. So I'm just going to say @ This is going to create an A record. And we want to select the specific droplet that we created. So this one's Ubuntu FastAPI. You should only have one. But if you have other droplets, make sure you select the right one. And then select Create Record. And at this point, if we do sanjeev.xyz in our web browser, it's going to take us to our DigitalOcean server. However, keep in mind, the changes to DNS usually take a little while to propagate. So you could potentially have to wait up to an hour or 2 hours. Namescheap says it could take up to a day, but it never takes a day. So if you don't see these changes immediately, just give it 10, 15 minutes, and then you'll see that they work. But I'm going to add one more, and that's going to be for my subdomain, because I don't want to just do sanjeev.xyz. I also want to redirect www.sanjeev.xyz to my server. So I can create a CNAME record. And I can say www. And so you can see what this is going to look like. And I'm just going to say @ right here. So that's going to point it to this record essentially. All right. And so what this is saying is that if you send a request to sanjeev.xyz, it's going to send it to the IP address of our server. And then if you send a request to the subdomain of www.sanjeev.xyz, it's going to be an alias for sanjeev.xyz. So it's essentially just going to follow this. All right. And so now if I go to sanjeev.xyz, you can see that we are successfully able to access our API. And if I go to /docs, once again, this should still work as well. And that's pretty big. Let me minimize that. And if I do the same thing for my subdomain of www.sanjeev.xyz, this should also work. All right, so we've got our domain set up. And once we have our domain, we can now finally set up SSL. So we can handle secure HTTPS traffic, because we don't want to send our application traffic over HTTP. And we want that nice little lock symbol, that green lock symbol. So we'll tackle that in the next video. Okay, so it's now time to set up SSL for our application. So I want you to search for certbot. So this is the website for Let's Encrypt, which is a free SSL service. And here they've got excellent documentation. What we want to do is select get certbot instructions, and then we can just specify what software we're running. So this is for Nginx, and the system is going to be Ubuntu 20.0.4. The reason it asks for this information is that it actually will automatically reconfigure Nginx for you to handle HTTPS, because normally when you want to set up HTTPS, you have to change some configs in Nginx, and it gets a little complicated. And so it's saying the first thing that we have to do is we have to install snapd. If you installed Ubuntu from DigitalOcean, snapd should automatically be installed for you. So you can do snapd -- version, I think. Or is it snap -- version? I think it's snap version. Yeah. Okay. So it's snap. Okay. So we've got snap installed. That's perfect. And then what we want to do is we want to install with this command right here. So just copy this. And we're pretty much just going to follow this website, because like I said, the instructions are fantastic. So we'll install certbot. All right, certbot's installed. Then we want to do this command. So you have two options. You can either just generate a certificate, or you can have certbot automatically configure Nginx for you. We're going to have certbot do the work for us. And so we can just paste this in. All right, and then we have to provide an email address. So this is going to be whatever email you want to use. And then we got to agree to the terms of service. You can do no for this one. Right, then we have to specify what domain names we want to generate a certificate for. So we want to generate a certificate for sanjeev.xyz in my case, and then www.sanjeev.xyz. All right, and it looks like it did some magic to our default config file that we were originally changing. So if we actually go to the sites available folder, which we're already at, and just do a cat default, you're going to notice some changes to this file. And that's because certbot actually made a whole bunch of changes. And the main change is, where are these changes? Not here, not here. Here we go. So this server block is for SSL configuration. And so these are the changes they made. So we're going to listen on port 443. So that's the default SSL or HTTPS port. That's good. And I guess that's for IPv6. This is for IPv4. These are going to be the two certificates that were generated. And then there's a few other configs that it added. And we also have this server block right here, which is going to actually redirect HTTP requests to HTTPS. So we can never even use HTTP anymore. It's going to ensure that our clients always use HTTPS and it'll redirect them to HTTPS. And if you can see that right here, if host equals www.sanjeev.xyz, we want to send a 301 redirect to HTTPS and then host request right here. And we're doing the same thing for just the sanjeev.xyz. And so that's all done by certbot. And so now if I go here and I do sanjeev.xyz, take a look at this. We got the little green lock. That means connection secure. That means we're using HTTPS. And you can see the HTTPS here. And if I hard code it to be HTTP, look at that. It still has the lock because it redirected to HTTPS. And let's just make sure that the docs work now. And it looks like the docs still work. So we now have HTTPS set up on our Nginx server. And just like we did with our service, we want to make sure that Nginx has been set up to automatically start upon a reboot. So we could do a systemctl status Nginx. And let's just quickly verify if it has been set up to do so. And I can see that on mine, it's set up to be enabled. So it will automatically start upon reboot, which is what we want. And I think this is the default configuration when you install and set up Nginx. However, if you see disabled here, just go ahead and do a systemctl enable Nginx. And that's going to make sure that it will be moved to an enabled state so it'll get started upon a reboot. The last thing that we need to do to complete our deployment process is set up a firewall on our machine. And the reason we want to set up a firewall is just for basic security purposes. We want to make sure that we only open up ports that we're going to be using. Because right now you can access this box on any port, and we want to make sure that we really harden our system so that only the traffic that should be sent to this box is allowed to this box. We don't want people trying to connect to different services on our machine that they shouldn't be. So we're going to be using the built-in firewall called a UFW. And if we do a sudo UFW status, the UFW is the firewall. And so you can see right now it's inactive, and that's perfect. And what we have to do is we have to set up a whole bunch of rules. And we have to tell the firewall what kind of traffic should we allow to our machine. And we can run sudo UFW allow, and then we can specify what specific port we want to allow traffic on, what specific IP addresses we should be able to talk to. So since this is a public API, we want to make sure that technically anyone can access our server from HTTP and HTTPS. So we're going to do allow HTTP. So this is going to allow HTTP traffic. And you can see it created an IPv4 and an IPv6 rule. We want to allow HTTPS traffic. And keep in mind, we have to SSH to our machine so we can access it. So we have to allow SSH as well. And if you wanted to, you could also allow 5432. So that's going to be to allow Postgres traffic. Now, the way we've set things up, you don't need to actually allow this port. because technically our app, right, our FastAPI is running on the local machine. So it's not going to be hindered by this firewall. So it can access the database because it's running on the local machine. So if you wanted to make it so that no one from the outside world can directly access your database, you would not want to allow this. And that's what a lot of people do, because it can be a little risky opening up your database port, because then people can potentially access your database. So it's up to you. However, if you want to be able to, go to PgAdmin, and if you want to be able to connect to your box remotely, then you're going to have to allow 5432. So it's just up to you. It's your preference. Do whatever you want to do. I'm going to allow this just for demonstration purposes so that I can show you that, hey, when you allow 5432, we can connect remotely. So I'll add that rule. And then finally, we have to start our firewall. So we do sudo ufw enable. And it's just going to tell us that we could potentially lose connection because we're starting up a firewall. That's fine. And we've started up a firewall. So if I do a sudo ufw status, you can see that it's active, and you can see all the rules that it's put in place. So it's saying we allow port 80 traffic from anywhere. We're going to allow that. Port 443, we're going to allow from anywhere. And same thing with SSH and 5432 and all of the IPv6 rules as well. And then everything else is dropped and blocked. And let's just double check that we can access the docs. And it looks like we can. And just to make sure it's not cached or something like that, still works. And now we've got our firewall. And the firewall will start up automatically, so you don't actually have to configure anything else. If you do want to delete a rule, you can do sudo ufw delete allow, and then whatever rule. So you can do HTTP, or you can do 5432, whichever one you want to delete. So now that we have our application deployed, one of the common things that you're going to have to do is make changes to your application and then push out those changes. So I'm going to show you guys how we can do this in a manual process. Ultimately, if you're developing an application, it's best to set up a very efficient CI/CD pipeline, but that's a little outside of the scope of this course. So I'm going to just show you how to do this manually, and you'll see that it only requires a couple of commands. So go ahead and make your changes, whatever code changes. So I'm going to say, hello world, couple of exclamation points. All right, we'll save that. And what we're going to do is we're going to do a git add -- all again. And we're going to do a git commit -m, give it some meaningful message. Changed the world. All right, and then we're going to do a git push. And before we do that, if you type in, just do a git push. Then we provide origin, which is the name of our remote, and then the branch that we're on. So we can say main. And that's going to push it up to our GitHub repository. And at that point, once it's there, you can just quickly verify if you want, but I'm going to assume that it's there. And then what we're going to do is we're going to go into our application folder, which is in our home directory. Then we go into apps and then source. And then here, we're just going to do a git pull. So it's going to pull all the changes that were made. So it's going to grab the latest changes, and all right. So we've pulled all of our code now. And keep in mind, if you had changed the requirements.txt file, then you definitely want to do a pip install, pip install -r requirements.txt if you did, but we didn't change any of that, so we don't need to do that. And what we can do now is we have to restart our application, because if I just refresh this, you can see nothing's changed. There's no exclamation points. So we'll do a sudo systemctl restart API. And let's try this out now. And we've got all of the exclamation points now. So that's how you push out changes through a manual process. But like I said, it's best to set up a CI/CD pipeline. In this section, we're going to focus on Dockerizing our application. I originally wasn't going to do anything on Docker, but I figured I would just make a quick video just to show you guys how we can quickly set up our FastAPI environment within a Docker-based environment. And I'll also show you guys how to set up a Postgres database within Docker. This is going to be a fairly quick run through of Docker. I'm going to assume that you guys have a basic understanding of Docker. And I'm going to assume that you already have Docker installed on your machine. So we're going to get right to it and get started on setting up our FastAPI within Docker. So I have Docker Hub open, which is just, a public repository of different images that we have access to. You can create an account if you want to. You don't have to create one at this stage. The only time we'll need to create an account for this course is if you want to push an image up to a repository hosted on Docker Hub. If you don't want to do that, then you don't need to go ahead and create an account. But what we want to do is we want to figure out an image that we're going to use for our FastAPI Docker container. And so just go ahead and search for Python. And what we're going to do is we're going to use the official Python image. So select the official Python image, and you'll see that there's a couple of different options. So you can scroll down, you can see the different versions of Python. And we're actually going to use version 3.9.7 in this case. But you can see that with the default Python image, we have all of the different versions that we could pretty much ever want. And then they got slim images, they got the Alpine images as well. But we're going to use just the standard image. Now, if we use this specific image, the problem with this is that this is just a basic image with Python. There's nothing else on it. At that point, if we just have a basic Python container, then we have to do all of the work of copying our source code onto the Docker container, and then we have to install all of our dependencies and set up our application. And that kind of defeats the purpose of Docker, because the main idea behind Docker is that we actually create an image that has everything that we need to run our application. So we just start up the image, or I guess we technically start up the container, which is made from the image, and that should just have everything it needs, and it should just start working right away. So that's exactly what I want to do. And to actually get that to accomplished, we're going to have to create our own custom image. And all custom images need to start off with the base image. So we're going to start off with this base Python image, and we're going to customize it by doing a few things, including copying our source code into it and installing all the dependencies and setting up a few other details. So to actually create a custom Docker image, we're going to go to our project directory, and we're going to create a file that's referred to as a Docker file. Now, this Docker file is going to have all of the steps necessary to create our own custom image. And the first thing that we have to do is we have to set up or specify our base image. So we're going to use this Python 3.9.7 image as the base image. So what we do is we say from, and then the name of the image. So this is the Python image. And then if we want to, we can also do a version. So I'm going to do 3.9.7. And if you're wondering where I'm getting this from, this is all from the documentation. You just say from, the name of the image, which in this case is Python, and then you could see the different tags. So if you want 3.9.7, slim bullseye, that you got that. And if you want to see them going over that in an example, we're kind of basically just following this essentially. The next step is going to be an optional step, but I always like to do this. We're going to use the worker flag, and this is going to set the working directory. So I'm going to say this is going to be user source /app. Now, how do I know that there's a folder called user/source? I've actually run the Python image myself, and I checked to see where I could actually set up my application. So I found that there is a path here, and then I want to create a folder called app, and this is where I'm going to store all of my application code. And once again, you can take a look at the documentation, and it does the same thing. So if you're ever lost, just take a look at the doc, and it's going to help explain things. But like I said, this is the optional command in this case, because what it really does is it's going to tell Docker, this is where all of the commands are going to essentially run from. So it's like doing a CD into /user/source/app. And then anytime we give it any instructions, it's always going to do everything in that directory. So it's just going to help simplify some of the later steps, but it is technically optional. The next thing that I want to do is I want to copy our requirements.txt file from our local machine onto our Docker container. So we use the copy command. And we say we want to copy requirements.txt. And then we have to specify the directory within our container or image that we want to copy it to. So I'm going to say /. So where does this exactly point to? Well, remember, we set our working directory. So everything is going to be with regards to that directory. So when I say the current directory, that means this directory. Now, if we didn't have this line right here, then we would have to specify the full path to that directory. So you can see that it's kind of simplifying things for us, because then we can just kind of say, hey, I want to use the current directory because that's what the working directory is. And the next thing that I want to do is run a command, which is going to be responsible for installing all of our dependencies, because we have our requirements.txt file copied into our Docker container. So we're going to do pip install -r and then requirements.txt. And if you want to, we could also specify the --no -cache -dir if you wanted to as well. And so that's going to install all of our dependencies. Then the next thing that I'm going to do is I'm going to do copy --. So what does this mean? This is going to copy everything in our current directory, so all of our source code, and then it's going to copy it into the current directory in our container. So what is the current directory? Well, that's the one that's set by workdir. And once again, if we don't have this defined, then we would have to specify the full path of /user/source/app. Now, one thing that you might notice that's a little unusual is the fact that we copy all of our source code at the end right here, which is going to include everything in our directory, including the requirements.txt file. So you might be wondering, well, why exactly do we copy just the requirements.txt file up here? Well, this is a little bit of an optimization that Docker provides us. So when Docker runs, when we build images from a Docker file, it actually treats each one of these lines or steps as a layer of the image. So kind of builds an image by running the first layer, then creating the second layer, the third, fourth, and fifth layer. And it actually caches the result of each step. So this is important because when you cache the result, if nothing changes, then we can just use the cache result. So let's say I, run this image, or I create an image from this file. It's going to take a certain amount of time because it has to do a pip install requirements.txt where it's installing all of the dependencies, which does take a decent amount of time. But if I run this again, right, and nothing changes, well, then it can just use the cache result because it knows nothing's changed. And this is important because when I change my source code here, maybe like my database.py file, it's going to see what steps changed, right? And so if I change my source code, does that change the base image? No, we're still using the same base image. Does it change the working directory that we used? Nope, still the same. Did it change the requirements.txt file? Nope, still the same. Did it change any of the dependencies that we installed? Absolutely not. It only changed the final step. So this causes Docker to be able to use the cached result of step 1, 2, 3, 4 of step 4, and it only has to rerun step 5. But if we change requirements.txt, this file right here, then it knows that this step changed here. So it's going to have to rerun this step, then this step, then this step. Right? And so this gives us an advantage because anytime we change our source code, we only have to run this last step. And if we change our requirements.txt, then we have to run all of these steps. And keep in mind that this step is the longest step. And so if I had actually, if I can comment this out. So if I didn't have this line and instead I copied all of my source code right here, what would happen is every time I changed any code in any of my files, I would have to rerun a pip install every single time. And that would cause us to have to rerun the longest step in our build process. And so that's why we have this optimization. That's why we copy the requirements.txt file so that we can cache that result. And so anytime we make any changes to that file, anytime we make any changes to our source code that's not in that file, we don't have to rerun a pip install. All right, and then finally, we have to give it the command that we want to run when we start the container. So we'll say cmd brackets. And so the command that we want to run is uvcorn app.main app. And so the way we actually specify the command is we break out each word of the command. So here we do uvcorn, and then we say app.main app. And then here we're going to pass in the host flag and the port flag like we did on our Ubuntu machine. So we do --host 000, and then we do --port. And that's going to be 8,000. Okay, so it's basically anytime you have a space between the commands, you just split it up into a different string within this list. That's just kind of the syntax that you have to use with these Docker files. But it's the same thing as running uvcorn app.main app and then --host --port 8,000. Oops, 8,000. So it's just going to essentially run this in our container. We just have to provide it in this format. All right, and so now our Docker file is complete and we can actually build our image. So what we're going to do is I'm going to do a Docker, and then the command to build our image is build, and then we'll do a -- help so we can see all of the different flags. And most of these don't really matter. The only one I really care about is a tag. So I want to give this a name. So I'm going to say Docker build -t. I'm going to give this image a name that I think is reasonable. I'm just going to call this FastAPI. And we have to pass in one last argument, which I forgot, which is going to be the context. You could think of the context as just kind of the directory where the Docker file is. So it's going to be in the current directory because we can see the Docker file is in the root of our folder structure. So I could just say dot. And so now it's actually going to build our image. And if I do a Docker image ls, we can see all of our Docker images, and you'll see that I've got a whole bunch, but we've got my FastAPI right up here. And so now we can go ahead and use this image for actually building out a container. And we can run a whole bunch of Docker commands like docker run, and then specify the image that you want to use, and then pass in all the flags. But I don't like doing that. I don't like working with docker run. Instead, I want to use docker compose. And if you have never worked with Docker Compose, it does the same thing as running Docker commands on the CLI. We just provide all the instructions on a file so that we don't have to remember all of these long commands with all of these extra flags. We literally write out the flags in a file, and then we can just say Docker Compose up, and it's going to bring up all of our containers. So we're going to take a look at Docker Compose in the next video and see how we can get that set up. All right, so we're going to learn about how we can use Docker Compose to automatically spin up our containers with the desired configuration. And you're going to see that it's so much easier to use Docker Compose than just running docker run whenever you need to, because we can spin up multiple containers all with one command, and we can also tear them down all with one command. And to use Docker Compose, we have to provide the set of instructions using a file called docker-compose.yml. And so this is a YAML file, and if you don't know too much about YAML, it's just I guess it's technically like a markup language, I guess. But the most important thing to understand is that spacing matters. So this is kind of like Python, where you need to make sure that the tabs and the spaces are just right and everything lines up, or then it's going to start to throw errors. And the first thing that we need to do is specify what version of Docker Compose we want to use. So we say version, and I'm going to say just version 3. It's not the latest, it's just kind of the most common one. If you actually go to the Docker documentation for Compose file, you'll see the different versions that you can specify, and you can actually take a look at the documentation and see what feature was introduced in what version, so you can figure out what version you need to perform all of your operations. We're not doing anything special, so version 3 is just fine for us. Then within Docker Compose, we have a concept of services. And so a service, really, at the heart of it, is nothing more than just a container. So if you want Docker Compose to spin you up a container, you have to define a service. If you want Docker Compose to spin up 4 containers, we're going to have 4 different services. Pretty simple. So we have to give each service or each container a name. So we're going to have one container for our FastAPI, and I'm just going to call this container API, or this service API. And the first thing that we need to do is we have to specify either the image that we use. So I could technically say like image, and then we can point to like the Python image, or I can specify build, where we can essentially do the same thing that we did before in the previous video, where we ran docker build and then provided the location of the Docker file, but we could just specify that here within Docker Compose, so that Docker Compose will automatically build the image for us if it doesn't exist. So we'll say docker build, and then we specify the context or the path to the Docker file, which is the current directory, based off of where the Docker Compose is, so they're in the same directory, so I just say current directory. And then we have to specify a port that we want to open up, because this is an API, so the outside world needs to be able to reach our container, but by default, all containers can't talk to by default, the outside world can't actually talk to your container. So we have to open up or poke holes on our local machine to open up some ports. So we say ports, and this expects an array of ports. And so there's 2 different ways to do an array. With YAML or with a Docker Compose file, we can do, just an array like this, where we just provide a list of things. Or we can also do it like this, where we do a dash and then provide, something, and then a dash for the next entry in the list. So I'm going to use this syntax because I kind of like it better. But to open a port, there's a specific format that we're going to use. So what we say is there's going to be two numbers. There's going to be the port on local host, and then we do that, and then we do the port on container. All right, so what's essentially happening is we're telling Docker, if we receive traffic on our local host on this port specified here, we're going to forward it to this specific port on the container. So the second number is a little bit easier to set up because it's going to be whatever port our application's running on. So if we take a look at our Docker file, we can see that our container is going to be listening on port 8000. So we want to set this second number to be port 8000. And keep in mind, you could choose to use any other value. So if you decided to use port 80 here, then you would just change it to port 80 here. But I'm going to leave it as 8000 just for simplicity's sake. Then the second number that we're going to use is going to be the port on the local machine or on the local host, which in this case is my Windows machine. But if it's on like a production server, it's going to be whatever machine or IP of that specific server is. And so here we could specify any port. So if you can literally pick any port that's open. So if I said port 4000, what that means is that, if I go to my my Postman, this would be the equivalent of doing localhost colon 4000, right? Which is that first number. And so anytime we send traffic to that specific port on a local machine, it's going to route it to port 8000 in our container, which is what port our application's listening on. But if I change this to port 8000 as well, then our request would be localhost port 8000. So I always like to have the two numbers match up because it's just simpler, but sometimes that's not an option. So just pick a open port on your localhost machine. It doesn't really matter what it is. Just make sure that you remember what it is. And I'm going to leave it like that, and I'll delete this line right here. And for now, I think this is good enough. And what we're going to do is we're going to try to run this and see what happens. So I'll say docker-compose up. And then if I do a -- help, we can see some other flags that we may need. And the only flag that I really need right now is the -d. So this is going to run the containers in the background so that we're not automatically connected to it. So I'll do just -d. Right. And so you'll see if you take a look, what's happening is we're rebuilding our image. So because we specified the build right here, it's going to build our image. And then it's going to start our containers. So you can see that it's creating FastAPI _API_1. And so the naming syntax comes from the project directory. So it's called FastAPI, right? So that's why the first word. Then we do underscore. Then the name of the service. So I called this service API. So then it's API. And then it has the number 1 because there's one instance. But if I told it to spin up 4, then I'd have 1, 2, 3, and 4. So we've got our container. If I do a docker ps, we should be able to see. Nope. Oh, we can see it's down, and that's because if I do a docker ps-a, and we can see that this one right here looks like it stopped 43 seconds ago. And so it crashed for whatever reason, and that's okay. What we can do is, I think we can actually see the logs after it goes down. So if I do docker logs FastAPI 1, we can actually take a look at the logs at what caused it to go down. And we can see a couple things, but we can see that we get the Pydantic error for our settings object, which is all of our environment variables. So obviously a container is like its own separate machine. So it needs all of the environment variables passed to it, or then our application is going to crash. So how do we pass an environment variable in Docker? Pretty simple. We just pass a environment field. And then here it's going to provide, you need to provide an array of environment variables. So I do dash. And then here we just specify our environment variable. So I'm actually going to copy and paste this section right here. And so these are all of our environment variables. Keep in mind, if you don't want to actually write out all of your environment variables, we can actually use Docker to point to a .env file or a environment file on your local machine. And if you want to do that, it's pretty simple. Here we would just specify the env_file. And then you can actually provide multiple files, but in this case, you just provide the path to the file. So it's going to be in the current directory, and it's going to be .env. So you can do either one or a combination of both. I'm just going to use this format so that we can see all of the environment variables, and I'm going to just comment this out for now, just for documentation purposes. And now what we're going to do is we're going to do a Docker compose down just to tear everything down. And I'm going to bring it back up in detached. And notice this time it didn't build the image. So why exactly didn't it build the image? Well, Docker Compose is very simple. All it does is it goes to Docker image, basically just runs a Docker image ls, and it looks for the image that it would have created. And there's a very specific format that it uses, which is going to be the name of the folder or the directory, and then underscore, and then the service. So since the image was already created previously, it doesn't recreate it. However, if you obviously make changes to your Docker file and you want to make changes, then you would have to do Docker up. And then if you look for the flags, there should be a let's see, build. This is going to force it to build a new image. So keep in mind, anytime the image has to change, and but the image already exists, then you have to pass in that flag to force Docker Compose to let it know that, hey, I made some changes. I need you to rebuild it for me, because Docker Compose can't detect that. All right, so now if we do a Docker PS, we can see that it's running now and it didn't crash. And we should be able to access it on port 8000. So if I actually go here and just do localhost 8000 with the GET request, looks like it's working. Okay, so now that we can actually access our API, which is running in a container, the next thing that I want to do is I want to set up our Postgres database. And you might be thinking, well, we already have one installed on our local machine. Why are we setting up another one? Well, a couple things. First of all, if we're already Dockerizing our environment, it makes sense to set up our Postgres database, especially from a development perspective within a Docker container, because it's so much easier to set up a database in a container than it is to install it on our local machine, because we just spin up a pre-built image and that's it. So even if you don't actually want to Dockerize your application, from a development perspective, I strongly recommend you make use of Docker containers so that you can spin up a quick database just for testing purposes. But since we already have a Docker-based application now, we're going to just use a Postgres database that's running in a Docker container instead of on our local machine. Because if we take a look at the environment variables that we pass to our container, we provide a value of localhost. And so localhost means that the container is going to, or the API running in the container is going to try to access a database running locally on that container, which it's not. So let's create a brand new service, which once again is nothing more than another container for running our Postgres database. And so I'm going to go down here and we're going to create another service called Postgres. And here we're going to provide a image flag, right? Because here we did build because we're building our custom image. Here we're going to use the pre-built default Postgres image. So if we go back to Docker Hub and search for Postgres, you'll see this is the official Postgres image. And this is going to contain all of the documentation for setting up Postgres. But the main thing is there's a couple of environment variables that we have to pass. So first of all, the password that's going to be used for our database. We can give an optional Postgres user, but it's going to default to Postgres if we don't provide it. And then we also want to give it a Postgres database name. So we'll call it FastAPI like we've been using in our development environment. And that should be all that we have to do for the most part. So here I'll say environment. And we'll do Postgres underscore password equals, and then we can give this anything we want. So password 123. And then we want Postgres underscore DB. So this is going to be FastAPI. All right, the next thing that we want to do is when it comes to data within a container, that data doesn't persist as soon as the container goes down. All right, so when you delete the container, you lose all of your data. All right, and so from a database perspective, we don't actually want to lose our data. We want that to persist even if we kill off the container. So how do we actually save that data? We have to create something that's called a volume. And that's what allows us to save data from a container onto our local machine so that if we kill the container, we can always spin up a new container and just point it to those files. And there's a couple of different volumes that we can use, or types of volumes in Docker. There's anonymous volumes, named volumes, and I think bind mounts is the other one. We're going to make use of named volumes. And so to create a named volume, here under the Postgres database section or service, We're going to say volumes. And then we say dash, and then provide a name for the volume. So you call it whatever you want. I'm going to call this Postgres-DB. Right? And then we have to specify the path in the container that we want to actually save. So what directory do we want to persist on our local machine? And the path that the Postgres container or image actually stores all of its data, we can actually take a look at the documentation to figure this out. So if you search for volume, and so right here, this gives us an example, and this is going to tell us what we need to know. So we want to save /var/lib PostgreSQL/data. So that's where it's going to save all that data. So we'll copy that. And once again, this is the path in the container that Postgres is going to write to. So that's where all of our tables, all of the entries are going to get stored. So we want to copy that essentially and save it on our local machine. And the last thing that we want to do is anytime you use named volumes, we have to create another volume section globally and then just pass the name that we created. So whatever is here, you just put it down here. And the reason we have to do this is because named volumes are designed so that technically multiple containers can access them. So you define it down here first technically, and then multiple containers can reference them by just calling that. All right, so we've got this set up, and actually I realized I left my containers running. So what I'm going to do is I'm going to comment this out for a second, save this, and I'm going to do a docker compose down. So it's going to delete everything. Then we'll uncomment our Postgres service. Then the next thing that we want to do is we have to figure out, what is the host name or what's the IP address of our Postgres database. And, there's a couple of different ways to do that. But what's awesome about Docker is when you use Docker Compose, it creates a custom network. And a Docker network uses DNS. So we can actually say to reach the Postgres database, instead of looking for the IP address of that container, we can use DNS. And I can just say, if I try to reach the name Postgres, right, it's automatically going to resolve to our Postgres service. So whatever our service is called, we can just reference that. And this is going to allow this container to know that when you want to talk to the Postgres database, this name here is going to resolve to the IP address of this container. And so networking with Docker within Docker is so simple because that's all we have to do. And then the rest of the things, the default port, the password, the database name, the database username, those should all be okay. And we can just leave as default. And now I can then start this up. And it looks like image, something's wrong with the image. I forgot to give the image. So what's the image name? It's just Postgres. So that's just whatever this name is. That's all you need. All right. And so now we can see that it started up both. Let's just quickly test our API so we didn't break anything. So that works. And then let's go to create user, make sure it's point to port 8000 in this case. And if we create user, right, you can see that we have successfully created the user. So it looks like we can now access the database from our FastAPI container. Now, what I'm going to do now is delete everything again. So Docker Compose down deletes everything. And you can see I'm essentially able to destroy both of my containers with a single command. And that's kind of the power behind Docker Compose. And ideally, we want our Postgres container to start up first because our API is dependent on the container. So for our API, we can pass in another option. And I can say depends on. And here we can specify a list of services, in this case, just Postgres. And so this is going to tell Docker, I want you to start the Postgres container before the API container starts. Now, technically, it's not going to wait for Postgres to actually fully initialize. It'll just start the container. So you still want to put in checks in your code to make sure that, if you can't access the database because it's not initialized, you want to keep retrying. And so once again, we can bring this back up with a single command. And if you take a look at the order, you can see that we started up the database first. So now you'll always start up your database first and then start up FastAPI. And then you'll stop FastAPI first before stopping the database, because we set up the depends on. When it comes to working with Docker containers, we do experience a few extra challenges, especially from a development perspective. And I'm going to show you how those challenges actually work, or what those challenges actually are. And if I actually go back to my test request, wherever that is, where I'm just going to reach the default URL. So if I hit send, you can see it says hello world pushing out to Ubuntu, right? And that's because in my main.py file, it just says hello world pushing out to Ubuntu. Now, if I save this or change this and then save this, and then I send a request, right? We still get the same response. I don't get the new text that I added. So why is that? Well, there's a couple things that are happening, but the easiest way to figure this out is to actually poke around in your container and figure out what's happening. So I'm going to do Docker PS, and I want to see what the file system of FastAPI container actually looks like. So to do that, we do Docker exec-it. So that's going to enter into interactive mode. We specify the container name, and then we type in the word bash. So what we're doing is we're entering interactive mode, and we're going to override the default command of the container. So the default command is specified right here from the Docker file. So we don't want to run that. We just want to run bash, which is going to allow us to access the file system. That's the image name. So the name of the container is FastAPI_1. So let me add the 1. So now you can see that we get a Linux prompt. So we're in the Linux file system. And if I go into app and then go into, if I do cat, which is going to print out the contents of a file, we'll take a look at the main.py file. And you can see that it just says hello world pushing out to Ubuntu. So when I made these changes and added these extra characters, it didn't get pushed out to our container. And if you're trying to figure out why that is, it's pretty obvious, right? Because what we did was we created an image which copied all of our code here at that point in time. And then when we did a Docker compose up, it created the image, and then that was it, right? Nothing else changes, right? Afterwards, we went in and changed the code, but the image was already created. So whatever's in the image, nothing changes after that point. So any changes we make will not get copied over to our container. So what do we do in this case? How do we get around this limitation? Well, what we can do is we can make use of a special volume called bind mount. And a bind mount is a special volume because it allows us to sync a folder on our local machine with a folder in our container. So this app folder, which has all of our application code, what we want to do is we want to sync this folder in our container with this folder here so that if any changes get made here, it's going to get copied over to our container. And so under volumes in our API, we're going to define a volume here. And I'll say volumes, right? Just like we did with Postgres, very similar, except we're going to use a different syntax because this is a bind mount. So a bind mount, we have to first provide the path of the folder that we want to sync on our local machine. So this is our current directory. So we can just do / for current directory. But if you wanted to sync just one individual folder, maybe like the app folder, then you can do / app. Up to you, but I'm going to sync everything. And then we have to specify the path in our Docker container, which is going to be this folder right here. And that's going to automatically sync the two folders. And if you wanted to add some extra security, you can do RO. This means read only. So what this does is this makes it so your container can't change any of these files because only we should be changing the files, not the container itself. So this just adds a little bit of extra security if you wanted to, but it's still technically optional. And let me exit out of here. And now we'll do a docker-compose down. And we'll do a Docker compose up again. And now let's just change this all together. So bind mount works. So if we see that, that means everything's working. So let's save it. And if I send, we can see that I get the old one now, right? So whatever I changed here doesn't get copied over. So it looks like we didn't fix the issue. So let's actually take a look and see what's happening. And so how do we do that? We'll do the docker exec command again to go into the file system. Let's go into the app folder and let's cat that main.py file. And this is interesting because it looks like the bind mount did work because we can see that the code got updated. And if I make another change again, this time let's just add sort of. And if I cat this again, we can see that it's in there. So the bind mount is working and it's syncing the code with our local directory and our container. But there's one issue. And if I go back to my Docker file, you can see that I have my command right here, but this doesn't have the -- reload flag, which is what we need to restart the application. So anytime we make changes to our code, we need it to automatically reload when it detects any changes so that we can actually see the new application. And we didn't provide that in the Docker file, and so that's why it's not working. So this is actually a pretty simple fix. We just add the -- reload flag. So let's tear everything down. And we have a couple of options. So I can go here and say -- reload, and that would work just fine. But instead of doing that, what I would rather do is, I like this default one because this is the one you would technically use in production, because you don't want -- reload in production. But in our Docker compose file, we can actually overwrite it. So we can provide another flag called command. And here we can provide a command to overwrite that from the Docker file. So I'll say uvcorn app.main app -- host 000 -- port 8000 -- reload. All right, and let's bring this back up. Let's just see what it is currently right now. So we got whatever it is now, and let's make a quick change. And I'll just delete all of this and change this back to hello world. And let's test this out. And we can see that it does successfully update. And so now our bind mount works and we automatically restart our code. So our development environment more closely matches up with what we had before we moved to Docker. Okay, so if you haven't already done so, go ahead and create an account on Docker Hub. It's a free account, but I want to show you guys how we can set up a repository on Docker Hub so that we can actually store our images here. And so Docker Hub is kind of like the Docker equivalent of GitHub, where it's kind of acting as a repository, but instead of a repository for our code, it's a repository for our images. So we can upload our images. Anytime we make a new image, we can actually upload it so that we can track changes to our images over time. So make an account, and then we want to go into repositories, and we want to select create repository, and then give this a name. It doesn't really matter what you want to call it. I'm just going to call it FastAPI. And then we're going to do public because you only get one private repository. And so now we have a private it's the public repository. And so this is the URL to the repository, which is going to be your username. This is my username. And then this is the name that I gave it, so FastAPI. And so now what I want to do is I have an image, right? If I do docker image ls, we could see that I have my FastAPI_API. This is going to be the image that I want. And so how do I actually upload this image to Docker Hub? Well, there's a command called docker push. All right, so if I do a docker push -- help, you just pass in docker push and then the name of the image. So let's try doing that. We'll do docker push and then the name of the image, which remember, yours is going to be a little bit different because it's going to be based off of your folder. Let's try this. And it says requested access to resource is denied. So the first thing that we have to do is we actually have to do a Docker login. So we have to log into our account. So you do Docker login here. It's going to ask for your credentials. So we'll do sloppy networks in this case for me, and then it's going to be whatever it is for you guys. And then now let's try to push it again. And once again, we get a access to resource is denied. So what exactly is happening here? Well, when we want to push up a image, right, there's a very specific naming convention that we have to use, right? We have to name it exactly like this, sloppy networks /FastAPI. And we even see an example right here. So you do docker push, the name of your email or your account name, then the name of the specific repository, and then you can give it an optional tag name. So what we got to do is we got to rename our image. So how do we do that? I think it's docker image. I think, well, let's do -- help just to see if we can figure it out. We want tag. So this essentially copies an image and renames it for you. So let's do docker image tag -- help. And here we just provide the source image and then the target image. So what is my image called again? It's going to be this one right here. And we just do docker image tag, then the image that we want to rename. And then we give it the new name, which has to be your account / then the repository. And then you have an optional, tag. The default is just going to be latest. So I'm just going to leave it without a tag. So I do that. And if I do a docker image ls, we should see the new one right here. And so now I can do a docker push. It looks like I didn't copy that. So let's try this one more time. And now it looks like it's pushing something. So let's give this a minute or two. And then once it's done, let's take a look to see if we have successfully pushed it to our repository. All right, so it looks like it's successfully pushed. So now if I go back to my Docker Hub page and do a refresh, we can see that last pushed was a few seconds ago. So now we've successfully pushed it to our Docker Hub. And so, if we set up an actual production Docker environment, we could just pull the image from this specific URL or this specific repository. Now, before we wrap up the Docker section of this course, there's one last thing that I want to show you guys. And that is that if you take a look at what we have right now, we have an identical clone of our previous development environment, but we're now developing within a Docker container. So our Docker container environment is an exact clone of our previous development environment. The issue is that, when we move to production, assuming that you're using Docker in production, which is kind of the main idea behind Docker, is that your development environment and your production environment are almost exactly the same because you're using the same exact Docker images and containers. But if we try to use this Docker compose file in production, there's going to be a whole bunch of issues. First of all, obviously these environment variables would need to change and we can't hard code them. We wouldn't want the -- reload flag. And you certainly don't want a bind mount because the code shouldn't be changing. And then the ports that we use could also potentially be different. So even though the Docker environments from our production and development environments should be roughly similar, there are going to be some differences. And so we need to account for that. And so what I like to do is I actually like to create two different Docker compose files, one for development and one for production. So that's what we're going to do. But first of all, let's do a Docker compose -down. That we can just tear everything down for a second. And once that's down, I'm going to copy this. And paste it. And we're going to rename these files. So this one is going to be called Docker compose -dev. So this is going to represent our development environment. And this one is going to represent our prod environment. All right, so we've got our dev and our prod environment. The dev doesn't need to change because we had already set that up for a development environment. The production one is going to change a little bit. So first of all, the command, right? We don't want the -- reload. So we could specify the exact command we want, which is the one without the -- reload. And that should be all that we need. However, keep in mind, this is the default command from the Docker file, right? So we could technically just remove this or just comment it out. And so I'm just going to comment it out in this case. But if you wanted a specific custom command for production, you can just provide that here. The whole idea is that this file is going to represent all the changes for our production environment. Then maybe we want, instead of listening on port 8000, we want port 80 so that we can use our web browser. Most of the things can stay the same. The environment variables definitely need to change. And so with a production environment, first of all, we're not going to hard code the values. We usually want to grab these values from the environment variable set on the host machine. So instead of actually hard coding these in, instead we can reference environment variables. So to reference an environment variable, what we do is we do $, curly braces, and then the name of the environment variable. So it's going to look on the Linux machine that it's running on for an environment variable called database hostname. So I figured we would just have them match just to show you what that would look like. And then we're going to do the same for all of these. And I'm just going to copy and paste this once again. So it's going to look like this. So it's just grabbing the data, the environment variable from the local machine. Keep in mind, they don't technically need to match, but it just makes it easier for troubleshooting purposes. And then for the Postgres database, right, we want the password to be the same environment variable. And then we would want the database name so that we're not hard coding that one as well. And we don't want the bind mount, so we will remove that. And that's about it. So that's all you have to do. So this just gives us both a development environment and a production environment. We'll save all of that. Now, starting up Docker Compose is going to be a little bit different now because we don't use the default docker-compose.yaml file name. So if I do a docker compose, if I can find the up, docker-compose up, right, you're going to see that it throws an error, right? Because it says it can't find a docker compose.yaml or .yaml with an A, or compose.yaml or compose.yaml with an A. So it looks for only these file names. So when we have a custom file name, we have to do docker-compose, and then we pass in the -f flag for the file name. And so we provide the path to the file. So it's just in the current directory. So I could just do docker-compose-dev.yaml, and then we just do an up and then -d. And then we can start it back up. And if you want to bring up a production environment, then you would do --prod. That's the only difference. So you don't really have to do anything else other than running the different specific Docker Compose file. And the last thing that I want to change is actually in your production environment, you don't actually ever want to build the image in a production environment. Instead, what's recommended is that when you're done developing, you push the brand new image to Docker Hub, right? And then in the production environment, we just pull this image from Docker Hub. So how do we pull this image from Docker Hub? Easy. We remove this build option. Remember, this is going to be in the prod file. And we set this to be a image. And here we just set this to the name of the repository. So we just do, your username /FastAPI -app, just FastAPI. So whatever is essentially right here. And then if you want a specific image with a specific tag, then you would add the tag as well. And so that's all we have to do. Feel free to stop your containers now if you want. And even when you do a down, you want to make sure you do a -f. So it knows which file to actually look for. And I misspelled that. And that's going to conclude the Docker section of this course. And so I think this is going to give you a solid foundation on how to Dockerize your FastAPI. Now, currently, whenever we make changes to our code, whether it's implementing a new feature or modifying the behavior of a previous feature or even fixing some bugs that we happen to catch, right, we have no idea if the changes we make break other functionality in our code. And so normally, anytime we make any changes, we then have to go into Postman and essentially manually test out every single scenario to ensure that things are working. And this isn't a very scalable solution. It's going to result in a lot of wasted hours. For every single time you make any changes to your code, you're going to have to test everything because you don't know what code you've broken by making those changes. And so this is where an automated testing library comes into play, where we can define a whole bunch of tests to test a majority of the functionality of our code. And so that way, anytime we make changes to our code, we can run our tests to see if we've broken anything. And keep in mind, obviously we can't test for everything, but we can at least test for enough things that we can catch some of the more obvious bugs. And so this section of the course is going to be dedicated to getting started with testing and really understanding the concepts of testing and seeing how we can get started with a library like Pytest. But I do want to provide one little disclaimer before moving forward. I wasn't originally going to post a section on testing for this course. And the reason for that is that I don't have much experience with testing. It's not something I do a lot of or at all, really. And so I want to make sure that you guys understand where I'm coming from when it comes to testing. And that is that, since I am not super proficient at testing, I don't really feel too qualified to actually teach it. And so what I want you guys to do take out of this section of the course is just how to get started with testing. How do you set things up? And what's the main ideas behind a test? I may not necessarily be teaching the best, most efficient way to test. I may not be using the most efficient way of testing. And there may be scenarios where I may not even be following best practices, but I want to show you guys how we can at least get some integration tests set up. And then at that point, what you guys can do is you can just forget everything else that I've taught you when it comes to testing. Once you at least have the groundwork, then you guys can, do your own research, figure out how you ultimately want to implement testing with any of your projects, and then go ahead and just run with that. So with that in mind, in the next video, we'll get started with getting Pytest installed and writing our first test. For testing, the library that we're going to be using is Pytest. So if you do a quick Google search, you can just search for Pytest, and the first result is going to take you to the documentation page for the Pytest library. And so I recommend you guys take a quick look at this just to see how it gets set up. And if you go on and do a little bit of reading before we actually get started writing our first test, definitely go ahead and do that. But once we've got that opened up, what we can do is we can install Pytest. So we can just do pip install Pytest just like we would with any other package. Then once that's done, we have access to the Pytest command. So just go ahead and run Pytest and see what happens. So it prints out a few things. You notice that we can see that the test session starts. So this is when we start testing. It prints out some information about the platform that we're running on, and that's okay. We can ignore all of that. And you'll notice that it says collected 0 items. We'll talk about this in a bit, but the more important thing to look at is it says no test ran in 0.04 seconds. And this is expected. We haven't created any tests, so obviously it's not going to be able to run any tests. But to run our testing, all we have to do is just run this command, and then you'll see that Pytest will go through all of your tests, run it to verify, that they all pass. And if there's any errors or anything like that, it's going to report that. So it really is as simple as that. But let's go ahead and create our test. And I want to store all of our tests inside a directory called tests. So inside the root directory of your project, just create a new folder. We'll call it tests. And technically, you can put this folder anywhere. If you wanted to put this test directory within your app directory, you absolutely could. It's a matter of personal preference. I'm just going to keep it outside of the app directory for now. And within here, I'm going to actually create a file. And this is going to store our first test. I'm just going to call this mytest.py for now. All right. And we obviously need to test a part of our code, whether that's a route or a path operation or a function or a class. We need to test something. And right now our code is a little advanced. And when I say advanced, I don't mean advanced because anything we've done is super advanced so far. It's advanced from the perspective of testing, where we're coming in from a background of no knowledge of testing. So we want to start out with testing the simplest functions. So I'm going to actually create a brand new module and essentially create the simplest module or function that I can possibly think of. So I'm going to create a new file, call it whatever you want. I'm going to call this calculations because it's essentially going to be a bunch of functions that we use to perform certain calculations. And I'm going to define the world's simplest function, which is called add. And I think you can guess what this function is going to do. It's going to take two numbers, which is going to be type int, and it's just going to return the sum of them. So we just say return num1 plus num2. Right? And the reason, once again, is because this is going to be very simple when it comes to testing, so you guys can at least have an understanding of how to actually perform these tests. So we've got this module defined inside our app directory. And then in our tests folder, we've got our mytest.py. And we're going to define our first test. So what is a test? Well, it's really just a function. It's either a function or a method within a class. We're going to start off with just doing functions because it's just a lot easier. And we're going to call this function test_add. Why did I give it that name? Well, it's testing the add function, so I think that makes sense. And technically the naming does matter, but we'll come back to that in a bit. Now, how does this function actually work from a testing perspective? Well, it's very simple. Pytest will run through all of our tests. And when it runs through this specific test, what it's going to do is if it runs through it and there's no errors get thrown, that means the test has passed. It's succeeded. That means our code is good. If our function throws an error of any kind, it's going to consider our function or our test as failing. Then the test has failed. So how exactly does that work? It's simple. We use something called assert. And if you aren't familiar with what the assert command does in Python, anytime you assert a true value, nothing's going to happen. The code just runs. However, if you assert a false value, that means it's going to throw an error. So it's no different than raising an error or throwing an error. In Python, it's just a simple way of doing that for testing purposes. If we return something that's true, then the assert won't do anything. If we return something that's false, then it will raise a Python error. And I'm going to show you exactly how that works. So if I just say assert true, and before this, I'm just going to do a print testing add function. And then down here, I'm going to just call the test_add function right here. And I'm going to just run this as a normal Python module. So we're not going to even treat it as an actual test or anything like that. We're not even going to use Pytest. So I'm just going to call Python. And keep in mind, the command is Python on Mac, but it's Py-3 on Windows. And then we're going to go into the test directory. And we're going to call my test.py, and I'm going to show you what happens. All right, we can see it says testing add function, which is from this print statement. And then you can see the assert did nothing. So it just ran and everything's fine. And that's expected because, like I said, assert only does something when we return a false value. So if I say false now, and I run this code, take a look at what happens. Hey, look, Python throws an error. So assert is simple as that. True means nothing's going to happen. False means it's going to throw an error. And we don't have to just say true or false. We can actually pass in a condition. So if I say 1 = 1, that's going to return true, right? So technically, an assert of true won't do anything. However, if I say 1 = 2, that's going to be a false statement. And if I run that, we can see that it asserts and it throws an error. So that's how we make use of assert within our testing functions. So I'm going to remove this. And we're actually going to test out our code now. So to test out our add function, the first thing that we have to do is we actually have to import it into this file. So we're going to import it. So we'll say from, and we have to go into the app directory and the calculations module. So we'll say app.calculations, import add. And now what we're going to do is we're just going to call the add function like we normally do. And we need to give it some test data. So I want you to think of two numbers that you want to use for testing, add them up, and what is the result should it be? So I'm going to say, I'm going to do 5 and 3. And I know that this function, if it works properly, should return a value of 8 because 5 + 3 = 8. And so I can just take the sum, store that in a variable called sum. And what we can do is, since I know sum should ultimately be equal to 8, I can assert that. And there should be no e there. So I can say sum equals 8. So that means if our code runs fine, sum should ultimately equal 8. And if we assert 8 = 8, that means it's going to return true and nothing should happen. Or Pytest should consider it as passing. However, if I mess up my code and for some reason the add function returns a value of 20, then when we do assert 20 = 8, well, that's going to be false. And it's going to throw an error, and it's going to consider that as a failing test because an error means a failed test. So that is the main idea behind a simple automated test within Pytest, right? You run the code with some test data, and you know what the result should be because you created this test data, and you just make sure that the result of the code matches with your expected result. So let's actually run our test now. So I'm going to do Pytest, and let's see what happens. And you see the same exact thing we saw before. Once again, it says it collected 0 items, no tests ran. And so why exactly is this happening? Well, if we go to our documentation and you scroll down to this feature section, you go to the auto discovery section. And so this auto discovery section is going to explain how Pytest finds all of the tests in your code. Because it does have a auto discovery functionality where it can actually go through all of your code, all of the directories and packages, and recursively look through them and find the tests. But it looks for specific keywords. And you can see in these directories, it looks for any files that start with test. So you have to do test _ and then some name, or some name _ test.py. And if we go to our code, right, we name this my test. This does not match what it's going to look for. And that's why it doesn't actually find any tests from that. So let's change this. I'm going to call this, let me rename this, and I'm going to call this, how about test _ calculations. All right, and so now if I run this, you can see that it throws an error, but I realized that, within my tests package, I do need to have the usual underscore init underscore .py to actually make it a package. So I'm going to do the same thing. I'll do underscore init underscore .py. Because of that, it wasn't able to actually import the file properly. So let's save that and let's try this again. So now if I run this, you could see that, hey, look, we collected one item. So I think it's safe to say that this collected one item probably means we have one test. So the number of tests equals items. And then we can see that inside the tests package, we have a module called test underscore calculations.py. And then there's a little dot. So the dot represents one individual test. And a green dot means good. A red dot means it failed, right? Green is pass, red is fail. And so if you have two tests, then you would see two dots. And then if the second test passed, it would be green. If it failed, it would be red. Simple as that. And so now we have successfully ran our first test. And just to make our code a little bit simpler, right, I could just, instead of having the sum variable, I can just cut this out, just paste it into here just to make it a little bit cleaner, and then we can remove all of this. And just to make sure I didn't break anything, let's run our test again. And we can see that once again, it worked just fine. Now, when it comes to the auto discovery of files, a few things to note. You don't necessarily have to follow this convention of test underscore calculations. If I actually rename this, and I call this, my underscore test, what did I call this? My test.py. Right, now if I obviously run this, it's not going to find any tests, but I can pass in the specific path or the specific module that I want to test. So if I do my test.py, then it is able to find the test. But I like to have Pytest be able to automatically find all my tests so that I don't have to specify this. So we'll rename this and go back to test underscore calculations, because it ultimately is a module that's going to be testing my calculations module. And another thing to note, the name of the test within the module also matters. If I call this, maybe something like testing underscore add, take a look at what happens. Whoops. I wanted to auto find it now, and I forgot to save it. Now, if I run this, it looks like it still works, but let me change this to just something random. Right? And so now we can see that no tests ran. So the naming of the function absolutely matters when it comes to auto discovering tests. And you want to stick to the standard of test underscore something. And I think somewhere in this documentation, it's going to go over, here we go, test from those files, collect test items. So a test prefixed test function or method outside of a class, or a test prefixed test function or method inside a test prefixed test clause. So it's got to start with test, essentially. It doesn't necessarily have to be test underscore. That's why testing underscore add worked just fine. It does have to start with the word test. That's why if I said add underscore test, I don't think this will work actually. Shouldn't based off of their description, and it doesn't. So keep in mind that the naming does matter. And I recommend you stick to the convention of naming all of your testing modules test underscore, then the name of the module that you want to test, and then your functions test underscore, and then the name of the function that you want to test or the functionality that you want to test. Now, a couple of things to note. I'm going to run this test again, and you'll see that it doesn't really give us much detail as to what's happening, but we can pass in other flags to get a little bit more detail or to change the functionality. So if I do pytest --help, you'll see that there's a lot of options, but I think something that would probably be helpful is like a -v for verbose, and I think we should have that in here. So let's see if I can find that. Here we go. -v is increased verbosity. So we'll just do pytest -v, and let's see what happens. And so now, instead of just having a dot, it's actually going to list out the specific test that's running. So I think that's a little bit more helpful. And I usually like to run these tests with a little bit of extra verbosity, just so that I know what's happening. However, maybe in an automated environment, you don't really care about that. And the other thing to note is that we have this print statement here, but nowhere in the output do we actually see anything get printed out. I don't see testing add function anywhere in here. And the reason for that is that by default, Pytest will not actually print out any of your print statements. We have to pass in an extra flag to do that. So to see the print statements, you have to pass in -s. So now if I run this, we can see that we ran this specific test and it ran testing add function. And so keep in mind, anytime you want to print something, you got to pass in the -s flag. Okay, guys, so testing really is as simple as that. But before we go on to more complicated tests, I want to just make sure that we fully understand how this works. So we're going to create a few more dummy functions that we can use for testings. And if I go back to my calculations.py, I've already written this out, so I'm just going to paste it in here not to waste your time. But you'll see that they all essentially do the same exact thing. They just perform some sort of mathematical operation. So I've got the subtract function, which just subtracts two numbers. I've got the multiply, which adds two numbers. And I've got the divide, which just divides two numbers. So let's test this out now. The first thing that we got to do is, well, let's import all of those. So there's subtract, multiply, and divide. And let's define our function for subtracting. All right. And so just like before, I'm going to do a one-liner. So I'm just going to say assert, and we'll say subtract two numbers. What numbers do I want to subtract? How about 9 and 4? Whoops, 9 comma 4. And we know that 9 minus 4 should equal 5. So I can do assert equals 5. All right. And if I run this again, all right, we can see that both tests pass. And just to make sure that, our testing actually works, let's actually go into our code and let's essentially create a bug. So if I want to add two numbers, right, we know that it's going to be num1 plus num2, but let's say, one of our moron colleagues went in and added 1, which is ultimately going to cause our function to break. And so ideally, if everything works fine in our testing, it should be able to catch this. Because if we add 5 plus 3, it's going to do 5 plus 3, and then it's going to add that extra 1. It's going to return 9. 9 equals 8 is going to assert to a false, which is going to throw an error. So if we try this out now, right, we can see that it did in fact fail. And because we set this to be verbose, we can see exactly what happened. So we ran the test add, and what happened was it asserted add 5 comma 3 equals 8. So it's asserting 9 equals 8, and that's going to throw an error. And so that way we see 1 failed, 1 passed, so the subtract function still passed because we didn't touch the code for that. So I'm going to go back and fix our bug in this case. And we're going to just set up a couple more test functions for multiply and divide. And I can just really just copy these actually. And I'll just change this to multiply, divide, and we'll just select a couple of numbers. So let's say, and I realized, looks like that's a typo. This should be multiply with an L. All right, and we'll say 4 and 3. So when we multiply 4 times 3, that should equal 12. And for divide, we'll change the function that we're calling to be divide, and we'll do 25. So 20 divided by 5 should equal 4. And so now if I save everything, we should ideally see all 4 of our tests pass. So let's try this out again. And you don't have to use the -v or the -s flag. If you're not printing anything or you don't want to see it, you don't need the -s. And maybe you don't want the verbosity, so you could technically remove those as well. And we can see that we get 4 dots, which means all 4 of our test functions have succeeded. If you're like me, the first thing that you may have noticed is that, testing with one set of numbers doesn't seem ultra reliable, right? That doesn't necessarily assure us that the function that we wrote actually does what it's supposed to do. I would ideally like to test with a couple of different sets of numbers. And the way to do that is, well, I'm sure if you just took a guess, right, you're probably thinking, well, maybe we just copy this function, paste it. Well, that should be back here. And then maybe just call this test add 2. Maybe we don't need this print statement anymore. And then you provide the other sets of numbers. So maybe like 4 and 2 should equal 6. And then you try this out and you run this. And we can see that that worked. And technically you can do that, but Pytest provides us a simpler way of doing this. So I'm going to delete this because we don't need that. I'm going to show you how we can do this using something called parameterize. So I'm going to import Pytest. So I'll say from, actually, I'll just say import Pytest. And we're going to add a special decorator from the Pytest library. So we say at pytest.mark dot parameterize. And so here we can essentially provide a list of numbers that we want to use for testing and then provide what is the expected result. And so, our function takes two inputs, 5 and 3, and we also need to provide what is the result. So these are all the values that we're providing. We have 3 values for this specific function. So we're going to tell this specific decorator what are the 3 things that we want to provide for each test case. So in quotations, we'll do num1, num2, and then the expected value. Now, what you call these doesn't matter. It's up to you, right? But these are going to be treated like variables, essentially. So you can call them whatever you want. You can call this X. You can call this Y. You could call this result. It doesn't really matter. But I'm going to stick with num1, num2, and expected. And more importantly, take a look at how this is set up, right? Your instinct is probably to do the end quote here, and then quote here, and then quote here like that. That's not what we want. That is not how it actually works, which I don't know why they decided to do it like this, but that's just what they've chosen. So instead, you remove these, and everything should just be one big string. So that's the first argument into this decorator. The second thing is going to be a list. And it's going to be a list of tuples, and each tuple should represent one specific test case. So the first tuple, we're going to provide our test case values. So we want, what is the value of num1? So in the first test, let's say we want 3 for num1. What's the second one? That's going to be num2. So it's going to line up with what we've put here. So we'll say 3, 2. And then what is going to be the expected value? Well, 3 plus 2 should equal 5. So we just say 5. And so that's our first test. If we want to add a second test, just do comma, add another tuple. And let's just add another set of numbers. So let's say num1 is 7, num2 is 1. We know that should equal 8. And just one more test. And here I'll say 12 and 4 should give us 16. All right. And so now what we can do is we can pass these variable names into our test_add function. So I'll say num1, num2, and expected. All right, so you want to make sure these match up with what you've placed here, because if this was called X, then you want to make sure that this is called X. But we'll change that back. And now in our code, we want to replace all of our test values with these variables. So this is going to be num1, this is going to be num2, and this is going to be expected. And so now if I run this, and we'll just do a -v just to see more in detail what's happening. Take a look at what's happening now. We can see that test add ran, and it ran with 325, which is the first test case. It passed. Then it ran the same exact test with these values, 718. That passed. And then it ran with these values, and that ran, and it passed just fine. And then finally, all of the other functions also passed as well. So this is one way of running the same test over with multiple values without having to just define 3, 4, 5 functions and just copying and pasting. It's a little bit cleaner doing it like this. So till now, we've just tested some simple functions, and you'll see that when it comes to testing, anytime you want to test a function, it's actually pretty easy. However, when you're working with classes, it gets a little bit trickier, and it usually involves having to write a little bit more code. So I've created a simple dummy class in this case called bank account, and this represents a person's bank account. And I've already written this out because I didn't want to waste your time writing this out. So if you want to pause this video and just copy down the code so you can follow along, go ahead and do that. But let me just quickly walk you through what this specific class is doing. But like I said, this represents a bank account. So first of all, we've got the constructor. So when we create a bank account, we can create a bank account with a specific amount of money, which is going to be referenced by the starting balance value. And then it's just going to set the balance property of the bank account class to be whatever you provide. If you don't provide a starting value, it's going to default to a value of 0. Then we've got 3 different methods. We've got deposit, which means we're going to deposit money into our bank account. So all we're doing is we're going to pass in a value, and then we're just going to add it to our total balance. Withdraw is the opposite. We're going to subtract a certain amount from our balance. And then collect interest is simple. We're just collecting interest. So here we just take our balance and then multiply it by 1.1, which I guess would represent a 1% interest rate. And so those are the 3 or 4 functions, methods, if you want to count the constructor method as well, that our bank account class has. So I want to go ahead and test this out now. So we'll go to our test calculations. And first of all, we want to import our bank account class. So let's create a test for our bank account. And the first thing I want to test is, let's create a brand new bank account where we set the default value, to, the initial amount to be 50. So here I'll say test, and I'm just going to call this maybe test bank set initial amount. I want this to be as descriptive as possible. And so here, what we're going to do is, first of all, we're going to create a brand new bank account instance. And since this test is going to test to ensure that we have actually created a brand new bank account with a certain amount of money, I'm going to provide a value. Doesn't matter what value you decide to use, but I'm going to use 50. And we'll just store this in a variable called bank account. All right. And so to test if our function actually worked, or the functionality of our constructor method actually worked, what we're going to do is we just say assert, and we want to check the bank account dot balance property equals 50, because we set the default value to be 50. And if we just quickly go back to our code, you can see that we set the starting balance, or we set our balance property to be whatever the starting balance is. It just happens to be a default of 0 if we don't provide one, but we are providing one, and that's what we're testing. So we can test this. Let's run our code now, and let's see if this worked. We can see that it did in fact work. All right, and just to introduce a bug, maybe we set starting balance to be, -1, right? So we've broken our code. Now if we run this one more time, all right, you can see it failed because we subtracted 1, so we're asserting 49 equals 50, which throws an error, which means we ultimately failed the test. So let me remove that bug. All right, the next thing that we want to do is let's test to make sure that the default starting balance works as well. So I'm going to create another function, and I'll call this about test bank underscore default amount. So in this case, we're just going to create a brand new bank account, and we're not going to pass in a value, so it should default to 0 if our code works. And then we'll store this in a variable just like we did before, and then we'll assert. I can copy this, but now it should equal 0. Okay, and let's test this out now. All right, and it looks like it worked, so great. And let's just quickly go ahead and test our last 2 functions out. Sorry, we got 3 more actually. So let's test the withdrawing functionality. So I'll do test underscore withdraw. And here we're going to initialize another bank account instance because we have to do that every time we want to test it. I'm going to give it a default value of 50. It doesn't have to be 50. Once again, you can choose whatever number you want. And we'll store that in a variable called bank account. And we'll call the bank account withdraw method. And we're going to withdraw, let's say $20. So we start out with 50, we withdraw 20. We know that the result should be 30. So if I just copy this assert statement once again, I can just change this to 30, and it should be no problem. Run this. Once again, all of our tests have passed. Let's try the deposit functionality now. So I'll create a test to test that. And I'm actually just going to copy all of this code because it's pretty much identical. You'll see that testing can become a little repetitive. We'll start out with an initial value of 50. It doesn't really matter. We'll change the method to be deposit. Maybe we want to deposit $30. So 50 plus 30 should equal 80. We test this out. Looks like everything's working. And the last thing that we want to test is the collect interest method. So let's create a function for that. We'll do test underscore collect underscore interest. And once again, I'm going to copy this code. And we'll just use it here. We're just going to change the method to interest or collect interest. Okay, so we start out with the value of 50. And so what should the interest be? Well, if I take a look at what my method actually does, it just takes the number, multiplies by 1.1. So that should give us 55, right? 1.1 times 50 should be 55. So I will say this should be 55. And let's see what happens. So if I run this, we can see that we did have one test failed, and I'm assuming it's going to be the last test, the one we just created. And we can see the test collect underscore interest failed. And the reason for that is that it looks like bank account dot balance returns a value of 55.00000001, which in Python is not the same thing as 55. So this isn't necessarily an issue with our code. It's just the way that we're comparing numbers in our test. So this is an issue with our test in this case because it's not accounting for some of the different rounding and the way that calculations occur within Python. So what we're going to do is we can just call the round method right here, and we can round it to 5 or 6 decimal places, depending on how accurate you want it to be. So it should now round it to this value, however many decimals is 5 or 6, and then convert it to an integer. So then we can compare these two because this is an integer, this is technically a float. So they're not going to be equal in that case. So now if I run this, we can see that it did successfully pass. So that's just something to keep in mind. That's why I added that little extra test case, just to make sure that, especially when it comes to those calculations, you got to make sure that you're comparing the right two numbers. If you look through all of the test cases for the bank account, you'll notice that there's some repetitive code. Right? For every single test case that we have for testing our bank account, you'll notice that we always have to initialize a bank account instance. Right? And you can see that right now, look at that. We are repeating our code across all of our tests. And when you get to more complex classes, more complex test case scenarios, right, you might have 50 tests for a single class. And we're, in this case, just repeating the same exact code for each one of them. And so when it comes to writing these tests, Pytest does provide us with some tools that we can use to minimize the amount of repetitive code. And one of those is called fixtures. And a fixture is a very simple concept. It's nothing more than a function that gets run before each one of your tests, or at least the specific test that you want. So we can create a function which does nothing more than initialize a bank account and then return it to our function that's about to run. So I'll show you how we can do that. Right, the first thing we have to do is let's create our fixture, and we can put it anywhere. I'm just going to put it here for now. But generally, you want to put it at the top of the file. Actually, I'll stick to the best practice. I'll say at pytest.fixture. And then here we create a name for our fixture. So I'll say this is going to give us or initialize us a bank account with a 0 initial value. So I'll call this 0 underscore bank account. Right, and so all we're going to do is we're just going to return an instance of bank account with an initial default value of 0. And then we'll create one more fixture. And this one is going to return a regular bank account with an initial value. And what value we want to give it, we get to decide. So I'll just say return bank account, and in this case, 50. All right. And so now what we can do is, for all of these tests, I don't need to initialize them here because I can have these guys reference the fixture. So to assign a fixture or have a fixture get called for a function, we just pass it in as an argument. So for test bank account set initial amount, we're going to reference the 0 underscore bank account fixture. So what exactly happens is when Pytest goes to run this test case, because it sees this as an argument into the function, it's going to, oops, that should be a 0. Okay. But what it's going to do is it's going to call this function before it actually runs the test case. So it calls this function, and then whatever we return here, which is the bank account, gets passed into a variable called 0 bank account. And so now, instead of creating a bank account instance, I can remove this and I can reference this variable, which is 0 underscore bank account. So let's test this out. Let's see if that broke anything. if we run this, oh, sorry guys. Let me undo this. I didn't mean to use this function. This is going to be for the test bank account default amount. So we want to remove this one. My apologies. And we don't need that in this one. And then this will be 0_bank account. So now all tests should pass. All right, so everything passes. But if you're still a little confused as to what exactly is happening behind the scenes or what is the order of operations, I'm going to add a few print statements. So I'm going to say testing my bank account. And then I'm going to put in a print statement inside my fixture as well, which is, say, creating empty bank account. And so now if we run this, I want you to take a look at the code. And I realize I have to pass in the -s flag to see the print statements. All right, so here we go. We're going to test bank set initial amount. Sorry, no, test bank default amount. And so you'll see that when we start this test, first things first is we create an empty bank account. That's that print statement for the fixture. So before the test even runs, we call the fixture because we've defined that here by saying, where is it? That it's going to be an argument into the default amount test case. Then after the fixtures run, which is just a function, we then run our actual test case, and then we get the print testing my bank account right after that. So once again, just to really drive home this point, a fixture is just a function that runs before a specific test case. That's all. But the great part is we can use this same fixture for all of our other tests. So let's go to the next test, which is setting an initial amount. And in this case, we have this fixture right here, which is the bank account one. And so I'm going to say this is going to go to bank account. So this will call the bank account fixture, and then we can remove this line. And we can just keep this here because it's referencing this variable now. And this should work now. So if we run this, once again, all tests pass. And I can just do this for all of them. So I can just call the bank account fixture. And I can just remove that line. Everything else can stay the same. And the same thing here as well. And finally, for the last one, we can do that. And so now you can see that we have saved ourselves a couple of lines of code for each function. And if I run this, you can see that all the tests pass. So at this point, you're probably thinking, this doesn't really look like it saved us a lot of code or a lot of, coding out. However, there's going to be certain things that you want to do that you want to initialize before every single test of your entire application. So maybe something like setting up a test database, right? You'd want that to be set up for each single test. Having to manually do that for each test case would become very cumbersome. And then the lines of codes that you're repeating start to become a serious problem. And that's really one of the best use cases for using fixtures is something like setting up a database or setting up, some sort of email service or something that you're going to use across a lot of your tests, and then having to initialize that manually for each test is going to require a lot of work. And so that's where fixtures really help save us some time. Okay, what I want to do is I want to create one more test. And this test is going to be a little bit different. I'm going to call this test about bank transaction, maybe. And so this is going to test us both depositing money and withdrawing money in one test case so that we can have a couple of different actions on a bank account. And so just like we've done before, when it comes to setting up a fixture so that we can retrieve an instance of our bank account class, I'm going to do the same thing, but we're going to use the 0 bank account. So it starts out with no money. And then what we're going to do here is we're going to reference the 0 when we're going to start off by depositing money. And let's say I'll deposit $200. And then we can also then withdraw a certain amount of money. So now we're testing both in one specific test case, and I'll say I'll withdraw 100. And we know that we should ultimately be left with $100. So we'll do assert 0 bank account dot balance equals 100. So let's test this out. And let's see how this works. And that works as well. But what I wanted to do is, for this specific test case, I wanted to show you that we can use fixtures and parameterize so we can test multiple values like we did for this specific test case. So what I'm going to do is I'm going to copy this so that we don't have to type this all from scratch. And we're going to create a couple of different test scenarios for this specific function. And in this case, we're going to have a deposited, we're going to have a withdrew, and we can have the expected amount. And keep in mind, you're not limited to having 3 variables. You can put as many as you want. It just happens to work out that I only need 3 in this case. And then we can provide some test data. So how about the same one we have right now? We're going to deposit 200, withdraw 100, and we expect 100 in the end. We can do the same thing. How about deposit 50, withdraw 10, and we should end up with 40. And then we've got our high roller, which is sitting there with a whopping $1,200. And he withdrew, how about 200? And he's going to end up with $1,000 at the end. And so now we can pass deposited, withdrew, and expected. And now we can use deposited here, withdrew here, and then we know what the expected is going to be. So let's try this out. All right, and we can see all 3 test cases run, and in this case, all 3 test cases passed. So I just wanted to show you guys that you can use this with our fixture. So it's okay if you're using a fixture, you can still use the parameterize decorator in this case to test multiple scenarios. If we go back to our bank account class and you take a look at the withdraw method, you'll notice that right now we're not performing any check to make sure that the user has enough money. And that's not really how a bank account works, because if you have $100 and you withdraw 500, the bank's going to be like, we can't do that. So it just makes sense in our code to actually perform some sort of check. And so usually, something simple is we'll say, hey, if amount that you're trying to withdraw is greater than your balance, well, what are we going to do? Well, we're probably going to raise an exception. So I'll say raise, and we're just going to raise a standard Python exception, and we'll just say something, hey, insufficient funds in account. Right? However, if we do have enough money, then we will actually perform that operation. So this is all good. If we go to our test calculations, and we just add one more scenario in this case, but this time we deposit, let's say, only $10, and we try to withdraw, 50. Well, what is the expected scenario, the expected value? And it doesn't really matter what we put in, because this is ultimately going to break our code, because we're raising an exception. So if I try to run this, right, it's going to fail because we're raising an exception. And remember, anytime you throw an error, that's going to automatically make the test fail. So what do we do? Well, first of all, let's remove this test case, because for scenarios like this where you expect to receive an error, we need to create a different test case. So I'll call this, how about test insufficient funds? And let's say we start out with, instead of using the 0 bank account, whereas the, instead of using this bank account, we're going to use the 0 bank account, and then we'll just try to withdraw money. So that's an easy way of testing it. So we'll say 0 _ bank account. So we'll have no money in our account. And we're going to withdraw some money. So we would do, actually, I'll just do a regular bank account. I don't know why I want 0. So we'll start out with $50, and we'll try to do a bank account withdraw, and we'll try to withdraw $200. So that should raise the exception. But how exactly in our test do we tell Python it's expected to receive an exception? Because right now, if we run this, once again, we're going to get the same exact error. Right? Failed. So what do? This is how you tell Python that you expect an exception. You do with, and then you call Pytest. Remember, we imported Pytest all the way at the top right here. So we'll do Pytest dot raises, and then you provide the exception that you expect. So in this case, this is just a regular Python exception. So you can just say that, and then you provide the command that you're going to run. Okay, and so that way, if this command throws an error or raises an exception, Pytest will be told to expect this. So then it would consider the test as passing. So now if I run this, we can see that the insufficient funds test passed. And if we go back to our code and actually remove this exception, we'll comment out that entire statement. What do you think is going to happen here? Right now it's failed because it did not raise an exception. Pytest is expecting an exception and we didn't raise one. So then it considers that an error in our code, because when we expect an exception, we should expect an exception. So I'll uncomment this. And now, in real code, right, you wouldn't just throw just a generic Python exception. You're going to usually create your own exception classes. So let's say we define our own exception, and I'll call this insufficient funds, and this is going to extend the exception class. And we'll just say there's no property, so I'll just say pass. And in this case, I'll say we'll raise an insufficient fund, insufficient funds. All right, so if I make this change, what do you think is going to happen? Do you think it's going to break our code? Well, let's run this. We can see that it passed. And the reason why it passed is because insufficient funds is a child class to the exception class. So when we say we expect an exception, technically we are getting the exception. It's just we haven't specified we specifically want a insufficient funds exception. And because this is inheriting from this class, Python says, hey, look, everything looks good. But if you did want to be as specific as possible, which is generally recommended, what we can do is I can import that exception. So we'll say from app.calculations, we can import insufficient funds. And now here we can say we expect a insufficient funds. And so now if I run this, we can see that it passes. And the benefit of this is that if for some reason our code raised another type of exception, it would consider this test as failing. So if I go back to my code and let's say that, for some reason something broke in our code and all of a sudden, instead of raising an insufficient funds error, we get some other kind of exception. And I can just simulate this by doing raise zero division error. So if you ever try to divide a number by zero, this is the exception that's expected. And so now if I run this, right, we can see that the test failed because we expected a insufficient funds exception, but we got a zero division error. And so that considers the test as failing because we've told it we've expected something, but we got something else. So it's generally best to explicitly define the exact exception that you expect so that you can make sure that, that nothing else is broken, because technically any part of your code can break and throw an error. And if it throws an error and we just try to, if we just tell, our test to expect any exception, then it may not be doing what we actually expect it to do. But we'll change this back. We don't need that anymore. Okay, so I think we have a good enough understanding on how to create a test, and I think it's time we actually started testing our application. When it comes to FastAPI, FastAPI automatically provides us a test client. So all we have to do is we just say from FastAPI.TestClient, import test client. And then all we have to do is then just pass in our FastAPI instance, which is stored under the variable app, and then we can just perform any requests to our application by doing client, which is what we named the test client, and then just doing a .get or a .post or whatever, And then we can get the response, and then we can assert anything that we want just to make sure that we get the responses that we ultimately expect. And keep in mind, when you make use of this test client, right, if you take a look at the documentation, it says that you use this the same way you would any requests object. So if you've ever used the request library from Python, right, this is the same exact object. So anything you could do with requests, you can do with the test client. So you can customize the request. You can, change the HTTP method. You can add a body, a payload. You can add a authorization header. It's really just doing what Postman's doing for us, but we're going to do it through code instead of manually opening up Postman and then, figuring out which request we want to send. We're just going to do it out in Python so we can do it all in an automated fashion. But if you haven't worked with the request library, definitely take a look at this. Just take a look at how we generate requests. It's not too difficult, right? It's just request.get, or in our case, we're going to call it client, but it doesn't really matter. And then you provide the URL that you want to run this against. And then, you can add in other properties like an auth header or anything like that. So it's just about customizing your specific HTTP request. And so I'm going to create a new file, and I'm going to call this, how about test_users. This module represent tests for, creating users and getting user profiles information and things like that. And just like it shows in the FastAPI documentation, let's just copy this line right here. And then what we want to do is we want to import from our app package, go to our main file. We want to import our FastAPI instance. So we want to import this app right here so that we can actually test it. So I'll say from app.main import app. All right, so we have our app instance, and we'll just copy this line right here, which is just setting our test client to a variable called client. And so now we can run whatever tests that we want. And I think, just to keep things simple, let's start off with the simple root path that we have right here, just to test that this works, because that way we don't have to worry about authentication or passing any other data. Let's start off with the simplest scenarios. So this is at the root URL. So we will go to our test users. And I'm just going to call this test root, because it's not really a real function or anything like that. And then here we'll say client dot. And since we are testing a specific path operation, this is a get method. So we want to send a get. So we'll do client.get. Then the URL. So we could just say /. We don't have to do, localhost, because it's not technically a running server. We actually just pass the actual app instance. So we just say the root path. And then you can pass in other things like, what payload and things like that. But we'll leave that for now. Leave it empty. And we'll store the response under a variable called res. And instead of doing an assert or anything like that, for now, I just want to print out the response. All right. And if I run this, okay, so a little bit annoying thing. Right now, it's going to run all of our tests. And if you just want to test one test or one module, then I recommend you just do the same thing, except pass in the path to just your specific module, so that we don't run all of our tests all over again. So we can just run one in this case. And if we take a look at this, we can see that it just prints out a response object. Not very helpful. But if you want to see what's the actual payload, we can say .json to see what the data looks like. And so then I can run this, and we can see that, hey, look, we get message hello world. And if I wanted to grab the message property, I could say .get and then message, and it should return hello world. Let's try this out one more time. And we can see that it prints out hello world. So to test that this route actually works, what we can do is we can just do an assert. And I could say assert and then literally just copy this exact message. And I can say, hey, the message should return a value of hello world. It's as simple as that, right? It's no different than what we did before with our, our addition function, right? We're just performing some action, running our code, and then making sure that the results are what we expect them to be. Right? And so now if I run this again, right, once again, still passes because it does return a value of hello world for the message property. And we can assert multiple things, right? It's not just one. We can do a second test case, and I can say res dot, and we can access a property called status code. It's even recommending that. So we can say, get me the status code. And I could say, well, I expect this to be a, if we don't change what the default status code is, it's going to default to a value of 200 as per the FastAPI documentation. So this should be a 200. We shouldn't get any other values. So if I run this, once again, everything works. But if I go into my code and create a little bug, let's say I just add, an exclamation point or something. Then if I run this, we can see that it fails. And that's because we expected hello world, but we got hello world exclamation. So let's change that back. And this time, let's create a different bug. Let's actually change what is the status code. And so I can't exactly remember how to do that. So let's go to our post router. And we just set the status code right here like this. So if I copy this and go back to here, and actually, was it in the decorator? Yeah, it's in the decorator. You put that in there. And we have to import status. And so now if I try this out and run this, once again, it's going to fail. And that's because we're asserting, and the response was a 201, but we expected a 200 as per our test, which over here says it should be 200, and it throws an error. So you can see we could test a lot of different things. You can choose to test each and every property that you're interested in to make sure that the response is exactly what you expect it to be. But at this point, I think we understand how to send requests. So let me just, first of all, undo those changes that I just made just to make sure I don't break anything else in my app. And we no longer need to import that. So remove that. We'll save everything and let's just run our test one more time just to make sure that everything's good. And it looks like everything passes. Before moving any further, I want to show you a couple of other flags that we can pass to the Pytest command so that we can kind of tweak the behavior of our testing. And the first thing that I want to do is, if you take a look at the output, you can see that we get a whole bunch of warnings. And depending on how many packages and libraries that you have installed, you could potentially see a lot more warnings. And I actually hate looking at these things. So what I normally like to do is I usually like to pass in the dash. I think it's a disable warnings, I think. And so now if I run this, you can see that there's no more warnings and we just see the testing information. So I think that looks a lot cleaner. And then the other thing that I want to show you guys is, till now, all of our testing, when we've broken a specific function or class, we've only had one test fail. And I want to show you what happens when you have multiple tests fail. So if we go all the way to the top in the test calculations folder, and then maybe I just change, the subtract function. So I'll change this to be 6 so we know that it's going to error out. And then also at the bottom, I'm going to change this test right here so that it returns 56 instead of 55. And so if we run this, and I'm going to do -v so we can see verbose, but you don't have to do that. But if you take a look at what happens, you can see that, it runs the first 3 tests, and then the 4th test fails, and then it just continues running through all of the other tests, and then it fails on the next one, and then it finishes running all of the other tests. So the default behavior is when a test fails, we're going to continue running all of the other tests. And this may not be the behavior you want, so maybe you've changed your code and you just want to see if we've broken anything. And so you want your code to ideally, run through the test, and the first time it fails, you want it to stop so that you can, then fix that issue and then run through the rest of the tests afterwards. Or you can manually run it again because, right now we only have like 16, 17 tests. So it doesn't take that long. But when you start to write a lot more tests and your code starts to grow, these tests can take, minutes, sometimes more than that, depending on, are you using an external API? Are you using a database? These all add a significant amount of time to your tests. And so if you just want to see if you've broken anything, you may want Pytest to stop on the first failure. So if you ever want Pytest to do that, all you have to do is you have to pass in the -x flag. So this will tell Pytest to stop after the first test fails. So if I run this, you can see that we get pass, 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 and then the first test failed, and then we stop and we don't do anything else. And so those are just the 2 flags that I wanted to go over. I don't think we'll really cover any other specific flags. I just wanted to go over these 2 because they just happen to be 2 of the ones that I do like to use occasionally. But let's make sure we go ahead and change all of our code back. So I think we changed this one. This should be back to 5. And this should be changed back to 55. And just to make sure, let's just run our code once more, just to make sure we didn't break anything, and we could see all 16 tests pass. So now that we know how to simulate a request to our API, let's create a test for testing the user create functionality. So what we're doing is we're going to create a user, and we're going to test this specific route right here where we create a user. So let's try this out. We're going to do the same thing. I'll call this def test _ create _ user. And here I can say res equals client like we did before, but this time it's going to be a post request. And the URL that's going to be /users. All right, and then since we're now sending a request, to create a user, we have to send data in the body. So to send data in the body, you say JSON equals, and then you pass in a Python dictionary. So this is going to get sent as the body. And if you go back to our specific route, which is right here, you can see that we expect the users create schema. So if we take a look at the schemas, you could see that somewhere in here, where's user create? Here we go. We expect an email and a password. So let's send an email and a password. And so for email, we'll say this is going to be hello123@gmail.com. And the password is going to be password123. And just to see that it worked, let's do a print, and I'll say res.json. And then the test requirements, how do we verify that it works? Well, let's start off with something very simple. So we'll say assert, and I'll say res.statuscode. We know that when we create a user, we expect a 201, and we can just verify that by taking a look at the path operation. But I think this should be good. And then now if I run this, and I'm going to run just this file, so I'll say test user. And let's see what happens. So we see both of them passed. And how do we verify that? Well, we should see this user in our database, right? So if I go to my PgAdmin, go to my database, and we'll go to our schemas, tables, and go to users, and we'll do a view edit all. All right, we could see the hello123, so it was successfully created. I'm just going to quickly delete this again. Well, actually, let me show you what happens if we don't. I'm actually going to do something unique here. I'm going to say, well, actually, let's just do an assert, and I'll say res.json.get, and we want to get one field just to verify that it's correct. So what's the data going to look like when it comes back? Well, we should see a print, but I didn't. That's because I forgot to do the -s flag. But going back to the route, we're going to send the response as a user out. So we expect it to match this specific model right here. So it should have an ID, an email, and a created at. So let's add that in there. I expect the email to equal the email that I gave it. And you can really do as many, asserts as you want. So you could verify each single property has been set. You can verify that an ID has been set. I'm just going to keep it simple. We'll just say just the email. We'll just run that check. And so we'll run it again. And I'm going to do the -s flag as well. All right, and we see that it failed. And we can see that it failed because there's a duplicate key violates unique constraint of email. And that's because this user was already created, so I can't recreate him. So let me delete this. And I don't think if I select the number and then go to, oh no, it doesn't look like I can. There we go. Now once I select that number, I can delete this user. And then we could save that to database. And so now if I run this again, we should see it work. And we can see that both tests pass. And we can see that both of our assert statements were checked and validated, and they both looked good. But instead of doing it like this, we can even take it one step further. Instead, what we can do is I can actually import this user out schema into my test. So I can say from app.schemas import user out. And then I can remove this print statement. And what I can do is here I can actually use the schemas. Actually, sorry. I'm actually going to change this import. I'm going to just import all schemas. So I'll say from app import schemas. And now I can actually create a new Pydantic model, and I'll say schemas dot user out. So we're going to create a new schema, save this as a variable. I'll call this new user. And we can pass in the data that we get back from the response. So I can say res.json. And remember, we have to actually unpack the dictionary so it's in the right format to create a new user out model. And now this is going to perform a certain level of validation. So it's going to confirm, hey, do we have an ID? Do we have an email? Do we have a, what was the other thing that we needed? And do we have a created at? So it's going to make sure it's got these three things. It's not going to check to make sure that it's the right email. It's not going to check to see if it's the right ID, but it's going to check to make sure that at least it has these three properties. So it automatically does some of the validation for us, and it'll throw an error if one of those are missing. And if it throws an error, then obviously Pytest will consider this test a failure. So by doing this, we've kind of saved us a little time. And now I can actually change this. Instead of doing this, I could say new underscore user dot email equals this value. So now if I run this, hopefully this works. And it looks like it failed. And let's quickly see what happened here. Oh, once again, I forgot to delete the user beforehand. So we'll delete him and then try this test one more time. And they passed. So I think this is what we're going to do moving forward. We're going to make use of our Pydantic models to do some of the validation for us automatically so that we don't have 60 or 7, well, probably not 60, but we won't have 5, 10 different assert statements, which you can absolutely do. And you probably do want to, but this will remove some of them because it's at least checking to see if some of them are there. So before moving any further, we need to address something important. And that is that right now we are using our development database for our tests. And that's not good. I don't want to use my development database. I want to create my own separate database to perform testing on so that I don't get in the way of development or staging or any of our production databases. I want to create a completely separate database for testing. Right now, when we import our client, right, we're going to be using whatever the database is that we've defined in the rest of our app, which is going to be our FastAPI database within PgAdmin. And we can see that right here. And so that's why I'm having to go in and make sure that it's created. And we've already got some other data which could potentially break our tests. And so I want to make sure that we have a completely separate database for testing so that it does not get in the way of anything else. So how exactly do we do that? Well, one of the great parts about the way we've set up our database is if we actually go to our database.py file, right, you could see that we've actually set up a dependency. So when we set up our dependency, you can see we created this function called getDB, and this getDB actually returns the session local. So this is what allows us to actually make queries using SQL Alchemy. And that comes from this right here, from the session maker where we passed in all of our database connection details. And if we go into any one of our routes, it doesn't really matter which one, you can see that we pass in the dependency into the route. And the great part about having dependencies is that it's very easy to override a dependency in any environment, especially a testing environment. We can say, hey, instead of passing in, get DB, we can say, something like get, underscore test underscore DB, which is going to be a function that returns a test instance of our database instead of our development instance of our database. So I'm going to show you guys how we can set that up and how easy that is. So we'll go back to our test users. And we're essentially just going to copy all of this right here. So I want you to copy this all the way up to the URL. And we'll have to set up some imports, and we'll come back to that in a second. So let's just create some space. All right, so we've got all of this, and we need to import a few things. So we'll start off by, we'll have to import settings. So we'll say from app import. Actually, we'll say from app.config import, I think it's settings. Yep. All right, so we've got that cleared. We then have to import create engine. And so we'll go up here and I'll say from Sqlalchemy import create underscore engine. And then we need our session maker as well. And I think if I hover over this, nope, it doesn't look like it'll auto import that for me. So I'll say from Sqlalchemy.orm import session maker. All right, it looks like we got most of the issues. We still need declarative base, and we'll import that. I'll say from Sqlalchemy.ext.declarative import declarative base. And if you guys don't know where I'm getting this, I'm literally just copying this straight from this file. So everything that's here, you can just copy it as well. And if we go down, I think we have everything, right? We no longer have any errors. So we've got all of our imports. And so this is the function that returns our session local. So this is what allows us to query the database. This is our session object, right? And this is how it's set up exactly in the database.py file. So what I'm going to do is I'm going to create another function, but this time I'm going to call it override underscore get underscore DB. And this is going to return this session local instance. But I'm going to rename this just so I don't get it confused. And I'll call this testing session local. And then I'll reference this. All right. And so that means right now in our current application, we're referencing the one that we created in our database.py file. But the one in our test, we're going to actually make use of this new one right here if we call this override get DB. So how exactly do we override the database or any dependency, really? Well, FastAPI has a section on here, and I think if I search for dependency, testing dependencies with overrides. All right. To actually set up the override, you just do app.dependency override, and then you provide what you want to override it with. And there's actually a better example. If I go to testing database, this will actually show you how to do that. So we've got the override DB, where we've created a different session object. And to override it, we just do app.dependency overrides. We pass in, we specify the dependency we want to override, which is anything with getDB, and then we want to override it with override underscore getDB. So essentially all that's really doing is in the functions, any of our routes, right, you can see we've got this depends getDB. So when we run that command right here, this override, all it's going to do is it's going to swap this out with the function that we have right here under test users called override getDB, which is just going to give a different session object. And this session object can point to another Postgres database. That's all we're doing. It's really that simple. That's why we set up that dependency when we first started configuring our database, so that we can easily test this during testing, because we can just use the override functionality that's used within a FastAPI. So I'm going to copy this. And right here, I'm going to paste it down here. And I realize I misspelled override, but we do have to import getDB now. So let's import that. So I'll say from app.database import get underscore DB. And so it's going to swap the dependencies out. And since we're still referencing the app object, we're going to pass that into TestClient. And so now anytime we use this client, it's going to use the new database. Now, currently our database is using the environment variables, which once again is going to point to our development database. So there's a couple things we can do. Since this is testing, we 100% could just hard code our URL, because I mean, it's our testing database. Who cares if our password and our information is already out there? So we could technically do an F string. Actually, we don't even need an F string. I could just say PostgreSQL. Whoops, this should be a string. PostgreSQL : // then we have the username. Right now for my database, it's just Postgres. And then we have the password, which is password123. Remember, this would technically be for your testing database, so it's not technically a problem if you put this in there and hard code it. However, you'll see that we could just use the environment variables and make a small tweak, but I'm just going to quickly write this out for you guys if you wanted to see it. And then the host name is going to be localhost, port is going to be 5432, and then our database name. So we could call this, you know, my development database is called FastAPI. I could call my testing database maybe FastAPI _test. So whatever my project name is and then underscore test, you can call it whatever you want. And so I could just hard code that and then comment this out, something like that. Or I could use this same thing, but just do a underscore test here. And so that way I don't have to hard code anything. It's going to actually pull it from the environment variables. So whichever method works for you, ultimately, that's all that matters. Now, I technically already have a FastAPI test database. So I'm going to actually delete this for now. So we'll say delete drop. All right. So I'm now in however your Postgres instance is set up. But since we're going to be using a database called FastAPI _test, we actually have to create one. So I'll say create database, and I'll say FastAPI _test. Okay, so we've got our test database created. And we've set up the override. Let's now actually test this out. So we're going to do one last thing. And I realize since we have a brand new database, there's no tables, right? If I go down to schemas, tables, right? There's nothing there. So we actually have to build out our tables before we actually do anything. So easiest way to do that is just copy, where's my main file? Here we go, this command right here. So this will tell Sqlalchemy to build all the tables based off of the models. We could use Alembic as well. So I'll show you guys how we can kind of get Alembic set up in our testing database so that it actually performs the migrations before test. But for now, we're going to keep things simple and we're going to use this. And so I'll just paste it right there. And we can remove this models. I don't know why that's there. And you can see that we get a warning right here. So we don't have anything base. So we actually have to import that from our database file. So I'll say from app.database, import base. And I realize we actually don't need this line right here. So we'll remove that. All right. So now our test database is completely set up. And when we actually run our first test, it's going to run this right here, which should create all of our tables for us. So let's take a look at our test create user. Everything should be good. We shouldn't have to touch anything. And our URL should point to FastAPI _test. So let's try this out. And I'm just going to refresh this. And yep, we shouldn't have any tables. Good, perfect. And let's run this now. So let's run just the test users. All right, and both of them passed. So how can we verify if both of them passed? Well, let's go to our tables. I'm going to refresh this. We can now see we've got all three tables, right? And that's because we ran this specific, well, not that command, this command right here. And if I do a users and then, where is it? View edit all data, all rows, right? We can see that our user was successfully created. So we have now gotten our test database set up so that we no longer interfere with our development database. And keep in mind, right, your test database doesn't even have to run on your local machine. You can run it anywhere. You can run it in a Docker container. You can run it on a remote machine. You pass in the details of your test database, and then your testing environment will handle the rest. So now that we've got our test database and we've successfully ran our tests, if we run our test one more time, take a look at what happens. We get an error, right? And we get an error because we saw this before in our development database. We already have a user, so we get this duplicate key violates unique constraint because this user already exists. So when we run this again, we try to create a new user with the same exact email. And this obviously causes things to break. And so how do we get around this limitation, right? I want to be able to run my tests as many times as possible, and I want it to kind of start out with a clean slate. Well, we can make use of fixtures. So let's take a look at our fixture. And if you already forgot what a fixture was, it's just a function that runs before your test runs. I'm going to create a fixture, and I'm going to have to, do we already import Pytest? We did not import Pytest, so let me import that in here. We'll say import Pytest. And I'm going to say, I'm going to create my fixture. Call this whatever you want. I'm going to call this client. So this is actually going to return, our client, right? This is our client object right here, which is the test client, which is what we use to actually generate the request. So I'm going to call this def client. And what this is going to do is I'm going to remove this line right here and just copy this. And I'm going to say return this. And we can just remove this line at that point. So this is going to return our test client instance. And so now, to get this to actually work, I'm going to pass in our client. And so now this client object references the client that we get from this fixture. And we'll do the same thing here. So what exactly has this solved? Right now, it hasn't really done anything for us, right? Our code is going to work exactly the same. If I save things and run it again, right, same exact issue. And obviously I can go in and I can delete this and then run this, right? It's going to work just fine. But it is nice because we now have this function that runs before each one of these tests that gives us our testing client. And what's even better is I can actually change this a little bit because I can change this to be a yield. Right? When you change it to yield, what it does is it gives us a little bit more flexibility because now we can, run our code before we return our test client. And after the yield, we can then run our code. Actually, this should be run our code before we run our test. And then this is going to run our code after our test finishes. So now we can put in logic for, what should we run before our code runs or before our test runs. We then yield, which is the same thing as return. It's going to return our test client. And then we can run some code after the test finishes. So what we can do is, before our code runs, I can copy this line right here. So before our code runs, I can create my tables. And then after my code runs, I can drop my tables. And if you want to drop a table, you just run base.metadata.dropAll instead of createAll, and it's going to drop these tables. And so now every single time my tests run, I'm essentially going to be starting out with a clean slate. It's going to drop all of our tables, all the data in each table. It's going to return the test client. We're going to run the test. And then, I messed that up. So when we finish a test, we're going to drop all of our tables, delete our data. Then the next time the test runs, what's going to happen is we're going to create all the tables again because there's no tables. We're then going to run the test. And then just like we did before, we're going to then drop all of our tables again. So what I'm going to do is, first of all, I'm going to manually drop these. And I'm going to have to drop votes first, or then it's going to throw some foreign key errors. And then we'll drop posts and then users. Okay, so now everything should work. And I'm actually going to test this out. So once again, just to reiterate, we're going to create our tables because we don't have any. We're going to then run our test, right? Yield just returns our test client to our create user, and then we can, perform all of this logic. After that's done, we'll then drop the tables again so we start from scratch the next time around. So let's try this out. All right, everything's worked. And if I actually go back to here and hit refresh tables, you can see there's no tables because we dropped the tables after we're done. And if I run this again, it works. We can run this as many times as we want. We don't have to worry about duplicate users because we're clearing out our database. And there's one more thing that you can do as well. If you wanted to, we could actually take this drop all and move it up here. So what's the benefit of doing like this, or why would you want to do it like this? Well, the nice part about this is, right, it's going to clear out anything we had previously. It's going to create our tables, and then it's going to run our test. And then the next test that we run, we're once again going to clear out our table. We're going to clear it out, and then we're going to build our new tables again. So this way, if your test fails, you can, pass in the -x flag to stop after it fails. And what's going to happen is it's going to keep all your tables and all of the data so you can see what was the current state of your database when the test failed. So that you can, ideally have a little bit of better idea of what's happening, troubleshoot a little bit more because you have access to your tables. Whereas if this is down here, right, it's just going to delete the tables after you're done and you can't even see it. So it's a matter of personal preference, but I like to keep the tables after it's done so that, if I do want to stop it and just kind of poke around and take a look, then I can. And if you guys don't want to use Sqlalchemy, you can do the same thing with Alembic, right? I can import, Alembic.config. Actually, I think technically the import is from Alembic.config import config. Sorry, not that. Nope. It's from Alembic import command. So what we could theoretically do is in here, instead of using these, we could say something like, I think it's command.upgrade. So you can upgrade, and then you can go upgrade to, I think, head, right? So this will build out all the tables for you. And then after you're done, you could then go in and say command.downgrade to base or something, right? You'd have to make sure you set up Alembic with all of the right environment variables and things like that. But that's all you would have to do if you didn't want to use Sqlalchemy's built-in functionality. So I'm going to just delete that just to keep things simple. We're going to let Sqlalchemy build the tables for us moving forward, just because it's a little bit quicker than having to build all of your revisions and things like that. So one of the cool things with fixtures is that we can actually configure a fixture to be dependent on another fixture. So we can essentially pass one fixture into an argument of another fixture. And the reason why I want to do this is I want to have one fixture that returns my database object. So if I want to ever manipulate data directly, and I want another fixture that returns my client. So this one is returning our client, so I want that. But I also want another one that returns just our database object. So what I'm going to do is I'm actually going to create a new fixture. I'll say pytest.fixture. And we can call this whatever you want. You can call it, like DB or session. I'm just going to call it session. And I'm actually going to move the logic of deleting and creating our tables up to here, because this is kind of handling all of the logic for the database. And you see all of this override functionality. What I'm actually going to do is I'm going to just copy this section right here. And paste it into here. All right, so this session fixture is going to yield the database object. So the database object that we used to query things. And what I can do now is I can pass in session, this session fixture, into my client fixture. And so by doing it like this, what's going to happen is any time I go to one of my tests and I pass in the client fixture essentially as a dependency, it's going to call this one. And the client fixture will actually call the session fixture before it runs. So it's intelligent to understand that a requirement for the client fixture is the session fixture. So we're going to run all this code. It's going to return the DB object, which is going to be passed into client as the session. And then here we can perform all the logic that we normally would. And I'm going to once again copy this override DB right here. And we can remove this. And we can remove that. Nope, actually, sorry, I didn't mean to remove that. Just space these out a little bit. So it's part of the override getDB function. And here, instead of yielding DB, since there's no DB, we're going to yield session, which is the DB So we'll say session, and then session.close. And I'm going to copy this line right here, do the override right here, and then we return a brand new test client. Okay, and the benefit of this is that not only do we get access to the client, if we wanted to, we can also get access to the database as well. So I could say session, and then I can go in here and I can make queries like session.query, models.post blah, right? So now I have access to the database object as well. And so I can make queries and I have access to the client. But if I call just the client, remember, the session database is an input argument into the client fixture. So the session will always run first, and then client will run because we're calling it right here. And then we just move the override getDB function into here as well as the override right here. And then as usual, we return the test client. So let's make sure we didn't break anything. Let's test out our code. And something's happening with my terminal, so let me open a new one. So let's try this again. I'm just going to do pytest test / and then test _ users. Nope, not test calculations, users. All right, and 2 passed, so perfect. Looks like we didn't break anything, and we've got a much nicer way of setting up our code. We can actually remove this override that's not within a fixture. We no longer need that. And we no longer need the create all right here outside of any of the fixtures because we're doing it all within the fixtures now. And once again, I just want to make sure I didn't break anything. So let's test that out. And we can see 2 have passed. Perfect. All right, so right now our test users file is a little bit cluttered with all of this database information. And I would like to move all of our database specific code to another file. So under our test folder, I'm going to create a new file and we can just call this database.py. And I'm going to essentially move all of my database code to that file. And that includes the fixtures as well. So these 2 fixtures, all of this, actually everything. We don't need any of this in our test users file. And we can just paste it into here. Now, this is going to break things because obviously it has no idea what schema. Okay, well, actually, before we do that, we do need to have schemas in here. So let me find where schemas is, and we'll just cut that out. But the other issue is that we no longer have access to the client fixture. So we have to import that. So I'll do from current directory database import. What is it? Client? I think it's client. Yep. So now we have client. And remember, we don't need to import. Actually, we may need to import session. Let's just double check to see if this causes any issues. So let me save everything. And let's test this out. Let's see if this works. Looks like we got 2 errors. Yep. And if you take a look at the errors, it says the session fixture is not found. So we actually have to import the session fixture from this file. Even though we don't actually call session in here, because client is dependent on session, because client is ultimately calling session, we need to make sure that session is also imported. So we have to do session here as well. And so now I think this should fix our issue. So now if we run this, yep, both tests have successfully passed. And if you actually take a look at our test file, you can see our test file is a lot cleaner. It's really just got our 2 tests and a couple of imports. And before we move on any further, there's one thing I want to point out, and I ran into this issue when I was, doing a dry run through my code. If you actually take a look at your routers, and we'll go to, since we're taking a look at test create user, this is going to be the /users. So if we go to users and then create user, right, you can see that the prefix is /users. So the route you want to go to is /users, and then you can see that we have to append whatever's here. So here it's appending /. Now, the way that Pytest works is that, or actually the way that anything works is that if you actually send a request to /users, it's a little bit different than /users/. And I'm actually going to show you what happens when we do that. So I'm going to, first of all, open up UVcorn. So I've started out my API. And if we go to create user, here I'm going to users and not users/. right? I'm not doing slash, I'm doing slash user. I'm just doing users, which is, wait, where did it go? Is it here? Where did I put the things I just typed? Yeah, here. So what we're doing is we're sending a request to this one, not the one above it, because the other one above it has a slash at the end. We don't have that trailing slash. So if I create a test user without that trailing slash, hit send, take a look at what happens in the logs. It says that when we get a request to slash users, we're going to send a 307 redirect to slash user slash, because technically the route's on slash user slash, and FastAPI is intelligent enough to actually send the redirect to here. However, this creates an issue with our testing, because if I just do slash, what's going to happen is when I do this res.status code check, it's going to check for 307 and not the final 207, the final 201. And I could show that to you guys. So let me go down here. We'll run our test real quick. And you'll see that it fails, and it fails because, well, there's a couple of issues. It fails. It says it fails because our validation for our schema failed, but I'm going to skip that and comment that out. And I'll comment this line out. I just want to take a look at the status code, because obviously if there's a redirect, there's no information in there. Right? And you can see that this fails because the response code is 307. So that's why you want to make sure you add that trailing slash, or then you'll run into some issues. So we've got our create user test pretty much done. You can feel free to customize it however you want. If you want to add a few extra assert statements, feel free to do that. But we're going to move on to login. So let's actually handle setting up the login. So I'm going to do def test underscore login underscore user. All right. And this test is going to be dependent on the client fixture, because we need to be able to send a request. So I'm going to pass in client. And I'm actually going to copy this line right here. We'll change it, of course, but all right. And so we're going to, this is going to go to slash login. And there's no trailing slash on this one, just because if you actually look at our specific route for login, I think it's under auth.py. You can see there's no prefix here. It's just slash login. So we don't need the trailing slash on this one. You just have to figure out how you set yours up and make sure it matches accordingly. We do slash login. But in this case, we don't want to send this data in the body. Instead, remember, if you go to Postman and you go to login user, we don't send it in the, well, we do send it in the body, but instead of using the normal JSON format, we have to send it as form data, remember? And so to change this to be form data, you just change JSON to be data. And we've got the same credentials, so this should work. Let's just quickly just do a assert. And what does a login return? A login returns a, it should just be a 200. So we'll do a 200. Assert res.status code equals 200. All right, and let's test this out now. And it looks like we got an error. So what happened here? Let's take a look. It looks like we got a 422 as our status code. Why would we get a 422? And if we take a look at our logs, we don't really get much information here. So what I'm going to do is we're just going to print res.json so we can see what's going on. All right, why did we get a 422? Is there any other details it's going to provide us? So I'll do a -s so it prints it out. And we can see in the print statement, it says, oh, look at this. There's some sort of validation issue. Detail, block body username message field required. Type value error missing. So remember, the field for the email when you log in is not actually called email. It's called username. So we have to fix that. So it's going to be username. All right. Now let's test this out once more. All right, we get another failure. So let's see. This time we got a 403. Okay, interesting. So what's happening? Why did we get a 403? Let's see. Detail says invalid credentials. Interesting. So if I go back to my login route, right, you could see that we get a 403 if the user doesn't exist, which means we couldn't find a user with that specific email, or if the password that was provided doesn't match what's in the database. So this is one of the issues. It's either the user doesn't exist, or the email doesn't exist, or the password is incorrect. So let's go into PgAdmin, and if you left your database config so that you don't drop it at the end, instead you drop it before a test case starts, you should be able to see all of your test data. So I'm going to refresh this. And if I go to users, view, edit data, all rows, right? Well, there's no users. Well, that's interesting, right? Because if I go to my code, during our test create user, we should have created a brand new user. So why can't we log in as this user? Well, that's easy to explain. So if I actually go to my my database.py, we have these fixtures, and the fixtures have a specific scope, which means when do they run? And right now they're using the default function scope. What that means is they're going to run before every single function that's dependent on them. So that means when we run test users, right, we can see that test root client, right? Since we're passing client into test root, we're going to run our fixtures before we run this function. Then before the next test, we're going to run our fixture again. And then before this test, we're going to run our fixture again as well. So why does that actually cause the user to get deleted? Pretty simple. Because we run this test, right? The test create user, the user's in the database, and then we start to run the test login user. And so since we're dependent on the client fixture, we go to the database.py file, we can see that the client calls session. Session, what does session do? Well, it drops the database, or it drops all the tables at least, and then it creates all of the new tables. So we get a brand new database every single test that we run. That's why the user isn't there. And if you want to learn more about scopes, I recommend you go here, and then I think, if I go to API reference, I think, and then fixtures, no, let's go to examples. And go to fixtures right here. And then here I can search for scope. Here we can see the different scopes. So the default right now is that our scope is functions, which means that the fixture is destroyed at the end of each test and it's run for every single function. We then have a fixture that's set to a scope of class, which means that it'll run once per class and it'll run all the tests in the class. Then we have a fixture module. So when a fixture is set to a module, that means for all of the tests in a specific module, right? Like in this case, all of the tests here, we're going to run the fixture just once at the beginning, and then we're not going to run it again for that module. So all of the tests will have access to just that first instance run, essentially. And then we also have it for package, where it's going to run once per package. And then we also have session, where it's going to run once at the start of the testing session, and it's going to get destroyed. And you can see how we can set the scope right here. You just do scope equals, and then whichever one you want. So if we go back to here, and we see this fixture, right, we could say, since the default is function, it's equivalent of doing scope equals function. And the same thing goes for the session, the database one as well. So these are going to run and get destroyed every single function. So at the end of the function, we're going to delete this test client, and then we're going to create a brand new one for the next one, which causes our database to get wiped and destroyed. So if we want our login user to be able to access what was created here, we could theoretically change the scope to be module instead. And I could change this for both. And so now what happens is at the start of this module, when we start running the tests here, we're going to run the fixture, right? Because the test root is calling it. So we'll run the fixture at the beginning, and we're going to just do it once, right? So then we'll call this one, which doesn't really do anything. We'll then create the user. But since we don't ever run the fixture again, we never end up running this session either. So we don't end up dropping our database or our tables. So we'll actually keep that same fixture, and then we'll run through all of our tests, and only at the end will we destroy that fixture. So we have essentially access to all of to our database for the entire module in this case. And so now if I actually run this, right, you can see all of our tests pass because the fixture will last the entirety of the module. I could even use package or session. Both of them would have worked. But this creates a little bit of an issue because this means that this test is dependent on this test completing. So if this test fails, then obviously this test is going to fail. And it actually creates issues because if I move this to the top, right, and I accidentally move my login user to before test create user, then this is going to break our tests once again because we need to create the user before we log in the user. And so in general, what we've done is bad practice. You don't want to make tests be dependent on other tests. Each and every single test needs to operate and run independently. They should not be reliant on other tests. If they are, it is not a valid test and you're doing it wrong. You want to make sure that all tests can run independently of one another. So what we've done so far with this little hack of changing the scope to be module is not a good solution. So in the next video, we'll take a look at what we can do to kind of overcome this limitation, this issue, so that we can make our login test case independent of our create user test case. Okay, guys, I wanted to make sure that we really did understand what scopes are when it comes to fixtures, because I feel like I didn't do that good of a job explaining it. So hopefully this video will help explain it a little bit more. And all I'm going to do is under our session fixture, I'm going to just do a little print statement right here that says my session fixture ran. And this is, I'm recording this video in the future, so I've got all of the other tests that we're going to cover done already, and I've kind of broken it out into test posts. So this is testing all of our post path operations. We've got one for users and one for votes. And I'm going to show you guys what happens when we use the default scope, which is it's scoped per function, right? This is the equivalent of doing scope equals function, which means that we're going to run this fixture for every single function that requests it. And so if I remove this, because once again, it's the default, and I run my tests, I want you to take a look at what happens. For every single test that we run, one dot represents the test, we can see it prints out. And so it's running through all the tests in test underscore posts, and then it's going to run all the tests in test underscore users and then votes. So you can see that because this is set to function, we're going to run this entire session fixture, this function, every single test that we have, or at least every single test that's requesting this specific fixture. That's why we see it run every single time. Now, if we change the scope to module, the behavior is going to be a little bit different. Now, if I change the scope to module, what's going to happen is that for every module that has a test that's requesting this specific session fixture, we're only going to run this fixture one time per module. And so now if I save this, and I'm going to no longer do -v, I'm just going to do just -s, so we can see this get printed out without too much extra data, because we're going to see a lot of tests fail, and that's perfectly okay. I want you to notice what's happening. So notice how the print statement ran here, and then the print statement ran here. And I had to cancel out of that because usually I end up with a ton of errors and then I lose my data. But you could see that the first module, which is tests underscore py, we could see that my fixture ran because it's because I told it to run because one of the tests is requesting it. Right? It runs, then one of the tests runs, and then the next test runs, and then the next test runs. So you could see that this is not printing out per test. It's only printing out one time per module. So when test the underscore post.py ran for the first time, and the first test required this specific fixture, it ran once. Then it didn't run for any of the other ones. That's why we see them all fail. And then the next module loads up, and we start running tests from there. So we run the fixture just one time. And then we don't run it ever again. So you can see 7 other, I think it's 6 or 7 other tests ran with no other modules, with the fixture not running any other time. And then we can see the same thing for votes. We can see that my fixture ran just one time. So this means that it's going to run only once per module. We also have session. So if I do session, it's going to be even more different. You're going to see it run only one time for my entire testing session. So you can see my fixture ran. It's going to keep going through, which is perfectly fine. And then when we get to the next module, we should see it not run at all, right? And so you can see it didn't print again. So it's going to go through all of the different modules. And I'm going to cancel out of that before I get too many errors, right? But now it only runs once per entire testing session. So that's when the scope comes into play. So keep in mind, depending on what you're trying to accomplish, you may need to tweak the scopes of your fixtures depending on what they're supposed to be doing. But for our database, we want to keep it set to function, which is the default value, because we want to load up a brand new database by dropping our tables and then creating new ones every single time we run our test. So the default works perfectly fine for us. Now, to make our login user test independent of any other test, so it's not reliant on a specific order or setting the fixtures to be of a specific scope, what we want to do is before our login user test runs, I want to actually go in, define a function that'll get called, that'll actually create a brand new user so that we can actually test the login user out. And so, as soon as I said the words, I want to run a function before a test runs, the first thing that should click in your head is you want to run a fixture, or you want to create a new fixture. So we can actually create a fixture that'll create a test user for us. So up here at the top of this file, let's create a new fixture. And I'm actually going to delete this test. We don't actually need it anymore. It's just taking up space, or I can at least comment it out, I guess. And I'm going to define a fixture here. And we have to import Pytest. So we'll say from, import Pytest. And we'll say at pytest.fixture. And I'm going to call this test user. So it's going to be responsible for creating a test user. And this is actually going to make a call to our create user route. So we actually need access to client so that we can actually make that request. And there's 2 different ways of doing this, right? We could just have access to the session object. We can have access to the session object, and we can just, session dot, I think, what is it? Well, actually, no, it would be like models.user, and then pass in the data for a test user, and then create it directly with the database. Or we could just make a call to our API and actually have it run through that. So I'm going to do that because it's a little bit simpler for now. But I'm going to define a dictionary with the data that I'm going to use for my user. So I'm going to have the email. And actually, it's going to be a little bit easier if I just paste this in. So we have the email set to something, and then the password set to something. And I'm going to change this back to client. And now I can say res equals client.post, and we'll send it to users. And then the data for the new user can just be user_data. And just kind of like what we've done here, we can, just to make sure that this didn't error out, we can do an assert and just say, res.status code equals 201. If that's good, I think it's safe to assume we didn't run into any errors on the back end. But then what I want to do is, not only do I want to create the test user, I want to actually return the information about the user so that this login user will have the correct data to send when he tries to log in. That way, if we ever change this data, we should automatically update this data. So what are we going to return? Well, we have access to, to res.json. And if I print that out, we can just quickly take a look at what that looks like. And for now, I'm just going to return nothing, I guess that's fine. I'll just return nothing. And here I'm going to change this to be, I'm going to pass in the test user, so that also runs. And so now this login user is dependent on two different fixtures, client and test user. And before we do anything else, let's make sure we clean up the scope. We don't need these to be set to that anymore. And if we run our tests, all right, the data we get back, we get the username. Oh, sorry, that's not what I want. This print. We get the ID, the email, and the created at. So what we'll do is I'm going to actually take this dictionary and I'm going to pass in the password as well. Because when I actually go to log in the user, I need to make sure that he has access to what my password is. But that doesn't get returned in the response. So what we have to do is we'll have to add a new field. So I'll say new_user equals, res.json. So we get that dictionary. And then we'll say new_user. We'll add in a new key called password. And I'll pass in user_data, which is this dictionary up here. And we'll grab the password from here. And what I'm going to do is then return new_user. And so anytime someone calls test user, or anytime we have a test that's dependent on that, it's going to run this function. It's going to return the new user. And so now that we have the new user, what we can do is I can say the username is test_user. And then we'll grab the email key. And then the password will be test_user. And this will be password. Okay, and so that way, if I ever change the password up here, it's going to automatically get updated down here. So we don't ever have to worry about that. And one thing to note is that technically, if I deleted this and just called test user, right? Test user would technically call client, right? And that would go all the way back here. And then client would technically call session. So it would call all of these functions automatically for us. However, the one issue is that in this test, we still need to make a call with client. So we still have to pass in the client object so that we can make use of it. But I did want to highlight that because this fixture is dependent on client, it will run whatever code is in the client fixture. And because client is dependent on session, it will run whatever code is there within the session. So it's all done automatically for us, right? So the order, once again, is going to be we'll run session first, we'll then run client, and then we'll run this test user. So let's test this out now. Hopefully this works. And it passed. Perfect. Look at that, guys. We were now successfully able to log in a user. So that's cool and all, but I want to do a little bit more validation for the login user route, just to make sure that, we got a token, the token is valid, and just do a few extra checks. So just like we did with the test create user, we can make use of the Pydantic model that we use for the response. So if I go into my auth.py under routers, and we can see for the login, the response model is set to a schema token. So let's import token inside our test users.py. So here, schemas, we already have access to schemas. And so I can say token, or what should I call this? I'll just call this login res, which equals, and then we'll call in schemas dot, I think it was a token. Was it token or token data? I think it was token. Well, let's just double check. It's token. Perfect. Okay, so token, and then what we're going to do is we're going to spread res.json. All right, so that's going to perform a little bit of validation. All right, and then when we get a token, I want to actually validate it. So how exactly do we validate it? Well, we want to decode the token. And so all of the logic that I'm going to implement here is essentially the logic that we use within our OAuth2 py file. So when we want to get the user, we want to verify the access token is valid. So how do we do that? All of the logic is right here. So we're going to decode the token, and we're going to make sure that the user ID is within that token. And that's all I'm really going to do at that point. So I will copy this. and we have to import JWT from, I don't know if it's Jose or Josie, who knows. So we'll import JWT. And what we'll decode is going to be in the login_res under the access token property. And then we have to pass in the secret key as well as the algorithm. So the secret key can be accessed with settings. Well, I have to import my config. So I'll say from app.config import settings. So now we have access to our environment variable. So I'll do settings.secret key. And then the same thing goes for the algorithm. So I'll set this to settings.algorithm. So we're able to decode it. And then I'll remove this check. I'll just say ID equals payload.getUserID. All right, and so once we get the user ID from the token, what we can do now is I can just assert does ID equal, and then is it going to match the ID of test user? So if we take a look at what test user was, that's coming from this fixture. And so it's going to return, oh, it looks like I did not, no, it should be in there. So since we grabbed the response, the ID should be there. So we can just call this test_user, and then we can just call ID. So I think that's a little bit more of a valid check because it's actually decoding the token just to make sure we didn't break anything there. And one more thing, we can assert login_res token type. So this should be set to bearer. All right, so let's test that out now. And everything worked. I think I've got one random print statement that I don't want, so I'll just remove that. And we have now successfully completed our login user test. Okay, guys, so before we actually create any more new tests, what I want to do is I want to create a special file under our test directory called conftest.py. So this is a special file that Pytest uses, and it allows us to define fixtures in here, and any fixtures you define in this file will automatically be accessible to any of our tests within this package. So it's package specific. So anything within the test package, even sub packages, will automatically have access to any of these fixtures. And the reason why I want to do this is I want to take all of our database code, essentially, or well, our database fixtures, and I want to copy all of it. And I want to move it to conftest. And so by moving it to conftest, this fixture, the session fixture, as well as the client fixture, will all be accessible to, test calculations, test users, any other test files within the test folder automatically. And so now I don't actually have to import anything. So I don't need to import from conftest. It'll automatically do that. It'll automatically have access to client, and it'll automatically have access to session. And what I'm actually going to do is I'm going to move this test user to conftest as well. Right? And so that way, because I've imagined that even for other modules that I create, especially like for voting and creating posts, they're going to need test users as well. So it makes sense to put this in this conftest so everyone has access to it, and I don't have to go around constantly importing things around like that. And now within our test users, I should be able to leave everything else. And you'll see that we're not importing client or test user anywhere here. But when I run this, we should see no issues. So let's give this a try. And you can see all of our tests passed with absolutely no issues because we are importing those from the conftest file. And keep in mind, let's say I created a new package. I'll call this whatever. How about API or something? It doesn't really matter what I call it. And I've got a whole bunch of tests in here, test_something.py. Because this package is still within the test package, it'll have access to all of the fixtures in the conf test py. But within a package, I can also create a new conf test. So I can make a new conf test.py down here as well. And when I do it within this package, then test users doesn't have access to that one, but anything within the API package will have access to the fixtures in the API folder as well. So conf test is package specific. So every directory you create, you can create a separate conf test file so that you can essentially scope fixtures, or you can make it so that fixtures are automatically imported into certain parts of your tests and not others. But we'll delete that because I don't actually need that. All right, so we've finished our successful login user test. The next thing we want to test is for a failed login. So I'll do the same thing. I'll call this about test incorrect login. And once again, a few things need to happen. We want the test user so that a test user gets created so we can try to log in with his credentials, or at least with the wrong credentials this time. And we do need access to client just because we're going to be making a request. And here I'll say res equals client.post. And we'll say login. And for the login data, we'll say data equals, and then we'll do a dictionary. Here, the username, we can use, in this case, test_user email. And then for the password, we could just give it any arbitrary password. We'll just say wrong password because we know that's the wrong password. And so when a user enters in their wrong credentials, we should get a 403. So we'll say assert res.statuscode equals 403. And in the response, it should tell us that we have invalid credentials. So I'll say assert response.json. So we'll convert it to JSON. We will get the detail property, and that should equal invalid credentials. Make sure you get the capitalization correct because it's going to do an exact comparison. And just to confirm if that's what the capitalization looks like, it should be invalid credentials. So just copy it directly from here. And this should be res, not response. Let's try this out. All right, and the incorrect login worked. Perfect. So that means we did receive a 403, and we did receive the message invalid credentials. But not only do I want to test the wrong password, I also want to test wrong email as well. And I also want to test wrong email and wrong password and a few different things. So how do we do that? Well, we can use parameterize, right? So let's import Pytest, which we already have. And we'll define our decorator. So pytest.mark.parameterize. So what are the properties that we want to pass? We're going to give it the attempted email, the attempted password. And then we could also get the status code. And we could also, match on a specific detailed message if you have a different detailed message for wrong password, wrong email, but we don't. So I'm not going to include that. And then now we'll just give an array with all of our, why does it do that? And so here we'll define our tuples. And I'm going to copy and paste this part just because I don't want to have to make you guys sit through this, but I've got a couple of different test scenarios. So here I've got the email being wrong email at gmail.com with the correct password. We expect a 403. I've got the right email, wrong password. I've got the wrong email, wrong password. I've also got no email. So if you put none, this is essentially leaving it blank. So with this set to none, you'll see that our API actually will send a 422 because the schema validation fails because it expects a username or a password. And then we'll try sending it with the correct email, but no password at all. We should get a 422 in this case because Pydantic performed its validation and found that it was missing fields. So that's what I'm doing here. And then we're just going to update all of this. So the email, the email is no longer going to be test user. It's going to be, well, actually, first of all, we have to pass it into our function. So email password, and status code. So we'll say email, password is going to be password, and status code is going to be status code. And we'll get rid of this check just because the invalid credentials won't apply when we get the 422. So let's try this out now. Yep, and we can see all of our tests have successfully passed. So we have now finally set up a test for making sure that when a user does not provide the proper credentials, we get the right response code and the right data back. And keep in mind, guys, right, in this case, I just set this up to be a very simple test just to check on the status code, but you could check any single field that you want. It's up to you. You can make your tests as specific as possible. You can make them a little bit more generic. It's up to you to decide on what you want to validate yourself. And like I said, I'm trying to keep this as basic as possible. Try to just make sure that we focus on how to actually create tests and less on the actual specific tests. If that's all of the things that I want to do for all of the user tests, let's move on to all of the post tests. So tests when it comes to creating, reading, updating, and deleting posts. So I'm going to store this in a separate module just to keep things nice and organized. However, you can keep everything in one file if you really wanted to, but no reason to do that. So I'll call this test_post.py. Now, when it comes to working with posts, we do have to deal with a little bit of an extra challenge. And that is, if you take a look at all of our posts path operations, they all require authentication. So how exactly do we deal with authentication when it comes to testing? Well, you're probably thinking, we could, define a post, define a test, and we can call this, get all posts or something, right? And then here we can pass in client, and then maybe test user. So we have access to that. And then we would just do, client.post login. So we log in, we get a token, and then after we get the token, then we can make a request to posts. And that is technically valid, but what I would like to do is I'd rather set up a fixture that automatically does this for us. But instead of actually making a request to our API, I want to just import the method, the OAuth2 method for creating an access token. So we could just import this into our test so that we can actually fake our own token or create our own token without having to use the entire API and go all the way through back into this same exact method to get a token, because that seems like a waste. And we're testing a whole bunch of other things that we don't want to test in this specific test. So what we're going to do is we're going to go to conf test, and I'm going to create a new fixture. I'm going to grab this, and I'm going to call this token. So we'll say token, and this is going to be dependent on test user. So we need a user to get created first before we run this fixture. And what we're going to do is we're going to import this specific function right here, create access token from OAuth2. And so I'll go from app.oauth2 import create access token. And just to quickly recap on how that function works, we pass in a dictionary, but I don't actually know what is in the dictionary. So let's go to, where is this? Who calls this? I think it's, no, it should be under users. Yeah. So create user. No, it should be under login. So under login, this is where we create the token. So we pass in data, which is just a property called user ID, and then we pass in the ID. That's all. Pretty straightforward. So we can do that. So I'll call create access token. And it's going to be a dictionary, and we call this, what is it, user underscore ID. And we're going to pass in, and we can get the ID of the user from test underscore user, which is being passed in, and we'll grab the ID property. And we'll just return this. So this is going to return a token, and that's why we call this function token. Then what I'm going to do is I'm going to create another fixture. I know there's a lot of fixtures here, but you'll understand why I want to do this. So I'll do def And here I'm going to call this authorized _ client. The reason I'm calling that is if we take a look at our current client, this just gives us an unauthenticated client. This new fixture will give us a authenticated client. So anytime we want to deal with any path operations that require authentication, we can just call this client the authorized client instead of the regular client. So that's going to save us a lot of time. And this is going to require the regular client and token because we need to get a token. All right, so we have access to the original client. And what we can do is we can update the headers because we need to pass the token inside the header. So we do client.headers. And then we have to pass in a dictionary. And what we want to do is we want to spread out all of the current headers. So we do client.headers. And then we want to add one more, which is going to be the authorization. And this is going to be an F string because we need to add the word bearer before it. And then we can pass in token. And then we'll return this client. So it's basically taking the original client and then just adding this specific header that we get from the token fixture. That's all. And so now when we go into get all posts, and I forgot to put the word test before it. Instead of client, we want to import authorized client. And we don't necessarily need test user at this point. It'll automatically get called because, this calls token, token calls test user. We only need to pass in test user if we want access to specific user data, but we're not using any of that information at the moment. So I'll do authorized client.get, and it's going to be /posts. We'll set the response equal to that. And we'll just do a print res.json just to see what that looks like. And I believe the status code should be a 200 because we're retrieving data. So I'll do res.statuscode equals 200. So let's just take a look and see what exactly is happening here. And now it's going to be test posts. And we get an error, so let's see what happened. Authorized client not found. So I think I forgot to save. Let's try this again. And I forgot to turn this into a fixture. So right now it's just a regular function. So let's make sure I add the fixture there so it's accessible to everyone. And now if I run this. Okay, so one passed. Let's take a look at the data that we got back. So when I did a print of res.json to see the data, I got an empty array. And the reason we got an empty array is that there's no test data in our database. There's no test posts. So we're going to have to actually create some test posts before we run this test so that we can actually verify that we got what we expected to get. So just like we did with the login user where we created a test user before, we're going to have to do this with our posts. We need to create a whole bunch of posts and then verify that we are able to retrieve those posts. So we'll tackle that in the next video. So let's create a fixture that will create a few initial posts so that we can actually test retrieving all posts. And we can use that same fixture for performing a few other tests. So things like updating a post, right? We would need to have a post in our database to update a post. Same thing with deleting. Same thing with getting an individual post. So this fixture is definitely going to be very reusable across a lot of our tests. So let's figure out where we want to store our fixture. We could keep it in our test.posts, test_post file, because all of our posts, all of our test posts, our tests for post data, I guess, if you want to call it that, will require that fixture probably. However, there are going to be other tests in our application that will need posts initially. So when you want to vote, we need a post already in our database. So I'm actually going to put it in our conf test file so that everyone has access to it. Well, technically anyone can access any fixture if they import it, but having it in the conf test file makes it simpler because we don't have to import it. So I'm going to put it in here. And this fixture is going to be a little bit different just because we're actually going to create the posts in the database ourselves. So here I'm going to call this test_posts. And so what we need is a couple things. So first of all, we need a test user, because if we don't have a user, we can't create posts, because all posts need to be associated with the user. Since we're going to work with the database, we're going to pass in session also. All right, and let's define some post data. So I'm going to create an array of dictionaries. And I'm actually going to copy and paste some data just because I don't want you guys to sit and watch as usual. All right, so what we're doing here now is we're creating 3 posts. So in this post data, I have an array, or sorry, in a list, and then a dictionary, and then here we're providing the title and the content and the owner ID. All right, so that's going to create a post, and we're grabbing the owner ID from the test user fixture, and we're just going to grab the ID from that. So we're setting the owner ID, and then I'm just going to create another post here and another post here. So the same user is essentially creating 3 posts. And so now, since we have access to session, we can actually just directly tap into our database and create that information for us, or those posts. So we can do, when it comes to Sqlalchemy, if you want to add multiple entries into a database, we have access to the add all method. So we can call session.add_all. And then here we have to pass in a list of user models. So this would be, schemas. Sorry, not schemas. We'd actually have to import models. So I'm going to import. Do I have models already in here? Doesn't look like it. So I'll import that as well. So we'll say from app. Let's just say from app import models. And I can say models.user. So we'll create a new user model, and then we have to pass in all of this data. So, right, we would need to be title equals, blah, and then content equals blah. And then we'd have to do another one. So I'd copy this, paste this in here, and so on. And then this would add it all at once. Now I can manually hard code this value into here just to kind of keep things simple. And I could do that. And actually, I will show you how to do that just in case. But I'll show you what I did when I was doing a dry run. So I'll copy the title. This is going to be set to first title. The second title is going to be here. Content. And second content. And then the owner ID is going to be the same for both, luckily. Well, all 3 actually. And that's not in the right format. Oh, don't do that. It should be equals. And the same thing here. And if we wanted to, we can copy this last one and then put the third one in. This will be called third title, third content. All right, let's save this. The auto formatter did not do much to help me out here. It still looks pretty ugly, but that's okay. And so that's one way of doing this. So it'll add it all. And then all we have to do is just do a session.commit. And then to get all the data back, I can just do a session.query. And we'll just say models.post. Oh, this should be user, by the way, not, this should be post, not user, because we're creating a post and not a user. We'll say models.post. And we can just grab all of them. Now, if you wanted to be able to take this dictionary and convert it easily to this format, there's a couple things you have to do. But technically, you could just leave it like this and it'll work fine. But this is a little bit more of Python than anything else. If you didn't want to hard code it in like this, because at this point we don't even need this dictionary. But if you wanted to take this dictionary and convert it into a list of user models, post models, what we can do is we can use the map function. And so the map function works like this. You call map, then you call some function that you define yourself, and then you call the posts underscore data list that we have up here. And so this function, what it's going to do is it's going to iterate through this list, and it's going to take each item in the list, which is a dictionary, and it's going to convert it into a models.post. So how exactly does that look? Well, first of all, let's rename this. And I'm just going to call this maybe create user model. And I'll define a function up here. And I don't know why I keep saying user. It's a post. We're creating posts, not users. Create post underscore model. And this is going to get passed in some object, but technically what's going to get passed into this function is each dictionary. So I'll call this post underscore data. Well, actually, don't call it post data. I'll just call this post. And so we have to put the logic of converting a dictionary into a post model. And that's pretty easy. All we have to do is just say models.post. And then we take post and then we spread it. That's it. All right. So what's happening here is we're taking a dictionary, which is what it's going to get passed into here. And then we're taking it and spreading it so it looks like title equals blah, content equals blah. And then we can just return that. And then this map, we just set it equal to some variable. I'll call this maybe post map. And I'm forgetting an E. Okay, so that's going to return. So that's going to essentially convert all of those to user models, but it doesn't return a list. It returns a map, which isn't quite the same thing. So to convert it to a list, all we have to do is then say posts equals, and we just say list, and then post underscore map. So that'll convert it to a list. And then under session.addAll, instead of hard coding those values, I could just say session.add underscore all, and I just pass in posts. And we can just comment out this line right here. Either one works. Choose whichever one you like. I don't really care. But this is all we need to do. We just have to return this. So I'll save this as posts. And we'll return posts. And that should create 3 posts in our database. And so now if I go to test posts and make this reliant on, what did I call it? Get test posts. If I then run this, right, you can see that we did in fact get multiple test posts. And it's up to you to decide what checks you want to perform. If we go to our post route and we take a look at the schemas, you can see that it's going to be of type list of schemas.postout. List comes from the typing library. So let's see if we can actually do this. I never actually tried this with this, but I think it should work. So I will import that. And then we'll also import from app, import schemas. And I'll just say posts equals res.json. And I'll say actually schemas dot, what is it? Post out. Yep, it's going to be post out. I don't think that'll work because, this is expecting one individual post, but this is going to be a list of posts. So I wonder if I can do, we'd have to do this manually. Like we'd have to iterate through it and then basically copy it out. And I think that would just take too much work. So we'll leave this section out. If you guys want to take that as a challenge, you can essentially create a post Pydantic model for each entry within the response, and then try to validate each single one. So instead, I'm just going to do a simple check. I'm just going to say assert, and we'll just grab the length of response.json. And I'm going to set this equal to length of test_posts, just to make sure that we get 3 exact posts. And if we ever change the number of posts that we have, this should automatically get updated. I think that's a good enough check for this test. So let's try this again. And we shouldn't get any errors, and it looks like it passed just fine. All right, guys, so I figured, you know what? Let me go ahead and just show you how we can actually do the validation using our schemas. We're going to use the same exact logic that we use here when it comes to performing the map, because we're essentially going to take a list of dictionaries and convert it to a list of schema models. So we're going to go back to our test. And what we're going to do is we're going to first define a function that's called, we can call it validate. And this is going to receive a post. And that's going to be a post, that's going to be a dictionary that we get back. And all we're going to do is we're going to return schemas.postOut. And here we're going to pass in the data. We're just going to unpack it with post. So that's all we have to do. And then we can call the map function like we did before. And I'll store this in a variable called posts_map, which equals map. We're going to call the validate function, and we're going to pass in res.json. And so we have a map. If you wanted to, you could technically convert it to a list by calling list post.map, but we're not doing anything with that data. However, just to show you, we can just print this out real quick. And so now if I run this, and we take a look at the print statement, you can see we've got a post out model, and it does all the validation. So it's going to make sure all of the properties are set and are there. And because we have it set as a post out Pydantic model, you'll see that it's very easy to perform extra checks with the assert statement. So now I can do other checks like maybe I want to say, actually, let me first save this as a variable. I'll say posts list equals list of posts map. Ooh, and that's supposed to be posts map. So we have access to this list. And now what I can do is I can just say assert. And here we can grab posts_list, grab the first post. And we can check certain fields. I could say like, hey, does the ID, it's going to be the post.id. Does that equal test_posts? We'll grab the first object and then grab the ID. Well, actually, it's going to be, I think I could do just .id. Yeah, because test post, keep in mind, when we do test post, this is going to return, not a Pydantic model or a dictionary, but this is going to return a Sqlalchemy model. So a little bit different, but we just call it .id, and I think this should work. So let's test this out. It did not work. What happened here? Yep, so I accidentally grabbed, I see, yeah. So this is expected just because I don't know the order that we're going to retrieve the posts in. I didn't provide a order by filter criteria when it comes to my my get post functionality. So it could be returning any post. So right now it's saying that, hey, this ID happens to be 2, this one happens to be 1. So the order doesn't matter. So this isn't exactly the best way to do it. But if you want to figure out a way to set up the order so that you always receive maybe the post with the lowest ID and then you compare the two, that would be perfectly fine. And then you can check other properties like what's the title? Does it match up with what we should expect it to be? Does the content match up with the content? You can put as many asserts as you can. But by doing this, we are able to perform a validation to ensure that at least we get what we expect. All the fields are there, and then it's just up to us to set up the necessary asserts to verify that the values are correct. But I'll remove that, and I think it's okay just to keep it like this for now. All right, so we set up a test for getting all posts. And what I want to do now is I want to test to make sure that a unauthenticated user is not able to retrieve all the posts. So I'll create a new test and I'll call this test, how about unauthorized user underscore get underscore all underscore posts. And instead of using authorized client, because we want to test if a unauthenticated user tries to access it, they get a 401, we'll just use the regular client, which is going to be a non-logged in user. And we want to make sure that test posts are here as well. And remember, because we're calling test posts, that's going to ensure that because test post is reliant on test user, it will in fact create a test user as well. So just to give you a heads up, we don't actually have to pass in test user into here because this should handle that automatically. And here I'll just say res equals client.get, and we'll just go to posts again. And I'm just going to assert a simple 401. So res.statuscode equals 401. That's really the only check I want to do. If they're unauthorized or unauthorized, there's no other things to check really. And we can see that it did successfully pass. Okay, so we've tested the get all posts. We're going to now move on to getting an individual post by an ID. But before we do that, I think it's best to actually test getting an individual post by ID when you're an unauthenticated user, because we can essentially just copy this code. And I can just paste it here. And instead of doing a user get all post, this will be user underscore get one post. And so everything else can be the same. We just have to change the specific URL. And so in this case, we're just going to grab the ID of one of the posts. So here, I'm going to change this to an F string. And I'm going to say test underscore posts. We'll grab the first one. And then remember, this is a Sqlalchemy model. And so we actually have to convert it to a dictionary. So we have to do dot underscore underscore dict underscore underscore. Sorry, the test posts is not a SQL. Is it a SQL? I think I could do ID. I think that should work actually. Never mind. I think we should be able to do that. That should be fine. And this should be a 401. So let's test this out. Let's make sure that this works. And that works. And what I also want to do is I want to test for a post, to retrieve a post with an ID that doesn't exist, I guess. So I'll call this a def test get one post. How about not exist? So this one, we're going to need an authorized client. And then test underscore posts as well. And I'm going to copy this. But we're going to change this, and I'm going to hard code some random number, like 88888. And then we'll just assert res.status underscore code equals 404. All right, so now we're going to try to retrieve a post that doesn't exist, and it looks like it passed perfect. So now let's actually try to retrieve a valid post. This one's going to be a little bit more work. So we'll say def test get one post. And we're going to copy these two. And I'm going to copy this one right here. So we're going to retrieve the first post from test post with an ID of 0, I think. And I'm just going to rename this to authorized client. And let's just do a print. Let's see what this looks like. So we'll say res.json. All right, and that's going to run. And it printed out the post so we can see what that looks like. And just like we did before, we can also do a validation. So I can say post equals schemas dot, what is it? I think it's post out. Yeah, post out. And we're going to pass in res.json. And do we need to unpack it? I think we have to unpack it. Let me print out post just to see what that looks like. Actually, I could just take a look at what we did up here. Yeah, we have to unpack it. Or spread it, whatever it's called. Yep, so now we've got our post model. Well, it's our Pydantic model. And so that does some level of validation. And then at this point, what we can do is I can say assert, and I could say does post dot, and then take a look at the format. We have to grab the post property. Actually, it's this first one. Yeah. So we'll grab post.post.id equals. Then we're going to compare it to the ID from test_posts. So it's a test_posts 0.id. And I think that should still work. All right, that works. And we can check a few other things. So we can say post.post.content. And if you're wondering why it's post.post, remember, if you actually take a look at our schemas, our post out, you can see that we have to grab the information about the post, we have to go into the post property. And then from in there, we can then take a look at all of these fields. So that's why we have to do it like that. And we'll say test_posts 0. And then let's see if we can do content. I believe this will actually throw an error because this is a Sqlalchemy model. So it's going to, oh, that actually did work. I'm surprised. Okay. All right, that worked. So if you guys want to, you can also essentially copy this line and then check to see if the titles match. You can essentially check every property if you really want to. So we'll just run that one last time. Perfect. And I'm just going to remove this print statement. And so those are all of the tests that I want to do when it comes to retrieving an individual post. I think I'm sure there's a couple of tests you guys might be able to think of, so feel free to implement that, but I think that's a good starting point on this. But in the next video, we'll take a look at creating a post. Okay, so let's move on to creating a post. I'll create a function. We'll call this test create post. And we're going to need an authorized client. We're going to need a test user for sure. And lastly, this is purely optional. If you want to, we could also set up all of our test posts if you wanted some posts in the database before you created one, just to potentially see if you run into any issues when it comes to creating posts when there's already posts, but it's optional. And we're going to set the res, and we'll set this to authorized client.post. And the URL is going to be /posts. And then let's give all of the data for our new post. So we'll say JSON equals title. And you know what? Instead of doing this, let's go ahead and set up a Pytest. What was it called? I already forgot what did we call it? A parameterize. So mark parameterize so that we can test multiple different values. Mark dot. Why is that not working? Okay, I have to import Pytest. And we don't need this line right here, so we'll say import Pytest. And so what are the values that we need? How about title? We need title for sure. We need content. And then we can also give a published value if we wanted to. And then let's give all of our... Come on, VS Code, don't do that. All right. First tuple. What do we want the title? How about awesome new title? Ooh, awesome new title. What's the content? Awesome new content. And what do we want published to be? How about true? And we're going to copy this, and I'm just going to put in some new values. favorite pizza. And we'll say, I love pepperoni. Ooh. Published. Let's say that's still a work in progress. Tallest skyscrapers. All right, so we've got some test data. Let's pass those values in. So title is going to be set to title. Content is going to be set to content. And then finally, published will be set to published. All right, we get a response back. Let's do a little bit of validation with our Pydantic model. So I can say schemas.post. And we'll just take the response, convert it to JSON, of course, and set that to created_post. And then we can just run a couple of checks. So let's assert the status code. So for creating a new post, it should be a 201. And then for, we could just assert a few extra values. So I could say like res dot, actually I can grab created_post dot title should equal title. And I can just do that. Whoops. I need 2 equals. And then I can just copy this a few times. We'll change this to content. Content. And then published. And while we're at it, we could also verify that the owner ID gets set. So I can say created_post dot owner_ID equals, and then we can grab test user ID. So I think that's a good number of things to check. So at this point, I think it's safe to say that all of these should work. All right. And all of those passed. Awesome. So we've got the create post done. There's one other thing that I want to test with create post, because if you go back to our, what is it? Our schemas. Where's our schema? I don't know if we have a create post create. So that's just going to be from post base. We can see published is set to a default value of true. So let's test to see if the default value of true gets set. And we theoretically could have put this test in here just by doing a none here, but I like to separate this out into a different test because we are testing a different functionality in this case. So we'll say test create post default published true. I'll do authorized_client and test user. Once again, we don't need test posts, but if you want to have it in the database just to make sure that everything's not broken when you already have posts already in there, we can keep that in. And I'm just going to copy this. Actually, I could essentially copy all of this. And we could just give it arbitrary titles. And then published, we'll leave out published. We don't want that anymore. And I'll just copy these values here. And published should be set to true by default. So even though we're not passing it, it should get set. And everything else should still be just fine. So let's test that out. Oh, it looks like it failed. So what happened here? Oh, I just pasted in the wrong values. All right. And then one last thing, just like we did for all the other routes within the post, we also want to test if we're not logged in. So I'm going to copy this one and just rename it. So test unauthorized user create post. We don't need to have test user in there, but why not? And I'm going to just copy this right here. And then just change this to a plain client. All right. And this should work. All right. And that passed as well. So we have got all of the create post tests done. I think in the next video, we will tackle either deleting or updating a post. Okay, so let's move on to deleting posts. And the first thing that we're going to do is we're going to test a unauthorized user trying to delete a post. So we'll say test unauthorized, delete post. And we'll have client test underscore user. And we'll definitely need test post in this case. And then we can essentially copy, well, I'll copy this one right up here. And we'll change this to, we don't need the body anymore. And the route is going to be, we're going to pass test underscore posts 0.id. All right, let's test that out. Yep, and I realized this should be a delete actually, not a post. That's why I got some other status code. Perfect. All right, so we got that one to pass. And so now let's test a valid deletion. So I'll say test delete post. And ideally, I guess we should be calling it like success, like we successfully deleted it. And this time we'll get the authorized underscore client. We'll get the test user and the test underscore posts. All right, we'll call this same request here. And just change this to authorized client. And this should give us a 204. I mean, you theoretically could also, then fetch all posts again, just to verify that the total number of posts is one less, but we're not going to do that in this case. You could, however, do that. And that failed. So what happened here? A 422. And two things. So I don't even know how this one ran with the same issue. We need to make that an F string. So I genuinely don't know why that actually worked. Little alarming, but let's test both of those out. All right, all of them passed. So we've got that done. Let's test deleting a non-existent post, so an ID that doesn't exist in our database. I'll say test delete post non-exist. And I'll just copy these. And I'll copy this. Actually, I'll just copy all of this. And I'll just change this to be some ridiculously high number. And this should be a 404. All right, that one looks good. All right, so the next one's going to be a little bit trickier. We're going to create a test where a user tries to delete a post that isn't theirs. So they try to delete a post that's owned by someone else. So we'll say test delete other user post. Now, there's a couple of issues here. So first of all, we need to actually have more than one user in the database, and we need to have posts owned by multiple users now. So this creates a couple of challenges. So how exactly are we going to set up more than one user? Well, I think it's best to use fixtures like we always have. And ideally, I would have set up a test user. Where is it? My test user. I would have set up a test user to actually create multiple users in our database, but I didn't. So I just have one. If we had set it up so that multiple users are in the database, then this test would be a little bit easier. Since I didn't, what I'm going to do is I'm essentially going to copy this. I'm going to copy this. And right above it, I'm going to create just a second one. I know it's not very original. Probably not the most efficient way of doing things. And it's going to be dependent on client. And we're just going to put a 1 or something. It doesn't really matter. Just so that we have another user. I'll make this 1, 2, 3. And so now we have 2 users, which is perfect. Down here in my posts data, what I'm actually going to do is I'm going to create one extra post. And we could just copy this data right here. And here, I'm actually going to pass in an extra fixture, which is going to be test_user2. So before test post gets created, we're going to create the second user. And here I could just grab the ID of test user 2. And actually, I don't even need to do that. I don't know why I did that. We don't even need to create a post owned by that user. We'll leave it like this for now. Nope, I was right. Actually, we do. I don't know why I'm flip-flopping like this. So the fourth post, 1, 2, 3, 4, is going to be owned by test user 2. And so now if I go back to test posts, here we're going to be logged in. Remember, authorized client is always going to be logged in as user 1. So we're going to try to delete that fourth post. And so we can do that by grabbing the ID of the fourth post. So we'll say need curly braces, test_posts. We'll grab the fourth one, which is an index of 3. And then we'll grab ID. And this should, I forget what kind of error it should get or what status code. I think it's 403. So we'll do assert res.status _code == 403. And it looks like that successfully passed. And so that one's good. And that pretty much wraps up all of the delete tests that I want. And then in the next video, we'll take a look at updating posts. All right, so let's update a post. I'll say def test_update post. Here, we need an authorized client. And we'll need a test user. And we'll need test_posts. All right, and I'm going to define a dictionary with the values that I want to update. And so here I've got the title, the content, and then the ID, which I'm grabbing from test posts. And I'm just going to use the first test post in there. And I'll say res equals authorized client dot, I think it's put. And then we're going to do an F string. And we'll say /posts. And this one will be test_posts 0.id. And then we have to pass in the data. So we'll do JSON equals data. So we're passing in this dictionary. Right. And just like we do with the other routes, if we go to the update post, Technically, we're sending it out with the schema of post, so we can just quickly validate it on our end on the test as well. So I can say updated post equals schemas.post, and we'll pass in res.json. And then we can assert a couple things. So we'll say res.statuscode is going to equal, what's an update? I guess we use 200 in that case. And then we can assert a few things. So we want to make sure that the new title, we can do updated underscore post dot title equals data dot updated. Data dot, this is a dictionary, so title. And we can do the same thing for the content. And I think that should be everything that we need. And just to, just to make sure that my tests don't take too long, I'm going to start commenting out all of my other code, all of my other tests in this file, just to make things a little bit quicker. But you can see how it starts to slow down just with just a couple of tests, really. So we can see that it did successfully pass, so that's good. We've got the first update post test. The next thing I want to do is I want to try to update another user's post. So we'll say update other user post. So this we need authorized client. We need test user. And we need test user 2. And test underscore posts. So we're going to try to update that last post. And so I'm going to define a dictionary with the values I want to update it with. So same thing, title, content. The only difference is the ID is going to be, I think it's actually 3. So the ID is going to be of the fourth item in that list. And I just want to make sure it's the fourth one. So 1, 2, 3, 4. So yeah, we need a value of 3. And I'm going to copy this. And just change this to 3. And we should get a status code of 403. And let's test that out. Perfect. And the last thing we need to do is a unauthenticated user trying to update a post. Actually, there's 2 more tests. So let me grab unauthorized user, this one right here. And this is going to be a put. And that should return a 401. And the last thing that we need is, and actually I need to update this name. So unauthorized test update post. We can also set up a test to update a post that doesn't exist. And I believe we can just copy the deleting the post that doesn't exist. Delete post non-exist. So I could just copy this one. And change this to a put. And we'll change the name to be update. And let's test this out. Hopefully everything works. Oh, one failed. What happened here? Okay, so it tries to validate it because I didn't provide any data. So I can just copy this data right here just so we can give it something. And so we can say JSON equals data. That's going to prevent us from getting validation errors. And that passed. Perfect. So let's take all that. And I'm just going to uncomment everything else so we can get all of our tests back. And that's going to wrap up updating posts. And that's actually going to wrap up all of my post cases. And so I guess the last thing that we got to do is set up all of the voting tests. And there's only going to be a couple of voting tests, but it should be fairly quick. All right, so let's move on to setting up our tests for voting. I'm going to create a new file. We'll call this test_votes.py. And let's define our first function. So I'll call this test vote on post. So this is going to be a successful vote on a post. What do we need? We need an authorized client, of course. And we need to make sure that there's some posts already in our database. All right, and now I can do a authorized client post. And here, this is going to be to the vote endpoint. And let's just give it some data. So here, we're going to pass the post ID. So this will be post_ID. And we'll grab the first item in our list, testpost.id. And I forgot my curly braces. That's why it's giving me an error right now. And we'll say, what is the direction. So we're going to be voting. So this is going to be dir set to 1. All right. And now technically, if you look at what's happening, right, we're logged in as user 1. And test posts, and if we go back to that fixture, where is this guy? That's owned by user 1 as well. So technically, we're voting on our own post. But if you look at our code, we didn't actually put any checks to stop us from liking one of our own posts. So it's perfectly fine in our test to do that just because our code is right now allowing it. If you didn't want to do it, then first of all, we'd have to update this code to make sure that we perform a check to verify that, hey, are we voting on our own code? If so, voting on our own post, then we should reject it, but we don't have that implemented. So for our test, it's perfectly fine because that's how our application works. But obviously, if you wanted to make sure that you're testing someone else's post, then you could just obviously pick the last item, so the third item in the array, because that's owned by test user 2. You just would have to make sure that you pass in test user 2 in this case, just to make sure that he gets initialized. But that's a good assignment for you guys. I would see if you guys can implement logic to make sure that you can't vote on your own post, and then go ahead and create your very own test to make sure that if a user tries to vote on his own post, he gets an error of some kind. But for us, this is good enough. I'll leave it as 3 just so we're voting on someone else's post. I'm okay with that. And we can just assert res.statuscode == 201. Don't really need to check anything else. And now I can just change this to test votes. Okay, so that one successfully passed. All right, the next thing I want to test on is what happens when a user tries to vote or like a post that he's already liked. So we'll call this a def test_vote_twice_post. And so we'll need an authorized client. We'll definitely need test posts. But there's one little issue with this one, right? We need to have a post that's already been voted on. And we don't have that right now. So how do we do that? Well, I mean, theoretically, we could initialize our test post fixture with some votes. But instead of doing that, I'm going to actually create a new fixture. And I'm going to keep it in this file because all this fixture will do is it will set up one of our posts to have a vote on it already. And I don't think really anybody else in any other test in our application is going to need that outside of the voting file because that's the only one that's concerned with voting. So let's test that out. So we'll import Pytest. And we'll set up our fixture. So pytest.fixture. And I'll call this test vote maybe. And so for this fixture to work, we definitely need an authorized client. Actually, we don't need an authorized client. We'll need test posts. We'll need a session because we're going to just change it in the database directly. And then we'll need our test user. And so let's, we're going to have to import our models. So I'm going to say import, not import, from app, import models. And I'm going to say models.vote. So let's create a new vote. So we're going to have to pass in the post underscore ID, which is going to equal test underscore user. We'll grab the third one, .id. And then we need to pass in the user ID, which equals, oh, it looks like we actually, yeah, we already have the test user. So I can say test underscore user ID. And then I can just do session.add new vote. And I need to create a variable or store this in a variable. So new vote. And then we can do session.commit. And so down here, I can pass in test underscore vote. And I'll say res equals authorized client dot post. And then JSON equals, what is the post ID? We'll grab this from test underscore posts. Grab the third. And we'll grab the ID. And then we'll set the dir to be a 1. So we're trying to revote on that vote. And we should get a 409. So we'll do assert res.statuscode equals 409. All right, let's test that out. One error. Oh man, what happened here? That's a key error, so something very simple happened. Yep, and I see my mistake. This should be test posts. All right, let's try that out now. And that worked. Perfect. All right, now let's try successfully deleting a vote. And so we will need all of these. We'll also need a test vote. And so we do res equals authorized client dot post once again. Ugh, I'm just going to copy all of this. So we got that. And then the direction is going to be 0 for deletion. And then we just need to assert res.statuscode. This is going to equal, I think we just left it as a 201. Okay, so that worked. And then now we want to delete a vote that doesn't exist. So unlike a post that we never liked. So we'll say def test underscore delete vote non-exist. So we'll need the same exact stuff right here. Okay, I'm just going to copy all of this for now, and then we'll change up the few details. Direction 0, same post. But I'll just grab, actually, we don't want the test vote because we want to make sure that there isn't a vote. So we're going to remove that fixture. And this should be a 404. Let's try that. that worked. And then finally, let's try voting on a post that doesn't exist. So we'll say, liking a post that doesn't exist. So we'll say def toast test vote post non-exist, and copy all of these. I copy this, set the direction to 1, and the ID is going to be 8,000. And we expect the status code to be 404 as well. All right, it looks like everything's good. The last thing that we just want to check is make sure that a user who isn't authenticated can't vote. So I will copy this. Test vote unauthorized user. And then we want just the regular client in this case. We'll do test posts 3.id. And this should be, what is it, a 401? I can't remember. Let me go to the other one. It should be 401. Okay. All right, guys. So I think we've covered all of the tests that I wanted to cover. We don't need this test calculations py file, but I'll keep it in there in the repo just so you can take a look at it. The database.py file is absolutely useless now, so I'm actually going to just delete. I'll keep it in there just in case you want to see it, but most of it's moved to conf.test.py. But just to make sure that everything's still working, I'm going to run my tests for all. Ooh, what happened here? Nope. Oh. Okay, yeah, that was wild. All right, remove this. Let's see what happens. Hopefully everything passes. And all 46 tests have successfully passed. So that pretty much wraps up all of the testing section. I recommend you guys think of different scenarios that could potentially break our application and set up tests for each and every individual scenario, because that's how you successfully set up tests, because you want to make sure you cover every individual corner case that you can possibly think of. Currently, when it comes to adding in new features and making changes to our code, we have to go through a very manual and cumbersome process before we can get those changes pushed out to our production environment. And so what I think would be good is for us to set up a CI/CD pipeline so that we can do all of this in an automated fashion. So I've created a couple slides just to kind of go over what our CI/CD pipeline is going to do. And I've got the generic definition of CI/CD, and it's probably not a very good definition. And I was thinking about just leaving out the slide because it doesn't really provide much, but I figured I'd just add it just in case. So CI/CD stands for continuous integration and continuous delivery. So continuous integration is the automated process to build, package, and test your application. And then the continuous delivery picks up where your continuous integration ends and automates the whole delivery of the application. So continuous delivery is responsible for actually pushing out those changes to your production network. So those two things make up our CI/CD pipeline. But let's actually take a look at what our whole manual process looks like right now so that we can see where a lot of the extraneous time consumption and manual process takes place. So our current manual process is that, we're going to make some changes to our code, and then we're going to commit those changes to Git, right? Because, we don't want to lose those changes. And then after that, we want to go ahead and run Pytest so that we can verify that our changes didn't actually break any known functionality to our code. And if our tests pass, we have an optional step of, building any images. So things like Docker images, if we happen to be running Docker in our development and production environment. If we're not, then this is an optional step. However, when it comes to the build phase, in this case, that some people referred to, other programming languages might require you to kind of build the application at the end to actually be able to deploy it. Python, you don't really need to do that. So that's why it's kind of an optional step here if you're not using Docker. But after we do that, we then move on to deploying our application. So I just have one row called deploy here, but keep in mind this one little block could represent multiple steps, because depending on how you actually deploy your application, making any changes or updating the code in your production environment could actually involve a very complex process. So with with Heroku, right, it's obviously a very simple process because all we do is we just do a git push to Heroku, and that's going to automatically cause Heroku to kind of handle all of the updating of the processes. So that's a feature that's built into Heroku, but we only get that if we use Heroku. There's obviously a number of different ways that we can deploy our application. If we decide to go the route of deploying our application on an Ubuntu server, then the deployment process in this case would be us logging into our server, us pulling in the new code with the changes, and then restarting the service so that our application actually uses the new code. But if you're using, some other production environment or you use some other method to deploy your application, this could be an even more complex process, something to keep in mind. So even though it's just one block listed here, it could actually be, numerous steps. All right, and so now I want to show you guys what our automated CI/CD pipeline is going to look like after we set it up. And so just like we did in the manual process, we're going to make changes to our code. Obviously, that's a manual step because we have to implement the changes to our code. And then we're going to commit those changes. And with a CI/CD pipeline, or specifically with the one we're building, that's all the manual steps that we have to do. We are done. We don't have to touch our keyboard or our mouse. It's basically hands off at this point, and we're going to let automation take over. And so usually when you commit changes to your code, that's going to trigger our CI/CD pipeline to run. And so what happens is our continuous integration phase starts at this point, as soon as we commit those changes. So in the CI phase, we do the first thing that we do is we pull our source code. So we pull our source code so that we can actually work with it. We then install any dependencies. So this is the equivalent of installing all of the dependencies listed in our requirements.txt file. We then run our automated tests. So that's running Pytest. And then, assuming the tests pass, we then build any images. This is once again an optional step for us. That's only needed if we use Docker. But that wraps up the continuous integration phase. So once that's done, the continuous delivery phase is going to take over. And so the continuous delivery phase, what it's going to do is it's either going to grab the latest code or the new build image, depending on what our deployment model actually is. And with the new image or code, it's going to then have all of the logic needed to push that new image or the new code into our production and make sure that our production is actually using our brand new code. And so these two steps are really the only manual steps. The continuous integration and the continuous delivery phase is all done in an automated fashion through code, essentially. And so some of the more common CI/CD tools include Jenkins, Travis CI, Circle CI, and Github Actions. Now, for our course, we're actually going to use Github Actions just because it's already integrated into GitHub. It's free. We don't need to install anything on our local machine. There's no software that we have to set up because it's all hosted on GitHub. So it's like a hosted service, and it's just going to make things very clean, very simple, and it's free. So it's going to make, and so everyone will be able to have access to it. So what exactly is a CI/CD tool? What does it provide? And so every time I heard CI/CD before I learned what it is, I always thought it was a very complex thing. And then when you find out what it actually is, it's actually just stupidly simple. Right? There's no magic behind CI/CD. It's all very manual, even though it's an automated process. You'll see that when we actually go to configure it, it's not really doing anything special. It's doing everything that we already do, but we're just providing instructions to a machine. So a CI/CD tool, what it does is it provides us a runner. And so a runner is just a fancy term for a computer or a virtual machine. It doesn't really matter, what is the underlying infrastructure. They give you a little machine that we can provide a bunch of commands for it to run. Right? So just like in our terminal where we run commands like pytest or pip install, right? We provide these commands to a computer. And these commands are usually configured or provided in a YAML or JSON file, or even through a GUI, depending on what your CI/CD tool is. But the different commands that we provide that little mini computer to run make up all of the actions that our pipeline will perform. And this pipeline or this virtual machine that we have is going to run based off of some event getting triggered. And so, like I mentioned, this is usually us either doing a git push or performing like a merge request. It doesn't really matter. There's a lot of different events that you can configure depending on your CI/CD tool. You can also set it up to run every single night at 2 in the morning. There's a lot of different options, but mostly it's going to be based off of a git push. And I wanted to provide just a quick example config of what our CI/CD pipeline is going to look like when we're done. So this is just a little snapshot of it. It's not all of it, but I wanted to show you just how simple setting up a CI/CD pipeline is. So this is the YAML file that we use to kind of tell the machine what are the steps that we want it to perform. And so you can see here, we've got this section called steps. So already you can tell we're just providing it a list of steps. Now, the syntax may be a little foreign, but you'll see that it's pretty easy to learn. You'll see that the first step that we have is there's this thing called action/checkout. So what this is actually doing is it's telling our machine to pull our code. So after we do a git push, it's going to pull our brand new code so that we can actually do something with the code. And then the next step is here we're setting up Python 3.9. So all it's doing is it's installing Python 3.9 for us. And then afterwards, we have to update pip. So it's going to run python-m pip install --upgrade pip. So that's going to upgrade pip so we have the latest version. Then we're going to install the dependencies. So that's pip install -r requirements.txt. So you can see all the things that we do on our local machine. We're just telling this little machine to do the same thing. And then afterwards, we then run Pytest. So that's going to first install Pytest. And then we just run Pytest, right? Just like we did on our local machine. We're just telling the machine to do the same exact thing. So we're just telling the machine a list of instructions that we have done by ourselves manually. We're just giving that list to it so it can run automatically. Right? And so hopefully you guys see just how simple a CI/CD pipeline is. There's nothing magical to it. It's just like telling a machine, this is what we want to do. I want you to run this every single time we do a git push. All right. So hopefully you guys understand this. In the next video, we'll get started on setting up Github Actions so that we can actually build out our CI/CD pipeline. All right, before we get started with working with Github Actions, I want you to open up a couple of web pages. So if you go to the Github Actions documents page, I definitely recommend you pull this up. Take a look at the quick start page and the reference page just to get an idea of how to work with Github Actions. I will cover everything, but you are going to forget some things I cover. So definitely know where the documentation is. Pull up the GitHub Marketplace as well. So this is where we can look up built-in actions that we can use in our CI/CD pipeline that have kind of handled a lot of the more complex logic. And then on top of that, you'll see that GitHub has this example tutorial on how to set up a CI/CD pipeline for a Python application. So this is what I kind of looked at to get started with building out a CI/CD pipeline for our FastAPI. And it kind of covers most of the things we do that we need. So if you want to, you could just follow this. And I think at that point, you'll have a good idea as to how to work with this. But once again, like I said, we're going to cover everything from scratch. But if we go to the documentation, you go to quick start right here, right, it tells you that we want to create a folder called GitHub. And then in that folder, we want to create a folder called workflows. So let's go ahead and do that. So in our main project directory, let me just minimize everything. I'm going to create a brand new folder. And I'll call this .github. And then we want a new folder within here called workflows. All right, and so here we can define all of our workflows, which kind of make up our CI/CD pipeline. You can have more than one. You don't need to just have one in this case, but we're just going to use one because we're keeping things simple. And so here, this is where we're going to create a YAML file. So if you aren't familiar with a YAML, it's just a certain type of markup language that's commonly used for like config files and things like that because it's very easy to read. But the most important thing to keep in mind is that spacing matters in YAML. So you definitely want to make sure that all the things are lined up very carefully, just like it was when it comes to like the Docker compose file. So we'll go here and I'm going to create a brand new file and I'm going to call this build-deploy.yaml. All right, and so we're going to give this workflow a name. So even though we gave it the file a name, we actually have to provide a name here. So we just do name and feel free to call it whatever you want. I'm just going to call this build and deploy code. Okay, and then we have to define when should our workflow, or in this case, which is our CI/CD pipeline, when should it run? When should it trigger? What triggers our code to run? And so like I mentioned, it's usually either a pull request or a git push. So to specify when we trigger this, you pass in the on field, and then you specify, should this be a push or a pull request, or should it run for both? And so if you want this to run only on Git pushes, you would just do on push. If you wanted to run on pull request, you would do pull request here. But if you wanted to run for both Git push and pull request, then you would do push and pull request. And there's a lot of flexibility too. So the way we have it set up right here, this would happen on every push on every single branch and every pull request on every single branch. But there's a possibility that maybe you don't want this to run for all of your branches, right? Maybe you only want this to run on the main branch and a couple of other branches, and then the rest of the branches you don't really care about. So what you can do is we can go down a level and then hit tab in this case. And remember, like I said, spacing matters. So we'll say push. And then here you can define all of the branches that should run whenever you do a push. So if I pass in main, what's going to happen is that this workflow is going to trigger every time we do a push, specifically only to the main branch and no other branches. And so you can provide a list of all the branches. So this is, another branch. This is, maybe some feature branch. All the names of the branches that you want your workflow to run on, you can specify that. And this is one way of providing a list in YAML. The other way is to actually go down here and then do a dash and then provide the name. So I would do main and then, some other branch and so on. And then if we wanted to, we could also customize all of the branches that should trigger this workflow on a pull request as well. So if I do pull request, and then I do branches, and this should be moved back here. And then here I do branches. And then I can do a list here as well. And I'll just call this, we'll give an example branch. I'll say test branch. Right. And so just to kind of read this through, anytime we do a push to either one of these branches, it's going to run our code. And anytime we do a pull request to this specific branch, it's going to run our code as well. So that's just how to set this up. We're not going to do any of that because we just have one branch in this case. So I'm just going to say we're going to run this on push and pull requests for all branches. And if we actually go to the documentation, I think, the reference page, you can go to the reference page and then select events that trigger workflows. And that's going to cover everything that we just covered. So it's going to go over all of that. And you'll even see that there's a scheduled event. So you can tell it to run kind of like a cron job, like, hey, I want this to run every single hour. And there's a few other like manual events that you can trigger and a couple of like webhook integrations as well. But we're not going to do any of that. We're just going to keep things simple for now. All right, so once we've defined what's going to trigger our workflow, we have to then create a job. And so if you go to the documentation, the GitHub Actions documentation says that a job is just a set of steps that execute on the same runner. So our runner is just a virtual machine. So when our workflow runs, right, we have to provide it a job, which is just a list of steps that's going to run on that specific runner in that case. And so here I'll go to jobs. This is where we provide a list of jobs. We're going to start out with just one in this case, and we can give this whatever name we want. I'm going to call this job one. Not a very good name. We're going to rename it in the future, but I want to just keep it simple for now. And what we want to do is we want to specify what type of machine do we want to run this on. And so like I said, a CI/CD tool like GitHub Actions is going to provide us a machine, a computer. And we have to specify what operating system do we want to run it on. So we're going to just use it on Linux, but keep in mind, you can run this on Windows, you can run this on Mac, you can even run it on all three if you want to test all of them. But since our since our production environment is running on a Linux machine, I think it makes sense that we do all of the testing and all of this on a Linux machine. So you pass in the runs on field, and then here we say Ubuntu latest. So this is going to be the latest Ubuntu version. And if we go to the reference page here and go to the workflow syntax, I think, and we go to jobs, that's going to provide us all of the information when it comes to what we can run this on. So you can see here, we can provide Windows 2022, or you can just grab Windows latest. We've also got, and I realize the text is probably small for you guys. We got different versions of Windows. We got Ubuntu latest, which in this case at the moment is just going to be the same thing as writing Ubuntu 20.0.4. but you can grab any one of these specific Ubuntu versions as well as Mac OS 11 and some of the other previous Mac versions. But like I said, we're going to stick to just running on Ubuntu, and we might as well just grab the latest version. And so once we specify the operating system, the next thing that we have to do is provide a list of steps. So we kind of went over what the steps would look like when we did the little PowerPoint demonstration. So here we say steps, and then we provide a list of steps. So when it comes to lists in YAML, you just do the dash, and then you provide the lists. And usually when it comes to a specific step, we give it the specific command that we want to run, as well as a name, right? A human readable name, so that when we look through the logs, we know which step is doing what. So we can say like, hey, this step is installing Python, or this step is running Pytest. And so here, if we say name, this is where we provide a description for what we're about to do. So the first thing that we always want to do is we want to check out our code. And so I'm going to say, hey, this is checking, or I'll just say this is pulling Git repo, right? It's going to pull our code, and then we have to provide the uses. So this is the actual command that needs to run on our machine to pull our repo. And with Github Actions, like I said, there's a marketplace of pre-built actions that we can use to, essentially perform various tasks. So pulling your code is a very common task. So they've definitely got an action for this. And so if I just search for checkout, because I know that's what it's called, you can see this is the one we want. And so this is what's going to be responsible for pulling your code. And so here you just say uses, you do actions /checkout v2. And you could specify a specific repository that you want to pull. However, GitHub already knows what repository we're working on because we did a git push. And since all of this is integrated together, we don't actually have to pass in any other field. However, if you look at the documentation, you can specify what specific repository you want, as well as any SSH keys that you may need and things like that. But this is GitHub Actions, so it's all already hosted on GitHub. So it's a pretty simplified process. So all we have to do is just copy this right here. And we can just kind of continue down and just provide as many extra steps as we want. I'm just going to provide a very simple step after this just to show you, a step is just nothing more than us giving a command. So I'm going to name this one, say hi to Sanjeev. And what we can do is this is a special action that we grab from the marketplace. But if you just want to run a command on the machine, which is just a Linux machine, we can run any specific Linux command that we want because we have access to the CLI. All we have to do is just use the run keyword, and then we specify the command we want. So if you wanted to install a package, we could do, sudo apt install whatever. Or if you want to reload the machine, you could do a reboot. I'm not sure why you would do that. So all I'm just going to do is I'm going to just make it say echo, which is just going to echo out exactly what I type in here. I'm going to say, hello, Sanjeev. And so it's just going to run this command on our Linux machine. And so this is a very simple example so far, but I think that's a good starting point so that we can actually understand what's happening. And what we want to do is we now want to actually push this changes to our Git repository. So let me open up my terminal. Make sure you do save all. And so once we push this, this will actually be part of our repository, and it's going to actually trigger GitHub Actions to actually trigger this workflow because we said that on every push, we should run this workflow. So I'll do git add all. I'll do a git push. Sorry, git commit -m adding first GitHub action. And then we'll do a git push. And we can do an origin main if you want to be specific. All right, so it's been pushed. And so now if we go to our GitHub repository, there's a actions tab right here. And so you'll see that I had a couple of other actions that ran because I was doing a dry run. But you'll see that the most recent one, which is the one we had, which is called adding first GitHub action. So this actually comes from the commit name. And we could select this and we can see exactly what happened. So this gives us a little summary. We can see that we have one job called job 1. And then we can see that the job ran and it successfully ran and it took 4 seconds. And if you click on the job, you'll see all of the steps. So the first thing is it sets up the job. And so you can see that it's creating a runner, which is once again just a virtual machine. And then it's going to provide us Ubuntu because we specified that as our operating system. It's going to set up a virtual environment. Don't worry too much about that. It's going to handle all of the GitHub permissions because it's all integrated with GitHub. Then we go down to the first action, which was pulling the Git repo, because we did say action/checkout v2. So then it's going to pull the GitHub repo. And then we could see the second option. The second action, which was say hi to Sanjeev. So all it's doing is just running this command on our Linux machine. So it's just saying echo hello Sanjeev, and then it just prints out hello Sanjeev. So this is all a CI/CD pipeline is. It's just providing a bunch of instructions for a little machine on the internet to run for us. Now, technically, the machine doesn't have to be on the internet. It doesn't have to be hosted. There's some CI/CD tools that you host yourselves on your own machine or your own server so that they actually handle running all of this, because even though GitHub Actions is free, they only give you a certain number of build minutes for free. And then after that, they'll start charging for it. So depending on how many times you build, it may actually be more cost effective to just set it up yourself. And then it looks like, GitHub Actions, there's a post pulling Git repo. So it's going to perform a few other like cleanup actions, and then it's going to then clean up the job. So we have successfully created our first simple example CI/CD pipeline, or GitHub Actions workflow in this case. So let's take our GitHub Actions to the next step. And I'm going to actually remove this example. I just wanted to show you guys how to do that. But after we pull our GitHub repo, the next thing that I want to do is I want to set up Python. And so to set up Python, once again, we can go back to the marketplace, if I can find it, because setting up Python seems like a very common task. So we can just search for Python. And keep in mind, when it comes to setting up Python, you could technically just do the same thing where we can say uses, and then we can run the command on a Linux machine to install Python, which would be something like sudo apt install Python, right? We could 100% do that, and that would 100% work. But because this is such a common task, there's already a pre-built action, so we don't even have to do that. And I think I searched for Python. Did that work? It didn't look like it worked. Here we go. Set up Python down here. So this is going to be responsible for setting up and installing Python on our machine. And you'll see an example of how to do this. You just say uses action/setup Python at v2, and then you say with, and then you specify the version, and then you can also provide the architecture as well. And what's really cool about this is that, let's say we wanted to test our code on multiple different versions of Python. Well, we can go under the strategy section. So right under where it says runs on, we can do strategy, and then we can provide a matrix and then a list of versions. So if we wanted to test version 3.7, version 3.8, 3.9, 3.6, and make sure that our code works on all of them, we can then create this matrix here. And then when we go to set up our Python, right, we would say with, and then for Python version, instead of providing one specific version, we actually pass, this is essentially a variable syntax in YAML, and then we just call matrix.python version, which is referencing this list right here. And so it'll just run our actions for all of these versions just to verify that everything works in all of the versions. But we're going to keep it simple. We're just going to do version 3.9. If you want to play around with it, I definitely recommend you try testing this out. But for us, it doesn't really matter. But keep in mind, it looks like you can even do the same thing for different operating systems. So if you want to test on Ubuntu, Mac, and Windows, you can do the same thing as well. But like I said, we're going to keep things very simple. And I'm actually going to change this to name, give this a name. I'm going to say install Python version 3.9. And then we'll say uses, and then we'll call that action now. So we'll do action/setup-python at v2. And then we pass in with tab, and we'll say python-version. And we'll say 3.9. And I think that's all we have to do. Let me see the example. Python version 3.9. Yep, that's all. We can leave the architecture. I'm going to use the default, which looks like it defaults to x64, so not a problem in our case. All right, and then after installing Python, the next thing that I want to do is I want to upgrade pip. So I'll create a description of update pip. And then we'll say uses. Actually, instead of uses, we're just going to run a command on the Linux shell. So we'll say run. And we just run python-m pip install -- upgrade pip. So this is the command that you would run on any Linux operating system or even on a Windows machine to upgrade pip. And then the next thing that I want to do is we're going to install all of our dependencies. So since we pulled our Git repo, right, with the actions checkout, we're going to have access to all of this code, and we're going to have access to our requirements.txt. So we have to make sure that we install all of these packages there as well. And so here I'll just say this is install all dependencies. And the command that we're going to run for this is going to be and you guys should know this is just pip install -r requirements.txt. All right, so I think this is a good starting point. Let's try committing our code again. So I'll just do git add --all. We'll do a git commit -m, added more steps. And then we'll do a git push origin main. All right, and then we'll go back to actions. Right, and we can see that our workflow is starting to run. That's why it's yellow. And we can take a look at its current status. So it's still running job 1, which is the name we gave it. And we can just kind of follow along. So it looks like it pulled our repo, installed Python version 3.9. It's then updated pip, and that's already completed. And now it's installing all the dependencies. So obviously installing all the dependencies takes a certain amount of time. That's probably going to be the longest specific step in our GitHub workflow at this point. All right, and it looks like that ran, and then it's essentially cleaning things up, and then it's completed, and we get the beautiful green check mark. So we can just close out of this, go back. And you can even see the list of all of our workflows that GitHub Actions has detected. So we have built-in deploy code, so that's the only workflow that we have, but keep in mind I can create essentially as many different YAML files inside this workflow folders to have different workflows. So I might have one specific set of, I might have a workflow specifically for one branch and a completely separate workflow for another branch. It just gives you a lot of customizability, but we're just going to have one workflow that works across all of our branches. Now, the next thing that I want to do is I want to run Pytest. So to run Pytest, right, it's a pretty simple process. So let me set up the name first. I will say, test with Pytest. And then we'll say run. All right, and I need to run 2 commands. So if you ever want to provide a list of commands to run, instead of having to create multiple different steps, I can do a pipe, go down a line, and just provide the list of commands. So we'll do pip install Pytest, and then we can go down a line and provide the second command. So then we just run Pytest. And you can, pass in whatever flags if you want the -v and the -s. But I'm going to keep it simple, and we're just going to keep it blank for now. Let's save this, and I'm going to then do the same thing. We'll do a git add --all. We'll do a git commit -m. And I'll say added Pytest step. And then we'll do a git push origin main again. And so from a learning perspective, right, this is kind of a slow process because we have to push all of our changes, and then now we have to wait for this whole thing to run. But once you understand how all of this works and how easy it is to set up, you won't have to keep doing this every single time or every single project. You can just essentially copy and paste most of your workflow. All right, so it looks like it's completed, and we get a red X. So it looks like something broke, and that's to be expected. And it's going to highlight what specific test failed, or sorry, what specific step failed. But we can see that it was the running Pytest. So if I just open this up a bit and then expand it, we can take a look at what the error was. So it looks like it installed Pytest, and that seems to have worked fine. And then down here, you can see that there's a couple of validation errors. And so it says that, we didn't provide a database, hostname, port. So it looks like there's the issues with environment variables. And that makes sense because this is a brand new computer that we haven't touched. So none of the environment variables have been set up. So obviously it has no environment variables, and our Pydantic validation of environment variables should have failed, and it did absolutely fail. So this is all to be expected. And so in the next video, we'll figure out how we can set environment variables in our workflows so that we can provide the information for reaching our specific database. So there's a couple of different ways that we can set up environment variables, and there's a couple of different places where we can define them. So I'm going to show you how to set a job-specific environment variable. That means this is an environment variable that will only be accessible from within one job. So in this case, our job that we've been working on is called job1. And so if you want to set an environment variable, you just set it right here. So we say env, and then you provide all of your environment variables. So in this case, let's say we want database hostname. And in this case, it's going to be localhost. We've now successfully set up one environment variable, and I'm just going to copy and paste all the others. And so now we've defined all of our environment variables in this case. And that should fix the issue, but I want to show you guys what other environment variables that we have as well. And if you want to know where I'm kind of getting all this information, like I said, we have the documentation, and there should be a section for environment variables here. And so I think we should see the same thing, right? Yep, we see the same thing. So env under the specific job, and you just provide the list of all of your environment variables. And then there's some built-in ones. So these are default environment variables that get set for you. So here you can see what's the run number, what's the GitHub job, what's the action path. We can even see what's a repository. So if you want to get the name of your repository, you can reference this specific environment variable, but we don't need to do any of that. But what I do want to show you is, if I had gone in and then created a second job called job2, right? This environment variable that we defined here is not available because this is defined under job1. So if you want to have an environment variable that's shared across all of your jobs, I can specify an environment variable here. So I can say env, and then I just provide my environment variable. So I could just copy this one as an example, and we can provide this. So then database hostname is going to be available for job1 and job2. But for now, we're just going to remove that because we don't really need it. We don't really need that right now. And I'm going to keep everything as default in this case. And we're going to check this into Git. So I'm going to do a git add --all. We'll do a git commit -m, added env variables. And we'll do a git push origin main. Okay, and then back to our actions page. If I see the added environment variable section, we can see that failed. Once again, this is going to be expected. So if we go under, it looks like there's a weird failure. No steps defined. Okay, so we got an error because I accidentally left job2, so it doesn't like it, the fact that I have jobs2 with no steps. So we're going to save this again, and we're going to do another commit. And I'll just call this committing again because I'm getting lazy. All right, and let's just make sure that we've kicked this off. All right, so it looks like we kicked it off, and there's no like major show-stopping errors at the beginning. But we should still see this fail, and that's to be expected. But I just want to make sure that we no longer have issues with environment variables. And I want to make sure that the environment variables that we set did successfully get applied to our runner. Okay, guys, so a couple of things to point out. So there's a whole bunch of errors, and that's to be expected, and that's okay. But we can see that it did process all of our environment variables, so that's great. So we did fix that issue. But you'll notice that, when we're running our test, we get a whole bunch of errors, and then eventually you'll see a whole bunch of Sqlalchemy errors. And the reason we see a whole bunch of Sqlalchemy errors is because if you look at the environment variables, we're pointing to localhost for our database. There's no database on this runner. This is a brand new computer. Why would there be a database installed? So we do eventually have to set up a database for testing on the runner itself, or we would have to point it to a remote database, whether that's hosted on Heroku or AWS, it doesn't matter. But for testing purposes in your CI/CD pipeline, I'd rather create one on our runner that we can just quickly spin up for testing. So once again, I just wanted to point out how to set up environment variables. The one thing I don't like, and I want to make sure I want to teach you guys, is that in this case, we're hard coding these values in here. And so this is all stored in our repository. Anyone can have access to it. This is our test database, so it's not a big deal. But I do want to show you how we can store these as secrets so that the runner has access to them, but no one else can see them, because storing it in here could potentially cause issues. If you didn't want this, the password and the username for your test database to get out. In my case, I don't really care, but it is important for you guys to understand how to actually do that. So as I mentioned in the last video, our environment variables are hard-coded into our workflow. So technically when we check this into Git, anyone can see it, which may or may not be a problem. But if it is a problem, I'm going to show you guys how we can work with Github Secrets. So if we go to our GitHub page and go to settings, here there's a section called secrets. So we can define secrets that we can use and access in our workflows. And so this is a repository secret. That means it's globally accessible across the entire repository, across all branches. There's no, any kind of environments or anything like that. So we'll select new repository secret. And here we just give it a name. So if you take a look at our environment variables, I figured since that's what it's going to represent, we might as well use the same one. So I'll say database host name in this case, and then just give it a value. So localhost. That's it, right? It's just a key value pair. We do add secret, and then you'll see it's stored in here. And so now in our code, if we want to reference this secret, which I happen to call database hostname, we just copy the name of the secret. And then what we do is we use $ curly brace, so 2 sets of curly braces, and we say secrets dot and then the name of the secret. So this will allow the runner to access the secret from our GitHub repo so that our workflow code doesn't actually expose all of this information. And so this is what you want to do for your passwords and things like that, especially when it comes to storing the information for connecting to your production database, which we will do in one of the later lessons. But before we proceed any further, I want to actually show you another option. So I'm actually going to remove this repository secret in this case, which is once again a global secret that our entire repo can access. Instead, what I like to do is I like to set up environments. So you can set up a whole bunch of secrets that are available depending on what the environment is. So I can create one for testing, one for development, one for production. It gives us a lot of flexibility. So I'm going to create a new environment, and I'm going to call this testing. And within the environment, we're under the testing environment, we can add a secret here. And so we're going to do the same thing. I'm going to call it database hostname. And in this case, we'll say localhost. We'll add the secret. And we can provide as many secrets as we want. And then what we can do is in our job, we can specify what the environment is for the job. So I can say environment. And then we provide the name, which is going to be testing, right? This is going to match up with whatever name we gave here. So I called it testing. So we give this the name testing, and it's going to have access to all of the environment variables that we defined here. And the way to access them is exactly the same way. You just do $, 2 curly braces, secrets, and then the name of the environment variable. Now, if there's an overlap with the name of your environment variables when it comes to the ones that you set in your environment, as well as the one you set globally for the repository, I don't actually know who takes precedence. I suspect it's probably the environment, but you should check the documentation to verify. But we don't have any global secrets. I'm going to be using environments for everything. So this keeps things nice and simple. And so now that we've set up this one, let's go ahead and just set up all of these while we have the option. And so we're going to set the port as well. Here we'll set the password. We've got the database name, which we'll just say FastAPI. Then the database username, it autofills because I ran through this all in a quick trial run before I started recording, so it's kind of cached in there. All right, and so now that we have all of our environment variables or our environment secrets set, we could just change all of these to reference those secrets. So we just do the same process, and in this case, it's just going to be the same exact name as the key in this case. All right, and so now that we got all of these set, let's just save this, and I'm going to check this into Git now, just to make sure that everything is kind of working so far. And we'll take a look at the job real quick, and hopefully there's no errors or only errors that we expect to see. And what did I call this one? ASDF. Oh, okay. So it looks like it failed already. So we clearly did something wrong. This workflow is not valid. Unrecognized name database_port. Well, what happened there? And it even tells me the position. So if I select show more, database_password. So let's see. What did we mess up? Yeah, simple mistake. I forgot the secrets dot before all of my variables. So that's why it had no idea what that was. We have to reference secrets to actually get access to them. And now let's try this one more time. All right, this looks a little better. All right, and so now if we look at the test with Pytest, you can see that the environment variables were passed in, and GitHub will automatically hide what all of the secrets are, because once again they're secrets, so you shouldn't see them. But it does show that we were successfully able to retrieve them, and we got the same error down here. This is just an issue with accessing the database because there is no database on localhost. So it's trying to connect to a database that doesn't exist, which is going to create all sorts of issues. So in the next video, we'll figure out what we can do to set up a test database on our runner so that we can actually run our tests. So when it comes to setting up a database on our runner, the easiest way to do that is to create a service container. So what's going to happen is Github Actions is actually going to allow us to spin up a Docker container, which really is the easiest way to set up to set up Postgres on a remote machine. That way we don't have to worry about any issues with potential installation of a Postgres database. And so I recommend you take a look at this tutorial, which kind of walks you through how to set up a Postgres service container. And it just gives you an example in this case, which we are essentially just going to copy in this case. But here we just, under jobs, we specify a service. We give this service a specific name or label, and then we just tell the image that we want to use. And in this case, we're just using the default Postgres image. This is the one that comes from Docker Hub, by the way. But you could technically use any image that you wanted to, but it's Postgres, so we might as well just use the default one. And then we can pass environment variables into the Docker container as well. So one of the things that we want to do is set up the password for Postgres, as well as even potentially the database name. And then what we want to do is we want to set up some health checks to wait until Postgres has started, because until Postgres starts, we should not run any tests because the tests are going to fail because the database is down. So we want to make sure that Postgres is up and ready before we actually start running our tests. So we're essentially just going to copy this line here. But let's go back to our code and we'll take a look at how to do this step by step. And so I'll just go under the environment variable section here, and we'll create a section called services. And I'm going to create a service called Postgres. And we're going to provide the image just like we saw in that example, and that's going to be Postgres. And let's pass some environment variables. So the first thing is going to be the Postgres password. So we're going to do Postgres_password. And here for the password, we can literally reference the same exact secret because they're going to be using the same password. And then we also want to give it a custom database name. So we want to automatically create the FastAPI_test database so that we don't have to do it in code. So I'll do Postgres_DB. And we'll do $, and then here I can pass in, where's my database name? So this is just going to be FastAPI at this point, but we want FastAPI_test because that's what our code has been set up to run. So we'll do _test, right? So this is kind of like string interpolation. So same thing. And then at that point, I think our Docker container is pretty much set up. We do have to specify the ports that we want to open up. So we'll say ports. And we want to do 5432. and then 5432. So this is what we want. And you're probably thinking, well, can we use the variables here? And I tried to do this. I tried to paste this here and then paste this here. And I actually got errors. I don't know why it didn't work, but for some reason this wasn't allowed. So you have to hard code these values, unfortunately. And then lastly, let's set up the options. So I'm going to just copy these options right here because we want those health checks for sure. Let's save this and make sure that all the spacing lines up, because a lot of times the spacings can mess up things. I have a auto formatter, so with for YAML syntax, it'll automatically format it so that all the spacing is set up properly. You want to make sure that you do it manually or set up or install a extension in VS Code if that's an option for you. Okay, so we've got our Postgres database, and I think we should be good to go. So let's try this: git add all, git commit. All right, and so we can see that our most recent test, in this case, happened to succeed. And if you actually go to the test with Pytest and just see the results, we could see that 46 tests pass with no issues. And so that means it did successfully connect to our database. And after that, it essentially completed the job. So now we've successfully added a database and we've successfully set up our CI pipeline. This is the CI portion of things to pull our code, install Python, set up, install all the dependencies, and to run our tests. So all of this happens in an automated fashion now just by doing a git push. So you could see how easy it is to get things started. And so I think from the CI perspective, the last thing I want to show you guys is how to essentially create a Docker image in our runner and push that out to Docker Hub so that our production network can then pull that brand new image. So there's a couple things that we have to do to get Docker working in our GitHub workflow. The first thing is we need to have a repository set up on Docker Hub to store our images. And if you did not create one during the Docker section, go ahead and create a new one. So log into Docker Hub, select create repository, and just give this a name that you can remember. In this case, this is going to be FastAPI. I'm going to call it that, and then make it public just to keep it simple. And so this is our repo, and then it's going to tell us how to actually push an image to it. And then if you go to this page right here, so docs.docker.com /CICD/GitHub Actions, it's got an excellent tutorial that we can follow for setting up Docker with our GitHub Actions. And so if we go back to our Docker Hub, the first thing that we want to do is we want to get an access token. So let's go here, and I think we go under settings. Or, well, it doesn't look like it's here. Maybe account settings. Yep, and then security, and then we can select new access token. And maybe we can call this GitHub Actions. And we're going to give it, whatever permissions that you want. Does the Docker give us information on what permissions? It doesn't look like it in this case. So just go ahead and select all of them for now. All right, and so it's going to give you your access token. Make sure that you don't share this with anyone else, and it's only going to be displayed once, so go ahead and copy it and make sure that you have this. Then what it's telling us to do is we want to create a secret for both our username as well as the Docker Hub access token. So let's create these two secrets in GitHub for Docker Hub access token and Docker Hub username. And I actually forgot what my username was. Okay, so it's sloppy networks. And so here we'll go into settings. And feel free to use either the global repository secrets or environment secrets. I'm going to just put this in the testing environment for now, but you can use either one in this case. And so we got Docker_hub_username. So this is going to be sloppy networks for me, but it's going to be something else for you guys. And the last one is going to be Docker Hub. What is it? Docker Hub access token. All right, and so once we've got that set up, you'll see that they're going to give us the steps on how to actually set this up in our YAML file. You can ignore the original, the setup process. And what we want to do is we want to go down to this section right here, which shows us how to log into Docker Hub. So we can literally just copy this straight up and just paste it in here. So we can just say, we'll do it at the, what step should we do this at? We'll do it at the end, just because why not? Because some of you guys might not be interested in setting up Docker. So it's going to be an optional step at the end. So we'll log into Docker Hub using this built-in action from the marketplace. And then here it's just going to provide two properties, username and password, which is going to reference the two secrets that we created. All right. And then we want to set up Docker build X. So we'll copy this one as well. Right, and then we have the build and push step right here, which in this case, it's once again a built-in action. And all it's going to do is we're going to provide a path to the context. So this is essentially where is the Docker file located. And this is technically optional, but if you want to, you can hard code the specific Docker file. I think it should default to this one because that's the default Docker file, but we'll just put it in just in case. And then the push means not only are we going to build the Docker image, we're also going to push it up to Docker Hub, and then we have to give it a specific tag. And if we go back to Docker Hub and I go to my repositories and I go to my FastAPI, it's going to show me the format of the tag that I need so that I can actually push it up properly. So it's going to be the username / and then the name of the repository, which is FastAPI, and then we can also give it an optional tag name as well. So once again, we're going to copy this and just update a few fields. Everything else should be just fine. The only thing that we have to change is this is going to be FastAPI, and it's going to reference the username. So it's going to be in the exact format. And if you want to give it a very specific tag, you can give that as well, but I'm going to just give it the default latest. And then here, it's just printing out the image digest, which is for us is optional. You'll see that it does provide us some optional things that we can do for optimization. So we can use the build cache so that we don't have to re-download all of our images every time we run, because that's going to extend the build time and the run time for our runner, which is eventually going to cost us a certain amount of money. So this is the code that you can use. And if you look at the bottom right here, this is going to show us all of the code at the very end. So we can literally just copy all of this if we wanted to and just use that instead of what we put. So that's what we will do. So let me just delete all of this and then paste it in. And we have everything. And once again, we just want to change the name to be our repository name, which is right here. We could also use a secret for that, but don't worry too much about that. And that should be all that we have to do for the Docker integration. If you don't have a Docker file, then I'd recommend I'll just pause this video, create a file in the root of your project directory called Dockerfile with a capital D, and just copy all of this, or you can follow what I go through in the Docker section if you guys skip that. And I think that should be everything that we need. So let's go ahead and push this and pray that it does not break anything and it works just the way we expect it to. So we'll do git add -- all, git commit added Docker, and then we'll do a git push origin. Yep, and it failed, so fully expected this. A step cannot have both uses and run keys. So what did we break here? Actually, it should, where is it telling us this? Yeah, this spacing got messed up, so that was a very obvious mistake that I should have caught. And I just have to move this back right there, and that should fix everything. So let's do this again. All right, so far it's not errored out, so it looks like things look okay. And we can see the build and push section failed, so let's see if there's an error. And it looks like there's some issue with the driver. Please switch to a different driver, docker buildx create -- use. So let's see what that is in this case. And I realized the documentation was a little confusing. This section that we copied at the end, it didn't include one of these steps, which is the buildx step. So before after we log in, we want to set up a buildx, which is the mistake that we ran into. So we want to copy this page right here, this section, and then we'll run that right after the login. And so now if we do a git add all, git commit -m, and then a git push origin main. Okay, so I think this time everything should work. But just to reiterate, because I think I went a little bit quickly, the steps are we first log into Docker using the login action right here. Then the next thing is we set up buildx, and then we call the build and push action in this case. And here we specify the context, which is saying just this current directory, and then the location of our Docker file. And then we're going to use buildx for the builder. And we set push to be true because we want to actually push it to the GitHub repo. And then here the repo is going to be our username / then the repository name, which happens to be FastAPI. We could store this in a secret, but I decided not to. And then these are just copied from the documentation so that we can cache all of the images so that we don't have to keep running all of this from scratch, which is a fairly long process. And then here we're just spitting out the image digest. And if we take a look at our workflows, and we can see that the last one, which is called ASDF, successfully ran. And if I actually go back to my Docker Hub in this case, and just hit refresh, right, we can see that we did successfully push an image a minute ago. So that means we have now successfully completed our entire CI portion of our CI/CD pipeline. The next step is to set up the continuous delivery, which is a matter of just providing a whole bunch of commands needed to actually push out our new code to our production network. And moving forward, just to kind of keep things simple and as quick as possible, I'm actually going to copy out all of the Docker steps because we're not even using Docker in production. So we don't actually need this. So we'll just comment that out just to make things as quick and as snappy as possible so that we don't use too many of our build minutes. So now that we set up the continuous integration part of our CI/CD pipeline, it's now time to move on to the continuous delivery aspect of our CI/CD pipeline. So this part is going to be responsible for pushing out the update to our production environment so that our code or our production environment is running our newest and latest code. So there's a couple things we can do, and I'm actually going to do this up here. Actually, we'll just do it down here. It's fine. So what we could do is, just to keep things simple, I could just provide another step, right? And we can give this, whatever name we want. I could say name, and then, hey, this is push changes to production. And then we can, provide the steps needed to actually push those changes out. However, instead of doing it like this, what I would like to do is I actually want to break it out into a separate job so that we can kind of have things nice and organized. And what I actually want to do is I want to rename job one because it's not very descriptive. I'm going to rename it to build. And then I'm going to create a second job, and we'll call this one deploy. So we've got two different jobs. However, the issue with jobs is that they don't behave the way that you think they would. And let me delete this. The way that jobs work is that by default in GitHub, the jobs run in parallel. And so what I mean by that is that when our workflow runs, GitHub is actually going to run the build job, and the deploy job in parallel at the same exact time. Now, we would definitely not want to do that because that would mean before we've even, run our tests and done anything else, we would try to actually deploy our new changes, which would be a terrible thing to happen. So we don't want it to run in parallel. How exactly do we configure that? Well, we pass in an option called needs. So you say needs, and here we tell it the list of jobs that need to complete before this job can run. So here we just say this needs to wait for the build job to run before this job runs. And so we just pass that into here. And you could pass in multiple jobs if you wanted to. We only have one other one. So this is going to cause this to run in a sequential order. And just like with the other job, we need the runs on property to define, that we want to run this on Ubuntu latest. And then I'm just going to create a test step. In this case, we'll do steps. And the first step is going to say uses. Actually, I'm just going to say name, deploying stuff. And here I'm just going to run a command on our server. And I'll just say echo going to deploy some stuff. All right, so let's test this out. I'll do a git add -- all, git commit -m. And if we go ahead and check GitHub and go to our actions, let's take a look at what happened in the adding deploy. And so you could see now that we have two different jobs, we can actually see the two different jobs here. And so it looked like build ran just fine. And then it looked like deploy also ran just fine. And so if I take a look at the deploying stuff, we can see that I ran the command going to deploy some stuff and it was successfully deployed, although we didn't actually deploy anything. But you get the gist of it. So now it's just a matter of figuring out what commands we need to run to actually push those changes out to our production server. And so, we covered two different deployment models in this course. There's Heroku, and then there's the Ubuntu server. So we're going to start off by going over how we can actually handle this with Heroku. And if we go to our code, right here, we're going to provide the steps to actually push an update to Heroku. Now, if you don't remember what we actually did to push changes out to Heroku, do a git remote, I think. Yep. So this is going to list out the Heroku remote. So if you want to actually push out the changes to your Heroku application, you would do a git push Heroku and then your branch, which is main. And that's going to update our application. It's pretty simple with Heroku. So in this machine, right, in our CI/CD pipeline, it's not quite as simple as running git push Heroku main, just because we don't have Heroku installed on this machine. Because when we set up Heroku, we had to install the Heroku CLI. We had to run Heroku login, put in our credentials, and then we had to we have to get our Git repo, we have to add the Heroku remote, and then we have to do a git push. So there's a couple of different steps. And so manually doing it, I just want to kind of write this out. We would, install Heroku CLI. We would, actually, before we even do that, we would, first of all, pull our GitHub repo. Because remember, this job is essentially starting everything from scratch, potentially on a different machine. So anything we did here, none of this stuff is available. So we don't actually have access to the repo that we pulled here. So we would have to do it again here. So we pull the repo, we install Heroku CLI, then we do a Heroku login, and then we do a, we have to add in a remote in Git, and I forget the command, but we'll just say add git remote for Heroku, and then we have to do a git push Heroku main. So those are the steps that we would have to run to actually deploy our application in our CI/CD pipeline. And this is all technically possible. You can manually do this, but it's actually a kind of a pain in the butt to actually do this. And instead, what I recommend you do is look for a action in the GitHub marketplace that kind of does this all under the hood. So that's what we're going to do because, deploying to Heroku is a very common task. So if I go to the marketplace, which I forget which tab was the marketplace. Oh, I think it's this one. Yeah. And so here, if I search for Heroku, you'll see that we have a couple of different options for deploying to Heroku in the marketplace. Let me just see view all, because I got to figure out which one is the one that I want. And this is the one that I want by Akhilesh NS. So this is the one that's got the most stars. So we'll select this one. And you'll see that in the example, the way that we actually deploy to Heroku is we have to get a Heroku API key. We have to provide our Heroku app name. And then we have to provide our Heroku email. So let's get this from our account, and then we will create secrets within our GitHub repository so we can store the information, because we don't want to hard code that into our YAML file. So going back to Heroku, if you go to your account, which is the little logo here, then select account settings, you'll see that the API key is right here. So we can just like reveal, and then I'm just going to copy this key. And what we're going to do is we're going to go to our GitHub repository. We'll go to settings. And then we can create our secret. So you can create a global repository secret, or you can do what I'm going to do, which is I'm going to create a brand new environment for production. We'll call this production. That is not how you spell production. And we're going to add a secret. And I'm going to, well, paste the value here, but the name, I'm going to just stick to what they used just to make it easier to remember. So Heroku _ API key, add secret. And then what else do we need? We have to add the email. So let's create a secret for the email as well, because why not? They didn't do that, but we're going to be a little bit more secure. And I'll call this Heroku _ email. And this is just going to be your email that you use to register. And then if you want to, you can also add the Heroku app name as a secret as well. You don't have to do this, but I'm going to do it. And what did I call my app? I can't even remember. FastAPI Sanjeev. Yours is going to be different, so make sure you update it accordingly. Okay, so wait, what happened here? Why is there only two? I think I may have accidentally overridden one of these keys. So let me put this information back in just in case, because you can't actually look at the keys after you save them. You can only update them. Okay, so we updated that, and then the API key, I have to copy this once more. All right, so we got those, and then let me once again add the Heroku app name. This is going to be all right, so now we've got our three keys. Hopefully I set those all up correctly. And keep in mind the name of this environment is called production. So for the other job, which is the deploy job, we're going to specify the environment just same way we did with the first job, just by referencing this code right here and just updating the name. And so this is going to be production. And then we can remove this unnecessary step. And I'll change this to be deploying to Heroku. And then we'll change this to be use. And so just like in the documentation, actually, I might as well just copy it because it's a little bit easier. So I can just copy this. And we can just update the app name with the secret that we defined. As well as the secret for the email. And that's all we have to do for the Heroku side of things. It's as simple as that. So that's why I always recommend you look for a built-in action so that you don't have to perform all of these steps by yourself. And I realized before we even do that, we have to actually pull our code just like we did in the first job. So we're going to copy that section right here where we pull the repo. All right, so we've got the repo and then we deploy to Heroku. And so what I'm going to do now is we want to check our code real quick and make some changes. That'll be easy to kind of quickly just test and see that we actually pushed out our changes. So under our main.py file, I'm just going to do what I always do. I'm just going to add successfully deployed from CI/CD pipeline. Okay, and so I'm going to save that. And then now we want to do a git add --all git commit -m push to Heroku example, and then we'll do a git push origin main. And before I do that, let me go to my app. So if I actually go to my app on Heroku, we can see it just says message hello world. And so after we commit these changes, we should see it send the new message. So I'm going to push this to GitHub now, and our CI/CD pipeline should run and push those changes out. All right, so now if I go back to GitHub and we take a look at the actions, I can see my push to Heroku example succeeded. And so you can see both the build phase and the deploy phase both succeeded. And if we want to take a look at the notes and then just see what happened with the deploying to Heroku section, we'll see the logs for this specific step. And so it looks like we can see Heroku's running in this case, and it looks like everything worked. So if I go back to my app and hit refresh, right, we could see we get the new message. So we have successfully updated Heroku using our CI/CD pipeline. It's as simple as that. And before I wrap up this video, this section or this video on deploying to Heroku, I found this one good article that shows you how to deploy to Heroku in a manual way. So if you don't want to use the built-in or the pre-configured GitHub action, you can actually create a custom workflow when it comes to actually manually logging in and then pushing all of these changes out to Heroku the manual way instead of using that pre-built action. But this is a little bit more complex, and this would only really be needed under very specific circumstances or just for learning purposes. So take a look at it if you want to see how it's done manually, but you never actually have to do that. Now, before we move any further, there's one thing that I want to check to make sure that our CI/CD pipeline properly does, and that is that if we get any kind of errors in the build job, I want to make sure that the deploy job does not run, right? And so when I say errors, it could be anything, right? Maybe we're unable to install all of our dependencies, or maybe, and more importantly, if our tests fail, right? If my tests fail, I don't want to push my broken code out to production. So I want to make sure that if the test fails, we stop right there and we don't proceed any further with the deploy. And so from a configuration perspective, you don't technically have to do anything. That's the default configuration, but I do want to verify that it actually does what we expect it to. So in the tests files, or if I can find it, tests, I'm going to go to, it doesn't really matter what test. I'm just going to go under test posts, and I'm just going to modify this to an incorrect value. I'm going to put this in the notes, change to this one, so I remember which one I changed so I can change it back from 200. So this should cause this test to fail, and if the test fails, then we want to make sure that we don't deploy. And I'm also going to go back to our main.py file to actually make some visible changes by changing this back to hello world to see if our code actually got updated accidentally or not. So we got everything set. We'll do a git add once again. We'll do a git commit -m broke stuff, and then we'll do a git push origin main, and we'll let that run. All right, so going back to GitHub now, let me go back to the actions page. And we can see the last run, it looks like it failed. So let's see where it failed. And so you could see here, it failed in the build stage. And then the deploy stage, if I select this check was skipped. So that means we actually did properly skip the deploy phase because the build phase failed. And we can see that we exited with an error code because one of our tests failed. Awesome. So let's go back. Let's fix this code real quick. And what was it? Test posts. And we'll change that back to a 200. Don't need those notes anymore. And now let's push out those changes once more. All right, and we'll go back to GitHub again. And let's go back to Actions and let's take a look. And we can see the last one did get deployed, built and deployed successfully. So if I go to Heroku, refresh this, we should see that this gets updated just fine. All right, so now that we can deploy our updates to Heroku, let's take a look at how we can deploy our updates to our Ubuntu server. So once again, it's just a matter of figuring out what exactly are the commands that we would need to run to update our production environment. So there's going to be a couple things. The first thing is, first of all, we would have to log into our Ubuntu server. And then once we log, and when I say log into our Ubuntu server, I mean like SSH to it. We would then have to move into our /app/source directory. And then we would run a git pull so that we can pull the latest code. And then we'd have to do a system CTL restart API. So how exactly do we do all of this? How do we log into our Ubuntu server? How do we SSH to it? Well, there's a really nice built-in action. If I can find the marketplace again. And I believe it's called SSH-action. And I don't think I can't find it in here, the one I used, but it's by Appleboy. And I'll just do Appleboy SSH. So search for that. There we go. This is the one we want, SSH remote command. So this will allow you to run commands on a remote machine. So let's take a look at how to do this. Here they give you an example. So you have to pass in the host, which is the IP address, the username, and the password. And then the SSH port is optional, but I think it should default to port 22, which is the one that's running on our Ubuntu server. So we don't actually have to define that. But that's all we really need. And then the script is going to be the commands that we want to run on the remote machine. So let's set this up. And I'll go down to here. And I'll say name deploy to Ubuntu server. And we're going to say uses Appleboy /SSH-action at master. And then with. So first we have to provide a host. And I'm going to store this in a secret, and we'll call this, what do you think we should call this? How about Ubuntu _host? Actually, we'll call this prod host. And then username, same thing. We're going to store this in a secret. So we'll do secrets.prod username. And then password, once again, in another secret. And I'll call this prod password. All right, then we have to provide the commands that we want to run. And so since we're going to use more than one command, we're going to do the little pipe symbol. And then here we just list out the command. So the first thing that we want to do is we need to move into our app directory. So we're just going to be the app/source. And make sure there is no front slash. That's going to break things. Then we want to do a git pull. Now this is where it might get a little interesting. I'm going to do it the wrong way first. So we do a system CTL restart API, but we do need sudo privilege. So we'll do sudo restart API, or whatever you call it yours. And so let's define these secrets real quick. And we'll go into the environments and then we'll go to our production environment. And so just go ahead and just create them here. All right, and then we're going to put in our password. I'm not going to show this one to you guys, so I'm just going to pause the video and then add it myself. And then finally, we need the username. And I believe I called mine just Sanjeev. I think that should work, hopefully. And so now we've got all of our secrets, and I think we should be good to go. Prod host, username, password. So let's try this. Actually, before we do that, I'm going to make one more change to the code so that we can actually see the changes. And so this is pushing out to Ubuntu. And we're going to have to do a git add once again. Then a git commit. And then git push origin main. All right, and let's go back now. Let's check on our actions. And it looks like it's still running. So it's in the deploy phase. And it looks like it's connecting. Oh, and it looks like it just finished. And it failed. So what exactly happened here? If we take a look at the logs, it says sudo, a terminal is required to read the password. So it's basically saying that when you run the sudo command, you get the prompt so that you can input the sudo password. And since this is all through a remote SSH connection, that's not really an option. So we have to pass in the -s option, the -s flag. And so the way we actually define this is going to be actually pretty interesting. But let's see, where's my file? So to use the -s flag, what we're going to do is we're going to say echo, and then we're going to echo the password, our sudo password, and then we pipe into the next command, and we do sudo -s. So the -s means that we're going to accept what the password as an argument, essentially. And this pipe command, what it's doing is we run echo and then whatever our password is. So this we actually replace with the actual password, and it's going to pass that into the input of this command. So it's going to pass it into the -s flag, essentially. So that's how you do this with a one-line command. Here, we're just going to pass our same environment variable. So we'll do secrets prod password. And I think that should fix it, actually. So we'll do a git add --all, git commit -m, password fix, and a git push. Okay, so let's go back to our actions. We can see that the password fix commit ran just fine and it succeeded. So the build phase and the deploy phase succeeded. So if I go to my Ubuntu server and we take a look at this, we can see that we did get the updated code. So we did successfully update our production server. And on top of that, technically, since we never took out the code for Heroku, we should see Heroku also deploy. So if I go to my Heroku app, we can see that pushed out to Ubuntu. So we now have successfully completed our CI/CD pipeline. We set up all of the continuous integration steps, which included copying our source code, installing all of the Python dependencies, testing our application, and then we set up the CD phase, which was just a matter of pushing those changes out to our production environment.